Hello everyone, in this video we're going to review the AP Precalculus Unit 1 Polynomial and Rational Functions. Topic 1.1 to 1.6. Alright, question number 1. The graph of the polynomial function f is shown above, where negative 5 less than equal to x less than equal to 5, so which means this is the domain of the function, right? So the function stops right here. The function f has local extrema at x squared negative 2 and x squared 2. So this is local maximum. This guy is local minimum, right? And the graph of f has a point of inflection at x equal to 0. So here's the point of inflection right here. Alright, on what intervals is f increasing? Alright, so in order to know if the function is increasing or decreasing, make sure you know the Christmas tree trick. Okay, so I have the Christmas tree trick right here. Okay, so you need to draw the tangent lines of the graph, right? So the tangent line like this. This is the first tangent line, this is the second tangent line, and this is the third tangent line. Now, if you see the graphs going this way, the tangent lines going this way, the slope is positive. If the slope positive, the function is increasing, right? If the lines going this way, the slope is negative. And if the slope is negative, the function is decreasing, right? So, look at this one right here. The function is increasing from negative 5 to negative 2 right here, right? From here to here. Alright, so it's going to be negative 5 to negative 2 union this guy right here. Alright, net 2 to 5, right? On what intervals is the graph of f is concave down? Okay, so if you see the graph goes like this concave down, this guy's concave up, right? So this is down and this is concave up. Oh, you see that if you have half of the concave down like this or like this is concave down. This guy like this or like this, concave up, right? So we look at this one, it's gonna be from negative 5 to 1 right here, right? So if you look at this one, it's gonna be from negative 5 to 0 right here, right? The function is concave down, so it could be negative 5, comma 0. Alright, number 2 right here, I'm gonna leave it for you to practice. Now let's move on to question 3. The graph of h is shown above, has relative extrema as x equal negative 3 and x equal to 2. So x equal negative 3, we have the local minimum, right? And x equal to 2, we have the local maximum, right? And the point of inflection as x equal to negative 1. So x equal negative 1, the point of inflection right here. Alright, on what intervals is h increasing and concave down? Increasing and concave down. So again, you're gonna draw the tangent line, right? So you're gonna draw this guy, this tangent line, this tangent line, and this tangent line right here. Now increasing, which means the slope is positive. So only this guy and this guy right here, the slope is positive. Now if you have the tangent line right here, the slope is positive, but the function is concave up, right? This guy, the slope is positive, which means the function is increasing, but it's concave down, right? So it's gonna be from negative 1 to 2 right here. So it could be negative 1 to 2. Now question B, on what intervals is h decreasing and concave up? Alright, decreasing and concave up. So we look at this one. This guy tells us the function is decreasing, right? And this guy right here, decreasing, right? But concave up, this guy is concave up, this guy is concave down, right? So decreasing and concave up should be this guy. So it's going to be negative infinity to negative 3 right here. So it could be negative infinity to negative 3. Now, on what intervals is h decreasing at a decreasing rate? Alright, the function is decreasing, so we look at this guy right here, either this guy, right, or this guy. now at a decreasing rate. So you're gonna draw two tangent lines and you compare, right? So right here I have the first tangent line right here. Now I have the second tangent line. It's gonna be right here. All right. Use the Christmas tree trick again. All right. If the tangent lines go in this way, the slope is positive. The tangent lines go in this way, the slope is negative. All right. If the lines go in this way, and if the line is steeper, the slope is bigger, right? So tangent line is steeper, the slope is bigger. Now, if the line goes this way, and then if the tangent line is steeper, the slope is smaller. Now we look at this one, we have two tangent lines right here, and then the function is decreasing, right? And then you look at this one right here, this guy right here, the first one right here, is steeper than the second one. So it's gonna be this one, steeper, the slope is smaller. So which means this guy increasing, right? The rate is increasing, right? But we need decreasing rate, so this is not the case. Now look at this one right here, we draw another tangent line right here. All right, and we see that this guy right here steeper than this guy, right? So this guy right here has a smaller slope than this guy, which means the slope is decreasing, right? So the answer must be 2 to infinitive. You're gonna put infinitive right here, positive infinitive right here, and negative infinitive right here. Now 3D, on what intervals is h increasing at an increasing rate? Now we look at this one right here. So we have two increasing intervals right here, from -3 to -1, and from -1 to 2, right? So we're gonna explore each of them, right? Now first one, I'm gonna draw another tangent line right here. I see that the tangent lines go this way, which means the function is increasing, so I'm good with this one. Right, now I'm gonna check if the reaction is increasing or decreasing. So I look at this one right here, I see that the tangent line is getting steeper, which means the slope is bigger. So the function has an increasing rate. So the answer must be this interval. So it's gonna be -3 to -1. Alright, and if you do this one, the function is increasing at a decreasing rate, from -1 to 2, right? So we only have one answer right here, -3 to -1. Determine if each of the following statement is true or false. Now question 4. The rate of change of the function k is increasing over the interval 4 to 6. So we look at this one, 4 to 6. This is 4 and this is 6 right here. So this guy right here, yes. The rate of change of k is increasing, yes. You can draw two tangent lines and you see that the first tangent line right here and the second tangent line right here, and you see that the second tangent line is steeper than the first one, which means the slope is bigger, so the rate of change is increasing, right? So this is true. Now question number 5. The rate of change of the function k is negative over the interval -4 to 0. -4 to 0, which means this guy right here. Alright, so the rate of change of the function k is negative. Yes, you can draw a tangent line. And you see that tangent line is going this way, which means we have the Christmas tree trick right here. So the rate of change of k is negative over this interval, so this is true. Now question 6. The function k is increasing at a decreasing rate over the interval 2 to 4. So 2 to 4, we have this guy and to this guy right here. Alright, so we draw one tangent line and we see that the tangent line going this way, which means the function is decreasing. But this guy say the function is increasing, so this is wrong. So this should be false. Now question number 7. The rate of change of the function k is positive and decreasing over the interval -6 to -4. So -6 right here, -4 right here. We have the function is going to be right here. Alright, So we're gonna check. The real chain of k is positive, so we draw the tangent line. And we see that the tangent line going this way, which means the real chain is positive, which is good. This is right. And decreasing, right? We draw another tangent line. So it could be right here. And we see that the tangent line getting less steep, which means it has smaller slope. And then the function has a decreasing rate, right? So this is true. So question number 7 is true. Now question 8. The graph of the function k is concave down over the interval -4 to 4. So -4 to 4 is going to be right here to this one right here. Alright, so this is not the case because this guy right here, from here to here, the function is concave up. And from here to here, the function is concave up. So that's wrong. So number 8 is false. Question number 9. The function k is increasing over the interval -6 to -4. -6 right here to -4 right here. So this is -6, this is -4. The function is increasing, yes, because we can draw a tangent line. And we see that tangent line is going this way right here. So the slope is positive, which means the function is increasing from -6 to -4. Now check 4 to 6. 4 to 6, it will be from here to here. And we draw another tangent line, and then yes, the function has the tangent line has the positive slope, so the function is increasing. So number 9 is true. Now question 10. The function k is negative and increasing over 4 to 6. Negative and increasing over 4 to 6, so 4 to 6 right here. Right? The function k is negative. So we check this one. We see that the function is below the x-axis, so this is negative, so this is true, right? And increasing, right? We draw another tangent line. We see that the tangent line going this way, so which means it has the positive slope, so which means the function is increasing, right? So question 10, this is true. Now question 11. The function k is decreasing at a decreasing rate over the interval -3 to 0 and 2 to 4. Right, so -3 to 0, we're going to draw this one. -3 to 0 is going to be right here. And 2 to 4. 2 to 4 is going to be right here. Alright. Now we're going to check if the function is decreasing at a decreasing rate over these intervals. So we draw the tangent line, and we see that tangent line going this way, which means the function is decreasing. Good. Alright, we draw another tangent line right here, and another tangent line right here, and we see that the slope getting bigger because the tangent line is going this way, and then if the tangent line steeper, the slope is smaller, right? Now this guy right here less steep than this guy, which means the slope is bigger, so the function is decreasing at an increasing rate. But it say the function is decreasing at a decreasing rate, so this is false. Number 12. The function k is positive and the graph of k is concave up over the interval -3 to 0. -3 to 0, so we have this guy right here. Alright. The function is positive, yes, because it's above the x-axis, so the function is positive. And the graph of k is concave up, yes, this is concave up, right? We have like something like this, or something like this, this is concave up. So the answer number 12 is true. Now number 13, the function is positive and the rate of change of k is positive over the interval 4 to 6. So 4 to 6 is going to be right here. Alright, so the function is positive, that's wrong, right? Because the function is below the x-axis, so this is negative, so this is false. Alright, so we know that the average rate of change formula is going to be f of b minus f of a over b minus a over the interval a, b, right? So we look at the first one right here, number 14. Find the average rate of change of the function f of s over this interval right here. So we have average rate of change is going to be f of 2 minus f of 1 over 2 minus 1. So we just substitute into the function right here. So we have 2 times 2q minus 2 plus 1. All right, don't forget parentheses, minus another parenthesis. So it could be 2 times 1q minus 1 plus 1 over 1, right? So if you simplify this one, it turns out to be 13. Now, question number 15 is going to be similar to the question number 14, so I'm going to leave it for you, okay? Now, question number 16, find the average rate of change of the function g of s over the interval negative 1 to 4, right? The function g of s, this is a piecewise function, right? All right, so now we're going to use the formula. It's going to be average rate of change is f of 4 minus f of negative 1 over 4 minus negative 1. So it turns out to be f of 4 is going to be, because 4 greater than 3, so we're going to use the second one right here. So it's going to be 4 squared plus 2 altogether subtract f of negative 1, which is less than 3 right here. So we're going to use the first one right here. So it's going to be 4 minus 2 times negative 1 over 4 minus negative 1 should be 5, right? So if we do this one and we simplify this one, it turns out to be 12 over 5, right? Now, question number 17 is similar to question number 16. I leave it for you, okay? Now, question number 18. Find the average rate of change. Now, question number 17 and 18 similar to question number 16, right? So I just leave it for you. Now, question number 19. Find the average rate of change of the function k of s over the interval negative 2 to 1, right? So we have the average rate of change is k of 1 minus k of negative 2 over 1 minus negative 2. So it's going to be k, look at the function k right here, k of 1 is going to be 4 minus k of negative 2 is going to be 8 over 3, right? So it's going to be negative 4 over 3, right? Now, look at number 20. Find the average rate of change of the function p of s over the interval negative 1 to 5. So negative 1 to 5 is going to be right here. All right, so we have the average rate of change formula is p of 5 minus p of negative 1 over 5 minus negative 1. So p of 5, we look at this one, we see that it's going to be 3, right? So this guy is going to be 3 minus p of negative 1. P of negative 1 is going to be 1 right here. Over 5 minus negative 1 is going to be 6. So it can be 1/3. Now, number 21, I leave it for you, okay? Number 22 to number 27, determine if the following functions could be concave up, concave down, or neither. In order to do this one, we need to calculate the average rate of change. If the average rate of change is increasing, the function is concave up. So average rate of change increasing, the function is concave up. If average rate of change is decreasing, the function is concave down. And if average rate of change both increasing and decreasing, the function is neither. All right, so we look at this one, we see that now we need to find the change of this one. So does that mean in order to get 4 from 3, I'm going to add 1, right? This one I'm going to add 2, this one I'm going to add 3, and this one I'm going to add 6, right? So in order to find the average rate of change, I'm going to take 1 and divide by the equivalent input intervals right here. This one 1, this one 1, this one 1. So the average rate of change, the first one is going to be 1 over 1, the second one 2 over 1, the third one 3 over 1, the last one 6 over 1. And you see that average rate of change is increasing, right? So because average rate of change is increasing, the function is concave up, right? In order to get 1 from -3, I'm going to add 4, and this 1, I'm going to add 6. I'm going to add 4, and I'm going to add 4. So the average rate of change is going to be 4 over 2, right? Because the equal length input interval is going to be 2, right? So it could be 2. Now you have another interval right here, 1 to 7 right here. So average rate of change is going to be 6 over 2, and it's going to be 3. And this one right here is going to be 4 over 2. And the last one right here, 4 over 2. So you see that, right? In this table, the function is both have the average rate of change increasing and constant at the same time. So it should be neither 7, and this one 5, this one 2. This one 1, right? So the average rate of change is going to be 7 over 3, 5 over 3, 2 over 3, and 1 over 3. And you see that the average rate of change is decreasing, right? So the function is concave down. Alright, so I'm going to leave number 25, 26, and 27 for you, right? Now let's take a look at the 28 to 31. Determine the least possible degree of the polynomials. Right, so you just find the change in y over the equivalent input intervals, right? So we look at this one right here. In order to get -3 from -3, you just add 0, right? This guy right here, you just add 2. 4. This guy right here, you add 7. This guy right here, you add 9. And this guy right here, you add 10. Right, so these output are not the same. So you keep calculating, right? So in order to get 4 from 0, I'm going to add 4. This guy, I'm going to add 3. This guy, I'm going to add 2. And this one, I'm going to add 1. They are not the same, right? So next, in order to get 3 from 4, I'm going to subtract 1. This one, I'm going to subtract 1. This one, I'm going to subtract 1. So after the first, second, and the third difference, all the output right here are the same, right? So the function has the degree 3. Because the third difference are constant. Now look at number 29. Over the equivalent input intervals right here, we're going to calculate the difference of the output. So in order to get 8 from 12, I'm going to subtract 4, subtract 2. Now look at number 30. Right, over the equivalent input interval, we have the change in the output. Right, so this one subtract 5, subtract 2, plus 1, plus 5, and plus 11. Right, next one, we're going to add 3. This one we're going to add, now we're going to add 0, 1, 2. Right, add 1 and then add 1. So after 1, 2, 3, 4 times calculate the difference of the output, we have the same constant right here. So the function has degree 4. 1, it's going to be 3, it's going to be 5, it's going to be 7, and it's going to be 9, right? The change in output is going to be 1, 3, 5, 7, and 9. Now we're going to calculate the average rate of change. So it could be 1 over 1. It's going to be 1. The second one, 3 over 3. It's going to be 1. The third one, 5 over 5. It's going to be 1. The next one, 7 over 7. It's going to be 1. And the last one, 9 over 9. It's going to be 1. So because the average rate of change is a constant, so the function is a linear, right? So this is degree 1. Now let's move on to question number 32 to 38. So question number 32 to 38. Determine if the following functions are even, odd, or neither. So keep that in mind. We have the formula if f of negative s is negative f of s, the function is odd. If you have f of negative s is f of s, the function is even. Right, so we're going to check this one. So we have y equal this one, right? So I just say f of so I just name this function as f of s, right? So I'm gonna check f of negative s. It's gonna be 2 times, right? When we see s, I substitute negative s, right? So I have negative s cubed minus 3 times negative s plus 9, right? I'm going to simplify. Negative s cubed is going to be negative s, so it could be negative 2s cubed. Negative 3 times negative s, it could be plus 3s plus 9, right? So because this one right here is not the same thing as original one, right? Now it's not going to be negative f of s, so this one should be neither. Now question number 34. We start from f of negative s. It's going to be negative s to the fourth minus 3. Make sure you put the parentheses. So it can be because this one has the even power. So any negative number raised to the even power is going to be positive. So we have s to the 4 minus 3. So this go back to original one right here. Right? So we have this one is going to be f of s. So we just prove that f of negative s equals f of s. So the function is even. Right? Now the last one right here. We have g of negative s. It's going to be negative 6 times negative s, all together raised to the power 5, plus 2 times negative s cubed minus negative s right here, right? So this guy turns out to be negative s raised to the 5th. Alright, so it's going to be negative s because this is odd power. So negative s is turned out to be negative s to the 5th, right? So negative s to the 5th multiplied by negative 6, so it could be 6s to the 5th. This guy, negative 2s cubed, and this one plus s. Now I can factor the negative side out, so it could be what? Negative side, I put this outside, so this guy turned out to be negative 6s to the 5th plus 2s cubed minus s, right? So you see the inside right here. This is actually the function g of s, right? So I rewrite the negative side outside. This guy actually the function g of s right here. So I just prove that g of negative s equals negative g of s. So the function is odd. Now look at number 36. Keep in mind the function is even. It's going to be symmetrical about the y-axis. If the function is odd, it's going to be symmetrical about the origin. Alright, the point right here. It's going to be 4, 3. So, because we have the opposite point right here, it's going to be negative 4 and negative 3. Right? So, which means the function is symmetric about the origin right here. So, the function is odd. We look at number 37 right here. Right, the function is not symmetric about the origin, nor the y-axis, so this is neither. Number 38, the function is symmetrical about the y-axis, right? Look, if we have the point right here, we have the opposite point right here. So they are symmetrical about the y-axis, so this is even. Alright, question 39 to 42. The polynomial function k is even, right? So this guy is even. And the polynomial function p is odd, right? Question 39. Find the values of a and b in the table above. So we need to find a right here, and we need to find b right here. So we know that because the function k is even, so we have k of negative s equals k of s. right? So we look at this one right here, this guy and this guy right here. So we have k of -3 equals 8. And then k of 3 right here must be the same thing, equals 8, right? So the answer for 8 right here equals 8. Now, look at this one. Because the function b is odd, so we have p of -s equals -p of s, right? So we have p of b equals 3 right here. And then we have p of -b is -3, right? So we look at this one right here, right? -b, so -3 is going to be right here, which means we have -4 right here. So we just equate this. So we have -b equals -4, and then b equals 4. So the answer is 4. Now question number 40. K of 2 plus p of -2. K of 2 is going to be the same thing as k of -2 because the function is even, right? P of -2 the same thing as -p of 2, right? Because by the formula, the function is even. We have f of -s equals f of s. If the function is odd, f of -s is -f of s, right? So we just substitute values. -2, k of -2 equals -6, so it can be -6, minus p of 2 is going to be 7, so -7, so the answer is -13. Now question number 41. K of -1 is the same thing as k of 1. So k of 1 is going to be 4. Now p of 3 is the same thing as -p of -3, right? So it's going to be p of -3 is going to be 2, so it could be -2. And the last one, find the average rate of change of p of s over the interval -5 to 5, right? So we have average rate of change is p of 5 minus p of -5 over 5 minus -5. Now we look at this table, we don't have p of 5, but we know because the function p is odd, so p of 5 is the same thing as -p of -5, right? So we just plug it in over here, so -p of -5 minus p of -5, right? Over 10, right? So p of -5 is going to be 4, so it's going to be -4 minus 4 over 10. So it's going to be -4 over 5, right? Graph of the polynomial function f is shown above, where the function is defined between -6 to 6, so we have the endpoints right here. Use the graph of the function f to answer the following. Now, f has a local minimum at, right? Local minimum is going to be this guy right here and this guy right here. So, at s equals -4 and 3, right? So, -4 and 3. F has a local maximum at s equals right here. Local maximum s equal to 0. This guy right here, -6. And this guy right here is going to be 6, right? The absolute maximum of f is the highest value right here. So the highest value right here is 5. At s equal to 6. The absolute minimum of f is the lowest one right here. So it's going to be -5. At s equal to -4. So it's going to be -4 right here. Now look at the second one. The function g has local minimum as this guys right here. So it's going to be s equal to 4. And this guy right here, s equal to -3. The function g has a local maximum at this guy right here, s equal to -5. And then this guy right here is going to be 0. You cannot count this one because you see the arrow, which means the graph keeps going up, right? The absolute maximum of the function g is none. Because this guy keeps going up, you don't have the highest point, right? The absolute minimum of the function g is this guy right here, right? It's going to be -3 at s equal to 4. All right, number 3, I'm going to leave it for you. This is similar. Number 4, the graph of the polynomial function k is shown above. Which of the following could be an expression for k, right? So we need to know that this guy and this guy have the same end behavior, right? So which means the degree must be even, right? So we know that this guy even. Now they both pointing up, so which means the leading coefficient is positive, right? So leading coefficient is positive, right? And we look at the 0 right here. We have 1 0, 2 0, and 3 0. But this 0 right here, because the function powers off the x-axis, so this guy multiplicity of 2. Alright, so we look at this one right here. We see that the leading coefficient is negative. We cross this one out. Right? Now, this guy right here. We look at question D right here. We see that. We look at the answer D right here. We see that the power right here, power 1, and power 1 right here. So it be odd power. So this is wrong. Right? We need even power. So we only have this one, and we just check the 0, right? So the 0 right here, -4, right? So in order to write the polynomial, it should be as minus the 0, so which means minus -4, right? And right at this 0 right here, we have multiplicity of 2, so this one must be squared, right? So negative turns out to be positive. The answer should be B. Now look at this one right here. The graph of the polynomial function p is shown right here. Which of the following could be the expression for p, right? So we look at this one. This guy and this guy have the opposite end behavior, which means the function is odd, right? And because the left-hand side right here pointing up, the right-hand side pointing down, the leading coefficient is negative, right? Keep that in mind. So we look at this one, we see that leading coefficient is positive. Leading coefficient is positive, so this form, right? And we have 3 0 right here. 1, 2, 3. All right, so the degree must be 3, right? And we look at this one, degree is 4, right? This is 2, this is 1, this is 1, so degree 4, this is wrong. So the answer must be C. And we check this. The 0 right here, -3, so which means as minus -3 times the second 0 right here as minus 0, right? And the third 0 right here as minus 2. And if we simplify, it's going to be right here. Alright, let's move on to question number 6 right here. Alright, we look at this one. This guy and this guy have the same end behavior, right? So the function is even. And then because they're both pointing up, which means the leading coefficient is positive, right? If they're pointing down, the leading coefficient is negative, right? So we look at this one right here. We see that the function has 2 real 0 right here. And they both bounce off the x-axis, right? So we have s minus -2, right? And they both bounce off the x-axis, so this guy must have the multiplicity of 2. So this guy multiplicity of 2, and then this guy as -3 power of 2, right? And we know that the final answer must be even degree. And then, of course, the function has the imaginary root, right? So we look at this one right here. Leading coefficient is positive. We need to cross out this one. It should be even degree, right? So this one right here, right? At least we have 4 right here. So we cross out A, right? Now we look at B and D right here. So you need to be careful because the function has imaginary roots right here. So the answer must be D. Now question number 7. We need to find x where the function g of x greater than 0, right? So the function greater than 0, which means it's above the x-axis, right? So it's going to be this guy right here. All right, so we put negative infinity right here, positive infinity, and negative infinity right here. So which means we need to find the domain of this one. So it could be negative infinity 2, 3, right? But because we don't have the equal sign, which means you don't include the 0, so we have the 0 right here as -2. We need to exclude this one, so it's going to be -2, -2, union -2, 2, 3, right? So you need to be careful. Now question 7b, g of s less than or equal to 0, which means the guy below the axis right here. All right, so it's going to be from 3 to infinity, right? Now, because we have the equal sign, which means we're going to include the 0, so the 0 is 3, so we have the bracket right here. And we look at this one, we need to include the 0 right here too, so this guy union -2. Now look at question 8 right here. All right, question 8, I'm going to leave it for you to practice. All right, question 9. We need to solve the inequality right here. So the first step you need to do is to find the 0 of this one. So s plus 4 equal to 0. And then s equal to -4. Now s minus 3 equal to 0. And then s equal to 3. The last one s plus 1 equal to 0. And then s equal to -1. Now you need to draw the number line. And then you need to place all the 0 on the number line. So I have -4, -1, and 3. The 0 must be in increasing order, so keep that in mind. The left hand side right here, you put negative infinitive. The right hand side, you put positive infinitive. Now, you're gonna pick a number within any interval, and then you check to see if within that interval is positive or negative, right? So I look at this one right here, from -1 to 3, I'm gonna pick a 0, right? So I substitute over here. So I have 0 plus 4, 0 minus 3, 0 plus 1, right? So I have 4 times -3 times 1, right? And I look at this one, it's going to be -12, and it actually is negative, right? So within this interval right here, I have negative, right? So I put a line right here, put a line right here, right? Now, if you see the multiplicity of each linear factor right here as an odd number, and then you keep changing the sign, right? This is negative, this guy positive, this guy negative, this guy negative, this guy positive. All right, so finally we're gonna look at this one right here. We need this guy to be greater than or equal to 0, right? So we only pick the positive one right here. Okay, so the answer must be -4 to -1, right? And we have the equal sign right here, which means we need to include it with the bracket union 3 to infinity. Right at negative infinity or positive infinity, you cannot put a bracket, you must put parentheses. So keep that in mind. Alright, so if you see the leading coefficient right here, negative number, multiply both sides by -1, right? So I have 3 times s plus 2 times s minus 1 times s minus 5 greater than 0. You need to flip the inequality symbol, right? So then you need to find the 0 of each of these linear factors right here. So I have 0 of this one is going to be -2, this guy 1, and this guy 5, right? So I place this guy on the number line, right? Now I need to pick a 0 within this interval, right? So I substitute over here. I have 3 times 2 times -1 times -5, which is positive, right? So this guy must be positive. And then I look at this one, I see that they all have multiplicity of odd number, right? So I keep changing the sign like this. Alright, so I look at the second inequality right here. Don't look at the first one. Look at the second. I need this one to be greater than or equal to 0, right? So the answer must be this interval and this interval right here. So because I don't have equal signs, so I don't need to include the endpoints, right? So it's going to be -2 to 1 union 5 to infinity. Alright. Now look at number 13. So we need to find the 0 of this one. So it could be s equal to 0 with multiplicity of 2, right here. And then s equal to -7 for this one. And then s equal to 4, right? So I draw the number line. So I need to place -7, 0, and 4 over here, right? I put a line right here. the left hand side I put negative infinitive, the right hand side I put positive infinitive, right? So I look at this one right here. I need to pick a number. I pick number 1 right here. I substitute 1 into this inequality. So I have negative 3 times 1 times 8 times negative 3, right? So it's going to be positive, right? So this guy positive. I put this positive, right? Now 4, you look at 4 right here. This is multiplicity of 1, right? So I keep changing the sign. Now 0 right here, multiplicity of 2, and then the sign doesn't change. This guy positive, this guy must be positive, right? Keep that in mind. When the graph passing the 0 with multiplicity even, right, the sign does not change. Keep that in mind. And then this guy right here, negative 7, this multiplicity of 1, so this guy change, right, negative. Now I need this guy to be greater than or equal to 0, so which means my answer right here, right? So it's gonna be negative 7, comma 4, right? And then I have the equal sign right here, so I need to include the endpoint. All right, now the last one right here, I need to find the 0 of this one. So the 0 of this one is going to be s equal to 0, multiplicity of 3, so I don't care, right? Keep in mind, I only care about the multiplicity of even power, right? This guy, s equals negative 8, multiplicity of 2, right? And s equals 5, multiplicity of 1, s equals 1, multiplicity of 2, right? So I draw a number line. I place all these number on the number line. So it could be negative 8 go first, and then 0, next one, 1, right? And then the last one should be 5, right? So I draw the line right here. Put positive infinitive right here, negative infinitive right here. So now I'm going to pick a number 2 within this interval, and then I'm going to substitute over here. So I have 4 times s cubed, which means 4 times 2 power of 3 times 10 power of 2 times 2 minus 5 is going to be negative 3 times 2 minus 1 is going to be 1, so 1 square. So this guy positive, 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 this is negative, right? So this guy must be negative, right? So the answer is negative. So this is negative. Now, you need to be careful. Look at 5 right here. Okay, so this is the 0, right? S equal to 5. This guy multiplicity of 1, right? So I keep changing the sign. S equal to 1, multiplicity of 2, so the sign doesn't change, so it could be negative right here. S equal to 0, right here, multiplicity of 3, so because this is odd multiplicity, right? So this guy right here keep changing the sign, right? Because multiplicity of 3. Now negative 8, which means the 0 of this one right here, multiplicity of 2, so this guy doesn't change the sign, so this guy positive, right? Now I need to conclude. I need this one to be less than or equal to 0, so the answer must be this right here, right? So it's going to be 0 to 5. Now I need to include the endpoint, so it could be 0 to 5 right here. And then right here, you see this guy multiplicity of 2 right here, right? S equal to negative 8 right here. This guy make the inequality equal to 0 right here. So this is going to be union to negative 8. All right, let's move on to the next one. Number 15 right here, we need to find all real zero and indicate the multiplicity of each zeros, right? So the first one, 0 is 3, right? Because we let s minus 3 equal to 0, s equal to 3, with multiplicity of 4, right? The second 0 is going to be negative 2, multiplicity of 1, right? Because it's the power of 1. This guy same thing, power 1, so this is going to be 1, multiplicity of 1, right? This guy right here, the 0 right here, s right here equal to 0, so the 0 should be 0, multiplicity of 1. The second one, negative 3, multiplicity of 1, right? This was 1. And the third one is going to be 2, multiplicity of 3, right? Okay, so this one right here, I'm going to leave it for you as a practice, right? So look at number 19 right here. Now this one, you need to factor this one out, right? So s squared minus 9, you're going to use the formula a squared minus b squared equals a minus b times a plus b, right? So this one is going to be s minus 3 times s plus 3, right? And then this one right here, I use complete square formula. So it can be a squared plus 2ab plus b squared is going to be a plus b all together square. Or you can factor trinomials and you still get the same thing. So it's going to be s plus 3 all together square, right? So I'm going to combine. So s minus 3, right? And this guy s plus 3 times s plus 3 square is going to be s plus 3 cubed, right? So the 0 right here, the first 0 is going to be right here, s minus 3 equal to 0, so s equal to 3 with the multiplicity of 1, right? This is 1. And then the second one, s equal to negative 3 right here with the multiplicity of 3, right? Alright, the next one, number 20 right here. I need to use the difference of 2 square to factor this one. So it can be equal to negative 2s times s plus 2 times s minus 2, right? And this one right here, it turns out to be complete square. So if I have a square minus 2ab plus b square, it's going to be a minus b altogether square, right? So this guy turns out to be s minus 2 altogether square. Now this right here, I use the s method to factor this one. So I put c right here, it's going to be negative 8. And I put b right here, it's going to be negative 2. I need to find two integers that multiply equals negative 8 add up to negative 2, which is negative 4 and 2. So this guy turns out to be s minus 4 times s plus 2, right? So then I'm combine. I have negative 2s right here. Now s plus 2 right here, it turns out to be s plus 2 square, right? S minus 2 right here, I combine this s minus 2 cube, right? And the last one should be s minus 4, right? So we have the first 0. Let's s equal to 0 right here, this guy right here. So s equal to 0, and this is multiplicity of 1. Second one, s equal negative 2, multiplicity of 2. Next, s equal to 2. This guy right here, multiplicity of 3. Next, s equal to 4. Multiplicity of 1, right? Let's move on to number 21 right here. So I just factor this one out. So it's going to be s times s squared minus 3s minus 10. And then times s squared plus 7s plus 10, right? So the first one right here, I use s method right here. So I put negative 10 right here, negative 3 right here, right? I need to find two integers multiply equal negative 10 add up to negative 3, which is negative 5 and 2. So this one can be written as s times s minus 5 times s plus 2, right? Now the second one right here, I need to find two integers multiply equal to 10 add up to 7, right? So it could be 5 and 2, right? So it could be s plus 5 times s plus 2, right? So I can rewrite this one as s plus 2, is going to be s plus 2 square, right? And then s minus 5 times s plus 5, right? So I need to find the 0, right? So the first one is going to be s equal to 0, this one right here, multiplicity of 1. S equal to negative 2 for the second one right here, multiplicity of 2. Next, s equal to 5, multiplicity of 1, right? And the last one, s equal to negative 5, multiplicity of 1, right? This is power 1. Now, let's move on to number 22 right here. We're going to factor this one out, so it could be s times s squared plus s minus 12, and this one factor s squared out, so it could be s squared times s squared minus 9, right? So you need to factor this one using s method, like what I did right here. It turns out to be s times s plus 4 times s minus 3, and this one right here, s squared and s right here, I combine, it's going to be s cubed, and this guy turns out to be s minus 3 times s plus 3, right? Okay, so you need to find the 0. So the first one, s equal to 0, multiplicity of 3. The second one, you're going to combine this guy and this guy right here, so it can be square, so I don't need to write this one. So it can be s equal to negative 4, multiplicity of 1. S equal to 3, multiplicity of 2. And the last one, s equal to negative 3 multiplicity of 1, right? This is power 1, this is power 1. Okay, so the last 23 and 24, I leave it for you to practice. Now let's move on to question number 25. So, given limit of the function f of x when s approaches negative infinity equals negative infinity, and limit of the function f of x when s approaches positive infinity equals negative infinity. So, the polynomial function f has n behavior above. So, which one could be, right? So, we look at this one, we see that limit of the function f of x when s approaches negative infinity equals negative infinity. So we need to sketch the rough draft right here. Alright, so we see that this one is y, this one is s. We need to put positive infinity right here. This guy negative infinity. This guy negative infinity, and this guy positive infinity, right? So we see that when s approaches negative infinity, which means s going this way, the function approaches negative infinity, the function going down. So which means the graph should be something like this, right? Now, when s approaches positive infinity, the function approaches negative infinity, right? Like this. So the end behavior should be something like this. So this guy, this guy, and this guy have the same end behavior, right? So which means we know that this is even degree, right? And then we see that they both pointing down, which means the leading coefficient is negative, right? Negative. So we look at this one, even power. So we need to cross out B and D. And leading coefficient is negative, so we're going to pick C. The answer A is wrong, right? Now, number 26, we do exactly the same thing, right? So we sketch this one. So this is S, this is Y. So we're going to put positive infinitive, negative infinitive, positive infinitive, negative infinitive, right? So limit of the function g of s when s approaches negative infinitive is positive infinitive, right? So s approaches negative infinitive, right? The function approaches positive infinitive, this could be like this. Alright, so the end behavior should be something like this, right? Now, when s approaches positive infinitive, this way, the function approaches negative infinitive like this. So the other end behavior should be like this, right? So we see that they have opposite end behavior, which means it should be odd degree, right? Okay, and then because the function pointing up to the left, which means the leading coefficient is negative. Alright, so we look at this one right here, odd degree. We need to cross out this guy and this guy. Leading coefficient is negative. We need to pick D. Now, number 27. We need to sketch the graph, right? So this is S, this is Y. And then we need to put positive infinity right here. Positive infinity, negative infinity, negative infinity, right? Now, when s approaches negative infinity, s going this way, the function approaches this way, right? So we have end behavior should be like this. And s approaches positive infinity, the function approaches positive infinity. So the other end behavior should be like this. So they have opposite end behavior, which means this is odd degree, right? And then because the left hand side right here pointing down, which means the leading coefficient is positive, right? So based on this information, leading coefficient is positive. So we need to eliminate C and A, right? Because we have negative 2 and negative 2 right here. Now we check the power. This is 5, this is 2, and this is 1. Add up to 8, so this is wrong, right? And the last one right here, 5, 2, and 2 right here, it's going to be 9. And leading coefficient is positive 2, so the answer must be D. Alright, the last one, we have let's case of s equal this one, and which of the following pairs of statement both about the end behavior of k is correct, right? So we look at this one right here, the highest degree right here. So we see that the highest degree is gonna be 4, right? So this is even. And then the leading coefficient is negative, right? So we know that the degree is even, so they both pointing up or pointing down, like this. Okay, and then because the leading coefficient is negative, right? Leading coefficient is negative, so we're gonna pick this one right here. So which means when s approaches negative infinity, the function approaches negative infinity. When s approaches positive infinity, the function approaches negative infinity, right? So s approaches negative infinity, function approaches negative infinity. So the answer is A. Now let's move on to number 29. Given the table right here, which of the following claim and explanation statement best fits the data, right? So question A, f is best modeled by a linear function because the rate of change over consecutive equal length input value intervals is a constant. We're gonna check this one right here. We see that this one adds 2 each time, right? And the right hand side right here, negative, in order to get negative 1 from negative 2, we're gonna add 1, right? And this one we're gonna add 4, right? So this is not linear, right? Because 1 divided by 2 is gonna be 1/2. 4 divided by 2 is gonna be 2. The average rate of change is different. It's not a constant, so this is wrong. Now, question B. F is best model of a linear function because the rate of change over consecutive equal length input values interval is a linear, right? This one at 7, right? So 7 divided by 2, it could be 7 over 2. If question A is wrong, question B must be wrong, right? Because the function is best modeled by a linear function, the rate of change over consecutive equal length input value intervals must be constant, right? So this is not a linear, so this is wrong. Now question C, f is best modeled by a quadratic function because the rate of change over consecutive equal length input value interval is a constant. No, this is not right, right? It must be linear, right? Yes, this is right. So we're going to check this one right here. We see that 4 over 2 is going to be 4 over 2, right? This is 7 over 2 and this is 10 over 2, right? Now we need to find the chain of this one, right? So this one right here, in order to get 4 over 2 from 1/2 over from 1/2, I'm gonna add 3.5, right? This one I add 3.5. This one I'm gonna add 3.5, right? So this one tells us the answer must be D. We look at this one right here, we see that every single times we're gonna add 10, right? Okay, the right hand side right here, this guy decreasing by 40, this guy decreasing by 20, this guy decreasing by 10, and this guy decreasing by 5, right? So I need to find the rate of change. So this one, the rate of change is negative 40 divided by 10. This guy, negative 20 divided by 10. This guy, negative 10 divided by 10. And this guy, negative 5 divided by 10. And I simplify this one, it's going to be negative 4, negative 2, negative 1, and negative 1/2. And you see that average rate of change is increasing, right? Negative 4 to negative 2 to negative 1 and negative 1/2, which is increasing. So because the average rate of change is increasing, the function could be concave up, right? So the answer must be B. Now let's move on to the next question. The graph of the function f is shown above. Which of the following statement about the function f is correct? So the function f is positive and increasing. No, this is not positive. It's only positive in this interval only, right? So this is wrong. The rate of change of the function f is positive and increasing. Yes, you can draw the tangent line. You see that the Christmas tree say if the tangent line is going this way, the slope is positive. And if the slope is positive, the rate of change is positive, right? And if the rate of change is positive, the function is increasing, right? So this is true. Now the function is increasing, so the answer must be B. Okay, question number 32. The graph of function g is, which of the following statement is true about the function g? Question A. The function g is an even function. Yes, because they have the same end behavior. And the rate of change of g is increasing. Now we need to draw the tangent line right here. The first tangent line, the second tangent line, and the third tangent line right here. You see that if the tangent line is going this way, the slope is positive, right? This guy 0, this guy is negative, right? So from left to right, the rate of change of the function g is decreasing, right? So this is wrong. Question B. Yes, that's right. The rate of change is decreasing. The function is even. Now question 33, the function h is increasing. We draw a tangent line. Yes, this is, the slope is positive, the function is increasing. Yes, and the rate of change of h is increasing. We just draw another tangent line. We see that, another tangent line right here. And you see that the tangent line getting less steep, which means the slope is smaller. Rate of change of the function h is decreasing. So the answer A is not right. The answer must be B right here. Decreasing. The function is increasing. Now question 34 right here. The function k is increasing. We draw the tangent line right here. And you see that the function, the line is going this way, the slope is negative, which means the function is decreasing. So we need to eliminate A, B, right? Now we draw another tangent line right here. We see that the tangent line getting less steep, and then this going this way right here, right? The tangent line is steeper, the slope is smaller, right? So which means the slope of this guy right here is less than this guy right here, which means the function has an increasing rate. So the answer must be C. Now let's move on to the next one. So we are at the home screen. We need to add graph right here, and we input the function. It's going to be negative plus 33.1. Okay, so you hit enter. Right, so it's going to be like this. Now we need to restrict the domain from -3 to 3. Right, so we need to hit menu, window, zoom right here. And then we're going to go to window setting. Right here, as min we put -3, and as mask we put 3, right? And y means y mask we just leave it. So we hit enter. So it's going to be like this. The function f has a relative minimum. So we have two relative minimum. The first one is going to be right here, and the second one is going to be right here, right? So relative minimum right here. We just hit menu, analyze graph, and minimum right here. Okay, we move the line to the left of minimum, hit enter. Move the line to the right of minimum, hit enter. So it could be -0.718. So it could be -0.718. So keep that in mind. The question asks you to find the relative minimum as the value of s right here. And the right hand side right here, we know that this is the lowest point right here. It's going to be at 3 right here. So, okay. Now, relative maximum, we do exactly the same thing. We hit menu, analyze graph, maximum, move the line to the left up, maximum, move the line to the right. So it could be 1.99 right here. So it could be 1.99. And the left one right here is going to be at s equal to -3, right? So -3 right here. On what intervals is the function is increasing, right? The function is increasing from the interval -0.718 to 1.99, right? This one right here, the middle one right here, because the tangent line has the positive slope. So we have the interval -0.718 to 1.99, right? Now, on what intervals is the function f is decreasing, which means the other one right here. It's going to be -3 to this one, and it's going to be from 1.99 to 3, right? So it could be -3 to -0.718 union 1.99 to 3, right? Right here you can include the endpoint right here, -3, and the right hand side should be 3, right? Now question 2 and question 3, you're going to do exactly the same thing. All right, so I just leave it as your practice. Now let's move on to the last one right here. Number 1. Which of the following statement about the zero of the function f is correct, right? Now look at this one. We have 1, 0, right? We have two imaginary zero right here, s squared plus 4. S squared plus 4 equal to 0, right? So it's going to be s equal to s squared equal -4. So we have two imaginary 0, two non-real 0, right? So we look at this one right here. We see that two non-real 0. So we need to eliminate a and b, right? Now we look at this one right here. We have the 0 is going to be s equal to 0. This one right here, we have the 0 s equal to 3. This one, we have s equal to 1. So we have 3 distinct real 0 and 2 non-real 0. So the answer must be C. On to question 2. Given a function g of s, on what intervals is g of s greater than or equal to 0, right? So we need to factor this one out, right? So we have a times c equals 2 times -12 is going to be -24, and b equal to 5. Now we need to find two integers, multiply equals -24, add up to 5, it's going to be 8 and -3. Alright, so I have s plus 8 times s minus 3. Now I look at this one, I see that the leading coefficient is 2. So I need to divide this guy by 2, this guy by 2. I simplify 8 divided by 2, it's going to be 4. So I have s plus 4 times this one. I cannot divide 3 by 2. So I need to multiply this one. So it's going to be 2s minus 3. Now I need to find the zeros of this one. So the zeros should be -4 and 3.5, right? So I put this guy on the number line. It's going to be -4 here, 3.5 right here. The left hand side is negative infinitive, the right hand side is positive infinitive. I put the line right here. Alright, so I pick a number within this interval, so I pick 0. I substitute over here. Right, so I have 0 plus 4 is going to be 4. 0 minus 3 is going to be -3. 4 times -3 is going to be negative. So within this interval, it's going to be negative. So I look at this one, I don't have the even multiplicity of the linear factor right here. So I keep changing the size. So this guy should be positive, this guy should be positive. Now I look at this one right here. I need this guy to be greater than or equal to 0. So my answer should be this interval and this interval. So it's going to be negative infinity to -4. And then union 3.5 to infinitive. Right here I put the parentheses, but right here I put the bracket, because these guys right here are both 0 of the inequality right here, and this guy right here we need greater than or equal to 0, right? So the answer must be D. Now question 3. The polynomial function has the 0, 3, multiplicity of 2, -4, multiplicity of 3, this guy. What is the least possible degree of this one? Alright, so we need to start from here, right? The function h of s has the 0, s equal 3, right? S equal 3, and then we subtract 3 both sides. So we have the linear factor s minus 3 equal to 0. So s minus 3, right? Power of 2, because the multiplicity of 2. Now, next one, s minus 4 multiplicity of 3. So I have s equal to -4. Add 4 both sides. S plus 4 equal to 0. So I have s plus 4 right here. Multiplicity of 3, so I put 3 right here, power 3. Now I have the next one, s equal to I. This is imaginary number. So whenever you have imaginary root, its conjugate must be the second root. So keep that in mind. If you have a plus bi is a root, and its conjugate is a minus bi, must be the second root. So we have s minus 2i, right? And then the other one should be s plus 2i, right? And the last one right here, this is same thing, s minus 5 minus 3i, and s minus 5 plus 3i, right? So now we're going to check the degree, right? This is power 2, power 3, this is power 1, power 1, power 1, power 1. So it's going to be power 9. So the answer must be D. Question number 4. The graph of the function h is shown above. Which of the following statements about the function h is correct, right? So we look at the rate of change of h is positive, which are the tangent line right here, right? And we see that the tangent lines go in this way, which means the slope is negative, right? This guy's slope is positive. So because the slope is negative, the rate of change is negative, right? So we need to eliminate the answer A, right? Answer B, the rate of change is negative, which is right, and decreasing, we draw another tangent line. Right, we draw another tangent line right here. And if it's going this way, if the tangent line getting steeper, the slope is smaller, right? Which means it's decreasing, right? So the answer must be B. Now, question number 5. The function k is given. Which of the following statement about the zero and multiplicity of k is correct, right? So we just factor this one. It's going to be s minus 3 times s plus 3. This one already leading factor, so s plus 3 square. And this guy turned out to be s plus 3 square right here, right? So we just combine them. It's going to be s minus 3 times s plus 3. So we see that 1 plus 2 plus 2 is going to be 5, right? So we look at this one, the 0 must be s equal to 3, s equal to negative 3, multiplicity of 5. So the answer must be A. Now look at number 6. Given this table, which of the following statements pairs about the function g could be true? Okay, the function g is an odd function and the graph of the function g is concave up. So we need to find the average rate of change, right? So this one right here, we need to add 2, add 2, add 2, and add 2. The right hand side right here, we need to add 1, add 4, add 5, add 6, right? Okay, so we need to find the average rate of change of each interval, right? So the first one is going to be 1/2, the second one is going to be 4/2, the third one is going to be 5/2, and the last one is going to be 6/2, right? And we see that the average rate of change is increasing, right? So because the average rate of change is increasing, the function is concave up. So because the function is concave up, we need to eliminate A and C, right? Now next one. In order to know if the function is odd or even, we apply the formula f of negative s is negative f of s. This is odd. F of negative s is f of s. This is even, right? This guy right here. So I have g of negative 1 equals negative 3, right? Now, I have g of negative 1, which means negative s right here. Negative 1 is g of 1, right? But g of 1 equal to 3, right? And this one equals negative g of negative 1, right? So I just proved that g of 1 equals negative g of negative 1, right? Which is the formula right here. So the function is odd. The answer must be B. Now let's move on to the next question. Question number 7. Right, given the function is even, right? So if the function is even, you have f of negative s equals f of s, right? So which means s opposite, right? S opposite, and then the output must be the same, right? Same output, but opposite s value, right? So we look at this one right here. A, we look at A, right? Same output. Now look at this is 2, and then we need opposite s value right here, right? Same output, so A equal to 1, right? Now B right here, and then I see that the output is 5. I look at the output right here 5, right? So B right here must be opposite to negative 3, so which means B equal to 3, right? Now C right here, C, and I look at the input right here 6, and then input must be opposite, right? So 6 and negative 6 right here. So C must be equal to negative 4. So negative 4. So if you add them up, the answer must be 0. So the answer is C. All right. Look at number 8. the function, which of the following statement about the function g is correct? The function g is increasing at an increasing rate or something like that. Okay, so you just draw a tangent line right here and you use the Christmas tree trick, right? The tangent line is going this way, the slope is positive, the function is increasing. The tangent line is going this way, the slope is negative, the function is decreasing, right? So because the tangent line is going this way, which means the function is decreasing. So I eliminate A and B, all right? Now, I need to draw the second tangent line right here, and I compare the slope of this guy and this guy, all right? So because this guy right here has smaller slope of this guy, because this guy is steeper than this guy. So if this guy has a smaller slope of this guy, which means the slope is increasing, right? So the function is decreasing at an increasing rate. The answer must be C. I'm going to leave question 9, 12, 11, 12 for you to practice. Let's move on to question number 13. Let the function f be an odd function such that f of -4 equal to 5 is the location of local minimum. Which of the following statements must be true? All right. So because the function is odd, right, we have f of -s equals negative f of s. So which means the input opposite and the output is still opposites, right? Because they both symmetric about the origin, right? So we look at this one. This is -4. This turned out to be 4. This 5 turned out to be -5, right? So I have f of 4 equals -5, right? And this is local minimum. This guy becomes local maximum. So the answer must be B. Alright, so I'm going to leave question number 14, 15 for you to practice. Right, this is similar to the previous one. Now question number 16, we need to write the polynomial function of this one right here. So we need to find the 0 right here, the 0 right here, the 0 right here, right? And we see that this guy piles off the x-axis, so this guy right here has the multiplicity of 2, right? This guy has the multiplicity of 2, and this guy multiplicity of 1. So total must be degree 5, right? So I look at this one right here, I see that this is degree 1, degree 1. So this is wrong. Degree is 1, 1, 1. This is 3, so wrong. This is 2, 2, 1. So this could be right. This guy 2, 2, 1. This could be right, right? Now I look at the end behavior right here. This guy and this guy opposite end behavior, which means the leading coefficient is negative. So the answer must be C. We're going to review the topic 1.7 to 1.11 about the rational functions. Alright, directions. For each of the following rational functions, write the limit statements to describe the left and right end behaviors. Alright, so on the x and y coordinate, you always put the positive infinitive right here, negative infinitive right here, positive infinitive and negative infinitive. Alright, so left end behavior, which means limit of the function f of s when s approaches negative infinity, right? S approaches negative infinity, which means it goes to the left right here. The function approaches the horizontal asymptote, which is 1, right? So horizontal asymptote y equals 1, right? So this one equals 1. Right end behavior, limit of the function f of s when s approaches positive infinity. It's going to be 1, right? When s approaches positive infinity, the function approaches horizontal asymptote, which means 1, right? Now, number 2, limit of the function f of s when s approaches negative infinity equals 2, because the horizontal asymptote is 2. You see the dashed line here, right? This one is y equals 2, right? So this one is 2. Limit of the function f of s when s approaches positive infinity is still 2, right? Now let's move on to question 3. Given the function, we need to find the end behaviors. Alright, so look at the highest degree terms on the numerators and denominators, right? Which means this guy right here. Alright, limit of the function h of s when s approaches negative infinity equals 2 over 3, right? Because y equals 2 over 3 is the horizontal asymptote, right? When degree on the numerator and degree on the denominator are the same. And then you just cancel out this one. So the horizontal asymptote is 2/3, right? Now, limit of the function h of s when s approaches positive infinity is going to be 2/3, right? Similarly, number 4 right here, you look at this one right here. Degree on the numerator is 2, right? This is power 1, this is power 1. So total is going to be power 2, right? Degree on the denominator should be, this is power 2, right? And this is power 1, right? So total is going to be s power 3, right? Because the degree on the numerator is 1 less than the degree on the denominator. So then the function has the horizontal asymptote y equals 0. Right, so keep that in mind. So limit of the function k of s when s approaches infinity equals 0. Limit of the function k of s when s approaches negative infinity is still 0. Alright. Now look at number 5 right here. The highest degree on the numerator is s power 4, right? The highest degree on the denominator is going to be s power 2, right? So in order to find the end behavior of this one, you just ignore the rest one right here. Because this one is dominating the whole thing, right? So you have negative 2 s power 4 over 5 s power 2. And you just simplify, it's going to be negative 2 over 5 s squared, right? So limit of the function rs when s approaches positive infinity is negative infinity, right? Because positive infinity, you substitute over here, it's going to be positive infinity multiplied by negative 2/5 is still negative infinity, right? Now limit of the function rs when s approaches negative infinity. This guy becomes positive infinity, right? Multiplied by negative 2/5 is still negative infinity, right? Now let's move on to number 6. We need to rewrite the function m of s as 3. This is coefficient. You need to rewrite it, right? Now s minus 1 squared. This one dominate the whole thing, right? So it can be s squared. You need to take this one with s, right? Now s plus 5. When s approaches infinity, this one dominates, right? So it can be times s over this one right here. You have 2s right here, dominate 3, right? So you have 2s. Don't forget parentheses. Power up 2 right here. Alright. Now you simplify, it's going to be 3s squared times s over 4s squared, right? Now s squared and s squared right here cancel out. So it's going to be 3 over 4s, right? Now limit of the function ms when s approaches positive infinity, it's going to be positive infinity, right? Because positive infinity multiplied by 3, 4 is going to be positive infinity. Now limit of the function ms when s approaches negative infinity, it's going to be negative infinity, right? Now let's move on to number 7 and number 8. Write a limit statement describing the output values for the following graphs and verbal description of the input values. Alright, the input values decrease without power, which means it's go to negative infinity, right? So limit statement is going to be limit of the function f of s when s approaches negative infinity, right? So negative infinity should be right here, right? This one should be positive infinity. This one should be positive infinity, and this one should be negative infinity. So when s approaches negative infinity, the function going down like this, right? So it's going to be negative infinity, right? Now, for the number 8, the input values increase without bound, which means it's gonna go to positive infinity, right? S value go to positive infinity. So you have limit of the function g of s when s approaches positive infinity. Alright, so this is positive infinity. This one is positive infinitive, this one is negative infinitive, this one is negative infinitive, right? So we just focus on this guy only, right? S approaches positive infinitive, the function approaches horizontal asymptote, which is y equals 1, right? So it's gonna be 1, right? Now let's move on to number 9, 10, 11, 12, 13, 14, 15, and 16. The graphs of the function h and k are given below. Use the graphs to find the following limits. Now, number 9, limit of the function h of s when s approaches 2 minus, right? Now first you need to label positive infinitive, negative infinitive, and negative infinitive. When s approaches 2 minus, look at 2 right here. This is the vertical asymptote, which is s equals 2, right? 2 minus, which means on the left of the vertical asymptote. So on the left of the vertical asymptote, which means this guy right here, right? So the function approaches negative infinitive, right? So this one is negative infinitive. Now, number 10, limit of the function h of s when s approaches 2 plus, right? So 2 plus, which means on the right hand side of the vertical asymptote, which is this guy right here, right? So it's going to be positive infinitive right here. Number 11, limit of the function h of s when s approaches 3 minus, right? 3 minus, this could be right here, which is, we have the whole right here, right? Now 3 minus, which means on the left of the whole, right? So the function approaches 3, right? Because the y value is 3, right? It's going to be 3. Now limit of the function h of s when h approaches 3 plus, which is on the right of the whole, right? It's still 3, right? So it could be 3. Now number 13, you need to put positive infinitive, negative infinitive, and negative infinitive right here. Now limit of the function k of s when s approaches 5 minus, right? So 5 minus is going to be right here, the whole right here, right? So 5 minus is going to be on the left of the wholes, right? It's going to be negative 2 right here, right? Now, limit of the function k of s when s approaches 3 plus, right? 3, which means the vertical asymptote right here, right? This is s equals 3. 3 plus, which means on the right of the vertical asymptote, which is this guy right here. The function approaches positive infinitive, right? Now, limit of the function k of s when s approaches negative infinitive, right? Negative infinitive, which means s go to the left right here. The function go up, right? So it's still positive infinitive, right? Now, limit of the function k of s when s approaches positive infinitive, right? So s go to the right, right? The function is going down. It's going to be negative infinitive, right? Now let's move on to number 17, 18, and 19. For each of the following, write the left and right limit statements for f of s as s approaches 1, right? Now left and behavior is going to be limit of the function f of s when s approaches 1 minus, right? Since number 17 right here, we have the common factor on the numerator and denominator. So this one is the whole, right? I need to cancel out this one. So then I just substitute 1 for s into the remaining one right here. So I have 1 plus 5 is going to be 6. 1 plus 2 is going to be 3. So the answer must be 2, right? Now, limit of the function f of s when s approaches 1 plus. It's going to be 17. 6 over 3 is going to be 2. Alright, now keep in mind, limit of the function when s approaches 1 minus, it doesn't mean that s equals negative 1. So you need to get rid of that mistake. Alright, 1 minus, which means on the left of 1. Now number 18, limit of the function f of s when s approaches 1 minus. Now you just substitute 1 minus for s in this situation. Again, 1 minus, it doesn't mean that negative 1. So keep that in mind. So I substitute 1 over here. It's going to be 1 minus 2. It's going to be negative 1, right? Times 1 minus 4. It's going to be negative 3, right? The bottom right here. I substitute 1 minus over here. So 1 minus right here, subtract 1. 1 minus, which means a number less than 1, right? So when you subtract 1, it's going to be 0 minus, right? Times 1 plus 2 is going to be 3, right? Now, the top should be 3, the bottom should be 0 minus, because 0 minus times 3, it could be 0 minus, right? 3 divided by 0 minus, it could be negative infinity. So keep that in mind. Now, right, it could be limit of the function f of s when s approaches 1 plus. It's going to be 1 minus 2 times 1 minus 4 over 1 plus subtract 1 is going to be 0 plus times 1 plus 2. Alright, so the top should be negative 1 times negative 3 is going to be 3. The bottom should be 0 plus, so the answer must be positive infinity, right? Now, number 19 right here, limit of the function f of s when s approaches 1 minus, it's going to be negative 2 times 1 plus 3 times 1 plus 1. Now the bottom right here, 1 minus subtract 1, it's going to be 0 minus, right? The top should be negative 2 times 4 times 2. It's going to be negative 16, right? Now the bottom right here, when you square 0 minus, it's still 0, right? It's positive 0. So the answer right here must be negative infinity, right? Now, limit of the function f of s when s approaches 1 plus, it's going to be negative 2 times 1 plus 3 is going to be 4. 1 plus 1 is going to be 2 over 1 plus subtract 1 is going to be 0 plus square, right? So the top should be negative 16, right? The bottom right here should be 0 plus, right? So the answer must be negative infinity, right? Now, let's take a look at the number 20, 21, and 22. For each of the following rational functions, determine and label any values of s where the graph has a hole or vertical asymptote, right? Now, keep in mind, the vertical asymptote is when denominator equals 0, right? The hole is when the numerator and denominator have the same common factor, right? Now, first we need to find a hole. S minus 2 and S minus 2 cancel out. This is a common factor. So the hole should be S minus 2 equals 0, right? So then S equals 2, right? Now, S plus 3 and S plus 3 right here cancel out. And again, this is not a hole. Keep in mind, the vertical asymptote dominates the hole. The hole dominates 0. Now, I need to cancel out s plus 3 and s plus 3 right here. So the final answer must be 1 over s plus 3. Alright, so the vertical asymptote is s plus 3 equals 0. And then s equals negative 3. S equals negative 3 is the vertical asymptote. It's not a hole, right? Keep in mind, vertical asymptote dominates the hole. Alright, if this guy and this guy occur at the same time, the vertical asymptote dominates, right? Now, number 21, you need to simplify this one. So I have s plus 7 over s plus 1, right? Now this guy cancel out this one, right? So I have s plus 2 left on the top, right? Now, the whole is s plus 2 equals 0. So then s equals negative 2, right? Because you just cancel out the numerator and denominator with the common factor, right? After you cancel out the common factor right here, you still have one factor on the numerator. So this one will be a 0, right? And you know that the whole dominates the 0, right? So this one is not the 0, right? Now, the vertical asymptote, you just let denominator equals 0. So you have s plus 1 equals 0. So s equals negative 1, right? Alright, number 22. You need to factor s squared out first, right? So I have s squared times s minus 1, right? Denominator, this is a complete square, right? It's going to be s plus 1 altogether square. Look at the numerator and denominator. You don't see any common factor, right? So there is no hole for in this situation, right? Now the vertical asymptote, just let denominator equals 0, right? So s plus 1 equals 0, and then s equals negative 1, right? Now let's move on to number 23, 24, 25, and 26. We need to solve the inequalities, alright, and write the answer in interval notation. Alright, now to solve the rational inequalities, you need to find the zero of the numerator and denominator, right? So first, I have s minus 3 equals 0, and then I have s equals 3, right? Second, s plus 2 equals 0, and then s equals negative 2, right? Now, I need to put this guy on the number line, alright? Negative 2 less than 3, so I put negative 2 right here and 3 here. Alright, right at these two guys right here, I have the 0, right? So I put 0 here, right? Because these two guys right here are 0 of this factor, right? Now, you need to pick a number within any interval, right? So within interval negative 2 and 3, I pick a 0, right? I substitute 0 for s into original 1 right here. So I'm gonna test, right? So I have 0 minus 3 over 0 plus 2. Now 0 minus 3 is going to be negative 3, right? So 0 plus 2 is going to be 2. This guy actually negative, right? So negative, I put negative side right here. I need to check each of these factors right here to see if there is any even multiplicity, right? So I don't see any even multiplicity, right? Because this one right here, power up 1. This guy right here, power up 1, right? Right, so I keep changing the sign, right? This is negative, this guy must be positive. This guy negative, this guy must be positive, right? Now, I need to write the solution. I need this guy to be less than or equals 0, right? So, my solution should be from here to here, right? And since this one has the equal sign, I need to include the 0 of the numerator, right? Don't include the 0 of the denominator, so keep that in mind. So my solution should be from negative 2 to 3 right here, right? So I put negative 2, comma 3. Now, negative 2 is the 0 of denominator, so this guy must be parenthesis, right? 3 is the 0 of the numerator, so this guy must be bracket. Now, let's move on number 24. The 0 of s minus 1 square is going to be s minus 1 equals 0. So it's going to be s equals 1, right? Now s plus 2 equals 0. Then s equals negative 2, right? Now s plus 1 equals 0. Then s equals negative 1, right? Now I need to put all of this guy on the number line, right? So I need to place negative 2 first. Next one, negative 1, right? And the last one should be 1, right? On the right hand side right here, I put positive infinitive. The left hand side right here, I put negative infinitive, right? Now I need to put 0 for the numerator. So the numerator, I have the 0 right here. S equals 1 right here, right? So right here, I put 0. Now, s plus 2 is going to be negative 2 right here. This one's still 0. On the denominator right here, s minus 1, so I put a line right here. Because s equals negative 1 make the whole thing undefined, right? Now I need to pick a values within any interval, right? So I pick 0 right here in this interval right here. I substitute 0 for s into this inequality right here. I need to check to see if it's positive or negative, right? So it's going to be 0 minus 1 is going to be negative 1. Negative 1 squared is going to be 1, right? Times 0 plus 2 is going to be 2, so times 2 over 0 plus 1 is going to be 1, right? So this guy is positive, right? Now, this interval is positive. Now, you need to be careful with the 0 right here, s equal 1 right here. So s equal 1 is going to be this guy right here. Alright, because s equal 1 right here is the 0 of this one, but this one has the even multiplicity. So, right at this one, you don't change the sign, you keep the sign. Now, this is the plus side right here, this one is still the same, plus side, don't change it, right? Now, this 0 right here has the odd multiplicity, right? Negative 1 right here, which means on the bottom right here, you keep changing the sign, right? So this is positive, this guy must be negative, right? S equal negative 2 right here is the 0 of this one right here, right? It's still odd multiplicity, right? So keep changing the sign. Alright, now, finally, you look at this one right here. You need this guy to be greater than 0, right? So your solution should be this interval right here and this interval right here, right? So I need to write the solution in the interval notation. So it could be negative infinity to negative 2, right? So negative infinity, right at this negative infinity, you need to put parenthesis, no bracket, okay? Comma, negative 2. Now, look at this one, I don't see equal sign, so this one must be parenthesis, alright? Union. Now, right here, you need to be careful. You're not going to include the 0 right here, 1. Why? Because you don't have the equal sign, right? So you need to exclude this one, right? So you need to write the interval from negative 1 to 1. Union, the interval from 1 to infinity. Alright, so keep that in mind. Now let's move on to number 25. You need to factor the numerator, right? So the numerator I have a equals 1, b equals negative 1, c equals negative 12. So I need to use S method. Now you need to find two integers that multiply equals negative 12, add up to negative 1 right here. So it's going to be negative 4 and 3, right? So the numerator can be factor as minus 4 times s plus 3 over s squared greater than or equals 0, right? Now you need to find the 0 of each of these factors, right? So I have s minus 4 equals 0, s equals 4, right? S plus 3 equals 0, s equals negative 3, right? Now s squared equals 0, s equals 0, right? This one is multiplicity of 2, right? So be careful on this 2 right here. Alright, so you need to place all this one on the number line, right? The left hand side is negative infinity, the right hand side is positive infinity, right? So it could be negative 3 go first, 0 next, and next one is going to be 4, right? Alright. The 0 on the numerator is going to be 4 and negative 3, right? So it could be right here. The 0 on the denominator is going to be 0, right? So on the denominator, I'm going to put a line because this makes the whole thing undefined, right? Now I need to pick a number within any interval right here. So I'm going to pick number 1 right here, right? I substitute into this expression right here to see if it's positive or negative, right? 1 minus 4 is going to be negative 3, right? 1 plus 3 is going to be 4. Negative 3 times 4 is going to be negative 12, right? 1 square is going to be 1. So this guy should be negative, right? So this guy should be negative side right here, right? Now I keep changing the side. If I don't see the 0 with the multiplicity of 2, right? Now write as 0 right here. It's going to be right here, multiplicity of 2. So I don't change the sign, I keep the sign. So this negative, this still negative, right? Negative 3 right here. This is multiplicity of 1, right? So I just change the sign, positive. Right at 4 right here, multiplicity of 1, right? I just change the sign, negative, and then this guy positive, right? Now finally, I need the whole thing greater than or equals 0, right? Which means this guy all the way to the left, right? This guy all the way to the right, right? So I need to write the final answer should be negative infinity, comma, negative 3, right? Because I have the equal sign right here, and negative 3 is the 0 of the numerator, so I need to include the bracket, right? Union, same thing. I need to include 4, right? Because 4 is the 0 on the numerator, right? Comma, positive infinity, right? Now let's move on to number 26. I need to find the 0 of each of this one, right? So I have negative 2s equals 0, and then s equals 0, right? Next one, s minus 3 square equals 0, and then you need s minus 3 equals 0, and then you have s equals 3, right? This one multiplicity of 2, right? So be careful. Now next one, you have s plus 2 equals 0, and then s equals negative 2. This is multiplicity of 1, right? Now the last one, s minus 4 square equals 0, and then s equals 4, right? This one multiplicity of 2, right? Alright, now I need to put all of this guy on the number line. On the left hand side, negative infinity. The right hand side is positive infinity. Now, the first 0 is going to be this guy. The second 0 is going to be this guy. The third one is going to be this guy. And the last one is going to be this guy, right? So I'm going to start from negative 2 first. The next one should be 0. The next one should be 3. And the last one should be 4, right? Now, which one is the 0 of the numerator? It could be 0 right here, right? So I put 0 right here. S equal 3 is the 0 of the numerator, so it could be right here, right? This one right here, I put a line because it makes the whole thing undefined, right? Alright, now I'm going to pick a number within any interval and I'm going to test for the sign of the inequality, right? Now I'm going to pick 1 within interval 0, 3 right here, substitute over here. So I have 1 times negative 2, it could be negative 2. 1 minus 3, it could be negative 2 squared, it could be 4. 1 plus 2, it could be 3. 1 minus 4, it could be negative 3 squared, it could be 9. So the whole thing right here should be negative, right? Because negative times 4, positive times 9 right here. So this will be negative, right? So within this interval, I put the negative sign, right? Now I need to check for the even multiplicity, right? Right at 3 right here. This is the even multiplicity right here. Do you see that? Alright. So right here, I don't change the sign. I need to put the negative sign, right? Now I check 4 right here. 4 is still even multiplicity right here. 2. So it's still negative, right? Now I check 0 right here. This is odd multiplicity, right? I need to change the sign, positive. Now I check negative 2 right here. It's odd multiplicity, right? So I need to change the sign, right? Now finally, I need the whole thing to be less than 0, right? So I pick the one with negative sign, right? So it's going to be right here. And it's going to be right here, right? Now be careful, you're not going to include the 0, right? Because you don't have the equal sign right here, right? So they are parentheses, so keep that in mind. Now it's going to be negative infinity 2, negative 2, parentheses, union, 0, 2, 3, right? Union, 3, 2, 4, union, 4, 2, positive, infinity. We're going to review the topic 1.7 to 1.11, rational functions. Alright, determine if the following rational functions have a horizontal asymptote, slant asymptote, or neither. Alright, now we need to review a little bit about the horizontal asymptote. Now, if the degree on the numerator is less than the degree on the denominator, we have the horizontal asymptote y equals 0. Now, if the degree on the numerator is equals the degree on the denominator, we have the horizontal asymptote, which is the quotient of the leading coefficient of the leading term in the numerator over the leading coefficient of the leading terms on the denominator. Now, if the degree on the numerator is 1 unit greater than the degree on the denominator, we have the slant asymptote. Now look at example number 1. We see that the degree on the numerator is 2, degree on the denominator is 3. So 2 less than 3, we have the horizontal asymptote y equals 0, right? Second one, this one is 2, this one is 2, so it's going to be equals, right? We're going to check the leading terms right here. Alright, coefficient is going to be 1 and 3, so the horizontal asymptote is 1/3. Now number 3, this guy is 1 unit greater than this guy, right? So we have slant asymptote, right? Now question 4, this guy is 2 units greater than this guy, so this one should be neither. Now number 5, this one has power of 1, this guy has power of 1, this guy has power of 1, this guy has power of 1. So total this guy power of 2, right? This guy power of 2, so they are equals, right? Now you're going to check the leading coefficient, right? Leading coefficient is 2 and 3. 2 times 3 equals 6 over, this one is 1, this one is 1. 1 times 1 equals 1, right? So the horizontal asymptote y equals 6. Now question 6, degree of this one is going to be 3, this one 2, so total is going to be 5, right? This one 2, this one 5, total is going to be 7, right? So degree on the numerator is 2 units less than degree on the denominator. So you have the horizontal asymptote y equals 0, right? Now number 7, degree on the numerator is 4, degree on the denominator is this one 1, this one 2, so total 3, this is 4. So the degree on the numerator is 1 unit greater than degree on the denominator. So you have the slant asymptote, right? Now number 8, degree on the numerator is this one is 2, this one is 2, so total 4. right? 2s power of 2 all together power of 2 is going to be s power of 4. Degree on the denominator is 2 and this one is 1, right? So it turns out to be 3, right? So the degree on the numerator is 1 unit greater than the degree on the denominator. So we have the slant asymptote, right? Now last one, degree on the numerator is s power of 0 right here, right? So it could be 0. Degree on the denominator is 1, right? So the degree on the numerator is 1 unit less than the degree on the denominator. So you have the horizontal asymptote y equals 0, right? Now, solve the following inequalities, write your answer in the interval notation. So first, you need to find the 0 on the numerator and denominator, right? So you have s minus 2 equals 0. So s equals 2, right? Now second one, s plus 3 equals 0. So s equals negative 3, right? Now you're gonna put this guy on the number line, right? So I have negative 3 go first, right? This one is 2, right? The right hand side you put positive infinity, the left hand side you put negative infinity, right? Right here you put 2 lines for me, right? Now you're gonna test the sign, right? So you're gonna pick a number within any interval, right? So I'm gonna pick 0 right here. I substitute into the inequality right here. Now I'm gonna check the sign, right? So 0 minus 2 is gonna be negative 2. 0 plus 3 is gonna be 3. So this guy actually negative, right? So I put negative side right here. Now I check to see if this guy has the even multiplicity. And then this guy doesn't have any even multiplicity. So I keep changing the sign, right? So the sign should be alternating, right? So this is negative, this guy must be positive. This is negative, this guy must be positive, right? Now what I need to do is to find the interval where this inequality less than or equal to 0, right? So my interval should be this guy right here, right? Negative right here, right? So s, I put s right here. So s must be greater than negative 3 less than 2. Now I need to check to see if I'm going to include the endpoints, right? So negative 3 right here is on the denominator, so I cannot include negative 3, right? Because if you include negative 3, it's going to be undefined, right? Now 2 is a 0 on the numerator. So s equal 2, I substitute over here, it makes the whole thing equals 0, right? And I have the equal sign right here. So I need to include 2, right? So my final answer must be negative 3, comma 2. Right here, I put a bracket, right? Now let's move on to number 11 right here. Alright, so I need to find the 0, right? So s plus 1 equals 0. So s equals negative 1, right? Now second one, s minus 3 equals 0. So s equals 3, right? Third one, s plus 5 equals 0. So s equals negative 5, right? Now be careful, s equals negative 1 right here has a multiplicity of 2, right? Alright, so now I'm gonna place this guy on the number line. I put 3 lines right here. Alright, now I'm gonna pick a number in this interval right here, 0, right? I'm gonna test for the sign, right? So 0 plus 1 is gonna be 1, right? 0 minus 3 is gonna be negative 3. 0 plus 5 is gonna be 5. So this guy is less than 0, right? So right here I put the negative side, right? Now I need to check the side right here. So I look for the 0 right here. This is 3. 3 has the multiplicity of 1, right? So the sign keeps changing, right? So this one positive. Now, the 0 right here, negative 1. Okay, negative 1 right here has multiplicity of 2, right? So if a 0 has an even multiplicity, the sign stays, right? So this is negative side, this is still negative side. It doesn't change. So keep that in mind. Alright, so next one, 0, negative 5 right here has a multiplicity of 1, right? So the sign keeps changing. Alright, now finally I need to find the interval where the inequality greater than 0, right? So I don't include the endpoint, right? So greater than 0 is going to be this guy right here and this guy right here, right? Because it's positive and it's positive, right? So I put s in the middle right here. So it should be greater than 3 less than infinity, and s right here should be greater than negative infinity less than negative 5, right? So I need to write this one in interval notation. So it should be negative infinity, comma, negative 5. Right? I need to put parentheses because I don't see any equal sign right here, right? Union 3 to positive infinity, right? Now let's move on to the number 12. Alright, so I need to find the 0, right? So I have negative 3s equals 0. and then s equals 0, right? Next one, s minus 7 equals 0, and then s equals 7, right? Now next one, s plus 2 equals 0, and then s equals negative 2, right? Right, this one we have the multiplicity of 2. So you need to be careful with this guy. So we're going to put this guy on the number line, right? Now, the left hand side always negative infinitive. The right hand side always positive infinitive. Alright, so we have 3 0. It's going to be 0, 7, and negative 2, right? So negative 2 go first. 0 right here, and 7 right here, right? Alright, so I put the line right here. Alright, so now I'm going to pick a number within any interval, and I'm going to test for the sign, right? So I'm going to pick 1 right here, right? Within 0 and 7. So I substitute over here, so I have negative 3 times 1 is going to be negative 3. 1 minus 7 is going to be negative 6, right? Over 1 plus 2 is going to be 3, right? So 3 squared. So this guy always positive, right? So we need to put positive side right here. Alright, now we're going to check for this one right here. 7. 7 has multiplicity of 1, right? So we need to change the sign, so it could be negative. Now 0 right here has a multiplicity of 1, right? So we need to keep changing the sign, right? Now s equal negative 2 right here has an even multiplicity right here, right? So you need to keep the sign, right? So this is negative, this guy must be negative. Alright, now finally we need to find the solution, right? So we need the inequality to be greater than or equals 0, right? So this one right here, greater than or equals 0, right? That's it, right? So I put s in the middle right here. Alright, so s must be from greater than 0, less than 7. Now I'm going to check to see if I'm going to include the endpoint, right? So I have the equal sign right here. So any 0 on the numerator must be included, right? So I have s equals 0 right here. So I need to put equal sign right here. S equals 7 right here is on the numerator right here, right? So I need to put the equal sign right here. So finally I have 0, 7. Now number 13, we need to factor this one out, right? So s squared plus 3s minus 28. We're going to use s method. Alright, now a equals 1, b equals 3, and c equals negative 28, right? So we're going to put negative 28 right here, which is c, right? We put b right here, which is 3. Now we need to find two integers multiply equals negative 28 add up to 3, which is 7 and negative 4, right? So the top becomes s minus 4 times s plus 7. Alright, the bottom, we need to factor s out. So we have s minus 9 inside, right? Less than 0. Now we need to find the zeros, right? So we have s minus 4 equals 0. S equals 4, right? Now s plus 7 equals 0. S equals negative 7. Now s right here equals 0, right? The last one, s minus 9 equals 0. So s equals 9, right? Now we need to put all 0 on the number line, right? Now I'm going to pick a number within this interval right here. I pick 1. Alright, I substitute over here. Then I'm going to test for the sign, right? Alright, so I have 1 minus 4 is going to be negative 3. 1 plus 7 is going to be 8. 1 outside. 1 minus 9 is going to be negative 8. So this guy positive, right? So I'm going to put the plus sign right here. Now I'm going to check to see if there is an even multiplicity. So there is none, right? So I keep changing the sign, right? So this is positive, this must be negative, positive. This is positive, this guy must be negative, and this is positive, right? Now finally, I need the whole thing right here less than 0, right? So I need to pick the negative one, right? This one and this one. So my solution must be between negative 7 and 0 and 4 to 9, right? So it could be negative 7, 0. Now I look at this one, I don't see the equal sign, so I don't include the endpoint, right? So I put parentheses for this guy and this guy. Union 4 to 9, right? Alright, next one. For each of the following rational function, identify and label any value of s where the function has a whole or vertical asymptote. Alright, now keep in mind, the vertical asymptote always dominates the whole. The whole dominates the 0. Alright, so keep that in mind. If the vertical asymptote and the whole occurs at the same time, the vertical asymptote dominates the wholes, right? So look at the number 14 right here. You see that s plus 4 and s plus 4, these guys are common factor on the numerator and denominator, so it should be cancelled out, right? So if you cancel out the common factor, this guy must be a whole, right? So a whole is s plus 4 equals 0, and then s equals negative 4, right? This is a whole. Now the vertical asymptote is anything remaining on the denominator, so you only have s minus 1 left right here. So s minus 1 equals 0, and then s equals 1. This one is the vertical asymptote, this one is the whole, so keep that in mind. Now number 15, you have s minus 3 and s minus 3, you cancel out, right? So you only have s plus 2 over s minus 3 times s minus 8, right? Now look at this one right here, you just cancel out s minus 3 and s minus 3, right? This guy actually the vertical asymptote, right? Then s equals 3, right? And previously you cancel out this one and you say s equals 3 is a whole, right? But look at this one, vertical asymptote dominate the whole, so this one is vertical asymptote, right? There is no whole in this situation, right? Now another vertical asymptote, s minus 8 equals 0, and then s equals 8. Now let's move on to question number 16 right here. This guy and this guy cancel out, right? So we only have s minus 7 left on the numerator times s plus 1 over 2s, right? Now in this situation, the wholes and the 0 occurs at the same time. The whole dominates the 0, right? So s equals 7 is not a 0, it must be a whole, right? So s minus 7 equals 0, and then s equals 7. This one is the whole. Now the vertical asymptote, you just let the denominator equal 0, right? So you have 2s equals 0, so s must be equal to 0, right? So this is the vertical asymptote. Now let's move on to number 17. We need to factor this one out, right? We're going to use s method for each of this one, right? So the first one, a equals 1, b equals negative 4, and c equals negative 12, right? So we need to find two number multiply equals c, which is negative 12, add up to negative 4, right? Which is b, right? Now it's going to be negative 6 and 2, right? So the top should be s minus 6 times s plus 2. Now the bottom, you still use the s method, right? Find two numbers that multiply equals 36 and add up to negative 12. It's gonna be negative 6 and negative 6, right? So the bottom should be s minus 6 times s minus 6, right? Alright, so we have s plus 2 over s minus 6, right? So you have s minus 6 equals 0, and then s equals 6. This one is the vertical asymptote. Now remember that you have a whole s equals 6. You have the vertical s equals 6. The vertical asymptote dominates the whole. So in this situation, you don't have the wholes anymore. You only have the vertical asymptote. So keep that in mind. Now let's move on to number 18. We need to factor the numerator. Alright, so a squared minus 9, we're going to use the formula a squared minus b squared equals a minus b times a plus b. Right, this one is the difference of square formula, right? So it's going to be s minus 3 times s plus 3, right? Because 9 right here, you can write 9s 3 squared, right? Now, the denominator right here, you just factor s out. So you have s squared plus s minus 6, right? Now you need to use the s method to factor this trinomial out, right? So you're going to put c right here, it's going to be negative 6. You're going to put b right here, it's going to be 1, right? Now you need to find two integers multiply equals negative 6 add up to 1, which is 3 and negative 2, right? So s squared plus s minus 6 can be written as s plus 3 times s minus 2, right? We cancel out s plus 3 and s plus 3 right here. So we have a whole s plus 3 equals 0, and then s equals negative 3, right? Now you have this guy and this guy on the denominator. So we have two vertical asymptotes. The first one is going to be s equals 0, right? The second one is going to be s minus 2 equals 0, and then s equals 2, right? Now let's move on to number 19. Alright, first we need to cancel out the numerator and denominator to find a whole if possible, right? So this one and this one cancel out. So we have s plus 3 power of 2 on the numerator, right? Denominator is going to be s minus 5 all together square, right? So because you cancel out this one, so s plus 3 equals 0 is a whole, right? So s equals negative 3. This one is a whole. Now second one, you have s minus 5 equals 0 because it's on the denominator, right? So you have s equals 5, and this is the vertical asymptote. Now since you cancel out s minus 5 and s minus 5 right here, and you say this one is the whole. Yes, of course, but because you have the vertical asymptote and the whole occurs at the same time right here, right? So vertical asymptote dominates the whole, right? So in this situation, we don't have the whole, we only have the vertical asymptote. Now let's move on to the next one. Write the equation of the horizontal or slant asymptote for each of the following rational functions. Alright, so we need to check for the degree on the numerator and the degree on the denominator. So since this guy and this guy have the same degree, right? We have the horizontal asymptote, right? So the horizontal asymptote is going to be the quotient of the leading term, right? The leading terms right here, right? So we have s squared over 3s squared. Now we cancel out s squared and s squared, so the answer must be 1/3, right? So y equals 1/3 is the horizontal asymptote. Now let's move on to the number 21, right? So the degree on the numerator is 3. Degree on the denominator is 4. So it's going to be 1 unit less than this one, right? So we have the horizontal asymptote y equals 0, right? Now number 22. Degree on the numerator is 2. Degree on the denominator is 1. So it's going to be 1 unit greater than this one, right? So we have the slant asymptote, right? Now, in order to find the slant asymptote, we need to do long division, right? So we have 4s squared minus 3s plus 5 divided by s plus 2, right? Now, if you want to review how to do long division and synthetic division, please check out the links in the description below, right? Alright, now 4 divided by 1 is going to be 4. S squared divided by s is going to be s. I'm going to multiply this guy back, so 4s times s is going to be 4s squared. Alright, I'm going to change the sign, it's going to be negative 4s. 4s times 2 is going to be 8s. I'm going to change this negative 8s, and then I do addition. Alright. So this one cancel out. Negative 3s plus negative 8s is going to be negative 11s. I'm going to bring 5 down, right? Now, next one. Negative 11 divided by 1 is going to be negative 11. S divided by s is going to be 1, so I don't need to write, right? So I'm going to multiply this guy back. Negative 11 times 1s is going to be negative 11s. So I change the sign, it's going to be plus 11s. Negative 11 times 2 is going to be negative 22. So I need to change the sign, it's going to be plus 22. Right? Now I'm going to add this guy up. So this one cancel out. 22 plus 5 is going to be 27. So this one can be written as h of s equals the quotient right here, 4s minus 11. Alright, the remainder right here, 27. So plus 27 divided by the divisor right here. So you need to put divisor as plus 2. Alright, finally, the slant asymptote is y equals 4s minus 11, which is the quotient. Alright, so keep that in mind. Now let's move on to number 23. Degree on the numerator is 3. Degree on the denominator is 2. So it can be 1 unit greater, right? So we have the slant asymptote, right? So we need to do long division again. Now, the leading terms right here, sq, leading term right here, s squared. Sq divided by s squared, it could be s. Now I'm going to multiply this guy back. S times s squared, it could be sq. I put sq right here, I need to change the sign. S times s could be s squared, I need to change the sign, it could be minus s squared. S times 3, it could be 3s, I need to change the sign, it could be negative 3s. Now I need to add them up. So this one cancel out. This guy add this guy, it could be negative 3s squared. 4s add negative 3s, it could be plus s, right? I need to bring this one down, minus 1, right? Now, the leading terms right here, negative 3s squared, divided by this one, it could be negative 3, right? Multiply this guy back, it could be negative 3s squared, so I need to change the sign, it should be plus 3s squared, right? Negative 3 times s, it could be negative 3s, I need to change the sign, it should be plus 3s. Negative 3 times 3, it could be negative 9, change the sign, it could be plus 9, right? Now I need to add them up. Alright, so I have this one cancel out. It could be 4s plus 8, right? Now, since the degree of the remainder right here is 1, less than the degree of the divisor right here. So, I'm going to stop right here, right? So, my slant asymptote should be s minus 3, right? So, y equals s minus 3 is the slant asymptote. Let's move on to number 24. Degree right here is 1, degree right here is 1, degree right here is 1, so total is 3. Degree on the bottom right here is 3. So the numerator and denominator have the same degree. So we have the horizontal asymptote only, right? Now the leading terms on the numerator is 2s times s, it could be sq. The leading terms on the denominator is sq only, right? Right here, sq. So it's going to be 2. So y equals 2 is the horizontal asymptote. Now be careful with this guy right here. When you expand this one, now a lot of students make mistake. They say s minus 7q equals sq minus 7q. This is wrong. Alright, you need to get rid of this mistake. You need to apply the formula a minus b altogether q equals aq minus 3a squared b plus 3ab squared minus bq. Now let's move on to the example number 25. Degree on the numerator is 2 right here and 2 right here, total 4, right? This guy 2 and this guy 3, so total 5. So the degree on the numerator is less than degree on the denominator. We have the horizontal asymptote. Y equals 0, right? Now let's move on to number 26. The graph of the rational function f is shown above. Which of the following could be an expression for f of s? Right. So we look at this one, we see that there is a hole, right? So we need to write a fraction right here. A whole s equals 5, right? So you see that s equals 5. So then you need to convert this one into the factor, right? So subtract 5 both sides. So you have s minus 5 equals 0, right? So you have the factor s minus 5, right? So you put s minus 5 right here. You know that the whole occurs when the numerator and the denominator have the common factor, right? So you need to put s minus 5 on the denominator, right? Now, you have the vertical asymptote right here. S equals 2, right? So you have s equals 2. Now convert this one into the factor. So subtract 2 both sides. So you have s minus 2 equals 0, right? So you put s minus 2 right here on the denominator, right? Now, look at this one. You have the horizontal asymptote y equals 1, right? So since the horizontal asymptote y equals 1, which means the degree on the numerator and the degree on the denominator must be the same, right? So on the numerators right here, you only have this one power of 1, this is power of 1, this one power of 1. So we need one more factor right here, so that the numerator and denominator have the same degree, right? So how do we find this one? Look at the 0 right here. 0s equals negative 1, right? So we need to convert this one into the factor. So we have s plus 1 equals 0. So this is the factor right here. So we put s plus 1 right here, right? It's going to be b, right? Now, question number 27. The graph of the rational function k has a whole s equals 3. Vertical asymptote s equals negative 2. Which of the following could be k? Alright, so you have a hole right here. So you need to convert this one into the factors. So you need to subtract 3 both sides, right? So s minus 3 equals 0. So this is a factor. Now, you need to convert this one into the factor too, right? So you need to add 2 both sides, right? So I have s plus 2 equals 0, right? Now, vertical asymptote, so I need to put s plus 2 on the bottom, right? Now, the holes right here, s equals 3, right? So on the top and bottom must have s minus 3, right? Okay, now we're going to check. We have a whole s minus 3. This could be right? This one wrong, right? This one has the whole s equals 3 right here. But this one doesn't have the vertical asymptote s equals negative 2, right? This is s plus 2, but this one s minus 2. So this one wrong. Now this one doesn't have a whole s equals 3, right? So this one wrong. So only A is correct. Now let's move on to number 28. Let the function g of s equals this one. Which of the following statements about g is correct, right? The graph of g has the vertical asymptote s equals 2. Now we need to simplify this one first, right? So this one cancel out. The top we have s minus 2 only, right? This one cancel out. The bottom we have s plus 1 square only, right? So in this situation you don't have the vertical asymptote, right? You have a whole, right? So this one is wrong. Now question B, the graph of g has a vertical asymptote s equals negative 1, yes, and horizontal asymptote of y equals 2, no, because degree on the numerator is 1 unit less than degree on the denominator. You have the horizontal asymptote y equals 0, right? So this one is wrong. Now question C, the graph of g has a vertical asymptote s equals 2, no, vertical asymptote s equals negative 1, right? So this one is wrong. Now D, the graph of g has vertical asymptote s equals negative 1 and horizontal asymptote of y equals 0, yes, that's correct. Now let's move on to the number 29. Let the function h of s equals s minus 2 power 5 minus s to the 5th over 3 times s power 4. Which of the following statements about the graph of h is correct, right? So in order to do this one, you need to revisit the concept you learned before, which is the binomial theorem or Pascal triangle. Alright, so please check out the link in the description below to review the old concept. Alright, so you see the power of 5 right here. You need to expand this one using the binomial theorem or Pascal triangle. Right? So this is power of 5, which means row number 5. Right? Now look at this one. You see the negative side right here. So you need to alternate the sign. Right? First one is going to be positive, and then next negative, positive, negative, positive, and negative. Now, if you see the plus sign right here, and then every single thing right here must be plus sign, right? Now we need to fill in the blank, right? The first term right here is s power of 5, right? So it can be s power of 5. The second term right here should be power of 0, right? So power of 0 we don't need to write, right? Next one, negative 5 times s power of 4, right? Remember that the exponent of the first term right here going down by 1 each times. The exponent of the second term right here going up by 1 each time. So keep that in mind. 2 power of 1, right? This one 10 times s power of 3 and 2 power of 2. Now keep in mind, you already put negative sign in front of this coefficient right here. So you don't need to print negative 2 inside right here. So be careful. Now negative 10 times s power of 2 times 2 power of 3. Keep in mind, you need to add the exponent up to make sure they all equals 5 right here. Alright. Next one, 5 times s power of 1, 2 power of 4. And the last one, negative 1 times 2 power of 5. S power of 0, you don't need to write, right? Then you're going to subtract s power of 5 right here, right? So I need to simplify this one. So this one cancel out. So the numerator only have this guy left, right? Over denominator, which is 3 times s power of 4, right? Now, I don't need to simplify this one because the question only asks you to find the horizontal asymptote, right? Now you look at the numerator and denominator to see the exponent are the same, right? So exponent right here, 4. Exponent right here is 4. So they are the same, right? So the leading term is going to be negative 5 s power 4 times 2, right? Over 3 times s power 4, right? Now I just simplify s power 4. So finally I have negative 10 over 3. This is my horizontal asymptote. So the answer must be D. Now let's move on to the last question. Let rs equals s squared plus s minus 6 over s cubed minus 5s squared plus 6s. Which of the following values of s are 0 on the graph of r? Alright, so we need to factor the numerator, right? And denominator. Now, to factor the numerator, you're going to use S method, right? You're going to put C right here and B right here. Find two numbers multiply equal C add up to B, right? A equal 1, B equal 1, and C equal negative 6, right? So it's going to be negative 6 right here, and B equals 1, right? So two numbers must be 3 and negative 2, right? So this guy becomes R of S equals S plus 3 times S minus 2, right? Denominator becomes, I'm going to factor S out first, right? So it could be S squared minus 5S plus 6, right? Now I'm going to use S method for this guy, right? So I put C equals 6 and B equals negative 5, right? So two numbers multiply equals 6 add up to negative 5, which is negative 2 and negative 3, right? So this guy turns out to be S times S minus 2 times S minus 3, right? So I put it over here, S times S minus 3 times S minus 2, right? Now I need to cancel out the common factor, right? So this one cancel out. So I only end up with S plus 3 over S times S minus 3, right? So you just let the numerator equal 0, right? So S plus 3 equals 0, S equals negative 3, right? So the answer must be B. We're going to review the topic 1.12 to 1.14 of the Unit 1 Transformation and Modeling Functions. Alright, question number 1. Let g be a function that is a transformation of the function f such that g of s equals 3 times f of s minus 2. Describe the transformation of the function f that results with the function g. Alright, so we know that the transformation form is going to be a times f of b times s minus h plus k. And then the order of transformation should be b, h, a, k. The trick for you to memorize this one is Brendan, hugs, and kisses, right? Now, A tells us that vertical dilation. B, horizontal dilation. H, horizontal translation. If h greater than 0, it translates to the right. If h less than 0, it's translated to the left. Is the vertical translation. If k greater than 0, it translates up. If k less than 0, it translates down, right? Now, anything related to s value, think opposite, right? Alright, now take a look at this one right here. Alright, so we see that h equal to, which is greater than 0, right? And a equals 3, right? Since h equals 2, it's going to be a horizontal translation 2 units to the right, right? And a equals 3 is going to be vertical dilation by a factor of 3, right? Now let's move on to question number 2. Let k be a function that is a transformation of the function h such that k of s equals h of 4s minus 1. Describe the transformation. Alright, so we see that b equals 4, right? And k equals negative 1, right? So there is a horizontal dilation by a factor of 1, 4, right? And vertical translation down 1 unit, right? Keep in mind, anything related to s value, think opposite, right? So right here, you see 4 right here, it's going to be horizontal dilation by a factor of 1, 4, right? Now let's move on to question 3. Let R be a function that is a transformation of the function p such that R of s equals 5p s over 2 plus 3. Alright, now we need to rewrite this function. It could be R s equals 5p of 1 half times s plus 3, right? So we see that a equals 5, right? B equals 1 half, right? And k equals 3, right? So there is a vertical dilation by factor of 5, horizontal dilation by factor of 2, and vertical translation up 3 units, right? Now let's move on to question number 4. Now we observe that a equals negative 2, right? So which means you have the negative sign in front of a, which is there is a reflection over the x-axis, so keep that in mind. Now you see negative s right here, which is b equals negative 1, right? No h and no k, right? So in this situation, we have the reflection over the y-axis, right? Because b equals -1. And vertical dilation by factor of 2, and then reflect over the x-axis, right? Now let's move on to number 5 and number 6. The table below gives values for a function f at selected values of s. Use the table to answer question 5 and 6. Alright, so g of s equals f of 3s plus 2. Now g of 3 is going to be f of 3 times 3 plus 2, right? So it could be f of 9 plus 2, right? So f of 9 is going to be -6, right? So -6 plus 2 is going to be -4, right? Now g of -1 is going to be f of 3 times -1, right? Plus 2. So it's going to be f of -3 plus 2, right? And then it's going to be f of -3 is going to be -1 right here. So -1 plus 2 is going to be 1, right? Now question 6. h of 3 equals -2 f of 3 plus 3, right? So it's going to be -2 f of 6, right? F of 6 equals 5, so it could be -2 times 5 equals -10, right? Now question B. h of 0 equals -2 f of 0 plus 3. And then it's going to be -2 f of 3, right? Now f of 3 equals -2 right here. So -2 times -2 is going to be 4, right? Now let's move on to question number 7. The function k is constructed by applying three transformations to the graph of h in this order. First, horizontal dilation by a factor of 1/2, right? So when we talk about the horizontal dilation, which means we talk about the value of b, right? Because b related to s, right? So when it comes to any variable related to s, think opposite, right? It's going to be b equals 2, right? Vertical dilation by factor of 3, which is a equals 3, right? Now, vertical translation. In the formula, I use k, right? Now, in this formula, they're going to use c, right? So you just let c equals -5 right here, right? Now, let's move on to question number 8. The graph of f is given in the x and y coordinate right here within the interval -4 to 4, right? The graph of g is f of x plus 1 minus 2. Alright, so observe that h equals -1, right? Because we have the formula a times f of b times s minus h plus k, right? So you just match them up. -h equals 1. So then h equals -1, right? K equals -2, right? So anything related to s is going to be opposite, so keep that in mind. Now h equals -1 is translated to the left 1 unit, right? And k equals -2 is going to be translated down 2 units, right? So you have a point right here, go to the left 1, go down 2. It's going to be right here. This point, left 1, down 2, is going to be right here. This guy, left 1, down 2, is going to be right here. Left 1, down 2, is going to be right here. Now you just connect this point and you get the graph. Alright. Now let's move on to question number 9. The function f is given on the x and y coordinate plane right here within the interval -3 to 4, right? The graph of h is given by 2 times f of -s, right? So in this situation, a equals 2, which means there is a vertical dilation by a factor of 2, right? And then you see b equals -1, which is there is a reflection over the y-axis, right? So by the order of transformation, we need to do reflection first, right? So I have a point right here. The distance from here to here is going to be 4, right? Now, I need to reflect this one over the y-axis, so 4 to the left right here, right? This one right here, 1, right? So it could be right here. Now this guy right here, 1, right? So it could be right here. And this one, 3, right? So it could be right here. Now I just connect this point, right? Now since a equals 2, which means you need to multiply the y values by 2. You need to keep the s value the same, right? Now you look at this point right here. x value is 1, y value is 3. So you just multiply 3 by 2. It's going to be 6, and you keep the same x value, right? So the new point should be right here, right? This guy is same thing. 3, 3. You multiply 2 by 3, right? So it can be right here. Now, this point right here, y equals -2, right? You multiply by 2, it's going to be -4, so it can be right here. S still -1, right? So it's going to be right here. And this one right here, s equals -4, y equals 1 right here, right? So you multiply 1 by 2, it's going to be right here, 2, right? So the point should be right here, right? Now you just connect this point. Now let's move on to question number 10. The graph of f is given in the xy coordinate plane right here, within the interval -3 to 4. Now we need to sketch the graph of k, given by -2 times f of x plus 3 plus 1, right? So look at this one, we see a equals -2, which means there is a vertical dilation by factor of 2, right? And reflect over the x-axis, right? Now h equals -3, which means there is a translation 3 units to the left, right? And k equals 1, which is there is a vertical translation of 1 unit, right? Now we need to reflect this one over the x-axis first. Alright, so it's gonna be like this. Now next one, we're gonna dilate this one vertically. Now next one, we're gonna dilate this one vertically by factor of 2, which means we're gonna keep the x value and we're gonna multiply the y value by 2, right? So we have this one. Alright, so we just finished reflection and dilation, right? Now we're gonna move to the left 3 units and move up 1 unit, right? So the final answer must be this. Alright, so the final one must be the pink one. Now let's move on to question number 11. The domain of the function h is -5 to 10, and the range is going to be -4 to 2. Now find the domain and range of the function g, where g of s equals h of s minus 5 plus 7. Alright, so let's domain of the function g is be hg. The range of the function g is yg. Alright. Now we look at this one, we see that h equals 5, right? K equals 7, right? So basically, I have S, H. You look at this one right here, anything related to S value, thing opposite, right? So this is subtract 5, which means you need to add 5 equals SG, right? Now, this one right here is the vertical shift, right? So you don't need to change anything, right? So we have YH plus 7 equals YG. Alright, keep in mind you only do the opposite thing when it's related to S value, right? Now the domain of the function h is given right here, right? So I just substitute -5 and 10 for h of h right here. So I have hg is going to be from -5, substitute over here, -5 plus 5 it could be 0. 10 substitute over here, it's going to be 15, right? Now the range, -4 substitute over here, it's going to be 3, right? 2 substitute over here, it's going to be 9, right? Now let's move on to question number 12. The domain of the function k is -4 to 8, and the range is going to be -7 to 3. Find the domain and the range of the function r, where r of s equals 2 times k s over 3 plus 1, right? So I just rewrite this one a little bit. This could be 2 k of 1/3 s plus 1, right? So I know that a equals 2, right? B equals 1/3, right? Now I just undo this one to get the function r, right? Does it mean I'm going to do the vertical dilation by a factor of 2 on the function k to get the function r, right? And I'm going to do the horizontal dilation by a factor of 3 on the function k to get the function r, right? Now, as I told you before, anything related to s value, thing opposite. Alright, so this is 1/3, right? It's going to be 3, right? So I have 3 s k it's gonna be S R, right? And we have the vertical dilation right here and vertical translation right here, right? So it's gonna be 2yk plus 1 equals yr, right? Now, sk is gonna be right here. Alright, so s equal negative 4, substitute over here. I have negative 12. S equal 8, I substitute over here. I have 24. So the domain of the function r is negative 12, 24, right? Now, for the range, y equals negative 7 right here, substitute over here. So I have negative 7 times 2 is going to be negative 14 plus 1, negative 13, right? 3, substitute over here, it's going to be 2 times 3 is going to be 6 plus 1 is going to be 7, right? Now let's move on to question number 13. The domain of the function f is given from negative 10 to 0. And the range is going to be from negative 8 to 6. Now we need to find the domain and the range of the function p given by negative 3 f of 2s, right? So we have a equals negative 3, right? And b equals 2, right? Now we're going to deal with the domain first, right? The domain, we need to use the b value, right? Now anything related to s value, thing opposite, right? So you have b equal to, which means 1/2, right? 1/2 of what? S right here of function f equals s of function p, right? So we have the domain. Now, the domain of the function f is going to be negative 10 to 0. You substitute negative 10 for s of f right here. Alright, so it's going to be negative 5. And 0 substitute over here is going to be 0. Alright, now the range is going to be negative 3 of y of f, right? This one right here equals y p. So the range is going to be right here, negative 8 and 6, right? So negative 8 substitute over here. It's going to be negative 3 times negative 8. It's going to be 24. Now, 6 substitute over here. It's going to be negative 18, right? So we need to rearrange this one, right? So it turns out to be negative 18, comma 24. Now, let's move on to question number 14. The table above provides data for 7 order pairs x and y. Which function type best models the data in the table? Linear, quadratic, or cubic? Alright, so we look at this one, we see that this guy and this guy, if we add them up, we divide by 2. It's going to be roughly number 5 right here, right? This guy and this guy, add them up, divide by 2, roughly 5. This guy and this guy, add them up, divide by 2, it's going to be this one. So this one is the axis of symmetry. So it should be quadratic function, right? So you know that quadratic function is going to be something like this, right? And the axis of symmetry is the one that split the quadratic function in half, right? This one is the vertex, so the vertex right here. Alright, axis of symmetry s equals 5, right? For the left range, the y values going down, look 40, 11, 3, right? The right range is going up, look 3.7, 11.25, and 39.5, right? Now let's move on to question B. Write the equation of the regression model for the data in the table. Right? So we're going to use the calculator because this question requires us to use the calculator, right? So I'm going to use the TIN SPY calculator first, right? So this is the home screen of the TIN SPY calculator. Now you need to hit spreadsheet right here, this table right here. Alright, now you need to name the column, right? I name S. For the second column right here, I name Y. Now I need to input the values for the table, right? Alright, now after you input the values for the table, you're gonna move your cursor to the right of these two columns right here. So it should be right here. Alright, now you're gonna hit menu number 4 right here. Start. Number 1, start calculation. And then you're gonna find the quadratic regression should be number 6 right here. Alright, now the first one right here, you need to put S. Now the second one right here, you need to put Y, right? Now this is F1, which means our equation is F1, right? Now you need to hit OK. So your quadratic equation should be, let's move on to question C. What is the ratio for the point whose S coordinate is 6.1. Alright, so x coordinate 6.1, which means this one right here. Alright, y equals 3.7, right? Now we have the formula. Restore is going to be actual value subtract the predicted value. Alright, actual value is the one given in the table. Predicted values is the one we need to use the formula right here to calculate, right? If the restore less than 0, the model overestimated the actual value, which means the predicted values bigger than the actual value, right? Now, if restore greater than 0, the model underestimated the actual value, which means the actual value is bigger than the predicted value, right? Now, we're going to use the calculator to calculate this one, right? Now, we need to use this model to predict the values of y when s equals 6.1, right? So previously we have the equation right here and we save our equation under F1, right? Now we just hit Control I and add calculator right here and we hit F1. Alright, hit parentheses, hit set point 1 and then hit enter. It's going to be 3.7855. Now you need to find the restore. So restore is going to be actual value subtract the predicted value. So actual value is going to be 3.7, right? Subtract 3.7855, right? So it's going to be negative 0.0855, right? Which is less than 0. So then the model overestimated the actual values, right? Now we can use the TI-84 plus E calculator to do this. Alright, I'm going to hit start, edit, and hit enter. Now I need to input values for the first and the second columns, which is L1 and L2, right? Alright, next I'm going to hit start, go to count number 5, quadratic regression, hit enter. Now I need to store equation right here. I need to hit fast, y fast, function y1, hit calculate, and this is my answer for the quadratic regression, right? So it's gonna be similar to this one, right? Alright, now I just hit graph, it's gonna be right here. Alright, so I want to see the whole thing, I just adjust the window, right? And hit graph, it's gonna be right here, right? Now we need to predict the y value when s equals 6.1, right? So you just hit second trace, number 1 right here, values. Alright, so you just hit 6.1, hit enter, it's gonna be 3.7855 right here, right? And it's good time to stop. Unit 2, exponential logarithmic functions. Alright, we're gonna talk about the arithmetic and geometric sequence. Topic 2.1. Now we have arithmetic sequence formula. It could be a sub n equals a sub k plus common difference times n minus k. Whereas a sub n is going to be n terms. A sub k is going to be k term. Okay, k always less than n. Now here's the hint. You need to find the common difference using the slope formula. Now for geometric sequence, g sub n equals g sub k times r raised to the n minus k, where r is the common ratio, r the multiplier. Alright. Now here's the hint. You need to plug both points into the formula to find the common ratio. Now let's take a look at the examples below. For question 1, 2, 3, use the information below to write an equation for the following arithmetic sequence. Then find the 11th term of the sequence. Alright, so you have the 4 terms and the 9 terms right here. Now you can treat 4 terms as the k terms and the a sub 9 right here as a 9 term. Alright, so we're going to use the formula right here. So we have equals a sub k, which means a sub 4, right? Plus the common difference, we don't know it, we put d, right? Now k equals 4, n equals 9, right? So it could be 9 minus 4. Alright, now I substitute values. Negative 3 equals 7 plus d times 5, right? Now I'm gonna subtract 7 both sides. So I have 5d equals negative 10, right? So d equals negative 2, right? Now I need to find the 11th term, right? So I need to substitute d equals negative 2 back to this formula right here, right? So I have a sub n equals a sub k. Now, in this situation, you can pick any of these guys right here as an k terms, right? You either pick this one as an k terms or this one as an k term, right? So I'm gonna pick this one. So a sub k, which means 7 minus 2 times n minus k, which means 4. Alright, now I need to solve for 11 terms. So I substitute 11 for n, right? So I'm going to end up with a sub 11 equals 7 minus 2 times 11 minus 4, right? 11 minus 4 is going to be 7. 7 times 2 is going to be 14, right? So 7 minus 14 is going to be negative 7, right? Now let's move on to question number 2. Alright, so the common difference is given, right? So we have a sub n equals a sub k, which means a sub 2 right here. It's going to be 5, right? Plus the common difference is going to be 3 times n minus k in this situation is going to be 2 right here, right? Alright, now I need to solve for 11 terms, right? So I have a sub 11 equals 5 plus 3 times 11 minus 2, right? So 11 minus 2 it could be 9. 9 times 3 it could be 27 plus 5 it could be 32. So a sub 11 equals 32, right? Now question number 3. Now we need to find the common difference d, which is the slope of the line passing through these points, right? So you just use rise over run, right? Going down by 1, so it could be negative 1. Go to the right by 2, it could be 2. So the slope is negative 1/2, right? That is the common difference, right? Now, I have a sub n equals a sub k. You can pick any points right here, right? So I can pick this point. A sub k equals 7, where k equals 1 right here, right? So it could be 7 plus common difference. Common difference is going to be negative 1/2 right here, right? So negative 1/2 times n minus 1, right? Because I picked the first term right here, right? A sub 1. Now, I need to solve for a sub 11, right? So I have a sub 11 is going to be 7 minus 1/2 times 11 minus 1, right? 11 minus 1 is going to be 10. 10 divided by 2 is going to be 5. So 7 subtract 5 is going to be 2, right? Now let's move on to the next one. For question 4, to set, use the information below to write an equation for the following geometric sequence. Then find the a term of the sequence. Alright. Now this is the geometric sequence, right? So we know that the formula is going to be g sub n equals g sub k times common ratio raised to the n minus k. Right? So you can use g sub 3 as g sub k, right? And g sub z as g sub n, right? Now we substitute over here, we need to find the common ratio, right? So I have 1.5 equals 12 times common ratio 6 subtract 3, right? So we're going to divide both sides by 12. So 1.5 divided by 12 is going to be 1 over 8 equals r raised to the third, right? We need to solve for r, right? So we're going to take cube root both sides. So r equals 1/2, right? Now we need to solve for g sub 8 equals. Now within these two terms right here, you can pick any terms as an g sub k, right? So I pick this one. It's going to be g sub 3 times common ratio is going to be 1/2 raised to the 8 minus 3, right? Now g sub 3 equals 12, so I put 12 here, right? Alright, so it's going to be 12 times 1/2 power of 5, right? So it's going to be 12 divided by 32. And if you simplify, divide the top bottom by 4. So it could be 3 over 8, right? Now, question number 5 is similar to question number 4. I'm going to leave this one for you to practice. The answer must be 384 for the terms g sub 8. Alright, now question number 6. Look at the graph right here. We need to find the common ratio. Alright, we see that the first term right here has the value 6, right? The second term right here has the value 3, right? So, we need to find the common ratio by taking 3 divided by 6, right? It's going to be 1/2, right? So, now, We need to find g sub 8 is going to be the first term right here. It could be g sub 1 times 1/2 8 minus 1, right? Now g sub 1 is going to be 6, right? Value 6 right here. So I put 6 right here. So it could be 6 over 2 power 7, right? So it's going to be 6 over 128. Now if you divide the top and bottom by 2, it's going to be 3 over 64, right? Now let's move on to the number 7, the word problem. Scientists are studying the growth of a particular bacterial colony in a laboratory. The population of the bacterial colony can be modeled using geometric sequence, where the first day of the study is day 1. The population on day 5 was 7,000 bacteria, and the population on day 8 was 32,000 bacteria. What was the population of the bacterial colony on day 7 based on the model? Alright, so here's the key information. This is a geometric sequence, right? So we have g sub n equals g sub k times common ratio raised to the n minus k, right? Now the k term, which means the fifth day right here, right? So you have 5, 7,000, right? Now the n term is going to be day 8 right here, right? So it's going to be 8, 32,000, right? So we use this point right here, substitute into this formula to find the common ratio, right? So this one represents g sub n, this one represents g sub k, right? So I have 32,000 equals 7,000 times common ratio raised to the 8 minus 5, right? I'm going to divide both sides by 7,000, so r raised to the 8 minus 5 is going to be 3 equals 32 over 7, right? Now I need to eliminate power 3 right here, so I need to raise to the 1/3 both sides, right? So the left hand side should be power 1/3, the right hand side should be power 1/3, right? So it turns out to be r equals 32 over 7 power 1/3, right? Now we need to estimate the population of the bacterial colony on day 7, right? So we're going to use this formula again. So we have g sub 7 equals g sub k. We can pick the fifth day as a g sub k, right? So I have g sub 5 times common ratio, which means 32 over 7 power 1/3 raised to the n minus k, right? So raised to the n in this relation, which means 7, right? Minus k, which means 5, right? Like that. Alright. Now g sub 5 equals 7,000, so I put 7,000 right here, right? Alright, so I simplify this one, so g sub 7 is going to be 7,000 times 32 over 7 raised to the third, right? Now I'm going to put this one on the calculator, right? So I hit add calculator here. It's going to be 7,000 times, and then the answer right here. Now you want to convert this one to decimal. You just hit menu number right here, convert to decimal, hit enter. So the answer should be question number 8. This is similar to question number 7. The only thing difference right here is the arithmetic sequence right here, right? After 7 minutes, there were 46 people in line, right? So we have 6, 46, right? Now, after 15 minutes, there were 134 people, right? So we have 15, 134, right? Now, question, how many people will be in the line after 19 minutes, right? So we have 19 minutes right here, question mark, right? Now, because it's an arithmetic sequence, so the formula is going to be a sub n equals a sub k plus common difference n minus k, right? We can use this one as a sub k, right? And this one as a sub n to find the common difference, right? So we have 134 equals 46 plus d times 15 subtract 7, right? Alright, so we need to subtract 46 both sides. So it turns out to be 88 equals d times 8, right? So divide both sides by 8, so d equals 11, right? Now, we have a sub 19 equals a sub k. We can use this one as a sub k, right? It's going to be 46 plus common difference. It's going to be 11 times 19 subtract 7, right? So it's going to be 46 plus 11 times 12, right? So it could be 46 plus 132, right? So it could be 178. Now let's move on to the next topic, exponential function topic 2.3 to 2.5. Now we have the general form of the exponential function. It could be y equals b raised to the s, right? Now if b greater than 1, this is exponential growth, right? Now you look at the one inside parenthesis right here, b equals 2 is greater than 1 is exponential growth. Now if a is negative, right, there is a reflection about the x-axis, right? Now this one right here, exponential decay, because b greater than 0 less than 1, right? b equals 1 half right here, right? So this is exponential decay, right? If a is negative, there is a reflection about the x-axis, right? So it could be like this. Now keep in mind, this function is concave up. If you see something like this, half of this one like this, the function is concave up, right? Now if you see something like this, half of this one is going to be like this, the function is concave down, right? The function is concave up, the rate of change is increasing. The function concave down, the rate of change is decreasing. So keep that in mind. Alright, now let's take a look at the first example, example number 9 right here. The graph of the function f is shown above. Which of the following could be an expression for the function f? Alright, now we know that the function f is decreasing, right? This is the decay function, right? So b must be greater than 0, less than 1, right? Because it's going to be right here, right? So we're going to eliminate a, right? Now look at b right here. There is a negative sign in front of a, right? So there should be a reflection over the x-axis, so it should be something like this, right? So we need to eliminate b, right? Now look at d, there is a reflection, so we need to eliminate d, right? Only c is correct, right? Now we can use the y-intercept to check, right? So y-intercept right here is going to be 0, 2, right? So we substitute 0 for s in this situation. The answer must be 2, right? So we get f of 0 equals 2 times 1/3 power of 0. It's going to be 2 times 1, right? Because 1/3 power of 0 equals 1, right? So it will be 2, right? So the y-intercept is 2. So the answer must be C. Now let's move on to question number 10. The exponential function cheese is defined by g of s equals a times b to the s, where a and b are positive constants. The table gives values of g of s at selected values of s. Which of the following statements is true? Alright. Now we look at the table right here. We see that in order to get 24 from 72, I'm going to multiply by 1/3, right? Now to get 8 from 24, I'm going to multiply by 1/3. To get 8 over 3 from 8, I'm going to multiply by 1/3. And this guy multiply by 1/3. Now look at the input value right here. You see that the input value is increasing by 1 each time, right? The outputs over consecutive equivalent input value intervals are proportional, right? So this is an exponential function, right? Now, since the common ratio is less than 1, right? So this is the exponential decay function, right? So the answer must be A, right? Because b greater than 0, less than 1, right? Now let's move on to question number 11. Which of the following exponential functions demonstrates exponential growth, which means b greater than 1, right? And a must be positive, right? Now, this one b less than 1, so this is wrong. This one a is negative, so this one wrong. This one b greater than 1, right? So this could be right. Now this is a less than 1, so this is wrong. The answer must be C. Now look at question number 12. The end behavior of an exponential function h is described by the limit statements above. So this one right here. Which of the following could be the function of h of s, right? Now from this given information, we can sketch a simple graph of this one, right? So when it comes to and behavior, you're going to put negative on the left hand side of the x-axis, positive right here, positive here, and negative here, right? Now, limit of the function h of s when s approaches negative infinity, right? So when s goes to the left, the function going down, right? Because it's negative infinity, so it should be something like this, right? Negative, negative. Now, limit of the function h of s when s approaches positive infinity, so when s goes to the right, the function approaches 0, which means it's close to the x-axis, so it's going to be something like this. Alright, so we see that this is exponential decay function and there is a reflection, right? So because exponential decay function, the value of b must be less than 1 and greater than 0, right? So I need to eliminate b and c, right? Now I look at this one, there is a reflection, a must be negative, right? So I need to eliminate a, the answer must be d. Now let's move on to question number 13. The exponential function k is defined by k of s equals 5 times 2 over 7 to the s. Which of the following statements about the function k is correct? Alright, so we know that b greater than 0, less than 1, right? So it's going to be exponential decay function. And the y-intercept is 5, right? So we're going to sketch the graph of this one. So it's going to be something like this. This is the y-intercept 0, 5, right? Now k is increasing. No, k is decreasing because the rate of change is negative, right? If you draw the tangent line of this guy, right, the rate of change is negative. Keep in mind, you have the Christmas tree trick. The rate of change positive is going to be something like this. The rate of change negative is going down like this. Rate of change is 0, it's going to be a horizontal line. Rate of change is undefined, it's going to be vertical line right here. Alright, now, so this is decreasing, so this is wrong. K is increasing, this is wrong. K is decreasing, right? So C and D could be right? And the graph of K is concave up. Yes, it's concave up, so the answer must be C, right? Now let's move on to question number 14. Selected values of the function f as shown in the table above. Which of the following claim and explanation statements best fits this data, right? Now from the table, we see that the s values is increasing by 1 each time, right? So this is the equivalent of input intervals, right? Now look at the output. Each time you're going to multiply by 4, right? So the outputs over consecutive equivalent input value intervals are proportional. The answer must be C, right? Now let's move on to question number 15. Which of the following functions is an equivalent form of the function y equals 4 raised to the 3s, right? Now, this is actually exponential manipulation, right? So you just manipulate this one, right? So I have y equals 4 raised to the 3s, so I just write y equals 4 raised to the third, and then raised to the s like that, right? Remember, you learned from algebra 1, a raised to the m times n can be written as a raised to the m all together raised to the n, right? Now, 4 raised to the third is going to be 64, right? So 64 raised to the s, the answer must be C. Now, question 16. Which of the following functions is an equivalent form of the function y equals 9 times 4 raised to the s, right? And this question similar to question number 15, right? We just manipulate this one, right? So we have y equals 9 times. Now 4 can be written as 2 power of 2 all together power of s, right? So it's going to be 9 times 2 power of 2 s, right? So the answer must be C. Topic 2.32, 2.9 exponential and logarithmic functions. Alright, question 1. Which of the following functions is an equivalent form of the function y equals 3 raised to the s plus 3? Alright, so we just manipulate this one. It's going to be 3 power of s times 3 power of 3, right? And it's going to be 27 times 3 power of s, right? And the answer must be D. Now question 2. f of s equals 4 raised to the s minus 2. So it's going to be 4 raised to the s over 4 squared, right? So it's going to be 1 over 16 times 4 to the s, right? So the answer must be D. Now question 3. The function g of s equals 16 times 9 to the s. We need to manipulate this one. So it's going to be 16 times 3 square raised to the s, right? So it's going to be 16 times 3 raised to the 2s. So the answer must be D, right? Now question 4. h of s equals 25 times 36 to the s. Alright, so we just manipulate this one. It's going to be 25 times 6 square all together raised to the s. And it turns out to be 25 times 6 raised to the 2s, right? So the answer must be D. Number 5, k of s equals 9 times 4 to the s. It's going to be 9 times 4 can be written as 16 raised to the 1/2, right? All together raised to the s, right? So it could be 9 times 16 raised to the 1/2 s, or 9 times 16 raised to the s over 2, right? So the answer must be C. Number 6, f of s equals 16 times 4 to the s. Now this one can be written as 4 square times 4 to the s, right? And it's going to be 4 square plus s, right? So the answer must be B. Next one, the exponential function g is defined by g of s equals -2 times e to the s, right? Which of the following pairs of statements correctly describes the end behavior of g? Alright, so we need to sketch this one, right? Now we know that y equals 2 times e to the s is an exponential growth function. Alright, so it's going to be something like this. Now, since you have the negative side in front of the coefficient 2, then there is a reflection over the x-axis. So it's going to be something like this. Now, answer choice A. Limit of the function g of s when s approaches negative infinity equals negative infinity. No. When s approaches negative infinity, the function approaches 0, right? Which is the x-axis, right? So this one should be 0. Limit of the function g of s when s approaches positive infinity equals negative infinity, right? This guy go to the right, this guy go down. You see that? So this guy should be negative infinity. Question B. Limit of the function g of s when s approaches negative infinity equals positive infinity. No. It's going to be 0, right? The x-axis. Limit of the function g of s when s approaches positive infinity is negative infinity, right? So this one is negative infinity. Answer choice C. Limit of the function g of s when s approaches negative infinity equals 0. Yes, that's correct. Limit of the function g of s when s approaches positive infinity equals negative infinity. Yes, that's correct. So the answer must be C. Now, question 8. Similar to question 7, right? Given the graph right here, we need to find the end behavior, right? Now, answer choice 8. Limit of the function f of s when s approaches negative infinity, right? Negative infinity right here. The function approaches positive infinity, right? S go to the left, the function go up, right? So this is wrong, right? Because it says negative infinity. Answer choice B. Limit of the function f of s when s approaches negative infinity equals positive infinity. Yes, that's correct. Limit of the function f of s when s approaches positive infinity, it approaches x-axis, which is 0, right? So it's B. Now, question 9, given the graph right here. Question, which of the following could be an expression for the function k right here? The exponential function has the form of f of s equals a times b raised to the s, right? Since the function reflects over the x-axis, so a must be negative, right? So a less than 0. And this is actually exponential growth function, right? It's going to be something like this, and then it's going to reflect over the x-axis, right? So b must be greater than 1, right? Now, look for the answer right here. A could be right? B is wrong, right? Because a must be negative, right? C is wrong. D could be right? Now, since this is exponential growth function, b must be greater than 1, right? So the answer D is wrong, right? So only A correct. Now, question number 10. the exponential function h decrease at an increasing rate. Most of students struggling with this question. Now you need to split this one into two statements, right? The first one, the function h decreasing, right? So if the function h decreasing is going down like this, right? Now the function h is decreasing at an increasing rate, which means the rate of change is increasing. So if you draw two tangent lines, you will see it. The rate of change is getting bigger and bigger, right? Because if you use the Christmas tree trick, the rate of change is negative, it's going to be this guy right here, right? And then if the tangent line is getting less steep, the rate of change is bigger, right? So in this situation, A must be positive, right? Because the exponential decay function has the form of this one, right? So A greater than 0, B greater than 0 but less than 1, right? So we need to eliminate A, B, and D, right? The answer must be C because there is no reflection over the x-axis, right? Now question 11. The exponential function f is defined by f of s equals a times b to the s, where a and b are positive constants. The table gives value of f of s at selected values of s. Which of the following statement is true? Alright, so we look at this one right here. We need to find the change in s, right? So we know that every single time the value of s increasing by 1, right? And the y values are proportional with a common ratio 2, right? So the outputs of our consecutive equivalent input value intervals are proportional, right? So this is an exponential growth function. The answer must be D. Because A positive and B greater than 1, right? B in this situation is 2. Now question 12, similar to question 11, right? The common ratio is 10, right? Which is B equals 10, right? So you need to eliminate A because B less than 1. Eliminate C, B less than 1. Only B and D correct, right? Now because B greater than 1, it's going to be exponential growth, right? This is not the case, so B is wrong. The answer must be D. Now number 13, the exponential function h is defined by h of s equals 3 times 1/2 raised to the h. Which of the following statements about the function h is correct? Alright, now look at the answer choice right here. We need to grab this one first, right? B less than 1 but greater than 0, this is exponential decay, right? Now answer choice A, the function h is increasing. No, it's decreasing, right? It's going down. The function h is increasing, that's wrong. The function h is decreasing and the rate of change of h is increasing, yes. Because the function concave up, the rate of change is increasing, right? And the function is decreasing because the rate of change is negative, right? Look at this one. You draw a tangent line. You see that the Christmas tree rate of change is negative because the tangent line is going down like this, right? So the function is decreasing. 14. Selected values of the function f are shown in the table. Which of the following claim and explanation statements best fits this data, right? Now you need to find change in s and change in y first, right? So look at this one. Every single time you're gonna add 3, right? And look at the right hand side. Every single time you're gonna multiply by 2, right? Observe that the outputs of a consecutive equivalent input value intervals are proportional, right? The common ratio is 2, right? So this is actually exponential function, right? So A is wrong because it's a logarithmic function. B is wrong, right? Logarithmic function. Only C and D could be correct, right? So we look at this one. The outputs are proportional, right? The input not proportional, right? So the answer must be C. So you need to be careful with this one, okay? Now question number 15. We need to find the change in S and change in Y, right? Now change in S, every single time you're going to multiply by 1/3, right? Now change in y, every single time you're gonna add 2, right? Now observe that the inputs over consecutive equivalent output value intervals are proportional, right? Because the common ratio right here is 1/3, right? So this is not an exponential function, right? So you need to eliminate C and D, right? Now look at this one, answer choice 8. It says the output are proportional. No, the input are proportional, right? So the answer must be B. Now let's move on to the next one. Use the graph and table of values below for problems 16 to 23. Alright, the graph of the piecewise linear function f is shown above, which is this one right here, and consists of 3 linear segments. Values of the function g and h are shown in the table above as selected values of f. Let f inverse and h inverse represent the inverse functions of f and h. Find the value of h inverse of 2 or indicate that it is not defined. Alright, so we need to find the inverse function of g and h, right? So in order to find the inverse function of g and h, we just swap s and y value, right? So g inverse is going to be -5. For h inverse of s, we just copy this one down, right? Because the function g and the function h right here have the same s value, right? Now, h inverse of 2. So you need to find the value of inverse function of h when s equals 2, right? S equals 2 right here. So the value should be 2 right here, right? So this guy equals 2. Now, question 17, find the value of f inverse of 2. So remember that the input becomes the output, right? So this is the input, it becomes the output right here 2, right? So it's going to be 0, right? Now number 18, the function k is defined by g of f of s, right? Find the value of k 0. Alright, so we substitute over here. It turns out to be g of f of 0, right? Now we look at the graph right here. We need to find f of 0 first. F of 0 is going to be 2, right? So it turns out to be g of 2. Now g of 2 is going to be -5 right here, right? So the answer is -5. Now number 19. The function m of s is g of f of s, right? We need to find m of -3. So it turns out to be g of f of -3, right? Now f of -3 is going to be -1 right here, right? So it turns out to be g of -1, right? -1 is going to be right here. So g of -1 is going to be -2, right? So the answer is -2. Next one, number 20. We need to find p of 1 where p is h of g of s, right? So we have p of 1 equals h of g of 1, right? Now g of 1, g right here is going to be -3, right? So it's going to be h of -3, right? Now look at the function h. H of -3 is going to be 4 right here, right? So the answer is 4. Number 21. Q of s equals f of s. So Q of -4 equals f of -4, right? Now f of -4 is going to be -2, right? So it's going to be f of -2. Now f of -2 is going to be right here. So it could be 1, right? Number 22. Find the value of r of 1. H of 1, right? Now the function h and 1 is going to be right here. The answer is 0, right? So it could be g of 0. Now look at the function g right here. 0. We don't see any value of s equals 0 right here, right? So this guy must be undefined. Number 23. The function Ls equals f inverse of h of s. We need to find L2, right? So L2 equals f inverse of h of 2, right? Now we need to find h of 2. It's going to be -2, right? F inverse of -2, right? Now we need to look at the graph of the function f, right? Negative 2 right here is the input of the inverse, right? It becomes the output, right, in the function f. So the output, negative 2, is going to be right here. Right? So the answer must be negative 4, right? Because f of negative 4 equals negative 2, right? Now, question number 24. What is the value of the expression log base 2 of 8 minus log 10? Alright, so this one can be written as log base 2 of 2 power of 3, right? Minus log base 10 of 10, right? Now we can bring 3 to the front, right? So it turns out to be 3 log base 2 of 2 minus log base 10 of 10, right? We know that log base a of a equals 1, right? So this guy turns out to be 3 times 1 minus 1, right? So it could be 2, right? So the answer must be B. Now question 25. Now we need to determine the value of this expression, right? So log base 9 of 3 can be written as log base 3 power of 2 of 3, right? Plus this guy same thing, log base 2 power of 2 of 2, right? Now we have the formula log base a power of k of b equals 1 over k log base a of b, right? This formula different from this formula, log base a of b power of k, right? When you bring it to the front, it's going to be k log base a of b, right? So this guy turns out to be 1/2 log base 3 of 3 plus 1/2 log base 2 of 2, right? So it's going to be 1/2. This guy equal 1, right? This guy equal 1, right? So plus 1/2 only. So it could be 1. So the answer must be C. Now let's move on to question number 26. What is the value of this expression, right? So we know that log base a of 1 always equals 0, right? Because a power of 0 equals 1, right? So this one equals 0, right? Now this guy turns out to be negative log base 6 of 1 over 6 squared, right? So it's going to be negative log base 6 of 6 power of negative 2, right? So you can bring negative 2 to the front. So it could be plus 2 times log base 6 of 6. So log base 6 of 6 equals 1, right? So the answer must be 2. So it could be D, right? Now let's move on to question number 27. We need to simplify this one, right? So it turns out to be, you can print it to the front. So it can be 3 natural log of e plus this one can be written as log base 3 square of 1 over 3, right? So natural log of e equals 1, right? So it could be 3 plus 2 right here. We can bring to the front. It could be 1/2, right? Log base 3. Now 3 right here I can bring to the top, so it could be 3 power of negative 1, right? Negative 1 bring to the front, it could be 3 minus 1/2, right? And you have log by 3 of 3 left, it could be 1, right? So only 3 minus 1/2, it could be 5/2, right? So the answer must be B. Now question 28. We need to simplify this one. So log 100, which means log base 10 of 10 squared, right? Remember, if you only see log a, which means log base 10 of a. So keep that in mind. Plus log base 4, right? Now 1 over 64, I can write this one as 1 over 4 power of 3, right? Now 1 over 4 power of 3, I can rewrite this one as 4 power of negative 3, right? Like this. So I bring 2 to the front, it's going to be 2, and then log base 10 of 10 equals 1, right? Plus negative 3 bring to the front, it's going to be negative 3, and log base 4 equals 1, right? So the answer must be negative 1, right? So A should be the answer. Now let's move on to question number 29. The decreasing function S gives the number of students inside a classroom after school ends. The table gives value of S of t for selected values of t in minutes since the school bell ended the day. If a model is constructed to represent this data, which of the following best applies to this situation? Alright, so we need to find the change in S and change in Y. We know that every single time the value of t is increasing by 1, right? And every single time the value of S of t is decreasing by 1/2, right? Alright, so the common ratio is 1/2, right? Which is less than 1, greater than 0. And this is a decay function, right? So the answer must be D. Now question 30. A fitness trainer created a new fitness program designed to help her clients increase their bench press. The trainer made estimates about the maximum amount one of her clients could bench press over time using her program. A linear regression was used to develop a model for the maximum bench press over time. The figure shows a graph of the results of the linear regression. Which of the following statements about the linear regression is true? Alright, now we look at the dot right here and we see that there is no clear pattern at all, right? So the linear model is appropriate in this situation. So the answer must be C, right? Now let's move on to question number 31. After Mr. Passwater launches his new social media app called Passwater Vision, the number of users registered on the app begins to increase rapidly. The number of users in millions using the Passwater Vision app is modeled by the function p. The number of users is expected to increase by 21% each month. At time t equals 0 years, there are 14 million users on Passwater Vision. If t is measured in years, now you need to know the difference between this guy and this guy, right? Which of the following is an expression for p of t? Note there are 12 months in a year, right? So we know that at t equals 0, there are 14 million users, right? So this is the y-intercept or initial value, right? So we see that 14 right here, 14, 14, so which is or could be right? Now next one, because the number of users is expected to increase by 21% each month, right? So we know that by the exponential growth function, it's going to be f of s equals a times 1 plus r raised to the t, where r is the growth rate, right? So the growth rate is 21%, right? So this guy turns out to be 14 times 1 plus this one right here is going to be 0.21, right? So it's going to be 1 plus 0.21 is going to be 1.21, right? Raised to the t, right? Now because this one is just measured in months, right? We need the answer to be years, right? So there are 12 months per year, right? So we need to take this one multiplied by 12. So it could be 14 times 1.21 raised to the 12t, right? So the answer must be D, right? Now let's move on to question number 32. Polonium-209 has a half-life of 102 years. In a particular sample, the amount of polonium-209 remaining after y years can be modeled by the function p, given by p of y equals a0 times 0.5 raised to the y over 102, where a0 is the amount of polonium-209 in the sample at time y equals 0, which is the initial value, right? Which of the following functions L models the amount of polonium-209 remaining after t days, where a0 is the amount of polonium-209 in the sample at time t equals 0. Now, here's the hint. There are 365 days in a year, so t equals 365 y, right? So from this one, we can solve for y. So y equals t over 365, right? I can write this one as 1 over 365 times t, right? So I substitute 1 over 365 times t for y in this equation right here. So I'm going to end up with L of t equals a sub 0 times 0.5 raised to the 1 over 365 times T times 102, right? Now, I can print 1 over 365 inside, so it will be A sub 0 times 0.5 raised to the 1 over 365 right here, right? All together raised to the 102t, right? So the answer must be D. Now let's move on to question 33. The table above represents values for a function k at selected values of s. An exponential regression y equals a times b to the s is used to model this data. What is the value of k of 3 predicted by the exponential function model? Alright, so this question is calculator active, right? So we're going to bring up the calculator. Now, I'm going to use two different calculators. I'm going to use TI and SPY calculator first, right? So, what I need to do is to go to main screen, right? Calculator. Now, I need to hit spreadsheet right here. I need to name the first and the second column with S and Y values, right? Then, I need to input the values for this table, right? So, I just copy this one over here. Then, I'm going to move my cursor to the right of this column, right? So, I'm going to hit menu, number 4, statistic. Number 1, start calculation, and then I need to hit A right here, exponential regression. Alright, so for the first one, I just rename this one as, next one should be Y, right? I save my equation as F3, right? So I need to use this one later. I need to hit OK. The answer should be 5.13, which is the initial value, and the common ratio should be 0.685 something, right? Now, I need to determine the values of k of 3 right here, right? So I need to go to the home screen, right? So I need to hit Control I. Add calculator here. Alright, so I need to hit F3 because previously we saved our equation as F3, right? So F3 right here. And open parenthesis, put 3. Close parenthesis, hit enter. The answer is 1.65384. So A must be the answer, right? Now we can use TI-84 plus CE calculator to do this problem, right? So this is my calculator. Now I need to hit start, edit. Alright, the first column right here, I need to go up, hit click, go down. The second one, go up, hit click, go down, right? Now I need to input the values for the table, right? So now you hit start, go to count right here, and find the exponential regression. It's going to be number 0 right here. Hit enter, and then S list, which means L1, Y list, which means L2. You need to store regression equation, right? So I'm going to store this one as Y1, right? So you need to hit vars, Y vars, function Y1, hit calculate. So the answer is right here, right? Now we need to solve for k of 3, right? So you need to hit vars, go to Y vars right here, function Y1, alright? Hit parenthesis, put 3, close parenthesis, hit enter. The answer is right here, 1.6538, right? Now we can also use decimals to do this problem, right? So we're gonna bring up decimals. It's gonna be right here. We hit the plus sign right here, and then hit table. Alright, we need to input values for the table, right? Now we need to hit this one right here, add regression. Alright, we need to choose exponential right here. Now we need to put the check mark on log mode right here to get the exact value right here, right? If you don't put the check mark on log mode, you will get the wrong answer. So keep that in mind, right? So the answer is 5.13047 times 0.68566 right to the s, right? Now to find the value of f of 3, we need to copy this equation over here. Alright, so after you copy the equation over here, now you need to calculate f of 3, right? So you just put f of 3 and put equal sign and hit enter. The answer is 1.6593, right? Now let's move on to the last question, 34. A wind turbine uses the power of wind to generate electricity. The blades of the turbine make a noise that can be heard at a distance from the turbine. At a distance of d equals 0 meters from the turbine, the noise level is 105 decibels. At a distance d equals 100 meters from the turbine, the noise level is 49 decibels. The noise level can be modeled by the function S of d equals a times b raised to d, where S of d is the noise level in decibels at a distance d meters from the turbine. Use the given data to write two equations that can be used to find the values for the constants a and b in the expression for S of d, right? As d equals 0, we have S of 0 equals a times b power 0, right? But S of 0 equals 105 decibels, right? So a times b power 0 equals 105, right? So we have the first equation. It's going to be a times b raised to the 0 equals 105, right? Now the second one, S of 100 right here, equals a times b power of 100. And then as d equals 0, it's going to be 49 decibels, so it could be 49, right? So we have the second equation, a times b power of 100 equals 49, right? Now, question B, find the values for a and b, right? So from the first equation right here, we can say that b raised to the 0 equals 1, right? So a equals 105, right? Now we substitute 105 for a into the second equation. So we're going to end up with 105 times b power of 100 equals 49, right? Now divide both sides by 105. So b raised to the 100 equals 49 over 105. Now raised to the 1 over 100 both sides. So b equals 49 over 105 raised to the 1 over 100, right? Now question C, use the given data to find the average rate of change of the noise level in decibels per meter from d equals 0 meter to d equals 100 meters. Express the answer as a decimal approximation. So the computations that lead to your answer, right? So recall that the average rate of change formula is given by f of b minus f of a over b minus a, right? Now, in this situation, it's going to be s of 100, right? Subtract s of 0, right? Over 100 minus 0. Now, s of 100 is going to be 49, right? It's right here. Minus s of 0 is going to be 105, right? Divide by 100 minus 0, right? 49 subtract 105 is going to be negative 56 divided by 100. So it could be negative 0.56 decibel per meter. We're going to talk about the inverse functions. So an inverse relation will undo a given relation, which means you're going to switch x and y. Alright, so for example, if you have a table, now you need to find the inverse of this relation. So basically, you just switching the x and y values, right? So this is x equal 1, 3, 4, 6, right? And then this guy turns out to be y value. So you put 1, 3, 4, 6 right here. Now negative 1, 2, 0, 2 go over here. Alright, so let's take a look at the first table right here. This original table and this is the relation. We're going to check the x value right here. You see that every single x value produces exactly one y value. So this relation is a function. Now look at the second table right here. You see that one x value right here produce two different y values right here. Alright, which means x repeating. So when x repeating, this is not a function. Alright, let's move on to the next example. Now, given the graph right here, we need to sketch the inverse relation of the given graph. Alright, so this is my original relation. So I have the points right here. It's going to be negative 2, negative 1. The next point is going to be right here, -1, 2. Next one is going to be 2, 1. And the last one is going to be 4, 3. Now, next one, I have the inverse relation. All right. So basically, I need to swap x and y right here. So I get the new coordinate points. So it's going to be -1, -2. This guy right here, 2, -1. And then this guy, 1, 2. Right, this guy, 3, 4. All right. So basically, I just grab this guy on the coordinate plane right here. So -1, -2, -1, and -2. The points right here. 2, -1 is going to be right here. 1, 2 is going to be right here. And 3, 4 is going to be right here. All right, so I connect this guy. Okay. Now, the original relation is a function because it's past the vertical line test, right? So you draw a vertical line test, you see that every single time the vertical lines miss the graph at 1 point, right? But the inverse relation is not a function because it does not pass the vertical line test, right? You just draw a vertical line right here. You see that the graph missed the vertical lines as 3 points right here, right? So this is not a function. The graph of inverses are reflections over the line y equal x. So basically, you just draw the line y equal x right here. You see that original function and the inverse reflect over the y equals x. Now, if I call the original function, it's going to be f of x, and then the inverse function should be f inverse of x, like this, right? Now, let's move on to the next example. We need to find the inverse functions of this guy right here, and then we need to find the domain and range of the inverse function. All right, before we're going to do that, let's review the concept. So if two functions are inverse of each other, the domain of the original function is the range of the new function. The range of the original function is the domain of the new function. So now I need to find the domain of this one. This is actually the rational function. So if you grab it, it's going to be something like this. Now the first thing you need to find the vertical asymptote. So the vertical asymptote, you just let the denominator equal to 0. So vertical asymptote equals s plus 3 equal to 0. So s equals -3, right? So this is my vertical asymptote. So vertical asymptote is going to be something right here. So this is -3. Now the horizontal asymptote, because the degree on the numerator and degree on the denominator, they're both the same. So the horizontal asymptote is going to be 1, right? Coefficient of s divided by coefficient of s right here should be 1, right? So the horizontal asymptote right here, y equals 1. This is s equals -3, right? So this is 1. All right, so if you grab it, it should be something like this. All right. So the domain of this function is going to be -∞ to +∞ except -3, right? So you need to write the domain is going to be a real number except -3. All right. Now the range, right? We're going to go from bottom to top. So it's going to be all real numbers except y equals 1 right here, right? So the range is going to be all real number except 1. Now, if you do the right thing, and then the domain of this guy right here becomes the range of the inverse function. The range of this guy right here becomes the domain of the inverse function. Now, in order to find the inverse function of this function, the first step you need to do is rewrite this one. Replace f of s with y. All right, so I have y equals s minus 2 over s plus 3. Now next step, you're gonna swap y and s, right? So y right here you put s, S right here, you put y. Alright, and you copy everything down. Minus 2 plus 3. Okay. Now, next one, you see the denominator right here. You need to multiply both sides by denominator. So I'm going to multiply both sides by y plus 3. Y plus 3. Alright. So then, this guy cancel out. So I have this guy multiplied by this guy. You just multiply this one out. So it could be sy plus 3s equals y minus 2. Alright, now you need to solve for y. So basically, you print every single term related to y to the left. Alright, other terms print it to the right. So I have sy on the left. I just rewrite this one. Okay, I have y right here. I need to print it to the left. When you print it to the left, which means you need to subtract this one. When you print this one to the left, you need to change the sign of the terms. So when you move a term from this side to another side, please change the sign of the terms. So this is positive becomes negative y equals positive 3s. I'm going to print it to the right. So it turns out to be negative 3s minus 2. Copy them down. Okay. Now I need to solve for y. I need to factor y out. So it's going to be y right here. Right. When I factor, I need to take each of these terms divided by y. So sy divided by y is going to be s. Negative y divided by y is going to be negative 1. Close parenthesis equals negative 3s minus 2. Alright, so I need to divide both sides by s minus 1. So I have y equals negative 3s minus 2 over s minus 1. Alright, now I need to replace y with inverse function. It's going to be negative 3s minus 2 over s minus 1. Alright, so now I need to find the domain and range of this one. So this is domain and range. This actually is right here, right? The domain of this one should be the range of this one, right? So all real number except 1. The range of this one will be the domain of the original. So it's going to be all real number except negative 3. Alright, now I'm going to check to see if it's right. Now domain. So in order for a function to be defined, denominator must be different from 0. So have s minus 1 different from 0. So s different from 1, right? So it's exactly all real number except 1, right? Now, the range, which means I need to get rid of the horizontal asymptote. When you write the inverse function, it's going to be something like this. The vertical asymptote is equal 1, so it could be right here. And the horizontal asymptote is going to be negative 3, right? So it's going to be something right here. Alright, so the graph should be something like this. Alright, so we need to find the range, which means all real number except the horizontal asymptote, right? The range, you're going to go from bottom to top, so the graph keeps going down, and this guy keeps going up, right? And the graph never touched the horizontal asymptote right here. So it's going to be all real number except negative 3, right? So it could be right here. Now let's move on to the second example. Alright, so I need to find the inverse function of this one. Before I do this one, I need to find the domain and range of the original function, right? So domain, which means denominator different from 0, right? So s minus 3 different from 0, s different from 3, right? S minus 3 not equal to 0, s not equal to 3, right? So it will be all real number except 3. Now, the range. You look at this one, this is a rational function. The degree on the numerator is 0, less than the degree on the denominator, right? So the horizontal asymptote is y equal to 0. So it can be a real number except 0, right? Okay, so I need to find the inverse function, right? So the first step you need to do is to replace g of s with y. So y equals 1 over s minus 3. Now I need to swap s and y. So this guy y becomes s. This guy becomes 1 over y minus 3. Now I see the denominator. I need to get rid of the denominator. So I multiply both sides by y minus 3. This guy y minus 3. Alright, so this guy right here cancel out. Now I need to multiply this one. So it will be sy minus 3s equals 1. Now anything related to y value, I move to the left. right? And anything not related to y value, I move to the right. So when you move a terms from this side to another side, you need to change the sign of the terms. All right. So sy, I just rewrite this one. Negative 3s move to the right. This turns out to be 3s plus 1. All right. Now I need to solve for y. I need to divide both sides by s. So it will be y equals 3s divided by s. It will be 3 plus 1 divided by s. It will be 1 over s. Oh, you can rewrite this one as 3s plus 1 divided by s. That's fine. Okay. So look at this one. You see that the horizontal asymptote is 3, right? Horizontal asymptote is going to be 3. The vertical asymptote is going to be s equal to 0. This is y equals 3, right? Now the domain. This is the range right here. This is the domain right here. So range is going to be all real number except 3, right? And the domain right here is going to be all real number except 0, right? So we look at this one right here. We see that they are swapped, right? Domain becomes range. And then the range becomes domain right here. Okay? Now let's move on to the next example. We need to replace f of s with y, right? So I have y equals square root of s minus 3 plus 2, right? Now we need to swap s and y. So it can be s right here, and then this guy becomes y minus 3 plus 2, right? Now I need to solve for y, so I need to isolate y. So in order to do that, I need to get rid of 2 right here. So I subtract 2 both sides. So I'm going to rewrite this one as s minus 2 equals square root of y minus 3. So I need to flip this one. So it could be square root of y minus 3 equals s minus 2, right? Now I need to square both sides, right? So it could be, if I square the left hand side, the radical side is gone. So I have y minus 3. And then I need to square the right hand side. It could be s minus 2 altogether square, right? So then I need to solve for y. It's going to be y equals s minus 2 altogether square plus 3. All right. Now if we wrap this one, it's going to be something like this. This graph comes from the parent function of the quadratic function. Shift to the right 2 units and shift up 3 units. All right. So this is 1, 2, and this is 1, 2, 3. So it could be somewhere right here. So the graph should look like this. So this is the inverse function. It could be f inverse of s right here. Right, so I replace y with f inverse of s equals s minus 2 altogether square plus 3. Right, this is my answer. So the domain is going to be all real numbers, right? Because this guy keep going further to the left, this guy keep going further to the right. So the domain is to be all real numbers. Now the range, we're gonna go from bottom to the top. So this is the minimum value. Minimum right at 3 right here. So it could be 3 all the way up. So it could be y greater than or equal to 3. Or you can write at the interval notation. It could be bracket 3 comma infinity, and this is the range. Now let's move on to the next example. Right, we need to find the inverse of each functions. Now let's move on to the next example. We need to find the inverse of each function and list the domain and range of the inverse function. So the first one is going to be f of s equals s minus 3 altogether cube plus 4, right? All right, so the first thing you need to do is to replace f of s with y. So it will be y equals s minus 3 cube plus 4, right? And then you just swap s and y, right? So this is s equals y minus 3 cube plus 4, right? And then you need to get rid of 4 to isolate y, right? So it can be s minus 4 equals y minus 3 cube. Now take cube root both sides. So it can be cube root of s minus 4 equals y minus 3, right? Now I need to get rid of negative 3. So it can be cube root of s minus 4 plus 3 equals y. Alright, so I just flip this one. So it will be y equals cube root of s minus 4 plus 3, right? Now I need to replace y with f inverse, so it will be like this, equals cube root of s minus 4 plus 3, right? We need to find the domain of this one. So now you see that the expression under the radical sign is going to be s minus 4, right? But this is a cube root, so you can take cube root of any number, right? 0, positive or negative, it doesn't matter. You still get the answer. So the domain should be all real numbers, right? Now the range. So this guy right here always defined. So the range should be all real numbers. And if you use a calculator, you grab this one, you see that it takes all real numbers. Now let's move on to the next one. If I have f of s minus 4 equals negative 4 times s plus 2, right? So the first thing I need to do is I replace f of s with y. So I have y minus 4 equals negative 4 times s plus 2, right? Now I need to swap s and y. So this y becomes s minus 4 equals negative 4 times y plus 2, right? So I need to isolate y. So how do I do this one? Right, I need to distribute this one first. So I have s minus 4 equals negative 4 times y, it could be negative 4y. Negative 4 times 2 is going to be negative 8, right? Now next one, I need to isolate y. So in order to do that, I need to divide both sides by negative 4. So I have s minus 4 divided by negative 4 equals y plus 2. Alright, so I need to get rid of 2. I need to subtract 2 both sides. So it will be s minus 4 over negative 4 subtract 2 equals y. Now I need to simplify this one, right? So how do I do this one? So it's going to be I rewrite y equals s minus 4 over negative 4 minus 2. Alright, so it can be y equals, you have the common denominator negative 4. So I multiply this one by negative 4. So it can be s minus 4. Negative 4 times negative 2 is going to be 8. So I plus 8. And I write everything under negative 4 like this. So y equals s plus 4 over negative 4. Now I need to write this one in the slope-intercept form. So it can be y equals, check each of the terms divided by negative 4. So it can be negative 1 over 4 s. 4 divided by negative 4 is going to be negative 1, like that. And I replace y with f inverse. It's going to be negative 1 over 4 s minus 1. And this is the linear function. Domain and range should be all real numbers. Okay, so domain, range, right here, all real numbers. Alright, now let's move on to the next one. Now if the function is increasing or decreasing only, then it is invertible. If the graph turns, which means it has a maximum or minimum, then it is no longer invertible because there will be the output values that are the same for different input values. Alright, in other words, if the original graph passed the horizontal line test and then it has an inverse. So for example, if you have the graph like this, okay, then this function has an inverse because you draw a horizontal line test. You see that the horizontal line intersects the graph as 1 point only. And then its inverse will pass the vertical line test. The second example is going to be like this. Alright, this has an inverse or it is invertible. Now let's move on to the next example. If the function has an inverse, then the original function and the inverse must be reflected over the line y equal x. Alright, so basically you need to sketch the line y equal x. It's going to be like this. So this is y equals ask. And this guy, y equal s right here. Okay, and you see that the function on the left, this is decreasing function, right? So this is decreasing function right here, and the one on the right, this is increasing function. So it could be right here. So both of them have an inverse, right? Now you just reflect this guy right here, right, over the line y equal s, right? So the coordinate of this point is going to be -3 and 1, right? So it turns out to be this guy -3, 1. So it turns out to be 1, -3. So it's going to be right here. And this guy right here is going to be 2, -3. So it turns out to be -3, 2. So it's right here. Now you pick the point right here. It's going to be -1, 0. So it turns out to be 0, -1. So it could be right here. Now you pick the points right here. It's going to be 1, -1. So it turns out to be -1 and 1. So it's going to be right here. And then you just connect them. Alright, so you just connect them, and if you sketch the graph, it should be something like this. Now you do the same process for this one. Right, so the point right here, 2, 3 becomes 3, 2, right? So 3, 2 is going to be right here. This guy right here, 1, 0 becomes 0, 1, so it could be right here. This guy, -2, -1 becomes -1 and -2, so it could be right here. And the last point, this guy, -3, -4 becomes -4 and -3, so it could be right here. Alright, so you just get this one. And again, the domain and range of the original function and the inverse will be swapped, alright? Which means the domain of original function right here is going to be from -3 to 2 right here, right? Right, the endpoint right here. -3, so domain is going to be close bracket -3, 2. And the range is going to be -3 to 1 right here. -3 to 1, right? So this is from original function. Now, the inverse, you just swap this one. So the domain, you're going to take -3, -3, 1. And the range, you're going to take -3, -3, 2. And then you look at the graph right here, you see that this is exactly right here. -3, 2 and -3, 2, 1 right here. Right? You do exactly the same thing for this one. So this guy, the domain, -3, 2, 2. This guy becomes the range of the inverse. So the range of inverse is going to be -3 to 2 right here. Right? The range of this one is going to be -4 to 3. This guy becomes the domain of the inverse function -4 right here. 2, 3 right here. Right? So for example, if I have the function f of s equals s minus 2 square plus 5, and we have a restrict domain is going to be s less than or equal to 2. Alright, this is actually horizontal shift 2 units to the right and 5 units up from the parent function y equal s squared, right? So 2 units to the right is going to be right here, and 5 units up is going to be something like this, right? So if you grab it, it's going to be something like this. And then the domain s less than or equal to 0, so which means you only take this guy, right? And then if you find the inverse function, you need to get the line y equal s, right? So you know that this guy and this guy reflect over the y equal s. So if you grab the inverse function, so it's going to be something like this. Alright. Now go ahead, find this one. I'm going to replace f of s with y. So it could be y equals s minus 2 square plus 5, right? So I need to swap s and y. So it could be s equals y minus 2 altogether square plus 5. I need to get rid of 5, so I subtract 5 both sides. So it could be s minus 5 equals y minus 2 altogether square. Alright, so I rewrite this one. It's going to be y minus 2 altogether square equals s minus 5. Take square root both sides, so it could be minus 2 equals plus and minus square root of s minus 5, right? Now we look at this one, we have two values right here. Now we need to know which one we're gonna pick, right? So we look at the domain right here. Domain tells us that if this function has an inverse, and then the domain right here becomes the range of the inverse function. So the range of the inverse function is gonna be the one on the right hand side right here. Alright. So basically s less than equal to 2 is the same thing as y less than equal to 2, right? So I have y less than equal to 2. I subtract 2 both sides, so I have y minus 2 less than or equal to 0. Alright, so the left hand side right here less than equal to 0. The right hand side right here must be less than equal to 0. That's why I picked the negative side. So from here I have y minus 2 equals negative square root of s minus 5. Right, so I'm going to add 2 both sides. So it will be y equals square root of s minus 5 plus 2. This is my answer. So I just replace y with f inverse, right? It's going to be negative square root of s minus 5 plus 2. And then this is my final answer. Okay, now I need to find the domain and range of this one. So keep in mind, the domain is going to be the one under the radical side right here, s minus 5 right here, must be greater than or equal to 0. So s greater than or equal to 5. So this is my domain. Now the range is going to be right here. You just take this one, but you replace s with y. So y less than or equal to 2. This is my range. Now I'm going to challenge you with this problem. You need to find the inverse of the following function and then find the domain and range of the inverse, right? So f of s equals 4s squared plus 4s plus 5, where s greater than or equal to negative 1/2, right? Now let's move on to the next example. Alright, so for example, given a function f of s with the table right here. Now let g be the inverse function of f such that g of s equals f inverse of s, right? So basically, the first thing you need to do is to get the new table. I need to switch s and y value, right? Because f of s and g of s are inverse of each other. So the domain of this one becomes the range of the other one, right? So s right here, I take every single value right here. So it could be 6, 3, 1, negative 1, negative 3, and negative 7. The g of s is going to be negative 3, negative 2, 0, 1, 4, and 6, right? Okay, now question number 1, we need to find f of f0, right? So we start from inside to outside, from right to left when we talk about the composite function, right? f of 0 is going to be equal to 1, right? So then this guy becomes f of 1, right? It's going to be negative 1. So this final answer, negative 1. Now, g of negative 3 is going to be 4 right here, right? Now, g of 6 is going to be negative 3. Now, we need to start from g of negative 1 first, right? G of negative 1 is going to be 1. And then this guy becomes g of 1 is going to be 0. So the final answer is 0. Now, this one, we need to start from f of negative 2 first. So f of negative 2 is going to be 3. Alright, so we rewrite this one as f inverse of 3, right? F inverse of 3 is the same thing as g of 3, right? Because f inverse which means the g function, right? So g of 3 is going to be negative 2, right? Now this one, f inverse of negative 3, which means g of negative 3, right? G of negative 3 is going to be 4. Now let's take a look at this one right here. The function k is given. The domain is going to be negative 4 to 11. And then k inverse represents the inverse of k. Now they ask you what is the minimum value of ks. The minimum value, which means the y value, right? So we look at this one right here. The minimum right here is going to be -3. So it's going to be -3 here. The minimum value of k inverse, which means the minimum of range of k inverse, right? Means the domain of the function k. So the range of k inverse is going to be -4 less than equal to y less than equal to 11. It's going to be right here, right? So the minimum value should be -4 right here. Now we need to find the k inverse of z, right? K inverse of z. So we look at this one right here. K inverse of z, which means the y value of the original function. So the y value sits right here, right? And we find the coordinate point. It's going to be 11, right? So this guy equals 11. Now k inverse of 4, which means 4 is the y value of original function. So 4 right here. Okay, we project down right here, and the s value should be 6. So the answer is 6. Now we need to prove that if two functions f of s and g of s are inverse, if and only if f of g of s equal s and g of f of s equal s, right? So to show that two functions are inverse, we must show that the f inverse of f of s and f of f inverse of s right here both equals s. Alright, so let's take a look at the example. For example, I have the function f of s equals 2s minus 3, and the function g of s is going to be 1/2 s plus 3/2, right? So I need to prove that the function f of s and g of s are inverse. So I'm going to start with f of g of s, right? So I rewrite this one f of, right? G of s is going to be right here, right? So instead of g of s, I put 1/2 s plus 3/2, right? Now I'm going to substitute this guy right here for s into this function. So it turns out to be 2 parentheses times 1/2 s plus 3/2 close parentheses and minus 3, right? Instead of s, I put this one, okay? So I distribute this one 2 times 1/2 s, which means s, 2 times 3/2, which means plus 3, and then subtract 3 right here. So the answer is s, right? So I'm good right here. Now I need to check the other side. So I have g of f of s is going to be, I rewrite function g. So f of s is going to be 2s minus 3, right? So now I need to replace s right here with 2s minus 3. So it's going to be 1/2 parentheses 2s minus 3. And then I'm going to add 3/2 right here. You see that? Alright, so I distribute 1/2. So 1/2 times 2 is going to be s right here. 1/2 times -3 is going to be -3/2 plus 3/2. So it's going to be s, right? Now you need to conclude since f of g of s equals g of f of s equals s, then f of s and g of s are inverse. Now let's move on to the next one. For example, I have the function h of s equals s squared plus 10, and the function k of s is going to be square root of s minus 10. I need to prove that this guy and this guy are inverse of each other. Okay, so this guy must have the domain s greater than or equal to 10, right? So I start from h of k of s, right? So I need to rewrite h function, right? So instead of k of s, I put square root of s minus 10, right? And then h of s equal s squared plus 10. Now h of square root of s minus 10, I replace s with square root of s minus 10. So it will be parentheses square root of s minus 10 square plus 10. Alright, so when I square this one, I don't need to put this one inside the absolute value because I have the domain right here. Okay, so it will be, I remove the radical sign. So s minus 10 plus 10. So it will be s. Now, k of h of s equals the function k. Now, h of s is going to be s squared plus 10 right here. Okay, so the function k is going to be right here. So I just rewrite the radical sign right here. Alright, now, instead of s, I put s squared plus 10. Right, and then I subtract 10 right here. So it's going to be square root of s squared, right? So because s greater than or equal to 10, so which means positive, so I just remove the radical sign, it turns out to be s, right? So since this one equal s, this one equal s, so they both inverse. Now let's move on to the next one. So for example, I have the function n of s equals 6 over s minus 4, and the function p of s equals 6 over s plus 4, right? Now I need to restrict the domain. The domain of this one should be s different from 4, right? And domain of this one s different from 0, right? Because if s equal to 0, this one undefined, right? Alright, so now I need to evaluate n of p of s first, right? So I rewrite the function n of s, right? It's gonna be n, and then p of s, I rewrite this one. So it can be 6 over s plus 4. Alright, so the function n of s right here. So it's going to be what? 6 over s right here, which means 6 over s plus 4, right? So I replace this one with 6 over s plus 4. And then I need to subtract 4 right here. Alright, so 4 and negative 4 cancel out. Alright, so it's going to be 6 over s. Right, so I 6 divided by 6 over s, which means I need to flip this one. So it could be 6 times s over 6. 6 and 6 cancel out, so the answer is s. Now, I'm going to start with p of n of s. So it's going to be, I rewrite the function p, right? Now, n of s is going to be right here. So 6 over s minus 4. Alright, now I need to substitute this one into the function p right here. So the function p is going to be 6, right, over s, but s equal this one right here. So I just write 6 over s minus 4, right, and then plus 4 right here. This guy right here is the main fraction, okay? So this one right here, I just flip this, so it turns out to be 6 times s minus 4 over 6 plus 4, alright? So 6 and 6 right here cancel out. So I have s minus 4 plus 4, and it's going to be s. So this guy and this guy, they are inverse. Let's move on to the last example. For example, I have the function f of s equals q root of 3 minus s, and the function g of s equals s q minus 3. Now I need to prove this guy and this guy are inverse. So I start from f of g of s. I rewrite the function f, and then the function g of s I replace with s q minus 3, right? It's right here. Alright, so now the function f is going to be q root of 3 minus, right, minus s, but s equal this guy right here. So I should replace this one. Don't forget parentheses, q minus 3. Now I rewrite q root of, if you don't see anything, which means negative 1. So negative 1 times sq is going to be negative sq. Negative 1 times negative 3 is going to be plus 3. This guy equals q root of 6 minus sq, right? So this one not equal to s, right? We need s. Now I'm going to check the other one. I have g of f of s Alright, so I have g of f of s, which means cube root of 3 minus s, right? So the function g right here is going to be s cube, but s equal this one, so it's going to be cube root of 3 minus s right here, all together cube right here, right? Minus 3. So it turns out to be, so this one cube turns out to be 3 minus s, and then minus 3 right here. So 3 minus 3 is going to be 0, so it's going to be negative s. Alright, so the first one right here equal this. The second one equal negative s. They are different, so this is, they are not inverse. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals that take us higher. The night's young and it's just begun as she puts her hand in mine.
We're going to learn how to identify the inverse of exponential functions. Actually, the inverse of exponential functions are logarithmic functions. Alright, so first we need to know how to identify the exponential functions and logarithmic functions given the tables. Alright, so in order to identify the exponential functions, we're going to look at the input and output. If the input values are changing additively, while the output values f of s changing multiplicatively, and then that is the exponential functions. Conversely, if the input values s are changing multiplicatively, the output values f of s are changing additively, which means equally spaced, and then that is logarithmic functions. Now let's take a look at the few examples. Now let's take a look at the first one. You see that the s value increasing by 1 each times. The y values multiply by 1/2 each times. So based on the definition of exponential function right here, this is actually the exponential function. Alright, let's take a look at the second one right here. We see that the s values multiply by 2 each times to get the next value, right? The y values increasing by 5 each times, which means you're going to add 5 each time to get the next value. So this is the logarithmic function. Now, let's take a look at the first one right here. We see that the s values multiply by 10 each times to get the next value. The y values multiply by 3 each times to get the next values. So this is neither. Now the last one. The s values multiply by 3 each times to get the next value, right? The y values add in negative 5 each times to get the next value, right? So this is the logarithmic function. Now let's move on to the next example. Given two functions, f of s equals 5 to the s, and the function g of s equals log base 5 of s, we need to prove that two functions right here are inverse of each other. So based on the properties right here, we need to prove this one. Okay, so keep in mind the base of the exponential function right here must be the same as the base of the logarithmic function right here. So they are inverse of each other. Keep that in mind when you do the multiple choice questions. Alright, so look at this one. So I'm going to start from here first. So I'm going to start from f of g of s. Alright, so this one the same thing as f of g of s equals log base 5 of s. So I just put this guy inside parentheses. Log base 5 of s. Now, this one is the same thing as, now I look at the function f of s, it's going to be right here. So I just rewrite 5 right here, right? Now you see that this is s, this is s. Now this is log base 5 of s, and then this guy must be log base 5 of s. Alright? Now, we learned before, we know that a to the log base a of s equals s. Keep that in mind. This guy right here and this guy right here must be the same to apply this formula. Alright, so this guy equals s, right? Because phi and phi right here should be the same. So I just prove the first guy right here. This guy equals this guy. Now I need to prove the second one. So I start from g of f of s right here equals g of, I'm gonna replace f of s with phi to the s right here. So I put phi to the s. Alright, so the function g is going to be right here. So I just rewrite log base phi right here. Now you look at this one, this is s, this is s. Now this is phi to the s. This guy must be phi to the s. Alright, again, you learned before. If you have log base a of a to the s, alright, so you just print s to the front. So it's going to be s log base a of a. But log base a of a right here equal to 1. So the answer is s times 1, which means s. Alright, so based on this formula right here, phi and phi right here should be the same, right? So the answer must be s. Now, since this guy equal s, this guy equal s, so I can conclude that f of g of s equals g of f of s equals s. So the function f of s and g of s are inverse of each other. Now let's move on to the next example. So suppose I have the function y equals phi to the s, and I'm going to ask you to sketch the inverse of this function. Alright, so based on the property of the inverse of the function f and f inverse, the line y equals s is an axis of symmetry of inverse functions. Alright, and if the point a and b belong to the graph y equals phi to the s, and then the point b a will belong to the inverse function of this function. Alright, so the first thing I need to do is I need to sketch the axis of symmetry. So the axis of symmetry is y equals s passing origin and split the first quadrant and the third quadrant in half. So it's going to be something like this. Alright, next one, I need to find a point on the original function. So you see that the y-intercept of this function is going to be 0, 1. And then the point on the inverse function should be 1, 0, right? So it's going to be right here. Alright, next one, I need to find another point. So the point's right here. I get this one right here. It's going to be 1, 5. And then it turns out to be 5, 1. So it's going to be right here. Now I just sketched the rough draft of this inverse function. Alright, so what do you learn from the original and the inverse functions? Now the first thing I learned, the y-intercept of this function, it's going to be 0, 1. This one becomes the s-intercept of these logarithmic functions, which means s-intercept is going to be 1, 0. Now the second thing I learned is the asymptotes of this function, which means the s-axis right here. You see that, right? The equation of the s-axis is y equal to 0. So you need to know these terminologies right here, just in case you see this one on the exam. You should be able to identify the correct answers. Alright, the asymptotes of this guy is y-axis, which means s equal to 0. Now the third one I learned is the limit of this function. Alright, the limit of the function, I call this one is f of s, and I call this one is g of s. So the limit of the function f of s when s approaches positive infinity equals, you see that s approaches positive infinity, right? This one is positive infinity, this is positive infinity, this is negative infinity, and this one is negative infinity. Alright, so when s approaches positive infinity, which means s go to the right, the function keeps going up forever. You see that? Alright, so it's going to be positive infinitive. Now, limit of the function f of s when s approaches negative infinitive. Alright, look, when s approaches negative infinitive, which means s going further to the left, the function approaches 0 because it's getting closer to the s-axis. So this one should be equal to 0. Now for this function, the limit of the function g of s when s approaches positive infinitive is going to be positive infinitive, because when s approaches positive infinitive, the function is going up, right? So it's going to positive infinitive. Now, limit of the function g of s when s approaches 0, right? Not negative infinitive, it's 0 right here, because the function can't pass the y-axis, right? So the function g of s approaches negative infinitive because it's going down right here. You see that? All right. Now, number 4. The function f of s is concave up or concave down. All right. So when the function is concave up, it should be something like this. All right. Or half of this one, which means you're going to cut this one in half. So it turns out to be something like this or something like this. The function is concave down, it's going to be something like this. When you cut this one in half, it should be something like this, or like this. All right. So we look at this one, we see that the function is concave up, right? So this is concave up. Now we look at this one right here. It should be something like this right here, right? So the function is concave down. All right. Next one. The function is increasing or decreasing, right? So we look at the rate of change. In order to do that, we just sketch the tangent line. Okay, so keep that in mind. Now, here's the trick. Keep in mind, we have the Christmas tree trick. Alright, if the lines go this way, right, go up this way, the slope is positive. If the lines goes this way, the slope is negative. Alright, if the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Look at this line right here. The lines go this way, the slope is positive. And if the line is steeper, the slope is bigger. Conversely, if the line goes this way, and then if the line is steeper, the slope is smaller. Now, based on this instruction, we're going to explore the function f of s and g of s to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so we look at the function f of s right here. We just draw a tangent line. So we see that the tangent line of the functions go this way, which means the slope is positive. So the function is increasing. Alright, now we're going to see if the function increasing at an increasing rate or decreasing rate. So we keep drawing tangent line. And we see that the tangent line is getting steeper and steeper, which means the slope is bigger and bigger. So the function is increasing at an increasing rate. Now we look at the right hand side right here, the function g of s. Alright, so we still draw the tangent line. And we see that the tangent line still go this way. So the function is increasing. Now, the function is increasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that if we draw the tangent line right here, we see that this guy right here is steeper than this guy. And then we see that the line is getting less steep, right? Then the function is increasing at a decreasing rate. Now, let's move on to the next question. Now, I still use this graph, and if the questions ask you to approximate the value of log base 5 of 2 using this graph right here. Alright, so we look at this one right here, the formula is going to be log base 5 of s right here. And then we need to approximate the value of log base 5 of 2. Alright, so which means s right here equals 2. Alright, so we look at this one, and then the function g of s, which means the log base 5 of s right here. So we're going to use this guy right here. Alright, we use the function g of s right here. Alright, so s equal to right here, and then I project down to the x-axis and the y-axis right here. And I see is that the function log base 5 of s when s equals 2 is going to be approximately 0.4. Now let's move on to the next example. Given a function k of s equals a to the s, passing 2, 3, and 6, 27. We need to find the arbitrary chain of the function m of s equals log base a of s on this interval 3, 27. Now first we observe that this guy's the base is a, this is a, and this is s, which means the function k of s and m of s are inverse of each other. So since two functions are inverse of each other, the domain of this function will become the range of the other function. So this guy right here, the function log base a of s right here, will pass the point. This is 2, 3. This turns out to be 3, 2. Alright, this guy 6, 27 turns out to be 27, 6. Right? Alright, so we have the formula of the rate of change is going to be f of b minus f of a over b minus a. Alright, so we look at this one right here. This guy right here is a, f of a. This is b, and then this is f of b. In this situation, it's going to be m, right? Right here, the function m. So we just replace f right here with m. Alright, so keep that in mind, the function m. So we have m of b minus m of a over b minus a. And we just plug it in. M of b right here equals 6 minus m of a, which means 2, over b, which means 27, a, which means 3. Alright, we just simplify this one. 6 minus 2 is going to be 4. 27 minus 3 is going to be 24. And we simplify this one, it turns out to be 1, 6. Alright, so let's move on to the next example. Given the function f of s equals 2 times log base 2 of s, and the function g of s equals 2 power of 2 of s. Now, we need to determine if the function f of s and g of s are inverse of each other. Alright, so in order to do that, we need to use the formula right here. Alright, so first I'm going to start from f of s of f of g of s, right? It's going to be the same thing as 2 times log base 2 of s. But in this situation, s should be g of s, right? So I put parentheses right here. 2 power of 2 of s. Now we apply the formula right here. Alright, for this one. So it turns out to be 2 times 2s. It's going to be 4s. Alright, the bottom one right here, we're going to have g of f of s. It's going to be 2 to the 2. Now we need to replace s with f of s, which means this guy's multiplied by 2 log base 2 of s, right? So we're going to simplify this one. So it turns out to be 2 to the 4 log base 2 of s. And then I apply the formula right here. Alright, I can print k back over here. Alright, so I have 2 power of log base 2 of s, and then power of 4 right here. And then I'm going to apply the formula right here, the first formula. And then the answer must be s power of 4. Now we look at this one right here. This is 4s and this is s power of 4. They are not the same, and they're not equals s right here. And then the function f of s and g of s are not inverse of each other. Now let's move on to the next example. So I have the function f of s equals 10 to the 0.25s and g of s equals 4 log s, right? I need to determine that if f of s and g of s are inverse of each other. Alright, so I'm going to start with f of g of s equals 10 to the 0.25. Now s value right here, I need to replace with 4 log s, right? So it's going to be multiplied by 4 log s, right? Now I need to simplify this one. So it turns out to be 0.25 times 4, which means 1, right? So I have 10 to the log s. Alright, so I know that if I just write log, which means log by 10, so I just rewrite this one as 10 log by 10 of s. So I look at this one, this guy, the same thing right here. I apply the first formula right here. So the answer must be s. Alright, now let's move on to the next one. G of f of s equals the function g right here. This could be for log s, but s equals f of s, right? So I just replace s right here with 10 to the 0.25 s. Alright, so this guy turns out to be for log right here, there is no base, which means base 10, right? So I just write log base 10 of 10 to the 0.25 s, right? Alright, so I'm gonna apply the formula right here. Alright, so the answer for this guy right here equals 4 times 0.25 s, right? And then this guy equals s, right? Because 4 times 0.25 equals 1. So both of them equals s. So then this guy and this guy right here are inverse of each other. Now let's move on to the next example. We need to find the inverse of this function. Alright, so this is the exponential functions. So by the definition right here, the inverse of this function must be the logarithmic function, right? So our goal is we need to find the inverse. Alright, so we have h of s equals 4 to the 5s. Alright, so we learned before. In order to find the inverse of the function, we need to replace h of s right here with y. Alright, so y equals 4 to the 5s right here. Alright, now next one, we need to swap s and y. So this guy turns out to be s. And then this guy turns out to be y. So 4 to the 5y right here. Okay. So next one, we look at the base right here. Alright. We see this is 4. And our goal is to find the inverse of this function. It turns out to be the log function, right? So we need to take a log base for both sides because the base right here is 4. And remember that the exponential functions and the logarithmic functions, if they are inverse of each other, they must have the same base. Alright. So I'm going to take log base for both sides. So I have log base 4 right here. And this guy's log base 4. Now I just fill in this one. So it's s equals 4 to the 5y. Alright. So I'm going to apply the formula right here. Alright. For this guy right here. So what do I have? I have log base 4 of s. I just rewrite. This one turns out to be 5y. Alright. Now I need to solve for y. I divide both sides by 5. So I have y equals 1 over 5 log base 4 of s, right? And then this guy right here, I just replace y with h inverse of s equals 1 over 5 log base 4 of s. And this is the answer. Now let's move on to the next example. For example, if I have a function m of s equals 5 times log base 2 of s. Alright, so I need to find the inverse of this function. And given the logarithmic functions, the inverse must be exponential, right? So that is my goal. And you look at this one, the base right here, 2, right? So the exponential function must have the same base, right? So this is the base 2, alright? Now, we start from here. Alright, so we have this is ms, we just put this is y equals log base 2 of s, and this is 5 right here, right? Now we just swap s and y, so it's going to be s equals 5 log base 2 of y, right? So we look at this one, we see the number 5 in front of log, so we need to eliminate number 5 first. Alright, in order to do this one, I just bring this one back over here. I use the formula right here. Alright, so it turns out to be s equals log base 2 of y power of 5, like that, okay? The reason why, because I need to apply the first formula right here, right? I'm going to turn this one into the exponential both sides with the base 2. So I put the base 2 right here, the base 2 right here equals right here. Alright, so I put this one as exponent, right? As, and this guy as exponent. Log base 2 of y power of 5. Because the exponential function and the logarithmic functions have the same base. This is 2, this is base 2. I need to create base 2, okay? So, for the right hand side right here, I'm going to apply the first formula right here, this guy. So it turns out to be 2 to the s equals y to the fifth, right? Okay, now I need to solve for y. So I need to raise to the 1/5 both sides. So it's going to be 2 to the s all together power of 1 over 5. Alright, equals y, right? Because y power of 5 raised to the 1/5. And then 5 right here cancel out. The answer must be y. That's why we have this one. Alright, so this one I'm going to multiply the power. So it's going to be y equals 2 to the s over 5. Now I need to replace y right here with m inverse, right? So I have m inverse of s equals 2 to the s over 5. And that is the inverse function of the original function. Now let's move on to the next example. We need to find the inverse of this function right here. Alright, so this is the logarithmic functions. So our goal should be the exponential. Right? And then I see the base right here, 8. And then the base of exponential must be 8. Now I need to swap s and y, right? So I have s right here equals 1 4 log base 8 of y, right? And then what I'm going to do next is I need to eliminate 1 4 right here, right? So in order to apply the formula right here. Alright, so I need to multiply both sides by 4. So it's turned out to be 4s equals log base 8 of y, right? And my goal should have the base 8 in the exponential function, right? So I need to take base 8 both sides, right? Of 4 to the s, and this is of log base 8 of y, alright? Now I need to apply the formula right here. So the left hand side should be a to the 4s. The right hand side should be y. So I need to rewrite this one as y equals a to the 4s. And then I need to replace y with f inverse, right? Of s equals a to the 4s. And that is the answer for this question. Now let's move on to the next one. We need to find the inverse of these exponential functions. Alright, so this is exponential function with the base 10, right? So our goal is the logarithmic function, right? And then the base right here, 10, and then this guy must have base 10 right here, okay? So the first thing I need to do is I replace t of s with y, right? So y equals 10 to the 3 over 4s. Alright, next one, I need to swap s and y. So this guy is s. This guy 10 to the 3 4y. Alright, so now I see the base 10 right here, and I need to take log base 10 both sides, right? So I have log base 10, and this is log base 10. Alright, so I need to rewrite everything. So this is s, and this is 10 to the 3 over 4y. Alright, so for this guy right here, I need to apply the formula right here. Okay, so it turns out to be log base 10 of s equals 3 over 4y. Alright, so I'm going to multiply both sides by 4 over 3. So it turns out to be y equals 4 over 3 log base 10 of s. And we learned that log base 10, we just write log, right? So y equals 4 over 3 log s like this, okay? And we just replace y with t inverse of s equals 4 over 3 log s. Topics 2.3, 2.10, and 2.11. Exponential and logarithmic graphs. Before we dive into the review, let's activate Bryan knowledge. We're going to explore the end behavior and concavity of the exponential functions. So exponential function is given by the formula y equal to a times b power of s, where a is the initial value on the y-intercept, b is the common ratio. Now, a must be different from 0, b must be different from 1. Alright, so we have two different cases. If b greater than 1, this is the exponential growth. If b greater than 0, less than 1, this is the exponential decay. Now we have four different cases. The first case, a greater than 0, b greater than 1. Alright, so this is exponential growth. So the function rise from left. So it's going to be something like this. Now, the second case, a greater than 0, b greater than 0, less than 1. So this is exponential decay. So the function falls from left. Now the third case, a less than 0, b greater than 1. The function looks like this. And the last case, a less than 0, b greater than 0, less than 1. So the function looks like this. So in four cases right here, the exponential function receives the x-axis as the asymptote. Alright, so this is the x-axis. The function of the x-axis is y equal to 0. Keep that in mind. The function of the y-axis, which is x equal to 0. We're going to use decimals to demonstrate the graph of four different cases of the exponential functions. The first case, a greater than 0, b greater than 1. So I'm going to let a equal to 1 and b equal to 2. Alright, so I have the first exponential function, y equal to 1 parenthesis 2 power of x. Alright, so it's going to be like this. Now the second case, I'm going to let a equal to 1, but b equal to 1/2. So let's see how it looks like. Y equal to 1 times 1/2 power of x. Right, it's gonna be like this. So look, it looks exactly the same thing as this guys right here. Now, case number 3, a less than 0, b greater than 1. So I'm gonna let a equal to -1, b equal to 2. So the third case, y equal to -1 times 2 power of x. Right, it's gonna be right here. So it looks like this one. And the last one, a less than 0. So I let a equal to -1. And b from 0 to 1. So I let b 1/2. Alright, so I'm gonna have the last one. So y equal to -1 times 1/2 power of x. So it could be like this. Alright. Now we're gonna explore the end behavior and concavative as well as increasing or decreasing. Alright. Now, in order to explore the end behavior of the exponential function, the first thing we need to do is to put the positive infinitive on the right of the x-axis, negative infinitive on the left of the x-axis, positive right here, and this is negative right here. Alright, so limit of the function f of s. So this is the function f of s. When x approaches negative infinitive, so you see that when x approaches negative infinitive, which means x going further to the left, the function is the red line right here, getting closest to the x-axis, and as we know that the x-axis, which means y equal to 0. So the limit of the function f of x when x approaches negative infinitive is going to be equal to 0. Now b, limit of f of s when s approaches positive infinitive. So which means s going further to the right, right? And the function going up. So which is the function approaches positive infinitive right here. Alright, so it could be positive infinitive. Now next one, we need to explore to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so before we do that, let's take a look at the trick. We call this is Christmas tree trick. Alright, now if you see the lines going up from left like this is increasing, which is the slope is positive. The guys going down from left like this, the slope is negative. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Alright, so I'm going to use this Christmas tree. Now look at this one right here. I'm going to draw a tangent line to see if the function increasing or decreasing. Alright, so I keep drawing tangent line like this. And you see that it looks like this line right here, right? Right. So the function is increasing, right? Now, the function is increasing at an increasing rate or decreasing rate. So we start from here. We know that the horizontal line right here, the slope is 0. So we start from 0 and then it's getting steeper and steeper. So, right, so if it goes this way and if it's getting steeper, the slope is bigger. Alright, so which is the function is increasing at an increasing rate. Alright, now, in order to understand if the function is concave up or concave down, okay, so we look at the streak right here. So if you see a bow like this here, the function is concave up. Alright, now let's move on to the second case right here. Alright, we have the limit of the function f of s when s approaches negative infinitive. So when s approaches negative infinitive, the function approaches positive infinitive. Look, it keeps going up forever. So it's going to be positive right here. So we have limit of the function f of s when s approaches negative infinitive is positive infinitive. Now, next one, limit of the function f of s when s approaches positive infinitive. Right, so when s approaches positive infinitive, which means s going further to the right, the function getting closer to the horizontal asymptote, which is 0 right here, right? So this guy must be equal to 0. Now see, the function is increasing or decreasing at an increasing rate or decreasing rate. We just draw tangent lines, right? So we see that the tangent lines go this way, right? Which is this one right here. So the function is decreasing. Now, if we keep drawing tangent line, we see that if the tangent lines go this way, right, the steeper, the smaller slope. Alright, so this is steeper right here, and this guy getting less steep, and this guy getting less steep. Alright, so the tangent line getting less steep, and until the tangent line approaches 0, which is the horizontal line right here. Alright, so which means the function decreasing at an increasing rate, right? Because, for example, this guy equal to -5, right? This is -4, right? -3, -2, etc. until 0, right? So you see that the slope of the tangent line is increasing, right? So this is decreasing at an increasing rate. Now we need to determine if the function is concave up or concave down, right? So this is part of this guy right here, right? So the function is concave up. So the function is concave up. Alright, let's move on to number 3. Alright, so we have the limit of the function f of s when s approaches negative infinitive. So when s approaches negative infinity, which means s going further to the left, the function getting closer and closer to 0, right? So this guy must be equal to 0. Now, limit of the function f of s when s approaches positive infinity, right? When s approaches positive infinity, the function getting down to negative infinity, right? Negative infinity right here, because it keeps going down right here, right? So it's going to be negative infinity. Now, see, the function decreasing, right? Because we draw a tangent line, we see that the tangent lines go in this way, right? Which is this one right here, right? The tangent lines go in this way, so this is decreasing. Now, decreasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that the function starts at 0 right here. It keeps getting steeper and steeper, but steeper this way right here. So which means the slope getting more negative, right? So if it's getting more negative, which means the function decreasing at a decreasing rate. All right, the function is concave down. If you see something like this, all right, part of this guy, right? The function is concave down, right? So the function is concave down. Now let's move on to the last one. We need to find the end behavior of this exponential function. So limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left right here, the function getting down, right? So it's going to negative infinity right here. So it's going to be negative infinity. Now b, the limit of the function f of s when s approaches positive infinity. When s approaches positive infinity, which means s going further to the right, right? And the function getting closer to 0, right? So which is 0 right here. Now c, the function is increasing or decreasing at an increasing rate or decreasing rate. So we need to explore that one, right? So we start right here, we see that. Now we start drawing the tangent line right here, right? The tangent line right here. You see that the tangent line is getting less steep, right? And you see that the tangent line is going this way right here, right? Which means it's positive, right? It's positive, which means the function increasing. But it's getting less steep, right? Until it approaches 0, right? So the function is increasing at a decreasing rate, right? We're gonna learn about the logarithmic functions. Suppose I have the function y equals 2 to the s, alright? So this is exponential function. Alright, so we have the general form. The exponential function is going to be y equals a times b to the s, right? So in this situation, a equals 1, b equals 2, right? 2. We have two different cases of exponential function. The first case, b greater than 1. The second case, b greater than 0 and less than 1. So in this situation, b equals 2, which is greater than 1. So we're going to explore the first case, b greater than 1, right? How do we find the logarithmic function? We know that exponential function is the inverse of logarithmic function, and logarithmic function is the inverse of exponential function, right? So if both functions are inverse, they will reflect each other over the line y equals s, right? So I'm going to draw like y equals s. It's going to be something like this. Now the logarithmic function will be the reflection of the exponential function over the line y equals s. Alright, so you look at this one, the y-intercept right here, 0, 1, becomes the s-intercept right here, 1, 0, right? You're going to pick another point. This is 1, 2, and this becomes 2, 1 right here, right? This one, 2, 4, right? And this becomes 4, 2. So this 4 and 2 right here, alright? And then you just connect this point. Now, in order to find the equation of this logarithmic function, we just take the inverse of this one. Alright, so how do we do that? Right, so we just swap x and y. It's going to be s equals 2 to the y, right? And then we look at this one right here. We see the base 2. So we're going to take log base 2 both sides, right? So this guy's same thing as log by 2 of s log by 2 right here. Right, so I just fill in the blank right here. This is s and this is 2 to the y. Alright, now this one I just bring y to the front, right? So it's gonna be log by 2 of s equals y times log by 2 of 2. But log by 2 of 2 is equal 1, right? So I have y equals log by 2 of s, and y, which means f inverse of s equals log by 2 of s. So the logarithmic function has the equation log by 2 of s, and this guy y equals 2 to the s, right? Okay, so now we're gonna explore the end behavior and characteristic of these two functions, right? Now first, all right, now we need to find the x-intercept. So x-intercept is gonna be none, right? Because the exponential function right here never touch the x-axis, right? The x-intercept for the logarithmic function right here is gonna be 1, 0, right? 1, 0. Now the y-intercept for this one is gonna be 0, 1. And the y-intercept right here, none, right? Right, asymptote of this one should be the x-axis of y equal to 0. The asymptote for this logarithmic function should be y-axis, right? S equal to 0, right? The function right here is you just sketch the tangent line and you use the grid merge tree trick. So I have the grid merge tree right here. Now if the lines go in this way, the slope is positive. If the slope is positive, the function is increasing. The lines go in this way, the slope is negative, and the function is decreasing. Alright. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Right? Now, when you draw a tangent line of this exponential function, it's going this way, which means right here, the slope is positive. Right? So because the slope is positive, the function is increasing. Now, you draw another tangent line. I draw this one right here. Alright, so look at the left hand side right here. If the line goes this way, and when the line is steeper, the slope is bigger. Now look at the right hand side. If the line goes this way, if the line is steeper, the slope is smaller. Now back to this question right here. So you see that this line and this line right here, right? From bottom to top, the line getting steeper, right? So because the line is steeper, the slope is bigger, right? Which means the rate of change is increasing. For example, the slope of this one equals 3, and the slope of this one is equal 5, right? So you see that to get 5 from 3 is going to be increasing by 2, right? So the function is increasing at an increasing rate. Alright, now go to the right hand side right here. It's going to be the logarithmic function right here. So you're going to draw a tangent line. So I draw a tangent line. And I still see that the lines go in this way right here. And then the slope is positive. So because the slope is positive, the function is increasing. Alright, in order to know if the function is increasing at an increasing rate or decreasing rate, I need to draw another tangent line. So I draw another tangent line right here. Alright, so I'm going to compare the slope of this guy and the slope of this guy. So I use this one right here, right? The line is steeper, the slope is bigger, right? The slope of this line right here is bigger than the slope of this guy right here, right? So for example, this is 5 and this is 3, right? So you see that to get 3 from 5, does that mean it's going to be decreasing, right? So the function is increasing at a decreasing rate because the slope of the tangent line getting smaller and smaller, right? Now, concave. Now, if you see the bow like this, if I cut this one in half, and I only see half of this one, half of this one. So if you see 3 cases right here, and then the function is concave up, right? So you look at this one right here, the exponential function right here is similar to this one right here. So the function is concave up. Now, if you see the bow upside down like this, or you cut this one in half and you only see half like this or half like this, right? The function is concave down, and you look at this one, it's going to be on the left hand side right here. So the function is concave down. All right, the domain of this exponential function is going to be from left to right, and you see that the function keeps going up and right, up and right. So the domain should be negative infinity to positive infinity, or you just say all real numbers, right? The domain of this one, you see that the asymptote of the logarithmic function is x equal to 0 on the y-axis, right? So the function starts from 0 all the way to the right? And the graph never crosses the y-axis. So the domain should be 0 to infinity. And you don't take 0 because x equal to 0 is the vertical asymptote, right? Now the range, which means you look at the y-axis, right? And you see that the function is always above this x-axis, right? And never touches the x-axis. So the range should be from 0 all the way to infinity, right? So you have infinity right here, negative infinity right here, positive infinity right here, and negative infinity right here. All right, so the range should be 0 to positive infinity. Now the range of this one is going to be negative infinity to positive infinity, because the graph keeps going up, right, and going down, right? So the range should be negative infinity, positive infinity, right? And you know that because the exponential function and logarithmic function, they are inverse, so the domain of this function will be the range of the other function, right? You just grab it. The limit of the exponential function f of x when x approaches negative infinity, right? This is called left limit. All right, so when x approaches negative infinity right here, the function approaches 0. It never touches the x-axis, right? So this guy should be 0 when x approaches negative infinity. Now when x approaches positive infinity, right, x go to the right, and the function keeps going up forever, right? So this guy, this should be right limit. All right, so the function of f of x when x approaches positive infinity is positive infinity. Now take a look at the logarithmic function right here. So we need to find the left limit and the right limit. So left limit right here and right limit right here. Now left limit, the limit of the function f of x when x approaches 0 plus. So keep that in mind, 0 plus, which means 0 from the right. So when x approaches 0 plus, the function approaches negative infinity, right? 0 plus, so it could be somewhere right here. So you see that the function approaches negative infinity because it keeps going down. So this guy negative infinity. Now, the right limit. Limit of the function f of x when x approaches positive infinity. The function approaches positive infinity because it keeps going up, right? So this guy positive infinity. Now let's move on to the second case of exponential function. Now in this situation, I'm going to let y equals 1/2 to the s. So in this situation, b greater than 0, less than 1. And this is a decay function, right? Now I need to get the inverse of this exponential function. So it should be logarithmic function. So I need to sketch the line y equals x, and both exponential functions and logarithmic functions reflect over the line y equals x. Alright, so this is the logarithmic function. Now, in order to find the logarithmic function, I'm gonna rewrite the exponential function y equals 1/2 to the x, right? So I just grab x and y. So it turns out to be x equals 1/2 to the y, right? I look at the base right here, it's gonna be 1/2. So I take log base 1/2 both sides, right? So I have log base 1/2, and this is log base 1/2, right? So I put s right here, I copy everything down. Alright, so this one I just print y to the front. So it's gonna be log base 1/2 of x equals y log base 1/2 of 1/2. Alright, so I know that this guy equals 1, right? So finally we have y equals log base 1/2 of x, and let's just change this one into inverse of x equals log base 1/2 of x, right? So the function right here, log base 1/2 of x, right? All right. Now the exponential function, the x-intercept is none, right? The x-intercept for the logarithmic function is going to be 1, 0. The y-intercept for the exponential function is going to be 0, 1. And then this guy, none. The asymptote, this guy, exponential function has the x-axis. So x-axis as an asymptote of y equal to 0. Right? The logarithmic function, the asymptote is the y-axis of x equal to 0. Now, look at this one and use the Christmas tree trick, right? I'm going to draw tangent line. So I draw a tangent line like this. And let's see that the lines go in this way. So the slope is negative. The slope is negative, the function is decreasing, right? So decreasing. Now, I draw another tangent line to see if the function is decreasing at an increasing rate or decreasing rate, right? So I draw the next tangent line right here. Now I compare the slope of this guy and this guy. I see that the line less steep, right? The line less steep, the slope bigger. You look at this one, this guy and this guy right here. This guy right here is steeper than this guy. So the slope of this guy is smaller, right? For example, this guy's slope is -5, right? Because it's going this way. The line steeper, the slope is smaller. And this guy is -3. Right? So from -5 to -3, it's going to be increasing, right? So the function is decreasing at an increasing rate. All right? Now, look at this guy right here. So I draw the tangent line right here. And I see that the lines go in this way, which means the slope is negative. The slope is negative, the function is decreasing, right? Now, next one, I draw the second tangent lines of this graph right here. And I compare the slope of two tangent lines right here. I see that the tangent lines right here is steeper than this one. So if the tangent line is steeper, the slope is smaller, right? So this guy right here, for example, this guy right here, -6, and this guy is -2. You see that? And then, all right, so you see that from -6 to -2, this is going to be increasing. So the function is decreasing at an increasing rate. Right, look at the exponential function right here. We see that the function is concave up because it has this guy, right? So this is concave up. And the logarithmic function is also concave up. Now the domain, right? This guy keeps going further to the left. This guy keeps going further to the right. So the domain right here should be -infinitive to positive infinitive. The domain for this guy is right, is from 0, right? Because the function never crossed the y-axis. So it could be from 0 to positive infinitive, right? Now the range right here, look at the exponential function right here. It's above the x-axis, so the range should be from 0 to infinitive. And the range for the logarithmic function right here is going to be -infinitive to positive infinitive, right? Oh, it keeps going down and this guy keeps going up. Now, the left limit and the right limit. So, left limit. Look at the exponential function right here. Limit of f of s when s approaches -infinitive is positive infinitive because the function is going up forever, right? This guy positive, this guy -infinitive, this guy -infinitive, and this guy positive infinitive. Now, the limit of the function f of s when s approaches positive infinitive, right? And then the function approaches 0, right? So it's 0 right here. Now, the left limit and the right limit of the logarithmic function. So the left limit of the function f of s when s approaches 0 plus the function approaches positive infinitive, right? 0 plus right here, the function is going up forever. Now, the right limit, the limit of the function f of s when s approaches positive infinity. The function approaches negative infinity because it keeps going down forever, right? When s approaches positive infinity, right? Alright, so next we're going to learn how to sketch a logarithmic function. How do we know the function is going up, down, left, right? So we know that if I just write ln, which means the log base e, right? But if I just write log like this, which means log base 10, right? Now let's talk about log s, right? So log s, which means log base 10 of s, right? Alright, so let's explore 4 different cases of the graph of the logarithmic function. So the first one, this is the base case. I have log base 10 of s, so I just write log s right here. So the base case is going to be like this. Now let's recall the transformation of the function, right? It's going to be a times f of b of s minus h plus k, right? If you multiply the input by -1, the function reflects over the y-axis, right? So this guy right here, it turns out to be like this. Right? Now, the third case, if you multiply the output by a -1, alright? So the function reflects over the x-axis, alright? So original function right here, when it's reflect over the x-axis, it could be something like this. Alright, and the last case, if you multiply the input and output by a negative number, like this, and then the function reflects over the x-axis and the y-axis. Alright, so based on the transformation rule, right, we need to do B, H, A, K, right? So we need to do the horizontal dilation first, right? So we need to reflect the original function right here over the y-axis first, right? Because you multiply the input by -1. So I reflect over the y-axis. So it's going to be something like this. Alright, so from this one, I reflect over the x-axis because I have the negative side right here. Now we need to do b first and then we do a later, right? A, which means vertical dilation, right? So -1 right here, and then I reflect over the x-axis. So it could be something like this. Alright, so the final answer should be this guy, the red one. Alright, now the trick for you to memorize is you look at the side right here. Now you see that you don't see the negative side, which means this is positive and this is positive. Positive in front of the whole thing, which means y value. Positive in front of s, which means positive s, right? Positive s, so go to the right right here, this is positive s. Go to the left, this is negative s. Go up, positive y. Go down, it's negative y, right? So this go to the right, so s positive. Go up, this is positive y, right? Right here, right? Now this one right here, you see that positive y and negative s. So go over here, negative s, and go up, positive y, right? Now look at this one, negative y and positive s, right? So this is positive s and negative y, right? Because the graph keeps going down. Now this one, negative y and negative s, right? So go to the left, negative s, and go down, negative y. So the function go to the left and go down, right? Now let's move on to the next example. So given the function f of s equals log base 5 of s. Now describe the transformation of the function f of s to get the function g of s equals 3 log base 5 of s plus 2 minus 4, right? So we look at the transformation formula right here. Now we need to do the dilation first. So dilation right here, we have no horizontal dilation, right? Now we look at this one. This is the plus side. The formula is subtraction side, right? So whenever we see the plus side right here, think opposite. So first, right, the function f of s is moved to the left 2 units, right? Now next one, we talk about the vertical dilation, which means a right here. So it's gonna be vertical dilation by a factor of 3. And the last one, we talk about -4 right here, which means k right here. Vertical translation down 4 units. Alright, so how do we find the vertical asymptote of this one? You just let this guy equal to 0, right? So you have s plus 2 equal to 0. You solve for s, so s equal to -2. So your vertical asymptote is s equals -2. Now to graph this one, you know that original function log base 5 of s is going to be something like this, right? And then the new function right here is going to be vertical dilation, translation left 2 units, right? So you have the vertical asymptote right here is 0, right? So you move to the left 2 units. So you have new vertical asymptote is going to be right here. All right. And then the function is moving down 4 units and vertical dilation by a factor of 3, right? So it's going to be something like this. All right, so you need to find a new domain. So the domain is going to be from -2 to infinity, right? And the range is going to be all real numbers, right? So it's going to be -infinity to positive infinity. Alright, the function is concave down. Now, the left limit of the function f of s when s approaches -2 plus, right? -2 from the right, right? So -2 plus is going to be -infinity, right? Because the graph keeps going down. Now, limit of the function f of s when s approaches positive infinity. The function approaches positive infinity, right? Because it keeps going up forever. Or you can use the trick I showed you in the previous example, right? You look at this one, this is plus sign, and this guy is plus sign, right? When s approaches positive infinity, the function approaches positive infinity, right? To the right and up. Alright, so to do this one, we just rewrite this one a little bit. So it's going to be 3 log base 5. Alright, so we just rewrite this one in this form right here. So I just factor -1 out. So I have negative of s minus 3 plus 1, right? The first thing I need to do is to find the vertical asymptote. So vertical asymptote is going to be, I just let this one equal to 0 right here. So I have 3 minus s equal to 0. So I have s equals to 3. Alright, so the first thing I need to do is look at the trick right here. I need to do horizontal dilation. So we have no horizontal dilation, alright, because the coefficient is -1 right here. But we have the vertical reflection, right? So the function f of s reflect over the vertical asymptote, right? It's not y-axis anymore, right? This should be vertical asymptote. Now next one, we talk about the h right here, which means horizontal translation. So obviously the function moved to the right 3 units, right? Now next one, we talk about the vertical dilation right here. So vertical dilation by a factor of 3. And the last one, we talk about k right here. K equals 1, right? So this is vertical shift by 1. Alright, so now we're gonna graph this one. So we have the original function is going to be like this. The vertical asymptote is going to be 3. So this is 1, 2, and 3. 3 right here. Alright, so we draw a vertical asymptote. Alright, now we just get the new one. So the new one should be something like this. Alright, now we need to find domain and range of this one. Domain is going to be -infinity to 3 right here, right? Range, it should be -infinity to positive infinity, right? Because the graph keeps going down and going up right here. Now, the function is concave down, right? And we have the vertical asymptote as equal 3. Okay, now the end behavior. So the left limit of the function g of s when s approaches negative infinity, right? The function approaches positive infinity. Now limit of the function g of s when s approaches 3 minus, right here. This is the right limit. So it's going to be negative infinity because the function keeps going down, right? Now let's move on to the last example. So for example, I have the function g of s is negative log base 5 of s minus 3 minus 2, right? So the first thing I need to do is to find the vertical asymptote. So vertical asymptote, I let this one equal to 0. So s minus 3 equal to 0 and s equal to 3, right? So if I graph it, original function is going to be something like this, right? And then this guy's 1, 2, and 3 right here. So vertical asymptote is going to be right here, s equal to 3, right? So now I look at this one, I need to do horizontal dilation first, b. So there is no horizontal dilation, I skip this one. Next one, horizontal translation, right? So actually the function fs shifts 3 units to the right, right? Now next one, we're going to talk about the vertical dilation, right? So there's no vertical dilation, but there is reflection right here, -1, right? So it's going to be -1 in front of the output, which means reflect over the s-axis, right? And the last one, this one k equals -2. So this is the function fs shifts down 2 units, right? Alright, so if you grab it, it's going to be something like this. Alright, so for 3 different cases right here, you can use that most to check your answer. Now, let's move on to question number 1. The graph of the function f is shown above. Which of the following statements about f is correct? Alright, we know that the function f is decreasing, right? Because the rate of change is negative, right? If you draw the tangent line, it's going to be negative. Remember the Christmas tree trick, right? Right here, the slope is negative. Right here, the slope is positive, right? And the function is concave up, so the rate of change is increasing, right? Now, the function is decreasing, the rate of change is increasing. The answer must be C, right? Now let's move on to question number 2. The graph of the function g is shown above. Which of the following statements about the function g is correct? Alright, the function is concave up, which means the rate of change is increasing, right? Now we need to cross out b and d because it says the function is concave down, right? Now draw the tangent line, and you see that the slope is positive, which means the function is increasing, right? So the answer must be A. Now question 3. The logarithmic function h is defined by h of s equals -2 natural log of s, right? Which of the following statements about the function h is correct, right? Now we need to graph this one, right? So we have the parent function of the logarithmic function is going to be like this. Alright, now you multiply by -2 in front of the output, which means there is a dilation and reflection over the x-axis, right? So the final function should be something like this. Now this function is concave up, right, and decreasing, right? So the answer must be C. Now let's move on to question 4. The graph of the function k is shown above. Which of the following statements about the function k is correct? A. The rate of change of the function k is positive and increasing. Alright, so in order to know if it's positive or negative, we just draw the tangent line. And we see that the rate of change is negative, right? You just use the Christmas tree trick. This is negative, this is positive slope, right? So you're gonna cross out A and B, right? Now the rate of change is increasing or decreasing. We look at this one, we see that the function is concave up, which means the rate of change is increasing, right? So the answer is C. Now let's move on to question 5. The graph of f is shown above. Which of the following could be the equation of f, right? we know that this is the graph of the logarithmic function, right? So we need to eliminate C and D, right? Now, this is the parent function of the logarithmic function, which means there is no reflection at all, right? So the answer must be A. If the answer is B, it should be something like this. Reflect over the x-axis because we have the negative side right here, right? Now question 6. The logarithmic function L is defined by L of s equals negative 3 log base 4 of s. Which of the following pairs of statements correctly describe the end behavior of L, right? So we just get this one first, right? So we have the logarithmic function is going to be like this. Alright, now since you have the negative side right here, so there is a reflection over the x-axis, so it's going to be like this. Alright, so I need to erase this one. Alright, now I need to label positive infinitive right here. This is negative infinitive. This one is positive infinitive, and this one is negative infinitive, right? Now we're going to check the answer choice. Limit of the function L as when s approaches 0 plus, right? 0 plus, which means on the right hand side of the y-axis, right? So it could be right here. Right, the function approaches positive infinitive. This one say negative infinitive, so this is wrong, right? Positive infinitive right here. So this is wrong. Now the answer choice B, limit of the function L of s when s approaches 0 plus, it could be positive infinitive, so this one right? Limit of the function L of s when s approaches positive infinitive. The function approaches negative infinitive. Yes, that's correct, right? So the answer B is correct. Now let's move on to question number 7. Let the function h of s equals 2 times natural log of s minus 3 minus 5. Which of the following gives the domain of the function h? Find the domain of the logarithmic function. Recall that log base a of b is defined when a greater than 0, a not equal to 1, and b greater than 0, right? Now since a is e, right, natural log is the same thing as log base e, right? So we don't need to worry about this guy anymore, right? We only worry about this guy right here, b greater than 0, which is the one inside parenthesis. So s minus 3 must be greater than 0. Add 3 both sides of s greater than 3, right? So which means it's going to be from 3 to positive infinity, right? So the answer must be C. Now let's move on to question number 8. The graph of f is shown above. Which of the following statements about the function f is correct, right? Now the function f is increasing. No, the function f is decreasing, right? Because if you draw the tangent line, you see that the slope of the tangent line is negative, right? So the function is decreasing, right? So you need to cross out a and b, right? Now we need to check for the rate of change. Now because the function is concave down, which means the rate of change is decreasing, right? So the answer must be D. Now let's move on to question number 9. The logarithmic function k is defined by p of s equals 1/2 log s. Which of the following statements about the function p is correct, right? Now we need to graph this one first, right? So the function p of s can be graphed as follows. Now look at the answer choice A. The function p is increasing. Yes, because if you draw the tangent line and you see that the slope of the tangent line is positive, right? So the function is increasing. You need to eliminate C and D, right? The graph of the function p is concave up. No, this is concave down, right? So the answer must be B. Now let's move on to question 10. The value of the function k as shown in the table above at selected values of s. Determine if the function k could be linear, exponential, or logarithmic. Explain your reasoning. Now, in order to do this question, we need to determine the change in s and the change in y, right? Now, in order to get 6 from 2, we need to multiply by 3, right? This guy multiply by 3. This guy multiply by 3. The change in y is you need to add negative 2, right? This one add negative 2. And observe that the input values over the equivalent output values intervals are proportional, right? Because every single time you multiply by 3. So this is a logarithmic function, right? So this value right here. Now let's move on to question 11. The function f is defined by f of s equals 3 times natural log of s. Which of the following could be the graph of f, right? So we know that the parent function of the logarithmic function is going to be like this, right? So because you have the positive 3 right here, so which means there is no reflection, right? So the answer must be A. Now let's move on to question 12. The logarithmic function f is defined by f of s equals 2 times natural log of s. Which of the following pairs of statements correctly describe the end behavior of the function f, right? So first we need to get this one, right? So the logarithmic function is going to be something like this. Look at the coefficient in front of natural log. There is no negative side, so there is no reflection, right? So we need to label this one positive infinitive. Now the answer choice A. Limit of the function f of s when s approaches 0 plus, which means on the right of the y-axis, right? So it could be right here, right? The function approaches negative infinitive. Yes, that's correct. It's going to be right here. Limit of the function f of s when s approaches positive infinitive. The function going up, right? Positive infinitive right here. So answer choice A, correct. Now let's move on to question 13. The function g is defined by g of s equals 3 times 2 to the s. Which of the following pairs of statements correctly describe the end behavior of g? Alright, so we need to get this one first, right? So we know that the exponential function is going to be y equals a times b to the s, right? If b greater than 1, it's going to be exponential growth, right? So in this situation, b equal 2, right? It's going to be exponential growth. So it could be something like this, right? Look at the answer choice A. Limit of the function g of s when s approaches 0 plus, right? So this one is talking about the vertical asymptote, right? So vertical asymptote only apply for the logarithmic function, right? So this is exponential function. So you need to eliminate answer choice A and B, right? Now, answer choice C. Limit of the function g of s when s approaches negative infinitive. The function approaches the x-axis, right? Look at this one right here. So which means 0, right? So this one could be right, right? Limit of the function g of s when s approaches positive infinitive. The function approaches positive infinitive, right? So answer choice C is correct, right? Now question number 14. The function h is defined by h of s equals 5 times 2 over 3 of s. Which of the following pairs of statements correctly describe the end behavior of the function h? And you know that the exponential function y equals a times b to the s, right? A is positive and b greater than 0 less than 1, right? So this is an exponential decay function, right? So go ahead, get this one, right? So it could be something like this. Now let's have a look at the answer choice A and B right here. Limit of the function h of s when s approaches 0 plus, which is the vertical asymptote, right? So this one only applies for the logarithmic function, right? So we need to eliminate A and B, right? Now, answer choice C. Limit of the function h of s when s approaches negative infinitive. The function approaches positive infinitive, right? This say 0, so it's wrong, right? Answer choice D. The limit of the function h of s when s approaches negative infinitive. The function approaches positive infinitive, so this is right? Limit of the function h of s when s approaches positive infinitive. The function approaches 0, right? Because it's getting closer to the x-axis, right? So the answer choice must be D. Now, question number 15. The function f is defined by f of s equals negative 1/3 log s, right? Which of the following pairs of statements correctly describe the end behavior of the function f, right? So we need to get this one, right? So we know that the logarithmic function is going to be something like this, right? Now, since you have the negative coefficient right here, which means there is a reflection over the x-axis, so it could be something like this, right? Now, I need to eliminate the previous one, right? Now, answer choice A. Limit of the function f of s when s approaches 0 plus, which means on the right of the y-axis, the function approaches positive infinitive, right? Now, it's a negative infinitive, so it's wrong, right? Now, answer choice B. Limit of the function f of s when s approaches 0 plus, it could be positive infinitive. Yes, that's correct, right? Now, limit of the function f of s when s approaches positive infinitive equals negative infinitive. Yes, that's correct, right? So the answer choice must be B. Now, let's move on to question number 16. The function k is defined by k of s equals negative 1/2 times 3 to the s, right? So we need to get this one. Now, we know that the exponential function y equals a times b raised to the s, right? B is 3 greater than 1, so this is exponential growth, right? So it should be something like this, right? Now, since a is negative, right? A equals negative 1/2, right? So there is a reflection over the x-axis. So the final one must be something like this, right? Now, limit of the function ks when s approaches negative infinity. The function approaches 0, yes, because it's getting closer to the x-axis, right? Limit of the function ks when s approaches positive infinity, right? This is positive infinity. The function approaches negative infinity, yes, it's going down, right? So the answer choice A is correct. Now let's move on to question number 17. The function h is defined by h of s is negative 4 times 1/3 raised to the s, right? Now we need to get this one, right? We know that b right here equals 1/3, so b greater than 0, less than 1. So this is a decay function, so it could be something like this, right? Now since you have the negative 4 in front of the output, so there is a reflection over the x-axis, right? So it could be something like this. Alright, now look at the answer choice A. Limit of the function h of s when s approaches negative infinity. The function approaches negative infinity, so it's a 0 right here, which means this is wrong, right? Answer choice B. Limit of the function h of s when s approaches negative infinity. The function approaches negative infinity, right? It's a 0 right here, so it's wrong. Answer choice C. Limit of the function h of s when s approaches negative infinity equals negative infinity. Yes, that's correct, right? Limit of the function h of s when s approaches positive infinity. The function approaches 0, right? It's go to the right. The function getting closer to the x-axis, which means 0, right? So the answer choice must be C. Now let's move on to number 18. The function f is defined by f of s is negative 2 times 3 to the s, right? Now we need to sketch this one. We know that the exponential function y equals 3 to the s is going to be exponential growth function, right? So it's going to be something like this, right? Now, since you have the negative 2 in front of the output, so there is a reflection over the x-axis, so it's going to be something like this, right? Now, answer choice A. The function f is increasing. Alright, in order to know if it's increasing or decreasing, we need to draw the tangent line, right? So, the tangent line is going down, which means the slope is negative, right? So the function is decreasing, so you need to eliminate A and B. Now, answer choice C, the function f is decreasing, right? And the graph of f is concave down, right? This is concave up, so this is wrong. The answer choice must be D. Now, number 19, the function g is defined by g of s equals 6 log s, right? So we need to get this one, right? We know that the log function is going to be something like this, right? Now, answer choice A. The function g is increasing, right? We just draw the tangent line, and you see that the tangent line has the positive slope, so the function is increasing, right? So we need to eliminate C and D. Now the graph of g is concave down, right? This is concave up, so it's wrong, right? The answer choice must be B. Now question 20. The function h is defined by h of s equals 7 times 1/2 raised to the s, right? So we need to get this one first, right? So because b right here is less than 1 but greater than 0, right? So this is exponential decay function. So it's going to be something like this, right? Now the answer choice A. The function h is increasing. No, this is decreasing, right? Because you draw the tangent line, we see that the slope of the tangent line is negative, right? So you need to eliminate A and B, right? The graph of the function h is concave up, right? So this is concave up. The answer choice must be C. Now question 21, there is a typo right here, right? This is exponential function. The exponential function k is defined by k of s equals 2 times 4/3 raised to the s, right? So we need to get this one. Now we know that 4/3 is going to be greater than 1, right? So it's going to be exponential growth function. So it's going to be something like this, right? Now, answer choice A, the function k is increasing. Yes, if you draw the tangent line, you see that the slope of the tangent line is positive, so the function is increasing, right? So we need to eliminate C and D. Now, the graph of k is concave up, right? So the answer must be A. Now, question number 22. The logarithmic function is defined by f of s equals negative 5 net log of s, right? We need to get this one. Alright, you know that the parent function of the logarithmic function is going to be something like this, right? Now, since you have the negative 5 in front of the output, so there is a reflection over the x-axis, so it could be something like this, right? The function f is increasing or decreasing. You just draw the tangent line. You see that the tangent line is going down this way, which means the slope is negative, right? So the function is decreasing, right? So you need to eliminate a and b. Now, look at the rate of change. Because the function is concave up, right? So the rate of change is increasing, right? So this could be c right here. Now let's move on to question 23. The logarithmic function g is defined by g of s equals 3 times log base 5 of s, right? So the logarithmic function is going to be like this. Alright, so look at this one right here. The coefficient in front of log base 5 of s is positive, so there is no reflection, right? So it could be like this. Now, answer choice A. The function g is increasing, yes, right? Because you draw the tangent line, you see that the slope of the tangent line is positive. So the function g is increasing. So you need to eliminate c and d, right? Now look at the rate of change. The rate of change is increasing or decreasing. It's going to be decreasing because the function is concave down, right? So the answer must be B. Now let's move on to question 24. The function h is defined by h of s equals 4 times 2 to the s, right? So look at this one right here. This is exponential growth function, right? Because b equals 2 greater than 1, right? So it could be something like this, right? Look at the coefficient right here. It's going to be positive, right? So there is no reflection, right? The function h of s is increasing, right? Because you draw the tangent line, the slope is positive, right? So the function is increasing. We need to eliminate c and d, right? Now look at the rate of change. Because the function is concave up, the rate of change must be increasing, right? So the answer choice must be A. Now let's look at the question 25. The function f is defined by f of s equals 6 times 1/2 raised to the s, right? Now observe that b right here is 1/2 less than 1, right? So it's going to be exponential decay function, right? So it could be something like this. Now since a is 6 positive, so there is no reflection, right? Now we need to know if the function is increasing or decreasing. Draw the tangent line, right? So the slope is negative. The function is decreasing, right? So eliminate A and B. Since the function is concave up, the rate of change is increasing, right? So the answer choice C is correct. Now number 26, the function k is defined by k of s equals negative 3 times 1/4 raised to the s, right? So we need to get this one. Alright, look at b right here. B equals 1/4, which is less than 1, right? So this is an exponential decay function, right? Now since a equals negative 3, so there is a reflection over the x-axis, right? So it could be something like this. Now look at the answer choice A. The function k is increasing. Now we need to draw the tangent line. And you see that the slope of the tangent line is positive. The function is increasing, right? So we need to eliminate C and D. We need to check for the rate of change, right? Since the function is concave down, the rate of change is decreasing, right? So the answer must be B. Now let's move on to question number 27. We need to sketch this graph, right? So we know that b is 3 greater than 1, right? So this is an exponential growth function, right? So it could be something like this. Now, since you have the negative coefficient in front of output, so there is a reflection over the x-axis, so it could be something like this, right? Now, I need to erase the previous one, right? Now, the function is decreasing, right? Because if you draw the tangent line, the slope is negative, so the function is decreasing, right? So we need to eliminate A and B, right? Now, we need to check for the rate of change. Because the function is concave down, the rate of change is decreasing, right? So the answer must be D. Now, since b equals 2 greater than 1, so this is exponential growth function, right? So it can be something like this. Now, since a equals negative 5, so there is a reflection over the x-axis, so it's going to be something like this. Now, in order to know if the function is increasing or decreasing, I'm going to draw the tangent line, right? And I know that the slope of the tangent line is negative, so the function is decreasing, right? So you need to eliminate A and B. Now, the rate of change is decreasing, right? Because the function is concave down, right? So the answer must be D. Now question 29. We need to sketch this one. we know that the logarithmic function is going to be something like this, right? Now look at the coefficient right here, it's going to be positive, so there is no reflection, right? Now look at the answer choice right here, the function g is decreasing. We need to draw the tangent line, and we know that the tangent line is going this way, the slope is positive, so the function is increasing, right? So you need to eliminate a and b. Now look at the rate of change, because the function is concave down, the rate of change is decreasing, so the answer must be D. Now let's look at number 30. We need to sketch this one. Alright, so look at this one, you see that 2/3, which means b less than 1. This is exponential decay function, so it could be something like this, right? Now, in order to know if the function is increasing or decreasing, I will draw the tangent line. So the tangent line is going down, the slope is negative, the function is decreasing, right? So I need to eliminate c and d. Now the rate of change is increasing because the function is concave up, right? So the answer must be A. Now number 31. The function h is defined -6 times log by 2 of s. So I must get this one. We know that the logarithmic function is to be something like this, right? Since a equals -6, so there is a reflection over the x-axis, so it could be something like this, right? Alright, now in order to know if the function is increasing or decreasing, we need to draw the tangent line. And you see that the tangent line is going down, right? The slope is negative, the function is decreasing. So you need to eliminate c and d. Now look at the rate of change right here. The function is concave up, the rate of change is increasing, so the answer must be A. Now question 32, we need to sketch this one. You know that the logarithmic function is going to be something like this, right? Look at the coefficient A right here, this is positive, right? So there is no reflection, right? Now, in this question, they just ask you about the rate of change only, right? So we just draw the tangent line only, right? So the slope of the tangent line is positive, right? So the rate of change is positive, right? We need to eliminate C and D, right? Now, since the function is concave down, the rate of change is decreasing, right? So the answer must be B. Now, question 33, we need to sketch this one, so it could be like this. B equals 4 greater than 1, right? So it could be exponential growth function. It could be something like this. Now look at the coefficient A right here. It could be -3, right? So there is a reflection over the x-axis, so it could be something like this, right? And the rate of change of the function f is positive or negative, right? We just draw the tangent line. And we see that the tangent line is going down, the slope is negative, right? So the rate of change is negative. We need to eliminate A and B. Alright, since the function is concave down, the rate of change is decreasing, so the answer must be D. Now look at number 34. We need to sketch this one. Alright, you know that the logarithmic function is going to be something like this, right? Since a equals -2/3, so there is a reflection over the x-axis, right? So it could be something like this, right? Now I need to eliminate the previous one, right? Now, the rate of change is positive or negative. We need to draw the tangent line. And you know that the tangent line is going this way, the slope is negative, right? We need to eliminate A and B, right? Now, since the function is concave up, the rate of change is increasing, right? So the answer must be C. Now, let's move on to the last two, 35 and 36. We need to sketch this one, right? Now, b equals 3/5, which is less than 1. So this is an exponential decay function, right? Now, since a equals 1, so there is no reflection, right? Now, we need to check for the rate of change, is positive or negative, right? Draw the tangent line. The tangent line is going down, the slope is negative. The rate of change is negative, right? So we need to eliminate A and B, right? Now, since the function is concave up, the rate of change is increasing, right? So the answer must be C. Now, number 36, the function case is -1/5 times 9 to the s, right? So we need to sketch this one. Because b equals 9 greater than 1, so this is an exponential growth function, so it could be something like this, right? Now, since a equals -1/5, which means there is a reflection over the x-axis, so it could be something like this, right? Now, I need to eliminate the previous one. Alright, in order to find the rate of change, I need to sketch the tangent line. right? So the tangent line is going down. The slope is negative, right? So I need to eliminate A and B. Now, because the function is concave down, the rate of change is decreasing, so the answer must be D. We're going to learn about the logarithm properties and logarithmic function manipulation. So look at the left hand side, we have the table of formulas right here. And the following errors that you need to get rid of. So don't apply these formulas. Alright. Now, example number 1, we need to condense its expression. Alright. So have the sum right here. I look at the first one. This is a product rule, right? Product becomes the sum, right? So this one I just go backwards over here. So it turns out to be log base 4 of x times y, right? Now this one right here, I look at the second formula right here. This is subtraction, right? So I convert it to quotient, right? So it could be log base 3 of 5 over z, right? Now the third one right here, I need to apply the first two right here. So I use the quotient rule, right? So it could be log base 10 of x over 5, right? And then I subtract log base 10 of z, right? Now I apply the quotient rule one more time. So it's going to be log base 10 of x over 5 divided by z. So I put z right here, right? Now question D. Before I apply the quotient rule, I need to print 3 back over here by using the formula right here. Alright, so I have log base 2 of x cubed minus log base 2 of y. Alright, so I'm going to apply the quotient rule. So it's going to be log base 2 of x cubed divided by y. Now next one. Alright, I still apply this formula right here, the power rule right here. Right, I bring 2 back over here. 5 go back over here, right? So I have log base 7 of a squared minus log base 7 of b power 5, right? And then plus log base 7 of 4, right? So I apply the quotient rule right here. So I have log base 7 of a squared over b power 5 plus log base 7 of 4. Now I apply the product rule right here. So it's going to be log base 7 of 4 times a squared over b to the 5th. Right, now let's move on to the next one. So in order to condense this guy and this guy, I need to make this guy as log base, right? So I need to apply the formula right here. Alright, so basically 2, I just write log base of 6 squared, right? Plus log base of x, and then I apply the product rule, right? So it's going to be log base of 6 squared times x, and then it's going to be log base of 36 x, right? Now let's move on to the second example. Which of the following expressions is equivalent to this guy? Alright, so we need to expand this guy. Alright, so I use the quotient rule. So it's going to be log base 3 of x squared minus log base 3 of y. Alright, so then I apply the formula right here, the power rule right here. So I'm going to print 2 to the front, right? So it's going to be 2 log base 3 of x minus log base 3 of y, right? Now I check the answer, so my answer should be C. Right? Now let's move on to the next 3 examples. Alright, example number 3. Given the function f of x equals log 6x. Alright, so if the function write like this, it means log base 10 of 6x, right? Is a horizontal dilation of the function g of x equals log s, which means log base 10 of s, shows that f can also be written as a vertical translation of g, with f of s equals g of s plus k, where k is a constant, right? So I just apply the product rule for f of s. So f of s is log set plus log s, right? And then I just rewrite this one as log s plus log set, right? Log s, which means g of s, right? So I just replace log s with g of s, right? So this is g of s. And log set right here, this is a constant. So I just replace log set with k, right? And then this is f of s, right? So the function f of s equals the function g of s plus something. And then this is actually vertical translation by k units, right? Now, let's move on to the example number 4. Let f of s equals log base 4 of s and g of s equals log base 9 of s. Show that f is a vertical dilation of g by finding the value of k, such that f of s equals k times g of s, right? So I start from the function f of s. It's gonna be log base 4 of s. Now I need to write this one in terms of g of s. So, but the function g of s is log base 9 of s. So I'm gonna apply the formula right here. Alright, this is called change of base rule. Right, so I look at the function g of s right here. I see that this is log base 9, right? So I need to write this one in terms of log base 9. So I just put a little 9 right here. Alright, so I just rewrite this one as log base 9. Now keep in mind, s above, 4 below. So I just write s right here first. Divide by log base 9 of 4, right? Alright, so this one I just rewrite as 1 over log base 9 of 4 times log base 9 of s, right? And then I just replace the whole thing right here with k, because this is a constant, right? So I have k times. Now this one right here, I just replace this one with g of s right here, right? So it could be g of s, right? So this is actually vertical dilation by a factor of 1 over log base 9 of 4. Now let's move on to the example number 5. Which of the following expression is equivalent to 3 natural log of x minus 4 natural log of y? Alright, so keep in mind, if we just write ln like this, which means log base e, right? So this one right here, I just apply this power rule right here. Alright, so I just bring 3 back over here, 4 back over here. So I have natural log of x power 3 minus natural log of y power 4. And then I apply the quotient rule right here. Alright, so I have natural log of x power 3 over y power 4. And the answer is A. Now let's move on to the next example. We need to write its expressions as a sum or difference. So we're gonna apply the first formula and the second formula right here. Alright, so this one right here, we just write this one as log base 3 of s plus log base 3 of y power 3, right? Now we apply the formulas right here, the power rule right here. So we can bring 3 to the front, right? So it can be log base 3 of s, I just rewrite, plus 3 times log base 3 of y, right? Now, this one right here, I just apply the quotient rule right here, right? So it's gonna be natural log of s squared minus natural log of y cubed, right? So I can bring 2 to the front and 3 to the front. So it's gonna be 2 natural log of x minus 3 natural log of y, right? Now, this one right here, you don't see the base, which means base 10, right? So you see log only, which means log base 10, right? So this is log 1000 plus log s power of 3, right? Now, log 1000, I just write log base 10 of 1000, I just write 10 power of 3, right? Plus log base 10 of s power of 3. So I can bring 3 to the front, right? So it can be 3 log base 10 of 10 plus 3 log base 10 of s, right? So this guy equals 1. So I just write 3 plus this one right here. I just condense this, right? I just write 3 log s, right? I don't need to write base 10 because base 10 would mean this one, right? Now, question number 4 is going to be log base 2 of 8 plus log base 2 of square root of s, right? Now 8, I can rewrite this one as 2 power of 3, right? So it can be equal to log base 2 of 2 power of 3 plus log base 2 square root of s, I just write as power of 1/2, right? So this one, 3 I bring it to the front, so it can be 3 log base 2 of 2 plus 1/2 bring to the front, so it can be 1/2 log base 2 of s. Now, this guy is equal 1, right? So the answer is 3 plus 1/2 log base 2 of s. Now, let's move on to question 5. So this one right here, before I'm going to apply the quotient rule, I need to convert the radical side into the exponent. So it can be log base 2 of 16s cubed over y squared altogether 1/2, right? So I can bring 1/2 to the front, right? So it can be 1/2 log base 2 of 16s cubed over y squared. Now I can apply the quotient rule. So it's going to be, alright, so I'm going to apply the product rule for this guy. So it's going to be 1/2 parenthesis log base 2 of 16. Now I can write 16 as 2 power 4, right? So I have 2 power 4 right here, right? Plus log base 2 of s cubed minus, now 2 right here, I can bring it to the front, so it can be minus 2 log base 2 of y. Alright, so I just rewrite 1/2. 4, I bring it to the front, so it can be 4 log base 2 of 2 is going to be 1, so I don't need to write, right? Plus 3, bring it to the front, so it can be 3 log base 2 of s minus 2 log base 2 of y, right? Now question number 6, I need to factor 9 out, right? So it could be log base 3 of 9 of s minus 3, right? And then I apply the product rule, so it could be log base 3 of 9 plus log base 3 of s minus 3, right? And then 9 right here, I can rewrite 9 as 3 power of 2, right? So I bring 2 to the front, so it could be 2. And then I have log base 3 of 3 left, but log base 3 of 3 is going to be 1. So I don't need to write 1. Plus log base 3 of s minus 3, right? Now let's move on to the next one. So we need to condense this one. We're going to apply the product rule right here. So it turns out to be natural log of 3 times s, right? Now number 8. Alright, so before we're going to condense this one, we need to apply the power rule right here, right? So we just bring 2 back over here and 4 back over here. So it's going to be log base 3 of s squared minus log base 3 of y power 4, right? And then we're going to apply the quotient rule right here. So it's going to be log base 3 of s squared over y power 4, right? Now, this one right here, we're going to distribute 1/2. So we have 1/2 log s plus 3.5 log y, right? Now we can bring 1/2 back over here and 3.5 back over here before we can condense them, right? So it's gonna be log x power of 1.5 plus log y power of 3.5, right? And then we're gonna apply the product rule right here, right? So it's gonna be log x power of 1/2 times y power of 3.5, right? And then we can write this one in the radical, right? So it's gonna be log square root of x times y power of 3 right here. Now the next one right here, we're gonna bring 3 back over here, right? And 2 back over here. So we have log base 5 of x minus 4 power of 3 minus log base 5 of y square, right? So it's gonna be quotient rule, right? So it's gonna be log base 5 x minus 4 altogether power cube over y power square, right? Alright, next one, number 11 right here, we can use calculator, right? Now we need to apply the formula right here, change of base rule, right? So we can use base 10 or base e, right? Now we just put little 10 right here. So we have log base 10 of 123 divided by log base 10 of 4, right? Or we can use natural log, which means log base e, right? So we can write this one as natural log of 123 over natural log of 4, right? Now we can print out the calculator. Alright, so we just hit add calculator right here and we hit control log right here. So base 10, we use base 10 of 123. Hit enter and then hit division, control log base 10 of 4 and hit enter. And then you want to convert this one into decimal. Menu, number, convert to decimal and hit enter. It's gonna be 3.471, right? So both give you the answer 3.471, right? Now question 12, you're gonna do similar, right? You're gonna do natural log, so it's gonna be natural log of 578 over natural log of 9, right? So you just hit the calculator. So natural log right here, hit control, natural log right here, 578, hit enter, divide by control, natural log of 9, right? Hit enter. So then you want to convert this one into decimal, just hit menu, number, convert to decimal, hit enter. The answer is 2.894, right? Now question number 13, describe any transformation on the function, then find the domain and range of the transform function. Alright, so we're going to use the product rule. So f of s is going to be log base 4 of 16 plus log base 4 of s. So I rewrite log base 4 of s. And then log base 4 of 16, I just rewrite 16 as 4 square, right? So I bring 2 to the front. And then log base 4 of 4 is going to be 1, right? So this one I add 2, right? So this is actually vertical translation of 2 units from the function log base 4 of s to get the function log base 4 of 16s, right? Now the domain of this one is going to be, we look at this one right here. We see that the vertical asymptote right here s equal to 0, right? So it could be from 0 all the way to the right. So the domain is going to be 0, infinity. And the range is going to be always negative infinity to positive infinity, right? Alright, so look at number 14 right here. I'm going to use quotient rule, so it's going to be log base 2 of s minus log base 2 of 8, right? Now 8, I can rewrite 8 as 2 power of 3, right? So 3, I bring it to the front. So I have log base 2 of s minus 3. And I have log base 2 of 2 left. Log base 2 of 2 is equal 1. So this is actually vertical translation down 3 units from the function log base 2 of s to get the function g of s right here, right? And domain is the same thing as this guy, right? Because the vertical asymptote is s equal to 0. Now look at number 15 right here. You can bring 2 to the front, right? Because you're not going to use the power rule right here. So it's going to be f of s equals 2 times log base 5 of s. So you're going to multiply the output by a number. This is actually vertical dilation by a factor of 2. And you look at this one right here. The vertical asymptote is s equal to 0. So the domain is going to be 0 to infinity. And the range should be negative infinity to positive infinity. And the last one right here, number 16. So we have h of s right here. Now I'm going to factor 16 out. So it's going to be log base 2 of 16 times 2 minus s, right? And then I just rewrite this one as log base 2 of 16 plus log base 2 of 2 minus s. I factor negative 1 out, so it could be negative of s minus 2, right? So this one right here, 16, I just write 2 power 4, right? And I bring 4 to the front. So I'm going to end up with 4 times log base 2 of 2, but log base 2 of 2 equals 1. So I just write 4 plus log base 2 of negative of s minus 2, like this, right? Alright, so I look at this one. I let this one equal to 0 right here. S minus 2 equal to 0. So s minus 2 equal to 0. S equal to 2. And this is your vertical asymptote, right? And you look at this one right here. You see the subtraction sign in front of the input, which means the function reflects over the y-axis. So when the function reflects over the y-axis, you're going to flip the domain. So the domain should be negative infinity to 2, right? You look at this one right here. Normally, if you don't have reflection, right, the domain should be from 0 to infinity. Now, the domain should be negative infinity to 2, right? And the range is going to be same thing, negative infinity to positive infinity. If you grab this one using a calculator or decimal, you will see it. Now, let's move on to the next one. So, let x and y be positive constants. Which of the following is not equivalent to this guy, right? So we just apply the formula right here. The product rule, the quotient rule, and the power rule, right? So this one right here, I just write log base 3 of x plus 3, right? And this one right here, I just bring 2 to the back. So it could be plus log base 3 of x minus 1 altogether square, right? And this one subtract log base 3 of x plus 2, right? Alright, so I apply the product rule. I combine this guy. So it could be log base 3 of x plus 3 times x minus 1 altogether square, right? Subtract log base 3 of x plus 2, right? And then I apply the quotient rule. So it could be log base 3 of x plus 3 times x minus 1 altogether square over x plus 2, right? Now x minus 1 altogether square, I can write this one as x minus 1 times x minus 1, right? Alright, so you need to read the question carefully. They say not, right? So look at B right here. B is equivalent, right? S minus 1 altogether square is going to be the same thing as S minus 1 times S minus 1, right? And then B and C similar, right? Now D, you can apply the complete square formula. So S minus 1 altogether square is going to be S square minus 2 times S times 1, and then plus 1 square, right? 1 square equals 1. So the answer D right here, correct, right? So the correct answer right here must be A, right? Because A is not equivalent, so the answer is A. Given log 3 equals x and log 4 equals y. Which of the following expressions similar to log square root of 12, right? So I start from log square root of 12. I write this one as log square root of 3 times 4, right? So I just split this one, it's going to be log square root of 3 times square root of 4, right? Now I'm going to apply the product rule. So it's going to be log square root of 3 plus log square root of 4, right? Now I convert the radical into the exponent, so it could be log 3 power up 1/2, right? Plus log 4 power up 1/2, right? So you can bring 1/2 to the front, so it could be 1/2 log 3 plus 1/2 log 4, right? Now log 3 equals s, so I just replace log 3 with s, so I have 1/2 x plus log 4 equals y. So I just replace log 4 with y. So I have 1/2 y. So I just factor 1/2 out. So I have x plus y inside. Right? So the answer must be D. Right? Now let's take a look at the last example. So I just rewrite log base b of 18 in terms of this guy right here. Right? So I have log base b of 18 equals log base b of, now I need to factor 18, right? So 18 divided by 2 is going to be 9. 9 divided by 3 is going to be 3. 3 divided by 3 is going to be 1, right? So 18 can be written as this guy multiplied. So it could be 2 times 3 squared, right? So I apply the product rule. So it could be log base b of 2 plus log base b of 3 squared. Now 3 squared right here, I can bring 2 to the front, right? So it's going to be log base b of 2 plus 2 log base b of 3, right? Now I replace log base b of 2 with this guy right here. So it's going to be 0.4307 plus 2 times, I replace this guy with 0.687. So times 0.6827, right? And then I'm going to hit the calculator. The answer must be 1.7961. And we're going to learn how to solve the exponential and logarithmic inequalities. Alright, so look at the formula right here. If they have the same base, a to the f of s greater than a to the g of s, then we have two different cases. Case number one, if the base greater than 1, and then you just have the inequality f of s greater than g of s. If the base greater than 0 less than 1, and then f of s less than g of s, keep that in mind, the inequality switch, right? Now if they have different bases, and then you need to take log both sides. If the base greater than 1, now depends on the base right here, right? So the base right here is a. You need to take log base a both sides, right? So log base a of a to the f of s greater than log base a of b to the g of s, and then you just bring f of s to the front, and then you have log base a of a equals 1. So that's why you have f of s greater than g of s times log base a of b, because g of s you can bring to the front, right? Now if the base from 0 to 1, and then you do opposite, right? So basically you just switch the inequality symbol right here. Alright, so let's take a look at the example. 5 to the s plus s less than or equal to 25 raised to the s plus 1. Now we need to convert this one into the same base, right? So the left hand side I just rewrite 5 raised to the s squared plus s less than or equal to 25 can be written as 5 squared, right? So 5 squared times s plus 1, right? And then this guy and this guy have the same base right here, and then because the base is 5 greater than 1, so I'm going to apply this case right here. Alright, s squared plus s less than or equal to 2 times s plus 1, right? Now you look at this one, this is greater than, and then this guy must greater than. Now original one less than equal to, and then this guy must be less than equal to, right? Now I'm going to distribute this one. It's going to be 2s plus 2, right? Rewrite the left hand side. Now I'm going to move every single thing to the left hand side. So it turns out to be s squared. Subtract 2s both sides and combine with s right here. So it turns out to be negative s. Subtract 2 both sides. So it could be like this, less than equal to 0, right? Now I'm going to use s method to factor this one. So I have c equals negative 2 and b equals negative 1. Now I need to find two integers multiply equals negative 2 add up to negative 1, which is negative 2 and 1. So this one can be factor s minus 2 times s plus 1 less than equal to 0. Now I need to find the 0 for each of these factor, right? So the first one s minus 2 equal to 0, and then s equals 2. Now the second one s plus 1 equal to 0, and then s equals negative 1. Alright, so I have the number line right here. Now I need to place negative 1 and 2 on the number line, right? So negative 1 go first because negative 1 less than 2, right? So I'm going to pick a number within this interval, right? The right hand side should be positive infinitive, the left hand side should be negative infinitive. Now I'm going to pick a number within this interval, right? So I'm going to pick 0. Right, so I'm going to substitute 0 into this inequality. So I have 0 minus 2 times 0 plus 1, right? It's going to be negative 2 times 1. It's going to be negative 2, which is less than 0. So this interval right here is going to be negative. Now I look at this one, I don't see any even multiplicity. So I keep changing the side, right? So this guy negative, this guy positive. This guy negative, this guy must be positive. Now, my goal is less than or equal to 0, right? So I only pick the negative interval, right? So negative interval is going to be from here to here, right? So it's going to be from negative 1 less than or equal to s less than or equal to 2, right? Because I have the equal sign right here. So this is my final answer. Or you can write this one as interval notation. It's going to be bracket negative 1, comma 2. Now let's move on to the next example. Given the function t of x equals 1 minus 4 times 2 raised to the s minus 3, we need to find all value of s such that the function t of x less than or equal to negative 31. Alright, we just let 1 minus 4 times 2 raised to the s minus 3 less than or equal to negative 31, right? So then I need to subtract 1 both sides. So it's going to be negative 4 times 2 raised to the s minus 3 less than or equal to negative 31 minus 1 is going to be negative 32. Now I need to divide both sides by negative 4. So it's going to be 2 raised to the s minus 3. When you multiply or divide both sides of the inequality, you need to switch inequality symbol. So this guy turns out to be greater than or equal to. Negative 32 divided by negative 4 is going to be 8, right? So 2 raised to the s minus 3 greater than or equal to 8 can be written as 2 power of 3, right? Now this guy finds the first case right here because the base is 2 greater than 1, right? So we keep the same inequality symbol, right? So it's going to be s minus 3 greater than or equal to 3. Add 3 both sides, it's going to be s greater than or equal to 6. Or you can write bracket 6, comma, infinitive. And that is your solution. Now let's move on to the next example. Given the function h of s equals 1 over 3 raised to the 2 over s, and the function k of s equals 12 minus 3 times 1 over 3 raised to the 1 over s plus 1. Now find all value of s such that the function h of s greater than the function k of s. Alright, so we just substitute. So it's going to be 1 over 3 raised to the 2 over s greater than 12 minus 3 times 1 over 3 raised to the 1 over s plus 1. Alright, so you just move every single thing to the left hand side. So it's going to be 1 over 3 altogether raised to the 2 over s plus 3 times 1 over 3 raised to the 1 over s plus 1 minus 12 greater than 0. Now this guy can be written as 1 over 3 altogether raised to the 1 over s altogether power of 2, right? Plus 3 times 1 over 3 power of 1 over s plus 1 over 3 power of 1, right? Because I'm going to use the formula a to the m plus n. It's going to be a to the m times a to the n, right? Minus 12 greater than 0. Alright. Now this guy right here, I can simplify this guy and this guy, right? So this guy turns out to be 1 over 3 altogether raised to the power 1 over s altogether power of 2. Now this guy comes from this formula a raised to the m altogether raised to the n. It's going to be a to the m times n, right? Plus 1 over 3 altogether raised to the 1 over s minus 12 greater than 0. Alright, so now I'm going to use chain alphabetical method. So it can be let a be 1 over 3 altogether raised to the 1 over s, right? And a must be greater than 0. Alright, so I'm going to substitute over here. So I have the equation a squared plus a minus 12 greater than 0. Now I'm going to factor this one out. So I'm going to use S method to factor this one. So I'm going to put C equals negative 12 and B equals 1, right? Now I need to find 2 into multiply equal negative 12 add up to 1, which is 4 and negative 3, right? So this one can be factored as a plus 4 times a minus 3 greater than 0, right? So I need to find the 0 for this one. The 0 for this one is going to be negative 4. The 0 for this one is going to be 3. So I put negative 4 and 3 on the number line. Alright, the left hand side I put negative infinitive. The right hand side should be positive infinitive. Now I need to pick a number within this interval. So I pick 0, right? I substitute back over here. So I have 0 plus 4, 0 minus 3. So it turns out to be 4 times negative 3, which is negative 12, and it's going to be negative, right? So right here, it's going to be negative. And I look at this one right here, I don't see any even multiplicity. So the sign keep changing, right? So this guy negative, this guy turns out to be positive, and this guy is positive. Alright, so now I need the whole inequality greater than 0, right? So my answer should be this interval and this interval. But I don't take negative 4 and 3 because I don't have equal sign here. So my answer must be negative infinitive, comma, negative 4. Union 3, comma, positive infinitive. Now I go back over here. I need to combine with the domain right here. Domain a greater than 0. Right? So this guy doesn't work because this guy less than 0. So I need to cross this one out. So my answer right here, a greater than 3, right? Because a from 3 to infinity, right? So I have a greater than 3, but a equals this one. So I substitute this guy back. So I have 1/3 altogether raised to the 1 over s greater than 3, right? Now 1/3 I can write 3 power of negative 1, right? Altogether raised to the 1 over s greater than 3, right? And then this power right here, I just use the formula right here. I'm going to multiply the power. So it will be 3 power up negative 1 over s greater than 3 right here. I can write 3 power up 1, right? Now I look at this formula right here. I see that a greater than 1. So I keep the same inequality direction, right? So I just have negative 1 over s. Keep the same, this guy greater than 1, right? This guy greater than this guy. So I'm going to multiply both sides by s. It's going to be negative 1 greater than s, right? Or s less than negative 1. Now, I'm going to subtract 1 both sides, so it will be negative 1 over s subtract 1 greater than 0, right? So I'm going to multiply both sides by negative 1. It's going to be 1 over s plus 1 less than 0, right? So I need to rewrite this one and this one in the same denominator. So it's going to be 1 plus this 1 I can write as s over s, right? So it will be 1 plus s over s less than 0, right? So I need to solve this inequality. So I need to find the 0 on the numerator. 1 plus s equal to 0. So then s equals negative 1. And then the bottom, s equal to 0, right? So I have 2 0, negative 1, and 0. I put these 2 0 on the number line. So negative 1 go first, and then 0 go right here. And then the left hand side should be negative infinitive. The right hand side should be positive infinitive, right? And then I need to pick a number in this interval. So I put 1 right here. I substitute over here, right? So I have 1 plus 1 over 1. It's going to be positive, right? So this guy positive. And then I don't see any even multiplicity. So I keep changing the sign. So it will be negative and this guy positive. Now I need this inequality, right? Less than 0, right? So I only need this guy right here, right? So it will be negative 1 less than s less than 0 is the final answer. Now let's move on to the next example. For example, we need to solve 2 raised to the s plus 20, 25 greater than 20, 25. Alright, so we look at this one right here. We see that this guy and this guy cannot be the same base, right? So I'm going to use this one right here, this case. Alright, because the base is 2, right? Greater than 1, right? So then I take log base 2 both sides. So I have log base 2 and this guy log base 2, right? And then I keep the same inequality symbol right here. And then this guy turns out to be 2 raised to the s plus 20, 25. And this guy 20, 25, right? Now, you have the formula log base a of b power of m. So you can bring m to the front. This guy turns out to be m log base a of b. Now, if you have log base a of a, it's going to be equal to 1, right? So this guy turns out to be, bring this guy to the front, it's going to be s plus 20, 25 times log base 2 of 2. But log base 2 of 2 is going to be equal to 1, right? So I don't need to write this one. Greater than log base 2 of 20, 25, right? So I just subtract 20, 25 both sides. So s greater than log base 2 of 20, 25, subtract 20, 25. Now this guy and this guy you cannot simplify. Don't take 20, 25, subtract 20, 25. That's wrong, okay? So you just leave the answer like this. And this is the final answer. Now let's move on to the next example. For example, we need to solve 1 over 2 altogether raised to the s plus 2 greater than 3. Alright, so we look at this one, we see that the base is 1/2 less than 1. And this guy, they are different base, right? So we're going to apply this case right here. Alright, so I'm going to take log base 1 half both sides. So I have log base 1 half. And this guy log base 1 and half, right? And then I have 1 half raised to the s plus 2. For this one right here, you need to switch inequality symbol. So this guy turns out to be less than. Alright? And then it's going to be 3 right here. Alright, so I bring s plus 2 to the front. And then this guy turns out to be log base 1 half of 1 half, right? Less than log base 1 half of 3, right? Now this guy equals 1, right? Based on the formula right here. So it's going to be s plus 2 less than log base 1 and half of 3. Now you subtract 2 both sides, so it's going to be s less than log base 1 and half of 3 minus 2. Now if you want to simplify this one further, you just rewrite 1 half as 2 power of negative 1. So this guy turns out to be s less than log base 2 power of negative 1 of 3 minus 2, right? And then negative 1 bring to the front is going to be 1 over negative 1, right? So s less than negative log base 2 of 3 minus 2. And this is the final answer. Now let's move on to the next one. Logarithmic inequalities. Alright, so basically we do exactly the same thing as we did in the exponential inequalities. So for example, if I have, now first I need to find the domain. So in this situation, this guy is b, and it b greater than 0, right? So I have s plus 1 times s plus 2 greater than 0, right? And then I need to find the 0 of each of these factors right here. So s plus 1 greater than 0. And then s greater than negative 1. S plus 2 greater than 0. Then s greater than negative 2, right? So then I need to put this guy on the number line. So I have negative 2, negative 1. Alright, so I need to pick a 0 in this interval right here. Alright, so I substitute over here. So I have 0 plus 1 is going to be 1, 0 plus 2 is going to be 2, 1 times 2 is going to be 2. So this guy is positive. So because I don't have any even multiplicity, so I keep changing the sign, right? So this guy is positive right here. Alright, so this is positive infinitive. This guy is negative infinitive, right? Now, I need this guy to be greater than 0. So the interval right here and right here, right? So it could be negative infinitive 2, negative 2, union negative 1, 2, infinitive, right? Alright, so this guy 1 can be written as log base 2 of 2, right? So we look at this one, this guy and this guy have the same base and greater than 1. So we're going to apply this formula right here. So I have s plus 1 times s plus 2 less than or equal to 2, right? Now I need to distribute this one. So it can be s squared plus 2s plus s plus 2. And then I subtract 2 both sides, right? Less than or equal to 0. Alright, so s squared, 2s plus s could be 3s, right? And then 2 minus 2 is could be 0. So this guy less than or equal to 0, right? So I factor s out, right? So it could be s plus 3 less than or equal to 0, right? So I need to find the 0 of each of these factors right here. So s equal to 0. And the second one, s plus 3 equal to 0. And then s equals negative 3, right? So I need to draw a number line. And then I'm going to put 2 zeros on the number line. So negative 3 right here and 0 right here, right? And this is positive infinitive. This is negative infinitive. I put a line right here, right? So I need to pick a number within this interval. So I pick a number 1 right here. So I substitute over here. So I have 1 times 1 plus 3, right? 1 plus 3 equals 4. 4 times 1, it could be 4. So this is positive, right? So positive. And since I don't see any even multiplicity, so I keep changing the sign, right? So it's negative and this is positive, right? Now, finally, I need this one to be less than or equal to 0, right? So it's going to be right here, right? So the answer for this one is going to be negative 3 to 0, right? Now, since we have equal signs, so we need to include negative 3 and 0, right? So Now, we need to compare the answer and the domain, right? So we need to draw this guy, right? So we need to put the -3 right here, -2 right here, -1 and 0. This guy is positive infinitive, this guy is negative infinitive. Now, I need to check the domain first, -infinitive to -2, right? So I need to eliminate this one. And from -1 to infinitive, right? So this guy is my domain, right? Now, the answer right here, -3 to 0, right? So I need to eliminate this interval, right? And I need to eliminate this interval, right? So only this guy satisfied, right? This guy and this guy right here. So my final answer must be -3. We need to include -3, right? So it's going to be -3, comma, -2, right? We're not going to include -2, right? Look at this one. Union, -1, not included, right? Comma, 0, 0 included right here. And this is the final answer. Now let's move on to the next example. So log base 1/3 of s plus 1 less than or equal to log base 3 of 2 minus s. And we see that this guy have different base. So it's fall into this case right here. Now we need to convert it to the same base, right? 1/3 we can write as log base 3 power of -1, right? Of s plus 1 less than or equal to log base 3 of 2 minus s, right? And then I have the formula log base a to the m of b. I can bring m to the front. So it's going to be 1 over m log base a of b, right? So -1 bring to the front. So it could be -1 over 1, which means -1, right? Log base 3 of s plus 1 less than or equal to log base 3 of 2 minus s, right? Now, -1, you can bring it back over here by using the formula m log base a of b, right? You can bring m back over here. So it could be log base a of b raised to the m, right? So this guy turns out to be log base 3 of s plus 1 power of -1 less than or equal to log base 3 of 2 minus s, right? And then s plus 1 power of -1 turns out to be 1 over s plus 1, right? So this guy turns out to be log base 3 of 1 over s plus 1 less than or equal to log base 3 of 2 minus s, right? And then this guy have the same base 3, right? So this guy base 3 greater than 1, right? So we just keep the same direction right here. So we have 1 over s plus 1 less than or equal to 2 minus s, right? And then this guy must be greater than 0, right? Look at this one. Because the domain of this one must be greater than 0, right? So I need to solve the left hand side first, right? So 1 over s plus 1 greater than 0, right? So the top already greater than 0. So I need s plus 1 greater than 0, right? So then s greater than -1. This is my domain. Okay, now I need to solve for 1 over s plus 1 less than or equal to 2 minus s, right? So I need to subtract 2 and s both sides. So this guy turns out to be 1 over s plus 1 minus 2 plus s less than or equal to 0, right? So I need to write this one the same base, right? By multiplying this one by s plus 1, this guy by s plus 1, right? So I have 1 minus 2 times s plus 1 plus s times s plus 1 all together over s plus 1 less than or equal to 0, right? So I need to simplify this one. It's going to be 1 minus 2s minus 2 plus s squared plus s over s plus 1 less than or equal to 0, right? So this guy turns out to be s squared minus s minus 1 over s plus 1 less than or equal to 0. Now observe that the domain is s greater than -1 is the same thing as s plus 1 greater than 0. So this one already greater than 0. In order for the whole thing right here less than or equal to 0, the numerator must be less than or equal to 0. So I only need s squared minus s minus 1 less than or equal to 0. So I need to use quadratic formula to solve this one because I cannot factor this one, right? So I have s1, s2 equals negative b plus minus square root of b squared minus 4ac over 2a, right? And then this guy turns out to be negative b, which means b equals negative 1. So it will be 1 plus and minus square root of 1 minus 4 times a equals to 1. And c equals negative 1, right? Over 2a. 2 times 1, right? So this guy turns out to be 1 plus and minus square root of 5 over 2, right? So I have two solutions and I need to put this guy on the number line, right? So the first one is going to be 1 minus square root of 5 over 2, and the other one 1 plus square root of 5 over 2, right? And then I need to put a line right here. Now I need to pick a number, right? Within this guy, this I pick a 0, right? So I put 0 over here. So I have 0 squared is going to be 0. Minus 0 is going to be 0. So I have negative 1, which is negative side, right? This guy positive, this guy positive, right? So in order for this guy to be less than or equal to 0, I need this interval right here, right? So it can be 1 minus square root of 5 over 2. Because I have the equal sign, so I need to pick this one, right? Comma 1 plus square root of 5 over 2. And this is my final answer. Alright, let's move on to the next example. Given the function f of s equals log of s squared minus 4s plus 7 minus log of s plus 3. We need to find the value of s such that f of s greater than 0, right? So, we need to find the domain, right? So, domain is going to be s squared minus 4s plus 7 greater than 0 and s plus 3 greater than 0, right? So, I have the inequality because f of s greater than 0, so does that mean we have log of s squared minus 4s plus 7 minus log of s plus 3 greater than 0. Alright, so I use the logarithmic property to condense this one, right? So it turns out to be log of s squared minus 4s plus 7 over s plus 3 greater than 0, right? Now, 0 can be written as log 1, right? So then I have s squared minus 4s plus 7 over s plus 3 greater than 1 because the base is 10, right? Already greater than 1, right? So this guy can be written as s squared minus 4s plus 7 over s plus 3 minus 1 greater than 0, right? And then I need to write this one the same denominator, so basically I multiply this one. So it turns out to be s squared minus 4s plus 7. Negative 1 times s is going to be negative s. Negative 1 times 3 is going to be negative 3 over s plus 3 greater than 0, right? Now I look at the domain right here. S plus 3 must be greater than 0, right? So the bottom right here, of course, already greater than 0, right? So I need the numerator greater than 0. That's it, right? So I need to simplify the numerator. So it can be s squared minus 5s plus 4 greater than 0, right? So I need to factor this one out. So it turns out to be s minus 4 times s minus 1 greater than 0, right? So I need to put 2 zeros on the number line, right? So the zero of this one should be s minus 4 equal to 0. Then s equals 4, right? S minus 1 equals 0. And then s equals 1, right? So I put 1 and 4 on the number line. Right? This is negative infinitive and this guy is positive infinitive, right? Now I need to pick a 0 right here. I substitute over here. So 0 minus 4 is going to be negative 4. 0 minus 1 is going to be negative 1. Multiply this one should be positive, so this guy is positive. Now there is no even multiplicity, so this is keep changing the signs, right? Negative, positive, right? Now I need this guy to be greater than 0, right? So my solution should be this guy and this guy right here, right? So solution should be negative infinity, comma 1 union 4, comma positive infinity, right? But we look at this one right here because the domain is s greater than negative 3, right? So we need to combine this guy with the domain, right? Because negative 3 is going to be in the middle right here. Negative infinity to negative 3, negative 3 to 1. Right, so the final solution must be negative 3, comma 1 union 4, comma positive infinity. Topics 2.13 to 2.15 logarithmic equation and semi-log plus. Alright, so part 1, no calculators. Solve the following equations. Now, remember that log base a of b is defined when a greater than 0, a not equal to 1, and b greater than 0. So, before you're going to solve the logarithmic equation, you need to find the domain. Alright, so the domain of this one should be s minus 1 greater than 0. So, s greater than 1, right? Now, we're going to solve this one. We know that log base a of b equals c. Then a power of c equals b, right? So you just draw the arrow right here. So you have s minus 1 equals 10 power of 2, right? So 10 power of 2, it could be 100, right? Now you're going to add 1 both sides, so s equals 101. Now you're going to check this one with the domain, right? 101 greater than 1. So s equals 101 is the solution, right? Now number 2, you need to find the domain, right? So the domain 2s greater than 0. Divide both sides by 2. So then s greater than 0, right? Now you need to divide both sides by 4. So you have log base 3 of 2s equals 2. Now you're going to draw the arrow. So you have 2s equals 3 squared, right? 3 squared equals 9, right? Now you need to divide both sides by 2. So s equals 9 half, right? So this is the solution because it's greater than 0, right? Now number 3, the domain s over 3 greater than 0. So then s greater than 0, right? Now natural log of s over 3 is the same thing as log base e of s over 3, right? Now you need to subtract 4 both sides, so it turns out to be 3, right? Now I'm going to draw the arrow. So I have s over 3 equals e cubed, right? Now I need to multiply both sides by 3. So s equals 3 times e cubed, right? Now this one is a solution because it's greater than 0, right? Now let's move on to number 4. We need to find the domain, right? So this one must be greater than 0 and this one must be greater than 0, right? So I have s greater than 0 and s minus 4 greater than 0. Now I need to solve a system of inequality right here. So I have s greater than 0 and s greater than 4, right? So I'm going to combine this guy right here. So I have s greater than 4, right? Alright, now I need to condense this one, right? I know that log base a of b minus log base a of c is the same thing as log base a of b over c, right? Now this guy turns out to be log base 10 of s over 3 equals log base 10 of s minus 4, right? Now both sides have the same log base 10, right? So I just equate this one and this one, right? So I have s over 3 equals s minus 4, right? Now I'm going to multiply both sides by 3. So I have s equals 3s minus 12, right? Now subtract 3s both sides. So I have negative 2s equals negative 12. And divide both sides by negative 2. So s equals 6, right? Now check the domain. S equals 6 greater than 4. So this is a solution, right? Now, number 6 similar to number 4, so I'm going to solve number 6 before number 5, right? So I need to find the domain first. So 4s greater than 0 and s minus 2 greater than 0, right? Now I need to solve a system of inequalities right here. So s greater than 0 and this one s greater than 2, right? Now I need to combine two inequalities. So I have s greater than 2, right? Now I need to condense this one by using the formula in the example number 4, right? So I have log base 2 of 4s divided by s minus 2 equals 3, right? And then I'm going to draw the arrow like this. So it turns out to be 4s over s minus 2 equals 2 power of 3. It's going to be 8, right? Now I'm going to multiply both sides by s minus 2. So I have 4s equals 8s minus 16, right? Now I need to subtract 8s both sides. So I have negative 4s equals negative 16. And then divide both sides by negative 4. So s equals 4, right? Now I'm going to check the domain. This guy greater than 2. So this is a solution. Now let's move on to number 5. I need to find the domain first, right? So I have a system of inequalities. S plus 2 greater than 0, s minus 1 greater than 0, and 3s plus 13 greater than 0, right? And I solve this one, so it turns out to be s greater than negative 2, s greater than 1, and s greater than negative 13 over 3, right? So I need to combine this one. It turns out to be s greater than 1 is the final domain, right? Now I need to condense this one by using the formula log base a of b plus log base a of c equals log base a of b times c, right? Now I need to apply the formula right here to condense this one. So it turns out to be natural log of s plus 2 times s minus 1 equals natural log of 3s plus 13, right? Now both sides have the same natural log, so I just equate this guy and this guy, right? So now I just distribute this one, right? So it turns out to be s squared minus s plus 2s could be plus s, right? Minus 2 equals 3s plus 13, right? Now I move every single thing right here over, right? So it turns out to be s squared 3s, bring it over here, it could be negative 3s, so it turns out to be negative 2s, right? 13, move it over here, so it could be negative 13, so negative 15 equals 0, right? Now I need to factor this one using the s method, right? I need to find two integers multiply equals negative 15 and add up to negative 2, which is negative 5 and 3, right? So this guy turns out to be s minus 5 times s plus 3, right? Equals 0. And then this is a 0 product, so s minus 5 equals 0 or s plus 3 equals 0. And then s equals 5, s equals negative 3, right? Now I need to check the domain. The domain is s greater than 1, so only one solution right here, right? This is not a solution, right? So be careful. Now number 7 similar to number 5, right? So I need to find the domain, right? So I have a system of two inequalities, right? So I have s greater than 0 and 2s plus 13 greater than 0, right? So it turns out to be s greater than 0 and s greater than negative 13 over 2. And finally, unit s greater than 0 is the final domain, right? Now I need to condense this one using the formula right here. Before I condense this one, I need to bring 2 back over here, right? I'm going to use the formula k log base a of b equals, bring it over here, so it could be log base a of b power a, right? So keep that in mind. Now this guy turns out to be natural log of s plus natural log of 3 squared, right? Equals natural log of 2s plus 13, right? Now I'm going to condense this one using the formula right here. So I have natural log of 3 squared equals 9, right? So I have 9s equals natural log of 2s plus 13, right? Now I need to equate this guy and this guy, right? Because they have the same natural log, right? So it could be 9s equals 2s plus 13, right? Now subtract 2s both sides, so I have 7s equals 13, right? divide both sides by 7, so s equals 13 over 7, right? This one greater than 0, right? Because the domain right here greater than 0, so this is a solution. Now let's move on to question number 8. Given two functions f of s and g of s. Now first we need to find the domain of these two functions, right? So I need to find the domain of the function f of s first, right? So it's gonna be s minus 3 greater than 0, right? Add 3 both sides of s greater than 3, right? Now the domain for the function g of s is gonna be s plus 2 greater than 0, right? So s greater than negative 2, right? Alright, now question A. Solve for f of s equals 1 for value of s in the domain of f, right? So f of s equals 1, which means 1 half log base 10 of s minus 3 equals 1, right? Multiply both sides by 2, right? So it turns out to be log base 10 of s minus 3 equals 2, right? Now I'm going to draw the arrow, right? So I have s minus 3 equals 10 square, right? 10 square equals 100, right? Now I need to add 3 both sides, so s equals 103, right? 103 greater than 3 right here, so this is a solution, right? Now question B, solve for g of s equals 8, right? So I have 3 natural log of s plus 2 equals 8, right? Now I need to divide both sides by 3, so I have natural log of s plus 2 equals 8 divided by 3, right? Natural log is the same thing as log base e of s plus 2, right? Equals 8 over 3, right? Now I need to draw the arrow, right? So it turns out to be s plus 2 equals e raised to the 8 over 3, right? Now I need to subtract 2 both sides, so s equals e raised to the 8 over 3 minus 2, right? Now look at the domain right here. We need s greater than negative 2, right? This one actually greater than negative 2, right? So this is a solution. Now question 9. The function j and k are given by these two guys, right? Rewrite j of s as a single natural logarithm without negative exponent in any part of the expression, right? Your result should be of the form natural log expression, right? Alright, so these are key information you need to keep in mind, right? Now j of s is going to be 1 over 3 natural log of s minus 4 natural log of y, right? Now you can print this guy back, right? Print this guy back over here. Remember, log base a of b. You have k in the front, you can print k back over here. So it could be log base a of b raised to the power of k, right? So this guy turns out to be natural log of s power of 1, right? Minus natural log of y power of 4, right? Now I'm going to use the formula log base a of b minus log base a of c equals log base a of b over c, right? Now natural log, which means log by e, right? Alright, so I can condense this one using the formula on the right hand side right here. So it turns out to be natural log of s power of 1 divided by y power of 4, right? You can leave your answer like this, or you can convert it to radical, right? So s power 1/3 is the same thing as natural log of cube root of s over y power of 4. Now, right? Now you're going to check to see if you satisfy the condition right here without negative exponent, right? You don't have negative exponent. Your result should be of the form natural log and expression. Yes, that's correct, right? This is natural log and expression. So this is the final answer. Alright, this question you're going to see mostly on the AP exam for the free response question. Now question B. Rewrite k of s as a single logarithm base 10 without negative exponent, right? Your result should be in this form, right? Alright, so k of s right here, I'm going to copy over here. So it turns out to be 3 log base 10 of s plus 2 minus log base 10 of s plus log base 10 of 5, right? Now I'm going to use the formula right here. I'm going to print 3 back over here, right? So it turns out to be log base 10 of s plus 2 q, right? Minus log base 10 of s plus log base 10 of 5, right? Now I'm going to use this formula right here to condense the first two right here. So it turns out to be log base 10 of s plus 2q over s, right? And then plus log base 10 of 5, right? Now I'm going to use the formula log base a of b plus log base a of c equals log base a of b times c, right? So I'm gonna condense this one. So it turns out to be log base 10 of 5 times s plus 2q over s. And this is the final answer, right? It satisfies this guy right here. And without negative exponent right here, right? Now let's move on to number 10. Given a function k of s right here, solve for k of s equals 7e for value of s in the domain of k, right? This is the exponential function, so the domain should be all real numbers, right? Now we have 2 times e raised to the 3s minus e equals 7e, right? I'm going to add e both sides, so I have 2e raised to the 3s equals 8e, right? Now divide both sides by 2. So it turns out to be e raised to the 3s equals 4e, right? Now I'm going to take natural log both sides. So I have natural log of e raised to the 3s equals natural log of 4e, right? Now for this one, I just bring 3s to the front, right? So I have 3s natural log of e equals natural log of 4e, right? Now I'm going to divide both sides by 3 natural log of e, right? Because I need to solve for s, right? So s equals natural log of 4e divided by 3 natural log of e, right? Now I need to simplify this one, so I'm going to expand this one using the formula right here. Alright, the product becomes the sum, right? So it could be natural log of 4 plus natural log of e over natural log of e equals 1, right? So it's going to be 3, right? Now natural log of e equals 1, right? So this guy turns out to be natural log of 4 plus 1 over 3. This is the final solution. Now let's move on to number 11. What are all values of s for which h raised to the 2s plus 1 equals 1/4, right? We need to make this equation have the same base both sides, right? So h right here I can write as 2 power of 3, right? Times 2s plus 1, right? This one right here I can write as 1 over 2 square, right? Now 2 square I can bring to the top. It turns out to be 2 power of negative 2, right? Now I need to equate the exponent, right? This guy equals this guy because they have the same base 2, right? So it could be 3 times 2s plus 1 equals negative 2. Now I need to distribute this one, so it could be 6s plus 3 equals negative 2, right? Subtract 3 both sides, so 6s equals negative 5, right? So s equals negative 5 over 6, right? This is the solution. Now let's move on to question number 12. This one is calculator active, right? So we can use the calculator to do this problem, right? Now, starting in 2018, a biologist studied the population of largemouth bass in a particular lake over several years. In 2019, which means t equals 1, there were 430 largemouth bass in the lake. In 2023, which means t equals 5, there were 715 largemouth bass in the lake. The number of largemouth bass in the lake can be modeled by the function L, given by L of t equals a plus b natural log of t, where Lt is the number of largemouth bass in the lake during the year t, and t is the number of years since 2018, right? Question A. Use the given data to write two equations that can be used to find the values for constant a and b in the expression for Lt, right? So you have equation right here. Now t equals 1, you have this guy, right? So you have L1 equals a plus b natural log of 1, and then this guy equals 430, right? The second equation, L5 right here, equals a plus b natural log of 5 equals 715 right here, right? Now question 2, find the values of a and b, right? So from this system of two equations right here, I have a plus b times natural log of 1. Natural log of 1 equals 0, right? So this guy turns out to be a equals 430, right? Now second equation, you have a plus b natural log of 5 equals 715, right? So you substitute 430 for a in this equation, right? So you have 430 plus b natural log of 5 equals 715, right? Now subtract 430 both sides, so you have b natural log of 5 equals 715 subtract 430. It's gonna be 285, right? Now divide both sides by natural log of 5, so b equals 285 divided by natural log of 5, right? Now you can bring up the calculator, so you have 285 divided by natural log of 5. It's going to be 177.08, right? Now question B. Use the given data to find the average rate of change of the number of largemouth bass in the lake in fish per year from t equal 1 to t equal 5 years. Express your answer as a decimal approximation. So recall that the average rate of change formula is going to be f of b minus f of a over b minus a, right? Now in this situation, it's going to be L, right? So I'm going to use L right here. So it's going to be LB, which means right here 5, right? L5 subtract L1, right? L1 right here. Divide by 5 minus 1, right? Now L5, I got it right here. 715, right? So I have 715 subtract L1, I got it right here. 430 over 5 minus 1, right? So this guy turns out to be 285 divided by 4, right? So it's going to be 71.25, right? Question 2 right here. Interpret the meaning of your answers from I in the context of the problem. Alright, so this is the average rate of change right here. So we're going to say that from 2019 to 2023, the population of largemouth bass increased at a rate of 71.25 bass per year. Now question 3, consider the average rate of change of the function L from t equal 5 to t equal b years, where p is greater than 5. And this average rate of change less than or greater than the average rate of change from t equal 1 to t equal 5 years found in 1. Explain your reasoning. Alright, so this guy right here, we got it right here, 71.25. Now, they ask us to determine if the average rate of change from t equal 5 to t equal p, where p greater than 5 is greater than or less than 71.25, right? So we're going to use the calculator to graph this function, right? Now, before we graph the function, we need to write the function first, right? So the function is going to be right here. LT equals a plus b natural log of t, right? So I have LT equals a plus b times natural log of t, right? Now, a equals 430, right? B equals this guy right here, right? Or you can use this one, 285 over natural log of 5, right? So this guy turns out to be 430 plus 285 over natural log of 5. Remember that this one is a constant, right? And natural log of t right here, right? Now I'm going to bring up the calculator. So I'm going to hit add graph right here, right? So I'm going to put the function right here. So I hit enter. Now I need to adjust the window range, right? So I need to hit menu, window, zoom, and hit window setting right here. Alright, so as mean, I'm going to put 0. As mass, I'm going to put 10. The scale is auto, right? Y mean, I'm going to put negative 5. Y mass, I'm going to put 1000. Alright, hit OK. It's going to be like this, right? And observe that the function is concave down, right? Now I'm gonna sketch this one over here. The arbitrary change of the function L from t equals 5, this is 5 right here, to t equals p, so p is somewhere else right here because p is greater than 5, right? So it's gonna be something like this. Alright, now the arbitrary change of the function L from t equal 5 to t equal p are going to be less than the arbitrary change from t equals 1 to t equals 5, right? Because the function L is concave down, so the arbitrary change is decreasing, right? Now let's move on to question number 13. The table above gives selected values of the life expectancy in years and income in $1,000 per year for individuals around the world. The data in the table can be modeled by the function L of S equals A plus B natural log of S, where S is the individual income in $1,000 per year, and L is the predicted life expectancies in years. Find the equation of L of S using the regression features of your graphing calculator. Alright, so I'm going to use 3 different methods: TI and SPY calculator, TI-84 plus CE calculator, and decimal. Alright, first I'm going to bring up the calculator right here. Alright, so I need to go to home screen, right? I need to hit spreadsheet right here, right? I need to name the first column, it's going to be S. The second column should be Y, right? Now I need to input the values for this table, right? Alright, now I need to move my cursor to the right column of Y columns, right? So it's going to be right here. Alright, so I need to hit menu, number 4 statistic, number 1 start calculation, and I need to find the logarithmic expression, right? So I need to go down, it's going to be right here, B, right? Now this one I need to name S, should be Y, right? Now it's going to be this one right here. Alright, so the equation should be L of S equals 56.8135 plus 6.5338 natural log of S, right? Now if I'm going to use the TI-84 plus CE calculator, I just hit start right here, edit. Now F1, which means the first column right here. Remember this one is S and this one is Y, right? So I just input the values for this table, right? Alright, so now I'm going to hit start again, go to count, find the logarithmic expression. Now hit number 9, logarithmic regression, right? L1 is the S column, L2 is the Y column. Go to store right here, hit vars, Y vars, function Y1 so that the calculator save our equation as Y1 for later use, right? Calculate. Alright, so it can be like this. It's exactly the same thing right here, right? Alright, so you can use decimals. You just hit the plus sign right here. Alright, table. Now you just input the values for this table. Alright, now you hit the 4 dots right here. And then you need to choose logarithmic regression. It's going to be right here. Alright, make sure you need to put the check mark for the log mode right here to get the exact value, right? So it's right here, right? Now question B. In 2009, the United States had a per person income of $41,256.10. And a life expectancy is going to be 79.43 years. What is the result of this data using the model found in part A, right? So we know that the result is going to be actual value subtract the predicted value, right? So this one is the actual value, right? It's going to be 79.43. Now we need to find the predicted values given the income is going to be $41,256.10, right? Now look at the table right here. Make sure the income is counted at 1,000, right? So you need to convert it one to decimal. So it could be 41.256, right? So it could be L of 41.256 10, right? Now, you're gonna bring up the calculator right here. Previously, you're gonna save your equation as F2, right? So now I need to hit Control I. I need to add calculator and I just hit F2. Alright, so remember whatever equation you save, you need to memorize that one, right? So I have F right here, 2. Parenthesis, I hit 41.256.110. Alright, so I hit enter. The answer is 81.1181, right? So it could be 79.43 subtract 81.1181, right? Alright, so I need to subtract this one from 79.43, and the answer must be negative 1.68815, right? Now you can use TI-84 plus CE calculator, right? Previously you saved your equation as y1, right? Now you just hit fast y1 function y1, right? You hit parentheses and you hit 41.256 and you hit enter. It's gonna be right here, right? And you subtract it from 79.43, right? It's gonna be right here. So negative 1.68, right? Now if you use that mode, you need to copy this equation into the new line right here, right? So I have f of s. I just hit f of 41.256, right? And I hit enter. It's gonna be 81 right here, right? Question C, a given country has an average income of $43,500. According to the model found in Part A, what is the average life expectancy of an individual from this country? Alright, so you just use this one right here. Now you just bring up the calculator. You just hit F2 again, right? Hit parentheses and you just hit 43.5, right? And hit enter. It's gonna be 81.4642 years, right? So now let's move on to question number 14. Question number 14 is similar to question number 12. Alright, so I'm gonna leave this one for you to practice. I'm gonna give you the key, right? So the key right here, A equals 570 and B equals negative 65.2401, right? Now let's move on to part 3, calculators active, right? Now, number 15, plot the following points on the same coordinate plane above. So this is semi-log plus, right? Now point A has the coordinate 0, 30, right? So x equals 0, y equals 30, right? So you know that this is 10, and this is 20, and this guy is 30, right? So point A is right here. Alright, point B, 1, 2. So this is 1 and 2 right here, right? The y-axis 1 and this guy 2, 3, 4, 5, something like that, all the way to 10, right? So 1, 2 should be right here. This is point B. Now point C, 2, 400, right? So 2 right here, 400. This is 100, 200, 300, 400. So it could be right here. This is point C. Now point D, 3, 1.5. So 3 right here, and this is 1. This is 2, 1.5 should be half of this one. So this could be right here. This is D, right? Now E, 4, 11. This is 4, and this is 10 right here, and this is 20, right? So 11 should be above 10 a little bit. So it could be right here, right? So this is E. Now let's move on to number 16. The grid above is a semi-log plot with the vertical axis logarithmically scaled. Plot the following points on the same coordinate plane above. Now, point A, 0, 2, right? So 0, this is 1, this is 3, this is 2 right here, right? So this is point A. Now, point B, 10, 18, this is 10 right here. Now, 18 is going to be right here, right? This is point B. Now, point C, 20, 6, this is 20, this is 3, this is 6, 6 should be right here, right? Now, point D, 30, 12, 30 right here, and 12 right here. This is 3, this is 9, right? Right? So this guy should be D. Now 40, 1.5, so it could be right here, right? Now number 17, the function f is graphed on the semi-log plot above, where the vertical axis has been logarithmically scaled. Which of the following function could be a model of f, right? Alright, so now first we need to connect this guy. And observe that this guy is a linear function, right? So we need to check to see if this guy right here a linear function, right? In the y-axis is logarithmically scaled, right? So we're gonna take natural log both sides, right? So I have natural log of f of s equals natural log of 2 plus e times s, right? It turns out to be y equals natural log of 2 plus e times s, right? So this one is the logarithmic function, right? This is not a linear function, so a is wrong. Now b, take natural log both sides, so I have natural log of f of s equals natural log of 2 plus e to the s, right? So this guy turns out to be y equals natural log of 2 plus e to the s, right? This one is the logarithmic function. This is not a linear, so b is wrong. Now see, natural log of f of s equals natural log of 2 times e to the s, right? So I'm going to use the product rule, so I'm going to expand this one, right? So it's going to be natural log of 2 plus natural log of e to the s, right? Now I can bring s to the front, so it turns out to be y equals natural log of 2 plus s natural log of e, right? So I can rearrange this one. It's going to be natural log of e times s plus natural log of 2, right? So it's the same thing as ms plus b, right? Where m equals natural log of e and b equals natural log of 2. They're both constant, right? So this is a linear function, so the answer must be C. Now we can check the last one. It's going to be natural log of f of s equals natural log of 2 times e raised to the negative s, right? So it's going to be y equals, use the product rule, expand this one, so it can be natural log of 2 times plus natural log of e raised to the negative s. Bring this one to the front, so it turns out to be natural log of 2 minus s natural log of e, right? So this guy turns out to be natural log of e times s right here. Don't forget the negative side right here. Plus natural log of 2, right? So it's going to be negative ms plus b, right? The slope is negative, right? Which means the graph going down like this, right? But you look at the graph right here, it's going up, right? So this one is not the right answer, right? Now let's move on to number 18. A set of data is shown on the semi-log plot above. If an exponential regression is used to model this data, which of the following claim and explanation statements best fits this data? Alright, so go back to number 17 right here. If an exponential regression is used to model this data, the line should be straight line, right? It should be linear, right? Now, you look at this one, it's not a straight line. It's a curve, right? So answer choice A. The ridge-draw plot will show a clear pattern. Because the exponential model was appropriate. No, the exponential was not appropriate, right? Because it's a curve, right? So answer choice A is wrong. The ridge-draw plot will show no clear pattern because the exponential model was appropriate. So this is wrong, right? Answer choice C. The ridge-draw plot will show a clear pattern because exponential model was not appropriate. This is right, right? D. The ridge-draw plot will show no clear pattern because the exponential model was not appropriate, right? This one must be clear, right? So this is wrong. And it's good time to stop. Unit 3, Trigonometry and Polar Functions. Topic 3.1, Periodic Phenomenon. Alright, question 1. The figure shows two full periods of the periodic function f. Which of the following statement is true? Alright, so we need to find the period of this function, right? So the period is going to be from here to here, right? So it's going to be 6 subtract 1 is going to be 5, right? Now we need to look at the answer choice and we need to eliminate the wrong answer, right? So we need to eliminate B and D. Alright, f of 31, we need to rewrite this one in terms of the period, right? So it's going to be f of how many times from number 5 go into 31? It's going to be 6 times, right? So it's going to be 6 times 5 plus 1, right? Now you just ignore this period, right? So it's going to be f of 1. And then f of 1 equals 1 right here, right? So the answer is A. Now we're going to use this information to do question 2 to 4. Alright, what is the period of the function g? Now we look at the graph, we see that this is where the period start and this is where the period end. Alright, so the distance from here to here, it could be from 0 to 7. So you take 7, subtract 0, it's going to be 7. So the period is 7. It's going to be B. Now question 3, what is the value of G32? We know that the period is 7, we just write 32 in terms of 7. So it can be equal to G of, now how many times for number 7 go into 32? It's actually 4 times, right? So it could be 4 times 7. And then the remainder should be 4, right? Because 4 times 7, it could be 28. 32 subtract 28, it could be 4. Right, so this guy is the same thing as G of 4, right? Now G of 4, we look at this one, it's going to be right here. The answer is 4, right? So the answer must be D. Now question 4, on which of the following intervals is the function g decreasing? Now in order to know if the function g is decreasing, we need to write each of these intervals right here in terms of period, right? So we know that the period is 7, right? So we just rewrite 70 in terms of 7, which is 10 times 7, right? Now you take 70, you divide by 7, you get 10, and the remainder is 0, so you're going to add 0, right? Comma, 72 divided by 7, you get 10, right? So 10 times 7, and remainder 2, right? So this guy is the same thing as 0, comma 2, right? Now the interval 0, comma 2 is going to be from here to here, right? So it could be right here. This is not decreasing, right? So this is wrong. Now same thing for this one. It's going to be 10 times 7 plus 2, comma 10 times 7 plus 4, right? So it's the same thing as 2 to 4, right? Because you just ignore this guy, right? This is multiple of periods, you just ignore it. So 2 to 4, it's going to be right here. This one is increasing, right? So this is wrong. Now 74 to 76, if you do the exactly same thing, it's going to be 4 to 6, right? Now look at 4 to 6, it's going to be right here, decreasing, right? So the answer must be C. Now let's move on to the next one. The graph of the function f is periodic with a period of 8. Value of f are shown as selected values of s. Use the information provided in the table to answer problem 5 to 7, right? Now we need to calculate f of 3. We need to rewrite f of 3 in terms of period right here, right? So remember that you can add or subtract the period, okay? So it's going to be f of 3 equals -5 plus 8, right? Now, after you have the period, you just ignore the period, so it could be f of -5, right? Now, f of -5, it could be -11 right here, right? So the answer must be A, right? Now, we need to rewrite f of -4 in terms of the period, so it could be f of 12 minus 2 times the period, right? Alright, so you just ignore this one right here, right? So it could be f of 12. Now f of 12 right here equals -6. So the answer should be B, right? Now question 7. For which of the following values of s does f of s equals -4, right? Now f of s equals -4, so you look at the table right here, it's going to be right here, right? So s must be 1. Now, you look at the answer choice right here, you don't see it's 1. Alright, so you can rewrite this one as f of 1 equals -4, right? Now I can rewrite f of 1 in terms of the period right here, 8, right? So I turn this one into 9 subtract 8, right? Now remember that if you add or subtract multiple of the period, and then it's gonna be answer still the same, right? So basically I just ignore this one right here. So this guy is the same thing as f of 9, right? F of 9, which means f of s, right? So s equals 9, right? So the answer must be D. Now let's move on to question 8, 9, and 10. The graph of h is periodic where h of s plus 9 equals h of s. Values of h are shown as selected values of s. Use the information provided in the table to answer problem 8 to 10. Alright, we need to calculate h of 2. This tells us that the period is 9. h of 2 can be written in terms of period, so it can be h of 2 minus 9, right? Remember that you can add or subtract multiple period, your answer stay the same, right? So this guy is the same thing as h of negative 7, right? So h of negative 7 equals 16, right? So the answer is D. Now question 9, h of h negative 3, right? Now h could be h of, now h of negative 3, h could be 10, right? So I just write 10 right here. Now we need to write h of 10 in terms of the periods, right? So it could be h of 1 times 9 plus 1, right? So it's going to be h of 1, right? Because I just ignore this one, right? So h of 1 equals 7 right here. So the answer is B. Now question 10. What is the value of h of 9k minus 1 where k is an integer? Now this one can be written as h of negative 1 plus 9k, right? So this one is the multiple of period, right? You just ignore this one. So this guy turns out to be h of negative 1, right? Now h of negative 1, you look at the table right here, it's not given, right? So you need to rewrite this one, right? And you know that, again, the period is 9, right? So h of negative 1 can be written as h of 8 subtract 9, right? This one is the period, so you just ignore it. So it could be h of 8, right? h of 8 is going to be negative 4 right here, right? So the answer is C. Now let's move on to question number 11. The figure shows a circle center at the origin with an angle of measured theta radians in standard position. The terminal right of the angle intersects the circle at the point R, right? Point R right here, and point S right here. Also lies on the circle. The coordinates of point R are negative s and y, right? So this is negative s, comma y, right? And the coordinates of point S are s and y. This is s and y. Which of the following is true about the cosine theta? Alright, so you have two different ways to do it. The first way is you need to find the reference angle because angle theta right here is bigger than 180 degrees, right? So the reference angle should be this one right here. Alright, remember that the reference angle is the angle created by the terminal right and the closest x-axis, right? So it's going to be right here. Now you look at the right triangle right here. So we're going to use cosine, right? Cosine it could be adjacent over hypotenuse. So keep that in mind. So we have cosine theta equals adjacent, which means this one right here, right? So this guy, which means negative s right here, right? Negative s over hypotenuse, which means this one right here. And this is the radius of the circle, which is 8 right here, right? So it could be 8. So the answer must be 8 right here, right? Now the second way you're going to do this one is to remember the formula. We have s equals r cosine theta and y equals r sine theta, right? Right, so s in this situation, which means negative s, right? So negative s right here. So you can calculate cosine theta equals negative s over r, right? So it can be negative s over r, which means 8. So the answer, negative s over 8, right? Now let's move on to question number 12. In the xy plane, two different angles, alpha and beta, are in standard position. Alright, so if two angles are in standard position, they have the same initial rate, right? Which means the positive x-axis, right? And share a terminal rate, right? Based on this information, which of the following gives possible values for alpha and beta? Now, if two angles share the same terminal rate and initial rates, they are coterminal angles, right? So if they are coterminal angles, the difference between them must be multiple of 2 pi, right? So beta equals alpha plus or minus k2 pi, or beta equals alpha plus or minus 2 pi, right? So I'm going to check the answer. A, B, C, and D. Now, alpha equals negative pi over 2. I need to add or subtract 2 pi. If I subtract 2 pi, it's going to be negative 5 pi over 2. It's not beta, right? So I need to add 2 pi to see what happens. So it could be 3 pi over 2. So answer choice A is not correct, right? Answer choice B is not correct because we have 3 pi over 2. This is negative 3 pi over 2, right? Now, answer choice C and D. Angle alpha is pi over 2, right? So I have pi over 2. I need to subtract 2 pi. It's going to be negative 3 pi over 2, right? So answer choice C is correct. Now let's move on to question number 13. Question 13 is similar to question 11. You still have two different ways to do it. Alright, you see that the angle theta is going to be right here. So you need to find the reference angle, which is this guy right here, right? And you use the trig ratio, right? So this guy is opposite, this guy is adjacent, and this guy is hypotenuse, right? So you look at the answer choice right here, sine theta, right? So you need to write sine theta equals opposite over hypotenuse, right? Now opposite, which means the y value of the point S right here. Point S it could be S, comma, negative y, right? So it could be negative y over hypotenuse, which is the radius right here, 5, right? So it could be negative y over 5. So the answer must be C, right? Or you can use the formula S equals R cosine theta, y equals R sine theta, right? So in this situation, we need to calculate sine, right? So we don't need to worry about this guy, right? So sine theta equals y divided by r, right? Now y in this situation is going to be negative, right? So negative y divided by 5, right? So the answer must be C. Now, question number 14 is similar to question number 12. Alright, you're going to do exactly the same thing, right? So I'm going to leave this question for you to practice. The answer must be D. Now let's move on to question number 15. Question 15 is similar to question number 13. The only thing different right here is tangent. Alright, so we look at this one right here, the angle theta right here. We need to find the reference angle. The reference angle should be this guy right here. Alright, so you're going to apply the trig ratio in the right triangle right here. Now again, you have two different ways to do it. Alright, the first way, you're going to draw the arrow and this guy becomes opposite. This guy becomes adjacent. This guy becomes hypotenuse. Now I put the point P right here. It's going to be S, comma, Y. And point R right here. It's going to be S, comma, negative Y. Right? So tangent theta equals opposite, which means this guy right here. This guy has the value Y, right? So Y over adjacent. It's going to be right here. Right? This guy, which means the S value right here. So tangent theta equals y over s, right? So the answer must be A, right? You apply the formula tangent theta always equals y over s. You learned before with the formula s equals r cosine theta, y equals r sine theta. Alright, so if you memorize the formula, it's gonna be helpful, alright? Now, question number 16, similar to question number 15. So, point P is going to be 4, 3. Alright, what is the value of tangent theta, right? Again, we have tangent theta equals y divided by s, right? Now, we need to find the reference angle, right? So, the reference angle should be right here. Alright, so we need to use this right triangle right here. Alright, so we draw an arrow. So this guy becomes opposite, this guy becomes adjacent, this guy becomes hypotenuse, right? So I have tangent theta equals opposite over adjacent. Opposite, which means the y value right here, right? Now we need to find the coordinate of point R. Point R is the reflection point of point P over the y-axis, right? So point R has the coordinate negative 4 and 3, right? So it's going to be y over s, right? Now y equals 3, s equals negative 4, right? So it could be A. Now question number 17, similar to question number 16. Alright, I'm going to leave this one for you to practice. The answer must be A. Now let's move on to question number 18. The figure shows a circle center at the origin with an angle of measure theta radians in standard precision, whose terminal ray intersect the circle at a point P and coincides with the line y equals -4/3s, right, in quadrant 2. Which of the following is true about the angle theta? So quadrant 2 right here. And you look at the angle theta right here. This is obtuse angle, right? So we need to find the reference angle, right? So the reference angle must be this guy right here, right? Now you need to create a right triangle, right? Now how do I know the side length of this guy and this guy, right? So I look at this one right here. This guy actually of this line right here, right? So it's gonna be y equals ms plus b, right? Now I just look at the slope right here. The slope, which means rise over run, right? Which means delta y divided by delta s, right? Now this guy actually rise. This guy actually run, right? Now I'm gonna draw the arrow right here, right? So I have tangent theta, right, equals opposite over adjacent, right? Opposite, which means rise right here, right? Rise, which means -4, right? Over adjacent right here, which means run. Run is 3 right here. So the answer is tangent theta equals -4/3. It must be D, right? Now question number 19. The figure shows a circle center at the origin with an angle of measured theta radians in standard position in a point P right here. On the circle, the terminal ray of the angle intersects the circle at a point Q here. The length of the arc PQ is 15 units, so this guy right here is 15. Now, which of the following gives the distance of point Q from the x-axis, which means they ask you to calculate this guy right here. Alright, so you need to find the angle theta first. Alright, so you know that angle theta equals length divided by radius. Because you have the formula arc length equals radius multiplied by angle theta, where theta is the central angle. Arc length is 15, right? So you have angle theta equals 15 divided by radius is 13 right here, right? So this guy equals 13. Now, this guy right here is y value, right? Now we need to calculate the distance from point Q to the x-axis, which is y value, right? So we have y equals r sine theta, right? So it's gonna be 13 sine of 15 over 13. So the answer must be D. Now if the question asks you to calculate the distance from point Q to the y-axis, which means S, right? So S equals r cosine theta, right? So it could be 13 cosine of 15 over 13, right? So in this case, the answer must be C, right? Now question 20, similar to question 19, but you need to calculate S value, right? So I'm gonna leave this one for you to practice. Alright, the answer must be C. Now let's move on to question number 21. The figure above shows a circle of radius phi along with the equilateral triangle PQO. Alright, which of the following gives the coordinates of point P? Alright, point P right here. Now, since the triangle POQ is an equilateral triangle, then the y-axis right here must be angle bisector of angle O right here, right? So each of this one must be the same, right? Now, we need to find the angle from here to here. Now, let's call this one as theta, right? So angle theta equals this angle right here, you know that 90 degrees, right? So it could be pi over 2 plus this guy right here, the little guy right here, right? This guy is half of this guy right here. But this guy right here equals 60 degrees of pi over 3, right? Because this one is equilateral triangle, so the measure of each angle must be 60 degrees, which is pi over 3, right? So this guy turns out to be 1/2 of pi over 3, right? Now you simplify this one, it's going to be pi over 2 plus pi over 6, right? So it's going to be 4 pi over 6, right? So it's going to be 2 pi over 3. So angle theta equals 2 pi over 3. Now you're going to apply the formula S equals R cosine theta. Alright, so R equals 5, right? Because the radius 5 right here. Times cosine of 2 pi over 3. And Y equals R sine theta. It's going to be 5 sine of 2 pi over 3. Now you need to find the coordinate points that has this guy. Right? So the answer must be C. Now let's move on to question number 22. The figure above shows a circle of radius 10, along with the isosceles right triangle PQO. Right? Which of the following gives the coordinates of the point P? Right? So we need to find the angle theta right here. Alright. Now observe that this angle right here equals 90 degrees, right? Or pi over 2. And this is isosceles triangle. So this x-axis becomes an angle bisector of this one, right? So each of this guy right here must be pi over 4, which is 45 degrees, right? So you have pi over 4 right here. So angle theta right here equals the whole thing right here, which is 180 degrees of pi, right? Subtract this guy right here, which means pi over 4, right? So it's going to be 3 pi over 4, right? Now, after you have this one, you just apply the formula. S equals R cosine theta, right? So it could be 10 cosine of 3 pi over 4. Y equals R sine theta. So it could be 10 sine of 3 pi over 4. Alright, now we look at the answer choice to see if anything match this one. Unfortunately, there's nothing right here match this guy right here. Alright, so we need to manipulate this one a little bit. Now you look at the unit circle. This is pi over 4. And this is 3 pi over 4. Alright, so cosine of 3 pi over 4, which means right here, and cosine of pi over 4, which means right here, they have the same absolute value, right? But they're opposite side, right? So this one right here can be written as negative 10 times cosine of pi over 4, right? Because cosine of pi over 4 is the same thing as negative cosine of 3 pi over 4, right? So I put negative sign in the front, so it can be negative 10 times cosine of pi over 4. Now, I look at the sine function, which means the y-axis right here, right? This is the sine function, this is cosine function. Pi over 4 and 3 pi over 4 have the same value right here. It's going to be right here. Alright, so this one right here, I just replace sine 3 pi over 4 with sine pi over 4 without changing anything. Right, so it can be 10 sine of pi over 4. Right, so this one is the y value, and this one is the s value. Right. Alright, now look at the answer choice. Definitely C. Right. Now let's move on to question number 23. Given the function f of theta equals 6 cosine theta, what are all values of angle theta for theta from 0 to 2 pi? So this one is the restricted domain, right? So you need to solve for 6 cosine theta equals negative 3, right? Divide both sides by 6, so cosine theta equals negative 1/2, right? Now, we look at the unit circle. We see that the angle where cosine theta equals negative 1/2, which is 2 pi over 3 and 4 pi over 3, right? So, the answer must be D. Now, question 24. The function g is given by g of theta equals 2 sine theta. Alright, we need to solve for g theta equals root 2 within this domain, right? So it can be 2 sine theta equals root 2. Divide both sides by 2, so sine theta equals root 2 over 2. Alright, now the angle where sine theta equals root 2 over 2, which is theta equals pi over 4 and 3 pi over 4, right? So the answer must be A. Now let's move on to the last two questions. the function h is given by h of theta equals 2 minus sine theta. We need to solve for h of theta equals 2, where theta from 0 to 2 pi, right? So I have 2 minus sine theta equals 2, right? Subtract 2 both sides, so negative sine theta equals 0, right? So sine theta must be equals 0, right? So theta equals 0 and pi, right? Because on the unit circle right here, the angle theta that makes sine theta equals 0 is 0 right here and pi right here, right? So the answer must be C. Now let's move on to the last one. Alright, so we have k theta equals 2, right? So we have 1 minus cosine theta equals 2. So cosine theta equals negative 1, right? Now, the angle theta that makes cosine theta equals negative 1 in this domain right here, theta must be pi, right? So the answer is C. Topic 3.4 to 3.7, sinusoidal functions, graphs, and modeling. Question 27. The figure shows the graph of a sinusoidal function f. Which of the following values is the period of the function f? Right? So we look at the graph right here. We need to look at the midline, right? Then we're gonna observe that the period is the length within one cycle, right? So you need to find where's the cycle start and where's the cycle end, right? So the cycle starts right here and end right here. And then the pattern keeps repeating, right? So this graph has two cycles, right? So the distance from here to here is the period, which is pi, right? So the answer must be C. Now let's move on to question number 28. The figure shows the graph of the sinusoidal function g. What is the amplitude of a function g? Alright, so first you need to draw the midline. The midline is 1, right? D equals 1. So the amplitude is the distance from the midline to the maximum. So it could be 3 subtract 1, it could be 2, right? So the answer must be B. Or you can apply the formula amplitude equals maximum subtract minimum divided by 2. Right, maximum is to be 3. Subtract minimum is to be negative 1 divided by 2. So the answer is 2. Now let's move on to question number 29. The figure shows the graph of a trigonometric function f. Which of the following could be an expression for f of s? Now observe that the function starts from the midline, right? So then this is the sine function, right? Now the sine function is going to be like this. Alright, so it goes from the midline up to the maximum, go back to the midline, go down to the minimum, and back up to the midline. Alright, now you look at this one right here, you see that the function starts from the midline, go down to the minimum. So there is a reflection, which means there is a negative sign in front of the function sine, right? So you need to eliminate A, right? We need to find the period, right? So the period is pi, right? It's to be from here to here. So we have the formula, the period equals 2 pi over B, right? But we have the period is pi, so we need to solve for B, right? So B equals 2 pi over pi, right? So it could be 2. So B equals 2, we need to eliminate this one because B equals 1. This one B equals 2, this one B equals 1 half, so this is wrong, right? So the answer must be C. Now let's move on to question 30. The graph of the sinusoidal function g is shown in the figure above. The function g can be written as g of theta equals a sine theta plus d. What are the values of the constants a and d, right? A, which means amplitude, right? So we have a equals maximum subtract minimum divided by 2, right? Maximum is going to be 0, right? The highest point right here. Minimum is the lowest point right here, which is negative 4, right? So you have 0 minus negative 4 divided by 2. So it could be 2, right? So you need to eliminate A and B. Now the midline D equals mass plus mean divided by 2, right? So it could be 0 plus negative 4 divided by 2. So it could be negative 2. So the answer must be C. Now question 31, similar to question 30. And we need to solve for A and B, right? Now the amplitude is going to be maximum subtract minimum divided by 2, right? So maximum is going to be 4. Minimum is going to be negative 8, right? So 4 subtract negative 8 divided by 2. Alright, so it will be 6, right? So the answer B and D incorrect, right? Now you need to solve for B. So you need to find the period first, right? Because B equals 2 pi divided by period, right? Now the period is the distance from here to here, right? So it could be pi, right? So 2 pi divided by pi. This could be 2. So the answer must be C. Now let's move on to question number 32. We need to find the period and amplitude of the function f, right? So the period is going to be from here to here, right? It's going to be pi over 2, right? So you need to eliminate A and B. Now the amplitude is maximum subtract minimum divided by 2, right? Maximum right here is 3, minimum is negative 1, right? So 3 minus negative 1 divided by 2 is going to be 2, right? So the answer must be D. Now question number 33, we need to find amplitude and the midline, right? So amplitude is going to be maximum subtract minimum divided by 2, right? So maximum is 6, minimum is negative 2, and it's going to be 6 subtract negative 2 divided by 2. It's going to be 4, right? So you need to eliminate A, B, and D. The answer must be C, right? Now you need to verify D, right? So D equals maximum plus minimum divided by 2. So which means 6 plus negative 2 divided by 2. It's going to be 2, right? Now question 34, we need to solve for period and amplitude, right? The period is the distance between two hills or two maximum, right? So it could be from here to here. Alright, so it could be 2 subtract negative 2, which means 4, right? So I need to eliminate A and B. Now I need to find amplitude. Amplitude is maximum, which means 3, subtract minimum, which means negative 1 divided by 2, right? So 3 subtract negative 1 divided by 2 is going to be 2. So the answer must be C. Now let's move on to question number 35. Given the graph, we need to find the corresponding equation for this graph. Alright, so we know that the general form of the trigonometric function is going to be A cosine of B times S minus C plus D, right? Or A sine of B S minus C plus D, where A is an amplitude or vertical dilation, B is the horizontal dilation, C is the phase shift, and D is the vertical shift, right? Now look at this one right here. We need to find the midline first, right? Midline equals maximum and minimum divided by 2, right? Now maximum is 3, minimum is negative 1, right? So if you add them up, divided by 2, it's going to be 1, right? So the midline is 1. Alright, now you look at the answer right here, we always have 1, right? Now we need to find the amplitude. The amplitude is maximum subtract minimum divided by 2, or the distance from the midline to the maximum, right? Amplitude is 2, right? So look at this one, we see 2, 2, this one is 2. Now keep in mind, if you have the negative sign here, which means there could be a reflection, right? This one 2. Alright, now next one, you need to find B. B equals 2 pi divided by period. Period is the distance between two hills, right? So it could be pi right here, right? So it could be 2 pi divided by pi. It's going to be 2, right? So this one is pi. This one is 2. This one is 2. This one is 2. So we need to eliminate A, right? Now, if you start from here, there is a reflection because the cosine function starts from the maximum, right? Back down to the midline, go down to the minimum, back up to the midline, and go up to the maximum. right? And also have the phase shift to the right, pi over 2. So this one is right, because you subtract pi over 2, which means shift to the right, pi over 2. But there is no subtraction sign right here. So this one may be wrong. Now, this one right here, you have the negative side, right? But the phase shift is pi, which is wrong because the phase shift is pi over 2, right? So answer choice C is wrong. Now, answer choice D, there is negative side right here, which is right, right? There is a phase shift 3 pi over 2, yes. If we start from here, right? Which means we shift to the right 3 pi over 2, right? And we start from the minimum, which means the negative side should be in front of the altitudes, right? This makes the right, right? Or we can use this way. We can pick the point 0, 3, right? We substitute into B, C, and D to see if both sides equals. That is the answer, right? So I'm going to pick the point 0, 3, which means S equals 0, right? And f of 0 must be 3, right? Now, this is f of 0, right? So I have f of 0 equals 2 cosine of 2 times 0 minus pi over 2 plus 1, right? Now, 0 minus pi over 2 equals negative pi over 2. Times 2 is going to be negative pi, right? Cosine function is even, so it turns out to be 2 cosine of pi, right? Because cosine of negative pi equals cosine of pi, right? Plus 1. Now, cosine of pi equals negative 1, right? So it could be negative 2 plus 1. It's going to be negative 1, which is not equal to 3, right? Because we need 3. So this is the wrong answer. Now, if you keep checking this one, it's going to be negative 2 cosine of 2 times 0 minus pi plus 1, right? Again, this one is negative 2 cosine of negative 2 pi, right? Plus 1. So it could be negative 2 cosine of 2 pi, right? Because the cosine function is even, right? So plus 1. Now cosine of 2 pi equals 1, right? So the answer is negative 1, right? Which is not correct, right? Now, if you substitute into the last one, we will see it. Negative 2 cosine of 2 times 0 minus 3 pi over 2 plus 1, right? So it could be negative 2 cosine of 2 times negative 3 pi over 2, right? Plus 1. Now it's going to be negative 2 cosine of negative 3 pi, right? Plus 1. Now cosine of negative 3 pi equals cosine of 3 pi, right? So it could be negative 2 cosine of 3 pi plus 1, right? Now cosine of 3 pi can be written as negative 2 cosine of pi plus 2 pi, right? Plus 1, right? I just ignore the period right here, right? So it's going to be negative 2 cosine of pi plus 1. Cosine of pi equals negative 1. Negative 1 times negative 2 equals 2. 2 plus 1 equals 3, which is this guy right here. So the answer must be D. Now let's move on to question number 36. Question 36 similar to question 35. The only thing different right here, this is going to be sine function. Now keep in mind the sine function starts from the midline, so it can be like this, right? Now if there is a reflection, it can be like this, right? So we look at this one, we need to find the period first, right? Now the period should be from here to here, right? So it can be pi over 2, right? Now we have the period is pi over 2. Now we need to solve for b. b equals 2 pi divided by pi over 2. Now to simplify this one, you look at the bottom right here. The denominator is 2. I need to multiply the top and bottom by 2, right? So it turns out to be 4 pi over this one cancel out pi, right? So it could be 4, right? So b equals 4. Look at this one, b equals 2, so this one wrong. b equals 4, good. This one good, this one good. Okay. Next one, we need to find the midline, right? The midline is going to be maximum at minimum divided by 2, right? Maximum is going to be 10. Minimum is going to be negative 20, right? So 10 minus 20 divided by 2 is going to be negative 5, right? So the midline is going to be right here. Now look at this one, we see that they all have the midline negative 5, right? Which is good. Now we need to determine the phase shift, right? Depending on the phase shift, we have negative sign in front of amplitude or not, right? So look at this one. If we pick the phase shift pi over 4, right? So which means we want the function start right here, right? So it's go down to the minimum first, right? So if it's go down to the minimum, it should have the negative sign in front of amplitude because this is a reflection, right? Look at the graph right here, right? So negative sign right here, which is good, right? So the answer could be B, right? Now we check this one right here. If we start the function from pi over 2, so pi over 2 right here, and then we go up to the maximum, right? If we go up to the maximum, there is no negative sign in front of amplitude, but this guy has the negative sign, so this is wrong, right? Now, if we start the function from 3 pi over 4, which means we start from here, it's go down to the minimum first, right? So there is a reflection, right? If there is a reflection, it should have the negative sign in front of 15, right? But there is no negative sign here, so it makes answer choice D wrong. So the answer must be B. Now, question number 37, very simple. Alright, I'm gonna leave this one for you to practice. The answer is B. Now, let's move on to question 38. The sinusoidal function h has a minimum at the point 2 pi negative 1. The first maximum after reaching this minimum value occurs at the point 5 pi 7. What are the values of the periods and amplitudes of the function h, right? Go ahead, sketch the graph, right? So the function has the minimum, right? So we just start right here, go down to the minimum, right? Back up to the midline, right? The first maximum after reaching this minimum, right? So the first maximum should be right here, right? So we just draw one cycle to see what happens, right? Now, this is the minimum. This is the maximum, right? We know that the period is the distance from here to here, right? Now, because you have the maximum value and the minimum values, right? So the period is twice the distance between maximum and minimum, right? So this one is half of the period, right? Because from here to here is the period, so keep that in mind. Alright. Now, in order to find the periods, we need to look at the s value of the coordinate point of the maximum and minimum, right? This is the first s, s1, this is s2, right? So, the minimum right here, s should be 2 pi. The maximum s equals 5 pi, right? s2 subtract s1, right? So you have 5 pi subtract 2 pi, right? This one is half of the period, right? Right? So P equals 6 pi, right? Now you need to eliminate C and D. Now you need to find the amplitude, right? The amplitude is maximum subtract minimum divided by 2. Now you need to look at the y value only, so be careful. The y value of the maximum is 7 right here. So 7 subtract y value of the minimum is negative 1, right? Negative 1 divided by 2. So it's going to be 4, right? So the answer must be A. Now, question 39, similar to question 38. I'm going to leave this one for you to practice. The answer must be C. Now, question 40. Which of the following best describe the behavior of the function g over the interval 0 to pi over 2, right? So 0 to pi over 2, which means this guy right here, right? Alright, so the interval should be this guy right here. Alright, so over this interval, the function g is decreasing, right? Because it's going down, right? So we need to eliminate A and B. Now, we need to know if the function decreasing at an increasing rate or decreasing rate, right? Now, since the function is concave up, so the rate of change is increasing, right? So the function is decreasing at an increasing rate. The answer must be C. Now, question 41. Over the interval pi over 2 to pi. Pi over 2 to pi. It's going to be from here to here, right? in order to know if the function is positive or negative, look at the graph. If it's above the x-axis, it's going to be positive. If it's below the x-axis, it's going to be negative. Now look at the yellow interval right here. It's going to be below the axis, so it's going to be negative. So you need to eliminate A and B. Now, to know if the function increasing or decreasing, you need to draw the tangent line, right? The tangent line is going up this way. The rate of change is positive. If the rate of change is positive, the function is increasing. So the answer must be C. Now let's move on to question 42. Which of the following best describe how the rate of change of the function g is changing over the interval pi to 3 pi over 2, right? Now, if the rate of change is changing, which means it's increasing or decreasing, right? So, over the interval pi to 3 pi over 2, it's going to be from here to here. Over these intervals, the rate of change is decreasing because the function is concave down, right? So, the answer must be D, right? The rate of change is decreasing because the function is concave down over this interval, right? Now, direction for number 44, 47. Use the graph of the sinusoidal function h below. Question 44. On the interval 0 to pi over 2, which of the following is true about the function h? Now, the function h is positive and increasing. 0 to pi over 2 is going to be this guy right here, right? Because the function above the axis, so it can be positive, right? So you need to eliminate C and D. The function is decreasing because it's going down, right? Which means the rate of change of the tangent line is negative, right? So it could be decreasing. The answer must be B. Question 45. On the interval pi over 2 to pi, which of the following is true about the function h, right? Pi over 2 to pi, which means this guy right here. The function is negative, right? Because it's below the x-axis, right? So we need to eliminate A and B, right? Now, the function is decreasing because it's going down, right? The rate of change of the tangent line is negative, right? Using the Christmas tree trick. So the answer must be D. Now, question 46. Over the interval pi to 3 pi over 2, the function is still negative, right? Because it's below the axis and it's increasing, right? Because the rate of change of the tangent line is positive, right? So it's going to be negative and increasing. The answer must be C. Now the last one, 3 pi over 2 to 2 pi. Alright, so it's going to be from here to here. The function above the axis, so it's going to be positive, right? And if you draw the tangent line is going up, the rate of change is positive, the function is increasing, right? So positive and increasing. The answer must be A. Now let's move on to question 48 to 51. Question 48 to 51 is going to be similar to the one we just did, right? Now I just leave the answer for you and I leave this question for you to practice. Alright, question 48, the answer is D. Question 49, the answer is A. Question 50, the answer is A. Question 51, the answer is D. Now let's move on to question 52. Alright, given the graph, we need to write the sinusoidal function for this graph, right? First, we need to find the amplitude, right? So the amplitude A equals maximum subtract minimum divided by 2, right? So maximum is 4, minimum is negative 2, right? So it could be 4 minus negative 2 divided by 2. It could be 3, right? So they all have 3, right? So the answer choice would be A, B, C, D, right? Now, we have the midline, they are 1, right? So we just draw the midline right here. Now, we need to find the period. The period is the distance between the initial point and the end point within one cycle, right? So it could be pi over 2, right? So the period is pi over 2. Now we need to solve for b. So b equals 2 pi divided by period, which means pi over 2, right? So we need to simplify this one by multiply the top and bottom by 2, because we look at this one, we see 2 here, right? Multiply this by 2. So it could be 4 pi divided by this guy cancel out. It could be pi. So pi and pi cancel out. It could be 4, right? So b equal 4. We need to eliminate a, b, and d. The answer must be c. Now let's move on to question 53. Question 53 similar to question 52, right? First, we need to identify the midline, right? They are -1, right? So we just draw the midline -1 right here. Right? So d equals -1, right? Now the amplitude is absolutely 2, right? So that's correct, right? So they all could be the answer, right? If you see the negative side, it could have the reflection depending on where you start the function, right? So now look at the phase shift. Answer choice A, there is no phase shift, which means you start from here, right? And then you go down, right? So if you go down, there should have the negative side in front of amplitude A right here. But there is no negative side right here. Choice A is wrong, right? Now, answer choice B. If you start from pi right here, which means there is a phase shift to the right, pi units, right? So you start right here. If you start right here, you go up first, right? If you go up, there shouldn't be a negative side in front of A, right? But there's a negative side right here. So this one is wrong, right? Now, if you start from negative pi, right? This one right here, which means you shift pi units to the left, right? Because the plus side right here. So it's gonna be right here. So you start from here and you go up first, right? If you go up, there shouldn't be a negative side in front of A, but there is a negative side in front of A, so this is wrong, right? Now last one, you start from -2 pi, right? Which means there is a phase shift 2 pi to the left, right? So it could be right here. So if you start right here, you need to go down first, right? So if you go down, you should have the negative side in front of A, negative side right here. So the answer D is correct. Now let's move on to question 54. Alright, we look at our answer choice right here. We see that the midline is 1, right? So we just draw the midline 1. D equals 1, right? The amplitude is 2, right? It's the way from the midline to the maximum, right? So 2. So you look at this one, they all have 2, right? And remember that if you have negative side, it could have the reflection depending on where you start the function, which means the phase shift, right? Answer choice A is cosine function. Cosine function starts from the maximum, right? There is no phase shift, and starting from the maximum, there is nothing right here, right? You must start right here, right? So the answer choice A is wrong. Now, answer choice B, this is a sine function. So you can start from the midline, right? But there is a phase shift pi over 2 to the right, right? So you start right here, right? So if you start right here, you need to go down first, right? So since you go down, you should have the negative side in front of the amplitude right here. But you don't have it right here. So the answer choice B is wrong, right? Now, answer choice C, there's a phase shift pi unit to the right, which means it's going to be right here, right? But this is a cosine function. So you need to either start from the maximum or minimum, right? Right at pi right here, there is no maximum or minimum, right? Pi right here is at the midline, right? So answer choice C is wrong. Now the last one, D. There's a phase shift 3 pi over 2, right? So you need to start from 3 pi over 2, and this is the sine function. So you need to start from the midline, right? So 3 pi over 2, you need to go down first, right? If you go down, you must have the negative side in front of amplitude, which is right here, right? So the answer must be D. Now let's move on to question 55. The function f is given by f of s equals -3 times sine 2s. Which of the following is the part of the function f for the interval 0 to 4 pi, right? Now we need to find the period, right? We given b right here equals 2, right? So b equals 2. So the period equals 2 pi divided by b, which means 2 pi divided by 2. So it could be pi, right? Now we need to look for the period, right? The function starts right here and end right here. This is one complete cycle, right? So it could be pi. So this could be right? Now let's check this one. The function starts right here and end right here within the cycle. So this is the period, so could be b, right? Now this one right here, the function starts right here and end right here to complete one cycle, right? So this is 2 pi, so this is wrong, right? So C incorrect. This one, the function starts right here and end right here to complete one full cycle, right? So it could be 4 pi, right? So this one is wrong. Now only A and B could be the answer, right? Look at the amplitude right here. Amplitude is -3 and the function sine 2s right here, there is no phase shift, right? Which means the function starts at the origin, right? And at the midline, right? So if the function starts right here, it goes up first. If it goes up, there is no negative sign in front of A, right? So you have negative sign right here, which makes answer choice A wrong, right? Now answer choice B, you start from the midline and you need to go down, right? If you go down, there is a negative sign in front of the amplitude, which is right here, right? So this one makes answer choice B correct. Now question 56. Given the function g of s equals cosine s, right? So g of s equals cosine s. The function h has the same period as the function g. The amplitude of the function h is twice the amplitude of the function g. So the function h of s equals, look at the function g right here, amplitude equal 1. So this guy must be 2, right? So it should be 2 cosine s, right? So then it's going to be 2 cosine s, which means g of s, so it will be g of s, right? So the answer must be B. Now let's move on to question number 57. Question 57 similar to question 55, right? Now we need to rewrite f of s, so f of s equals -2 cosine s plus 1, right? So you can see the midline 1, right? So the first one, the midline 1 right here, right? The second one, the midline 1 right here, right? The third one, midline 1 right here. And the last one, midline is -1, right? This makes answer choice D wrong first, right? Now we need to find the period, right? So the period for the first one is gonna be from here to here, right? So the period is 2 pi, right? Now from here we need to find the period first. The period equal 2 pi divided by b. It could be 2 pi divided by 1, right? Because b equal 1, so it could be 2 pi, right? So this one could be right? Now for this one right here, the period is from here to here, right? It could be 0 to 2 pi right here, so this one could be right. For this one right here, the period is from here to here, right? So 3 pi subtract pi, it could be 2 pi, right? So this could be right? Now next one, look at the amplitudes. The amplitude is absolute value of -2, which is 2, right? So the distance from the maximum to the midline, this one 2, yes. This one 2, right? That's correct. This one 2, that's correct, right? So it's good. Now the last one is the negative one. Keep in mind the cosine function starts from the maximum. Since you have the negative side right here, there is a reflection, right? So this function should start from the minimum first, right? This one starts from the maximum, so this one is wrong, right? This one starts from the midline, right? So this one is wrong, right? This one starts from the minimum, right? So the answer choice must be C. Question 58. Let h be the function given by h of s equals sine s. The period of the function k is twice the period of the function h. Now look at the function h of s right here. The period of this function is 2 pi, right? And then the period of this function h should be 4 pi, right? The graph of the function k is horizontal translation of h by -pi units, which means you need to shift the function h pi unit to the left, right? Since you have the period of the function k 4 pi, right? So you need to find b first, right? So b equals 2 pi divided by period, which means 2 pi divided by 4 pi. So it's going to be 1/2, right? So b equals 1/2, you need to eliminate a and b, right? Now there is a phase shift -pi units, which means you need to shift pi units to the left, right? So if you shift pi unit to the left, it should be plus pi, right? Now look at this one right here. You need to choose D because this one is the general form. This is not the general form. Keep in mind, the general form is going to be A times F of B times S minus C. Right here, it should be the factor form, right? Plus D, right? Now for this one right here, if I need to factor 1/2 out, so it's going to be H of 1/2 of S plus 2 pi. If I write this guy in the general form, that should have a translation 2 pi units to the left, right? Which contradicts this guy, right? So the answer choice C must be wrong. Now let's move on to question 59. Alright, you look at the answer choice right here and compare to the function right here. This is the cosine function. Cosine function always start from the maximum. And if there is negative sign in front of amplitude, the cosine function will start from the minimum, right? So look at this one right here. We need to draw the midline, right? The midline should be the x-axis, right? Because there is no vertical translation, right? So this guy start from the midline, which is wrong because this is for the sine function only. This guy start from the midline, right? So this one is wrong. This guy start from the maximum, right? We need minimum first, right? Because there is negative sign right here. So this one is wrong. The answer must be B. Now let's move on to question 60. Let f be the function given by f(s) equals cosine s. The function g is a horizontal translation of the function f by pi over 2 units, right? So which means you shift to the right pi over 2. Now we need to check for the answer choice right here. If you see the plus sign right here, which means there is a translation to the left, pi over 2, right? But we need to the right, right? So the answer A is wrong. This one is vertical translation, right? So this one is wrong. Now, this one right here, there is a reflection, right? Because there's negative side right here. But the question right here does not mention the reflection, right? So the answer choice D is wrong. Now, only answer choice C is correct. Why? Because if you graph FOS and GOS on the same x and y coordinate plane, you will see it. Now you have f of s, it's going to be cosine s, right? If you shift this one to the right pi over 2, it's going to be FOS equals cosine s minus pi over 2. Alright? It's going to be this one right here. Now, this one is the same thing as the function GOS equals sine s. Right, this guy and this guy right here overlapping, right? So, which means they are the same thing. Now let's move on to question 61. The function g is divided by g of s equal a sine b of s plus c plus d for constant a, b, c, and d. In the x and y plane, the points 3, -1, and 7, 3 represent the minimum and maximum value respectively for the function g. What are the values of a and d? Now, amplitude equals maximum subtract minimum divided by 2. Maximum is going to be right here, the y value 3. Subtract minimum is going to be -1. Divided by 2, so it could be 2. Eliminate C and D. Now, the midline D equals maximum plus minimum divided by 2. So it could be 3 plus -1 divided by 2. It's going to be 1. So the answer must be B. Now, let's move on to question 62. Similar to 61, you have minimum point, the maximum point. Alright, the question asks you to find B, right? So first, in order to solve for B, you need to solve for period because B equals 2 pi divided by period, right? So we just get the graph. So keep in mind, the period is the distance of 2s value of the minimum and the maximum multiplied by 2. So it's going to be the distance from here to here right here. Alright, so it's going to be 2 and this guy 4, right? So you take 4, you subtract 2, it's going to be 2 to find the distance right here. And you multiply by 2 to get the period, it's going to be 4, right? So after you have the period, plug it in over here, you have 2 pi divided by 4. So it's going to be pi over 2. So the answer must be C. Now question 63 is similar to question 62 and 61. right? I'm going to leave this one for you to practice. The answer must be D. Similarly, question 64, the answer must be C. I'm going to leave this one for you to practice. Topic 3.8, the tangent function. Alright, question 65. The function f is given by f of s equals 1 plus 2 tangent s. Which of the following gives the vertical asymptote of f? Alright, so you know that the formula of the vertical asymptote of the tangent function is pi over 2 plus k pi. Alright, so look at this one right here. The angle is s, so s equals this one. The answer must be A. Now, question 66. The function k is given k of s equals tangent of 1 half s. Which of the following gives the vertical asymptote of the function k? Alright, now keep in mind the formula for the vertical asymptote of tangent function is pi over 2 plus k pi. Right? Now, whatever inside parentheses right here, you check it out. So it could be 1 half s equal this one. Alright, now you need to solve for s, so you're going to multiply both sides by 2. So it could be s equals pi plus k 2 pi. Alright, so this is the answer. So the answer must be C. Question 67. The function g of s is given by tangent of pi s. They ask you to find the vertical asymptote, right? So you just let pi s, right? Anything inside parentheses, you need to check it out, equals pi over 2 plus k pi, right? Now you need to divide both sides by pi. So s equals pi over 2 divided by pi is going to be 1 half plus k only. So this is the answer. 1 half plus k, the answer must be C. Now question 68. The function h of s given by tangent of s minus pi. Find the vertical asymptote, right? So s minus pi, right? The one inside parentheses right here, equals pi over 2 plus k pi. Now you need to add pi both sides, so s equals 3 pi over 2 plus k pi, right? Now we look at the answer choice right here. We don't see any answer choice that matches this one. Alright, so we need to manipulate this one. Alright, so we need to solve this equation differently. Now I'm going to add pi both sides, so s equals pi over 2 plus k pi plus pi, right? So this one can be written as s equals pi over 2. Now I'm going to factor pi out, so it can be k plus 1 times pi, right? Now since k is an integer, so I can let k plus 1 be n, right? So I substitute n for k plus 1 into this equation. So I have s equals pi over 2 plus n pi. Now you look at the answer choice. A is the correct answer, right? The letter k right here and the letter n right here, they just variables, right? Now let's move on to question 69. The graph of the function f is given in the xy plane. If f of s equals a tangent of bs, where a and b are constants, which of the following is true? Alright, so we need to determine if a is positive or negative, b greater than 1 or less than 1. Alright, so if you have the tangent function, it should be something like this. Alright, if a greater than 0. If a less than 0, it's gonna be reflected over the x-axis, so it can be like this. Right? This one a less than 0. Now from here, you can eliminate C and D because a less than 0. Alright, now you need to solve for B. In order to solve for B, you need to find the period of the tangent function. Now, in order to find the period of the tangent function, you need to find the distance between two vertical asymptotes, right? So, I have the first vertical asymptote right here, pi over 4. The second one is going to be 3 pi over 4, right? So, I need to take 3 pi over 4, subtract pi over 4, right? So, it could be 2 pi over 4 or pi over 2, right? Now, I'm going to use the formula period equals pi over b, right? So I need to solve for b. So b equals pi over 2, which is the period, right? So in order to simplify this one, I'm going to multiply the top and bottom by 2, right? So this one cancel out. So I have 2 pi over pi. So pi and pi cancel out. The answer must be 2. So b equal to, which is greater than 1. So the answer must be A. Now, here's the thing you need to be careful. When it comes to the tangent or cotangent function, you need to use this formula because the period of the tangent and cotangent function is pi. Right? When it comes to sine and cosine function, the formula must be period equals 2 pi divided by b. Right? Because the sine and cosine function period 2 pi. Alright, so keep that in mind. Now, question 70. The graph of the function h is given in the xy plane if h of s equals tangent of b times s plus c, where b and c are constant. What are the values of b and c? Alright, so first you need to find b, right? In order to solve for b, you need to use the formula period equals pi over b, right? So you need to solve for the period first. The period of the tangent function is the distance between two vertical asymptotes. So it could be from here to here. Alright, so in this situation, the period is 2 pi, right? So I have 2 pi equals pi over b, right? So b equals pi divided by 2 pi. So it's going to be 1/2, right? So b equals 1/2. You need to eliminate c and d, right? Now, in order to solve for c, we need to find the phase shift, right? Now, we just pick a point on the graph and substitute into this function right here. We solve for c, right? So this point has the coordinate pi, 0, right? Substitute over here. So we have h of pi equals tangent of b. b equals 1/2, right? So you have 1/2 times pi plus c, right? And this one equals 0, right? Now, you need to solve for c, right? So tangent of this one equals 0 when 1/2 of pi plus c equals 0, right? Multiply both sides by 2. So pi plus c equals 0. Subtract pi both sides, so c equals negative pi, right? Since c equals negative pi, which means the function shifted to the right pi units, right? So the answer must be B. Now let's move on to question number 71. The graph of the function k is given in the xy plane. Which of the following could be the expression for the function k? Now we look at the graph of the tangent function right here. There is no reflection because it's going this way, right? So the coefficient in front of the tangent must be positive. Now this one is negative 2. You need to eliminate this one and this one, right? Now you need to solve for b. In order to solve for b, you need to solve for the period, right? So the period is the distance between two vertical asymptotes, which is 4 pi, right? Because 6 pi subtract 2 pi is going to be 4 pi. Now we're going to use the formula p equals pi divided by b. So b equals pi divided by period, which is 4 pi, right? So it's going to be 1/4, right? So the answer must be D. Look at the graph of the tangent function right here. It's going this way, which is there is a reflection over the x-axis, right? So the coefficient in front of tangent must be negative, right? So you need to eliminate C and D, right? Now we need to solve for B. In order to solve for B, you need to find the period, right? So the period is the distance between two vertical asymptotes, right? So it's going to be 8 pi, right? Because 4 pi subtract negative 4 pi, which is 8 pi, right? So I have the period equals pi divided by b. So b equals pi divided by period, which is 8 pi, right? So the answer must be 1/8. So the answer must be A. Now let's move on to question 73. Now we look at the graph right here. We see that the point of inflection should be at the x-axis, right? So there is no vertical shift at all, right? So look at the answer choice A and B right here. Shift down pi over 4, right? So the answer A and B must be incorrect, right? Now, we need to solve for B first. In order to solve for B, you need to find the period, right? So the period is the distance between two vertical asymptotes, which is pi over 2, right? So I have B equals pi divided by period, right? Which is pi over 2. Now I'm going to multiply the top and bottom by 2. So it could be 2 pi divided by pi, right? So it could be 2, right? Now look at the answer choice right here, only D correct, right? Now let's move on to question 74. The function f is given by f of s equals tangent of 3s minus 1. The graph of f is mapped to the graph of the function g in the same xy plane by vertical dilation of the graph of f by a factor of 4, right? Now we have the general formula a times f of b times s minus c plus d. Alright, a tells us that the vertical dilation by a factor of 8. B tells us that the horizontal dilation by a factor of 1 over B, right? This one is A. C tells us that the phase shift occurs, or horizontal translation, right or left. If C greater than 0, it shifts to the right. If C less than 0, it shifts to the left, right? D tells us that there is a vertical translation. If D greater than 0, it shifts up. D less than 0 is shift down, right? Now, because there is a vertical dilation by a factor of 4, we're going to multiply f of s by 4, right? So right here, I have f of s equals tangent of 3s minus 1, right? Now, you're going to multiply both sides by 4. So this guy multiplied by 4. Don't forget parentheses, alright? So it could be 4 tangent of 3s minus 4. The answer must be B. Question 75. The function h is given by h of s equals 5 tangent of 2s. The function h is mapped to the graph of the function k in the same xy plane by a vertical translation of the function graph by pi units, right? So which means you're gonna shift up pi units, right? So if you shift up, which means you're gonna add d, right? Add the output by d, right? So the new function should be 5 tangent of 2s, and then you add pi, right? So the answer must be A. Now question 76. The function f is given by f of s equals 2 tangent of 4s. The graph of f is mapped to the graph of g in the same xy plane by horizontal translation of the graph by pi over 2 units to the right, right? So you have the formula a times f of b times s minus c plus d, right? Keep in mind, when you translate to the left or to the right, that number should be inside parentheses of the domain right here, alright? So if c is positive, it shifts to the right. If c is negative, it shifts to the left, right? Now you have the equation right here. So I just rewrite f of s equals 2 tangent of 4s, right? If you shift pi units to the right, it turns out to be f of s minus pi over 2, right? It's gonna be 2 tangent of parentheses 4 parentheses s minus pi over 2, like that. Alright, so the answer must be B. Now, a lot of students make mistake, and this is a common mistake. Don't write like this. Pi over 2 must be inside parentheses. Look at the formula right here. Now, question 77. The function h is given by h of s equals 6 tangent of 2s. The graph of h is mapped to the graph of k in the same xy plane by a horizontal dilation of the graph of h by a factor of 5, right? Now, remember that we have the formula a times f times b times s minus c plus d, right? Horizontal dilation, which means the value of b right here. Horizontal dilation by a factor of b, which means you're going to multiply by 1 over b. Right? So in this situation, you need to multiply by 1 over 5. Right? So you have h of s equals 6 tangent of 2s. Right? Now, you need to solve for function k. So k of s must be 6 tangent of 2 times 1/5, right? Times s. Now I'm going to simplify. It's going to be 6 tangent of 2/5 s, right? So the answer must be D. Topic 3.9 Inverse trigonometric functions. Alright, so we need to review the range of the sine inverse, cosine inverse, and tangent inverse, right? So the range of the sine inverse should be the closed interval negative pi over 2 to pi over 2, which is on the unit circle. It's going to be on the first and the fourth quadrant. Alright. Now for the cosine inverse, the range should be 0 to pi, right? Which means on the unit circle, it's going to be the first and the second quadrant. Now, for the tangent inverse, the range should be the open interval negative pi over 2 to pi over 2. Now, keep in mind, the tangent inverse, we don't include the endpoint negative pi over 2 and pi over 2 because right at this point, the tangent undefined, right? On the unit circle, it's going to be on the first and the fourth quadrant, right? Look at question 78. The function f is given by f of s equals sine inverse of s. What input values in the domain of f yields an output value of cosine inverse of root 2 over 2. So we need to calculate this one first. Alright, so we know that cosine of pi over 4 equals root 2 over 2, right? Now we're going to take cosine inverse both sides. So we have cosine inverse of root 2 over 2 equals pi over 4, right? So this guy equals pi over 4, right? And this one is in the range of this one right here, right? From 0 to pi. So this works, right? Now we put this one back over here. So we have f of s equals sine inverse of s, right? Now pi over 4 becomes the output of this one right here, right? So this guy turns out to be sine inverse of s equals pi over 4, right? Now we need to solve for the input, which means we're going to solve for s, right? So we need to take sine both sides, right? So sine and sine right here. So then s equals sine pi over 4, right? Now sine pi over 4 equals root 2 over 2, right? So the answer must be D. Now question 79, the function g is given by g of s equals to cosine of root 3s. What input values in the domain of g yields an output value of pi over 2? So pi over 2 is the output of this guy, right? So we have the equation 2 cosine of root 3s equals pi over 2, right? So you're going to divide both sides by 2. I'm going to have cosine of root 3s equals pi over 4, right? Now, in order to eliminate cosine, you need to take cosine both sides, right? So then you have root 3s equals cosine pi over 4 equals root 2 over 2, right? Now, in order to solve for s, I need to square both sides, right? So I have 3s equals 2 over 4, which is 1/2, right? Now divide both sides by 3, so s equals 1 over 6. The answer must be C. Now question 80. The function h is given by h of s equals 1/3 tangent inverse of s root 3. What input value in the domain of h yields an output value of negative pi over 12. So we have the equation 1/3 tangent inverse of s root 3 equals negative pi over 12, right? Now we need to multiply both sides by 3. So it's going to be tangent inverse of s root 3 equals negative pi over 4, right? Now, in order to solve for s, you need to take tangent both sides, right? So we're going to take tangent right here and tangent here. So it's going to be s root 3 equals tangent of negative pi over 4 is the same thing as negative tangent of pi over 4, right? Because the tangent is odd, right? So then you have tangent of negative s equals negative tangent of s. So keep that in mind. Alright, now tangent of pi over 4 equals 1, right? So this guy becomes negative 1, right? Now divide both sides by root 3, so s equals negative 1 over root 3, right? So the answer must be B. Now question 81. The function k is given by k of s equals 3 sine inverse of 2 pi s. What input value in the domain of k yields an output value of pi over 2? So we have equation 3 sine inverse of 2 pi s equals pi over 2, right? Now you're going to divide both sides by 3. So I'm going to have sine inverse of 2 pi s equals pi over 6, right? Now, in order to solve for s, I need to eliminate sine inverse, right? So I'm going to take sine both sides, right? So this guy gone. I have 2 pi s equals sine pi over 6, which is 1/2, right? Now I'm going to divide both sides by 2 pi. So s equals 1 over 4 pi, right? So the answer must be B. Now let's move on to question 82. The function g is given by 3 cosine inverse of 4s, right? Now we need to find the input value where the output is pi, right? So we have 3 cosine inverse of 4s equals pi, right? Now you need to divide both sides by 3 first, right? So I have cosine inverse of 4s equals pi over 3, right? Now I need to eliminate cosine inverse by taking cosine both sides, right? So cosine of this one equals cosine of this one, right? So it's going to be 4s equals cosine of pi over 3 equals 1/2, right? So I'm going to divide both sides by 4, so s equals 1 over 8. The answer must be B. Now question 83. The function f and g is given by this guy and this guy in the xy plane for which x coordinate of the point of intersection of the graph of f and g. So in order to find the intersection between two graphs, you just equate them, right? So we have f of s equals g of s, and then you solve for equation, right? So you have 1/2 sine inverse of s over root 3 equals pi over 6, right? Now, in order to solve for s, you need to multiply both sides by 2 first, right? So it's going to be sine inverse of s over root 3 equals pi over 3, right? Now, in order to solve for s, you need to eliminate sine inverse by taking sine both sides, right? Now, this guy becomes s over root 3 equals sine of pi over 3 equals root 3 over 2, right? Now you're going to multiply both sides by root 3. So s equals 3 over 2, right? The answer must be B. Now let's move on to question 84. Consider the function f and g is given by this guy and this guy. Now we need to find the point of intersection between two graphs, right? So similar to 83, we just equate this guy and this guy, right? So we have 1 over 4 tangent inverse of s root 3 equals pi over 6, right? Now we need to multiply both sides by 4 first, right? So it's going to be tangent inverse of s root 3 equals 2 pi over 3, right? Now In order to solve for s, we need to eliminate tangent inverse, right? By taking tangent both sides, right? So we're going to end up with s root 3 equals tangent of 2 pi over 3 negative root 3, right? Now remember that you have a unit circle right here. Here's the trick. All students take calculus, so this is all students take calculus, right? In the first quadrant right here, all trigonometric functions have the positive value, right? Second quadrant right here, only side function has a positive value. The third quadrant right here, only tangent has the positive value. And the last quadrant right here, only cosine function has the positive value. Alright, so keep that in mind. So 2 pi over 3 right here, sine is positive, cosine is negative, therefore tangent is negative, right? Now divide both sides by root 3, so s equals negative 1. The answer must be C. Topic 3.10, trigonometric equations and quantities. Question 85. What are all values of angle theta within the domain 0 to 2 pi? Cosine theta square equals minus cosine theta. Alright, the common mistake students always make is they're going to divide both sides by cosine, which means cosine theta equals negative 1. This one wrong. Because if you divide both sides by cosine theta, you're going to miss solution. Alright, now what you need to do is to add cosine theta both sides. Right, bring every single thing to the left hand side. Right, so we have cosine square theta plus cosine theta equals 0, right? Now I'm a factor cosine theta out, so it will be cosine theta times cosine theta plus 1 equals 0. Now this is a 0 product. A times B equals 0. Then either A equals 0, B equals 0. Now keep in mind, the right hand side must be 0, and then you're going to apply the formula, right? Since the right hand side over here equals 0, so I'm going to apply this formula if I see the product, right? If the right hand side is not 0, you cannot apply the formula, so keep that in mind. Alright, so I have cosine theta equals 0 and cosine theta equals negative 1, right? Now you're going to use the unit circle to solve this one. Cosine theta equals 0, theta equals pi over 2 and 3 pi over 2, right? Theta equals negative 1, theta equals pi, right? Keep in mind, don't forget the domain right here, right? So your answer must be pi over 2 and 3 pi over 2. The answer is D. Now question 86. What are all values of angle theta where theta from 0 to 2 pi? 2 sine square theta equals 3.5, right? Now you need to isolate sine square theta first by dividing both sides by 2. Alright, so it will be sine square theta equals 3 over 4, right? Now you're going to take square root both sides, right? So sine theta equals plus and minus square root of 3 over 2. Alright, the common mistake students usually make when they take square root is only sine theta equals root 3 over 2. By doing this way, you're gonna miss solution, so that's wrong. When you take square root both sides, make sure it's gonna be plus and minus, keep that in mind. This one extremely important. Alright, now, so you have two equations, sine theta equals root 3 over 2 and sine theta equals negative root 3 over 2. Alright, yeah, now you're going to use the unit circle. Sine theta equals root 3 over 2, theta equals pi over 3 and 2 pi over 3, right? Sine theta equals negative root 3 over 2, theta equals 4 pi over 3 and 5 pi over 3. Alright, so we have 4 solutions. The answer must be D. Now question 87. We need to solve this equation within this domain, right? So you need to isolate cosine theta first, right? Divide both sides by 2, right? So we have cosine theta equals root 3 over 2, right? Now you need to find the angle theta where cosine theta equals root 3 over 2 on the unit circle, right? So on the unit circle, theta equals pi over 6 and 11 pi over 6, right? So the answer must be B. Now question 88. We need to solve this equation within this domain, right? So we need to isolate sine theta first, right? Divide both sides by -2. So we have sine theta equals negative root 2 over 2, right? Now you need to find angle theta where sine theta equals negative root 2 over 2, right? Look at the unit circle. Theta equals 5 pi over 4 and 7 pi over 4, right? So the answer is D. Now question 89. We need to solve this equation within this domain, right? So we need to isolate cosine theta, right? Subtract 4 both sides first, right? So we have 2 cosine theta equals 3 minus 4 is going to be -1. Divide both sides by 2. So cosine theta equals -1 half, right? Now you need to find angle theta where cosine theta equals -1 half by looking at the unit circle. It's going to be 2 pi over 3 and 4 pi over 3, right? The answer must be C. Now let's move on to question 90. We need to solve for this equation within this domain. Alright, so look at this one right here. It should be double angle, so you need to be careful. Alright, I just show you the common mistake students do. They're gonna divide both sides by 2, so it could be like this side theta equals 1 half like that. This is completely wrong. Right, so don't do like that, right? So on the unit circle, you need to find the angle where sine of that angle equals 1. It should be pi over 2, right? Angle right here, where sine equals 1, right? So after one cycle, it's go back to original spot right here, right? So you have 2 theta equals pi over 2 plus k 2 pi, right? So keep that in mind, where k is an integer, right? Now divide both sides by 2, so theta equals pi over 4 plus k pi, right? Now you left case be 0. So you have the first solution, theta equals pi over 4 plus 0 is going to be pi over 4, right? Now k equals 1. You have theta equals pi over 4 plus pi, right? So it's going to be 5 pi over 4, right? Now k equals 2. Theta equals pi over 4 plus 2 pi, right? So it will be 9 pi over 4. This one is not a solution because it's outside the domain, right? It's greater than 2 pi, right? You know that the domain is from 0 to 2 pi only, right? So only k equals 0 works, k equals 1 works, so you have solution pi over 4 and 5 pi over 4. The answer must be D. Now question 91. We need to solve for this equation where theta from 0 to 2 pi. Alright, now you need to isolate sine square first by dividing both sides by 2. So you have sine square theta equals 1 half, right? Now taking square root both sides, it's going to be sine theta equals plus and minus. Keep that in mind. Most students forget the minus side. When you take square root both sides, it should be plus and minus. Alright, it's going to be square root of 1 over square root of 2, right? Now I'm going to simplify this one. It's going to be 1 over square root of 2, right? Now I'm going to radicalize this one by multiplying the top and bottom by root 2. So it could be root 2 over 2, right? I'm going to split this one into two different ones, right? Sine theta equals root 2 over 2 and sine theta equals negative root 2 over 2. Now on the unit circle, sine theta equals root 2 over 2 when theta equals pi over 4 right here, right? And 3 pi over 4 right here, right? Because if you draw the line, this one actually root 2 over 2. And the second one is going to be right here and right here. It's going to be negative root 2 over 2. Right? Remember that the sine function is the y-axis, right? So this guy is 5 pi over 4 and 7 pi over 4. Right? So the answer must be D. Now question 92. Given f of x equals 1 minus 2 tangent s and g of x equals 1 plus 2 root 3. In the xy plane, what are the x coordinates of the points of intersection of the graph of f and g square theta from 0 to 2 pi, right? Now, the key information right here is the points of intersection, right? Whenever you see this one, you just let f of s equals g of s, right? And then you solve for s, right? So we have 1 minus 2 tangent s equals 1 plus 2 root 3, right? Now both sides have 1, right? So I just cancel out, right? Now I'm going to end up with negative 2 tangent s equals 2 root 3, right? I need to isolate tangent s by dividing both sides by negative 2, right? So tangent s equals negative root 3, right? Now, on the unit circle, you need to find the angle where tangent s equals negative root 3, right? Now, if you forget how to do it, just convert tangent s to sine s and cosine s. It's going to be like this, right? Equals negative root 3, right? The angle that makes tangent s equals negative root 3 is going to be 2 pi over 3 and 5 pi over 3, right? Because on the unit circle, the second quadrant right here and the fourth quadrant right here, sine and cosine opposites, right? If sine and cosine opposites, the answer must be negative. So tangent must be negative, right? So memorizing the unit circle is extremely important, right? The answer must be D. Now question 93. f(x) given by sine s times tangent s and g(x) given by sine s. We need to find the point of intersection within this domain, right? So again, let f(x) equals g(x), right? And then you have sine s tangent s equals sine s. Again, the common mistake students do is to divide both sides by sine s. That's completely wrong. Right? So don't ever do that, right? You need to move every single thing to the left-hand side, and then you factor them out using the zero product. Keep that in mind. Alright, so I have sine s times tangent s minus sine s equals 0, right? And then I'm going to factor sine s out, so sine s times tangent s minus 1 equals 0, right? So this is a zero product. I'm going to let each of this one equals 0. So sine s equals 0 and tangent s minus 1 equals 0, which means tangent s equals 1, right? Now I need to find the angle within this domain right here where sine and tangent equals 0 and 1, right? So the angle that makes sine equals 0 within this domain is s equals 0 and pi, right? The angle that makes tangent equals 1, where s equals pi over 4 and 5 pi over 4, right? So the answer must be B. Now question 94. Given a function f, what are the zeros of f on this interval, right? So in order to find the zeros of the function, we just let this one equals 0, right? So f of s equals 0 when 1 over 2 sine s over cosine s equals 0, right? Now, you're going to multiply both sides by cosine s, right? Remember that cosine s must be different from 0, right? Because if it's equal to 0, it's going to be undefined, right? So s must be different from pi over 2 and 3 pi over 2. So keep that in mind. This is the new domain inside of this one. Now you're going to multiply both sides by cosine s. So it's going to be 1 plus 2 sine s equals 0, right? Subtract 1 both sides, so you have 2 sine s equals negative 1, right? By both sides by 2, so you have sine s equals negative 1 half, right? Now you need to find the angle within the domain right here, and this one right here, where sine s equals negative 1 half, right? S equals 7 pi over 6 and 11 pi over 6. Now we're going to check to see if this one is inside the domain, right? This one within 0 and 2 pi and different from pi over 2 and 3 pi over 2, right? So the answer must be D. Now question 95. given fs equal this one and gls equal this one, we need to find the zeros of the function h, where h of s equal fs minus gls, right? Alright, so we take fs subtract gls, it's going to be 2 sine s cosine s minus cosine s right here, right? fs subtract gls, right? We let this one equals 0, right? Now, a lot of students make mistake. They're gonna add cosine s cosine, then they're gonna divide cosine by cosine s. That's completely wrong, right? Don't do that way. You need to factor cosine s out, right? So cosine s times 2 sine s minus 1 equals 0, right? And then you have the 0 product. The first one is to be cosine s equals 0. And second one, 2 sine s minus 1 equals 0, right? So I just rewrite the first one, cosine s equals 0. The second one, I need to add 1 both sides and divide both sides by 2. So sine s equals 1/2, right? Now I need to find the angle where cosine s equals 0 within this domain right here, right? So s must be pi over 2 and 3 pi over 2, right? Now I need to find the angle where sine s equals 1/2. Then s equals pi over 6 and 5 pi over 6, right? So the answer must be B, right? Now let's move on to question 96. The function f is given by fos equal 3 tangent square of s, right? Gls equal fos minus 1. They ask you to find the zeros of the function g, right? So the function g right here equal fos minus 1, right? So fos equal this one, so we have 3 tangent square s and then minus 1, right? And then we need to find the zeros of the function g, so we let this one equals 0, right? Now we're going to add 1 both sides, so we have 3 tangent square of s equals 1, right? Divide both sides by 3, so you have tangent square of s equals 1/3, right? And then take square root both sides, so tangent s equals, don't forget plus and minus, right? 1 over root 3, right? Now I need to write like this one, it's going to be plus and minus root 3 over 3, right? Now I need to split this one into two different ones, right? Now the first one, s equals pi over 6 and 7 pi over 6, right? The second one, s equals 5 pi over 6 and 11 pi over 6, right? So the answer must be C. Now question 97. fos given by cosine square of s, gls given by cosine s. We need to find the zeros of the function h, where h of s equals fos plus gls, right? So we just let cosine square of s plus cosine s equals 0, right? Now, don't divide both sides by cosine s, right? Keep that in mind. You need to factor cosine s out. So cosine s times cosine s plus 1 equals 0. And then each of this one must be equals 0, right? So you have cosine s equals 0 and cosine s plus 1 equals 0, right? And then on the unit circle, you need to find the angle where cosine s equals 0. S equals pi over 2 and 3 pi over 2, right? Now for the second equation, cosine s equals -1, right? So on the unit circle, the angle that makes cosine s equal -1 is s equals pi, right? So the answer must be C. Now question number 98. We need to find the angle theta within this domain where 2 sine theta plus 1 less than 0, right? Alright, this is the inequality, right? Now you're gonna subtract one both sides, so you have 2 sine theta less than -1, right? Now sine theta less than -1/2, right? Now you need to draw the unit circle. First, you need to find the angle where sine theta equals -1/2, which means theta equals 7 pi over 6 and 11 pi over 6, right? Alright, now you draw the horizontal line connecting these 2 points right here. And then this one right here actually -1/2, right? Now look at the y-axis right here. This is the sine function. right? Sine theta less than negative 1/2, which means anything below negative 1/2, right? So it's gonna be right here, right? So keep that in mind. Now we need to find the intervals where sine theta less than negative 1/2, so which means it's gonna be from here to here, right? So the answer must be theta greater than 7 pi over 6 and less than 11 pi over 6. Or you can write this one in interval notation, which means 7 pi over 6, comma 11 pi over 6. Now, don't include the endpoints, right? Because you don't have the equal sign right here, right? So the answer must be B. Now let's move on to question 99. The function f and g is given by f of s equal 2 cosine s and g of s equal root 2. What are all intervals of s within this domain where f of s greater than g of s, right? So we have 2 cosine s greater than root 2, right? Now divide both sides by 2, so you have cosine s greater than root 2 over 2, right? Now draw the unit circle. The cosine function is the x-axis, right? So you only focus on the x-axis, right? You need to find the angle where cosine s equals root 2 over 2, which means pi over 4, right? And 7 pi over 4, right? Now you're going to draw the line that connecting these 2 points, right? So the point right here is root 2 over 2, right? Now on the x-axis, the value that greater than root 2 over 2 is from here all the way to the right, right? Because from here all the way to the left is less than root 2 over 2, right? Now you need to find the intervals such that cosine s greater than root 2 over 2, which means it's from here to here, right? Now you need to be careful. When you write the interval, you cannot write pi over 4 to 7 pi over 4. This is a common mistake. You need to start right here. This one is 0, right? 0 to pi over 4, right? So the interval must be 0 to pi over 4 union. Now keep in mind, you don't have the equal sign, so you're not going to include the endpoints, right? Now look at the domain right here. You need to include 0 because you have the equal sign right here, right? So right here, I need to put the bracket for zeros only, not pi over 4, right? Because you don't have the equal sign here, right? So I'm done with this guy, right? Now the second one, it's going to be 7 pi over 4 to 2 pi right here, right? So it's going to be 7 pi over 4 to 2 pi. Now right at 2 pi, I'm not going to include the bracket, right? Because you don't have the equal sign right here, right? So the answer must be D. Now let's move on to question 100. The function f and g is given by f of s equal this and g of s equal root 3. We need to find all intervals of s for the domain of s from 0 to 2 pi, where f of s greater than g of s, right? So you let negative 2 sine s greater than root 3, right? Divide both sides by negative 2. Now, when you divide both sides by a negative number, you need to switch inequality symbol, right? So you have sine s right here less than negative root 3 over 2, right? Keep that in mind. Don't forget to switch this one, right? Now, on the unit circle, you need to find the angle where sine s equals negative root 3 over 2, right? Remember that the sine function is going to be the y-axis, right? So negative root 3 over 2, which means it's going to be 4 pi over 3 and 5 pi over 3, right? If you draw the line, right, this one actually negative root 3 over 2, right? Now the interval that sine s less than negative root 3 over 2, which means it's going to be below negative root 3 over 2. It's going to be this interval right here, right? So your answer must be 4 pi over 3 less than s less than 5 pi over 3, right? You don't include the equal sign because there is no equal sign here, right? So no bracket. The answer must be B. Topic 3.11. The secant, cosecant, and cotangent functions. Alright, question 101. What are all values of f of theta such that 5 plus 3 secant theta equals 11 within the domain 0 to 2 pi? Alright, Now keep in mind, when it comes to secant, cosecant, and cotangent, you need to convert it to sine and cosine, or tangent. So it's going to be really helpful. Alright, if you don't know the formula, please check out the link in the description below to see the trick I show you how to memorize this. Alright, so first I need to isolate secant theta, right? So I need to subtract 5 cosine, right? So you have 3 secant theta equals 6, right? Divide both sides by 3, so secant theta equals 2, right? Now I need to convert secant to cosine, right? So it's going to be 1 over cosine theta equals 2 over 1, right? Now I just flip this one, so it's going to be cosine theta equals 1 half, right? Now I need to find the angle within this domain where cosine theta equals 1 half, right? So theta equals pi over 3 and 5 pi over 3, right? Because on the unit circle, the angle right here, pi over 3 and 5 pi over 3 right here, make cosine equals 1 half. This one is 1 half, right? Cosine is the x-axis. Alright, so the answer must be B. Now let's move on to question 102. Right, we need to solve for this equation within this domain, right? So I need to divide both sides by 2. So I have cotangent theta equals root 3, right? Now cotangent, which means 1 over tangent, right? So it will be 1 over tangent theta equals root 3. I can write root 3 over 1, right? Now I need to flip this one, so it will be tangent theta equals 1 over root 3, right? 1 over root 3 is the same thing as root 3 over 3 if I write this one, right? Now, on the unit circle, you need to find the angle theta where tangent equals root 3 over 3, right? Which means theta equals pi over 6 and 7 pi over 6, right? So the answer must be B. Now let's move on to question 103. Given fs equal this and grs equal this, we need to find the points of intersection of the function f and g within this domain, right? So we just let this guy and this guy equals, right? Remember, f of s equals g of s, right? So it could be 5 plus root 3 secant s equals 3, right? Now I need to isolate secant s by subtracting 5 both sides, right? So root 3 secant s equals negative 2, right? Divide both sides by root 3, so secant s equals negative 2 over root 3, right? Now secant s, which means 1 over cosine, right? So 1 over cosine s equals negative 2 over root 3. Now I need to flip this one, so it will be cosine s equals negative root 3 over 2, right? Now on the unit circle, I need to find the angles where cosine s equals negative root 3 over 2, right? So s equals 5 pi over 6 and 7 pi over 6, right? So the answer must be A. Now question 104. We need to find the intersection between this graph and this graph within this domain, right? So we have 1 half cosecant square of s equals 2, right? Now multiply both sides by 2, you have cosecant square of s equals 4, right? Check square root both sides, so it will be cosecant s equals plus and minus 2. Keep that in mind, don't forget plus and minus sign, right? Now cosecant s, which means 1 over sine s, right? Equals plus and minus. Now 2, I can write 2 over 1, right? Now I need to flip this one, so it will be sine s equals plus and minus 1 half, right? Now I need to split this one into two different equations, right? So sine s equals 1 half first, right? Second, sine s equals negative 1 half, right? Now I need to find the angle where sine s equals 1 half, which means s equals pi over 6 and 5 pi over 6, right? Sine s equals negative 1 half, s equals 7 pi over 6 and 11 pi over 6, right? So the answer must be C. Now, let's move on to question 105. Given f(s) equals secant of 1 third s which of the following is the vertical asymptote of the graph of f? Right. So you know that secant s equals 1 over cosine s, right? So in order to find the vertical asymptote, we're gonna let cosine s right here equals 0, right? Because cosine s equals 0 is to be undefined, so it becomes the vertical asymptote of secant s, right? In this situation, the angle should be 1/3 s, right? So we have cosine of 1/3 s equals 0, right? Now, on the unit circle, you need to find the angle where cosine of 1/3 s equals 0, right? So you have 1/3 s equals pi over 2, and 1/3 s equals 3 pi over 2 within one cycle, right? Remember that it has infinitely many vertical asymptotes, right? So I just check within one cycle, right? Because I only have the values right here, right? Now, for the first one right here, I need to multiply both sides by 3, right? So you have s equals 3 pi over 2. Now the second one, I need to multiply both sides by 3. So s equals 9 pi over 2, right? Now I look at the answer choice. This one is not one of the answer choice, right? So I need to eliminate this. Now s equals 3 pi over 2, the answer must be D. Now, question 106, similar to question 105, we need to find the vertical asymptote of this function, right? So we know that cosecant s is 1 over sine s, right? So to find the vertical asymptote of this one, we need to let sine s equals 0, right? Because sine s equals 0 is to be undefined, right? So it becomes the vertical asymptote, right? So the angle right here for s, right? So you have sine 4s equals 0, right? I need to find the angle where sine 4s equals 0 within one cycle, right? So you have 4s equals 0 and 4s equals pi, right? Now divide both sides by 4, so s equals 0 and s equals pi over 4, right? Look at the answer choice right here, only D matches, right? So the answer must be D. Now question 107. In the xy plane, the graph of which of the following functions has a vertical asymptote at s equals pi, right? Now, in order to find the vertical asymptote, you need to convert it to sine cosine function, right? So this one turns out to be 1 over cosine s, right? Now, you need to let denominator equals 0, right? So cosine s equals 0, right? Solve for s, right? Within one cycle. So s equals pi over 2. 3 pi over 2. So it's different from this one, right? So A is wrong. Now second one, you're going to do the same thing, right? So 1 over sine of 1/2 s, right? Now you let the denominator equals 0, right? So you have sine of 1 over 2 s equals 0, right? So then 1 over 2 s equals 0. 1 over 2 s equals pi, right? Now multiply both sides by 2. So s equals 0. S equals 2 pi, right? This is wrong, right? So the answer B is wrong. Now C, it's the same thing, right? 1 over cosine of s minus pi, right? So then you let this one equal 0, right? So cosine of s minus pi equals 0, right? So then s minus pi equals pi over 2, right? Or s minus pi equals 3 pi over 2, right? Now you need to solve for s, so add pi both sides, so s equals 3 pi over 2, right? And this one add pi both sides, so s equals 5 pi over 2, right? So this is not the right answer, right? So C is wrong, right? Finally, cotangent s equals cosine s over sine s, right? So this one is undefined when sine s equals 0, right? And then s equals 0 or s equals pi within one cycle, right? So it matches this one right here, right? So the answer must be D. Now question 108. We need to find the function where the vertical asymptote of the function is s equals 1/2, right? So again, it's similar to 107, right? I'm going to leave this one for you to practice. The answer must be C. Now question 109. Which of the following is the vertical asymptote of the function k? Alright, so convert this one into cosine and sine, right? So it will be cosine of 1/2 s over sine of 1 half s, right? So this one is unified when denominator equals 0, right? So this one turns out to be sine 1 half s equals 0, right? So for s, so it will be 1 half s equals 0, or 1 half s equals pi, right? Within one cycle, right? So multiply both sides by 2, so s equals 0 and s equals 2 pi, right? So only this one matches, so the answer is D. Now, let's move on to question 110. Let LS be 4 minus root 3 cosecant s and GLS equals 2. We need to find the points of intersection of the graph f and g's within this domain, right? So we just let f of s equals g of s, right? And then it turns out to be 4 minus root 3 cosecant s equals 2, right? Now subtract 4 both sides, it will be negative root 3 cosecant s equals negative 2, right? Divide both sides by negative root 3, right? So cosecant s equals 2 over root 3, right? Cosecant s, which means 1 over sine s, right? So it's going to be 2 over root 3, right? Now I just flip this one, it's going to be sine s equals root 3 over 2, right? Now on the unit circle, I need to find the angle where sine s equals root 3 over 2, right? So s equals pi over 3 and 2 pi over 3, right? So the answer must be C. Topic 3.12, equivalent representation of trigonometric functions. Question 111. Which of the following expression is equivalent to 1 half sine 2s, right? So you need to memorize the trigonometric identities, right? So this one becomes 1 half sine 2s equals 2 sine s cosine s, right? This one is the double angles formula, right? Now 2 and 2 right here cancel out. So the answer is sine s cosine s. The answer must be C. Now question 112. Which of the following expression is equivalent to cosine 5 pi over 11 times cosine 2 pi over 11 minus sine 5 pi over 11 times sine 2 pi over 11, right? So you look at this one, you see that this guy and this guy are the same, right? So we just label A, this one A. This guy and this guy are the same, we just label B. It's going to be B. So we write this one down, so it could be cosine A, cosine B, minus sine A, sine B. This guy actually cosine of A plus B, right? So A equals 5 pi over 11, B equals 2 pi over 11. I just substitute this guy into this expression, right? So I have cosine of 5 pi over 11 plus 2 pi over 11. Now the common mistake student always makes, this guy is minus sine, this guy must be opposite, alright, when it comes to this formula. If this guy is plus sine, this guy must be negative sine, so keep that in mind. Alright, so this guy turns out to be cosine of, now they have the same denominator. You just add the numerators up, right? So it will be cosine of 7 pi over 11, right? So the answer must be B. Now, question 113, similar to question 112, right? So I just label this one A, and then this one must be A, right? This one is B, and this one must be B, right? So I just write this one out. So it could be sine of A cosine B minus sine B cosine A, right? This guy actually sine of A minus B, right? You just substitute values, right? A equals 2 pi over 7, right? So we have sine of 2 pi over 7 minus B, which means pi over 7, right? And then you just simplify, right? So 2 pi subtract pi is going to be pi. So pi over 7. The answer must be C. Now question 114, similar to 112, right? This one is A, this one is B, this one is A, and this one is B, right? Just write the formula out, right? So it could be cosine A times cosine B plus sine A times sine B, right? This guy actually cosine of A minus B, right? A lot of students make mistake, right? This guy plus side, this guy must be minus side. If this guy minus side, this guy must be plus side. So keep that in mind. Alright, so it could be cosine of A, which means 5 pi over 12. Subtract B, which means pi over 12, right? So it's going to be cosine of 4 pi over 12, right? Now we're going to simplify this one, so it could be cosine of pi over 3, right? Cosine of pi over 3 equals 1/2, right? So the answer must be B. Now question 115. We have sine of 7 pi over 12. We label this one as A, right? This one as B, this one as B, and this one as A, right? So just write out the formula, right? So we have sine A cosine B plus sine B cosine A, right? This one actually is sine of A plus B, right? Now A equals 7 pi over 12, right? So we have sine of 7 pi over 12 plus B, which means pi over 12, right? So it could be sine of 8 pi over 12, right? Now simplify it could be sine of 2 pi over 3, right? So sine of 2 pi over 3 is the same thing as sine of pi over 3, right? So it could be sine of pi over 3, which means root 3 over 2, right? The answer must be C. Now let's move on to the next question. The figures show two circles centered at the origin with angle measures of alpha and beta, respectively, in standard position. The terminal right of the angle alpha intersects the circle at point P. The terminal right of the angle beta intersects the circle at the point Q. The coordinates of the point P are 3 and 4, right here. And the coordinates of point Q are 12 and 5. This will be right here, right? Don't forget the radius right here, 13, and radius right here is 5, right? Now, what is the value of sine 2 alpha, right? So, we're going to use the trig identities. We need to expand this one, right? It's going to be 2 sine alpha cosine alpha, right? Now, remember that sine alpha equals y over radius, right? Cosine alpha equals s over radius. So keep that in mind. Right, so we have 2 times sine alpha equals y over r, right? So I have y over r times s over r, right? Now I substitute values y, which means 4 right here. At point P, s equals 3, y equals 4, right? So it could be 2 times 4 over radius equals 5, right? Times s equals 3 over 5, right? Now simplify it could be 4 times 3 is going to be 12 times 2 could be 24 over 25. The answer must be C. Now question 117. What is the value of cosine of alpha plus beta, right? So we need to expand this formula first, right? So we have cosine of alpha cosine beta minus sine alpha sine beta, right? Now cosine alpha is going to be formula right here, s over r, right? So you have s, which means 3, r, which means 5, right? So you have 3 over 5. Cosine beta is going to be s over r, right? S right here equals 12. R right here equals 13, right? So it could be 12 over 13, right? Minus sine alpha, which means y over r, right? So 4 over 5, right? And sine beta right here is going to be 5 over 13, right? Alright, now simplify this one. 3 times 12 is going to be 36 over 65. Now for this one right here, don't simplify this one. Don't cancel out 5 and 5, right? Because after you cancel out 5 and 5, and you need to multiply them back, right? So don't do that. So minus 20 over 65, right? And then I'm going to subtract 36 subtract 20 is going to be 16 over 65. The answer must be A. Now question 118. Cosine of 2 beta is going to be 2 cosine square of beta minus 1, right? Now, you know that cosine of theta is going to be S over R, right? S equals 12, R equals 13 right here, right? So we have 12 over 13, right? So we have 2 times 12 over 13 all together square minus 1, right? So it can be 2 times 144 over 169 minus 1, right? So it could be 288 over 169 minus 1, right? So it could be 288 minus 169 over 169, right? So it could be 119 over 169, right? The answer must be C. Now question 119. What is the value of this, right? So you need to explain this one using the formula sine of alpha cosine of pi over 2 minus sine of pi over 2 cosine of alpha, right? Remember you have sine of a minus b. It's going to be sine of a cosine of b minus sine of b cosine of a, right? Now we need to simplify this one. So sine alpha, which means y over r, right? So we look at the first diagram right here. Y equals 4 and r equals 5, which means 4 over 5, right? So we have 4 over 5 cosine of pi over 2 equals 0, right? Minus sine pi over 2 equals 1, right? Cosine alpha, which means s over r, right? Now s equals 3, r equals 5 right here, right? So 3 over 5. Now simplify is to be negative 3 over 5. The answer must be B. Question 120. Which of the following expression is equivalent to cosine square of theta minus 1 times secant theta? Alright, so we need to convert secant to cosine, right? And cosine square of theta minus 1, we need to convert it to sine, right? So it's going to be, remember that we have sine square theta plus cosine square theta equals 1, right? Now, cosine square theta minus 1. Now, since we have cosine square theta minus 1, right? So we need to rewrite this one as cosine theta minus 1 equals negative sine square theta, right? So this one right here can be written as negative sine square theta times this one right here secant is going to be 1 over cosine theta, right? Sine square theta I just rewrite as negative sine theta times sine theta over cosine theta, right? So that I'm going to simplify this one and this one right here. So I have negative sine theta times sine theta over cosine theta is to be tangent theta, right? So the answer must be B. Question 121. Which of the following expression is equivalent to cosine s minus sine s squared? Alright, I just want to point out the common mistake students always make. Alright, look, they're gonna do like this. Cosine square of s minus sine square of s. Right, this one completely is wrong, right? You don't have that formula. Keep in mind, a minus b all together square equals a square minus 2ab plus b square. If you don't know this formula, you just write it like this. A minus b all together square equals a minus b times a minus b 2 times, right? And then you just FOIL this one, right? Or you use box method, right? So if I FOIL me, this one is to be a times a is to be a square, a times negative b is to be negative ab, b times negative a is to be negative ab, right? And negative b times negative b is to be b squared. And if I simplify it, it's to be like this, right? Now go back over here. You need to explain this one using the formula right here, right? So I have cosine square of s minus 2 sine s cosine s, right? Plus sine square of s, right? Now the third term right here should be the plus sign, right? Keep that in mind, this is the plus sign. A lot of students make mistake, they put the negative sign right here, that's wrong, okay? The negative sign goes into the middle term right here, right? Now to simplify this one, I just group them, right? So I have sine square of s plus cosine square of s, right? One group minus 2 sine s cosine s, right? Now, sine square plus cosine square is going to be 1, right? This is Pythagorean identity, right? Minus 2 sine s cosine s is going to be sine 2s. This guy is the double angle formula, right? So the answer must be C. Now, question 122. Given 1 minus cosine s different from 0, which of the following is equivalent to this one right here, right? Now again, we need to apply the Pythagorean identity, where sine square of s plus cosine square of s equals 1. And then from here, you just manipulate this one, right? So in order to solve for this one right here, I need to subtract 1 both side and subtract cosine both side, right? So I have sine square of s minus 1 equals negative cosine square of s, right? So this side turns out to be negative cosine square of s, right? Now, in order to solve for this one right here, I need to subtract cosine square of s both sides, right? So I have sine square of s equals 1 minus cosine square of s, right? So I just replace this one with sine square of s, right? So I have sine square of s, right? Now, cosine square divided by sine square is going to be cotangent square, right? So don't forget the negative sign. Negative cotangent square of s. So the answer must be A. Now, question 123. We need to break this one down, right? So, cosecant square of s divided by cosecant square of s is going to be 1, right? Now, negative 1 divided by cosecant square of s is going to be negative 1 over cosecant square of s. Now, the common mistake students always make, they're going to cancel out this side and this side. That's completely wrong. Alright, so this side turns out to be 1 minus 1 over cosecant square of s. It's going to be 1 over sine square of s, right? Now to simplify this one, I just multiply the top bottom by sine square of s, right? So I have sine square of s, and this guy is sine square of s, right? This side cancel out. So this side turns out to be 1 minus sine square of s, right? Because 1 times 1 equals sine square, the bottom is 1, right? 1 minus sine square of s equals cosine square of s by Pythagorean identity. The answer must be C. Now question 124. Which of the following expressions is equivalent to this guy? Alright, so we just expand this one using the trig identity, right? Cosecant s is going to be 1 over sine s, right? Now, sine 2s, this guy is the double angle formula. It's going to be 2 sine s cosine s, right? Now, this guy cancel out. So it's going to be 2 cosine s, right? The answer must be C. Now, question 125. Which of the following expression is equivalent to 5 cosine 2 theta, right? So this guy is the double angle formula, right? So we just expand this one. It's going to be 5 times 2 cosine square theta minus 1, right? So it's going to be 10 cosine theta square, right? Minus 5, right? Because you need to distribute 5, right? So the answer must be C. Topic 3.13, trigonometry and polar coordinates. Question 126. The location of a point in the plane is given by polar coordinates 7, 5 pi opposite. Which of the following gives another representation for this point in the polar coordinates? Now you have the formula. If you given the polar coordinates are comma beta. Now if you add even pi to the angle theta right here, the radius stay the same. So it's still R. Now the angle change theta plus or minus k 2 pi, right? Where k is an integer. This one represents even pi, right? So which means you have 2 pi, 4 pi, 6 pi, 8 pi, etc., right? Now if you given the polar coordinate of theta, you add the odd pi to the angle theta right here. The radius becomes opposite, which means negative r, right? And then angle theta equals where k is an integer. Alright, which means you have pi, 3 pi, 5 pi, 7 pi, right? So this one is r pi, right? Alright, so to do this problem, I'm going to add or subtract 2 pi, and I'm going to add or subtract pi, right? So first I have 5 pi over 6, I'm going to add 2 pi, right? So it's going to be 17 pi over 6. It's not here, right? Now, if I subtract 2 pi to see what happens. So it could be negative 7 pi over 6, right? So if I subtract 2 pi, I get negative 7 pi over 6 is right here, right? And then look at the formula right here. If you add or subtract even pi, the radius stays, right? So radius is 7, is still 7, so the answer must be C. Now, if you add or subtract 2 pi and you still don't see the answer, and then you're going to add or subtract pi to figure out the answer, right? Now, question 127. I have the angle pi over 2 right here, so I write pi over 2 here. I'm going to add 2 pi, right? And then pi over 2, I'm going to subtract 2 pi, right? For these two cases right here, radius stay, right? Now, I'm going to simplify this one. It's going to be 5 pi over 2. And look at the answer choice right here. I don't see 5 pi over 2, so this case doesn't work, right? Now, this guy becomes negative 3 pi over 2, right? I look at this one, I see that negative 3 pi over 2 right here. But it say the radius stays, right? Radius 1, so it's still 1, right? But it's negative 1, so it's not the right answer, right? Now, I'm going to add or subtract pi, right? So pi over 2, add pi, right? Pi over 2, subtract pi. In this situation, the radius is opposite, right? Now, this guy becomes 3 pi over 2, right? So I look at this one, I see that 3 pi over 2 right here, right? But the radius is opposite, right? Radius is 1 right here. It becomes negative 1, right? But it's still 1 right here, so this is not the right answer. Now, this guy becomes negative pi over 2, right? So negative pi over 2, I got this guy and this guy, right? But the radius is opposite, right? So it becomes negative 1, right? So this is not the right answer. The answer must be A. Now question 128, similar, right? So I have pi over 3 add 2 pi, right? And pi over 3 subtract 2 pi, right? You're going to check for different cases. And pi over 3 add pi, right? And pi over 3 subtract pi, right? This radius stay, right? This one radius is opposite, right? Now I'm going to simplify this one. It's going to be 7 pi over 3. It's not here, right? So this is not the answer. This guy becomes negative 5 pi over 3, right? I check this one. It's not here, so this is not the case, right? Now this one becomes 4 pi over 3. It's right here, right? So radius must be opposite, right? Radius is negative 2 right here, becomes positive 2, so the answer must be D. Now question 129. We need to convert the polar coordinates to the rectangular coordinates. So we know that S equals R cosine theta, right? Y equals R sine theta, right? And R equals square root of S squared plus Y squared, right? Now we're going to substitute values, right? Radius is 2, 7 pi over 6 is theta, right? So I need to solve for S, right? So S equals 2 times cosine of 7 pi over 6, right? Now cosine of 7 pi over 6 is negative root 3 over 2, right? So 2 times negative root 3 over 2. So it could be negative root 3, right? Now I need to eliminate C and D, right? Now Y equals 2 sine 7 pi over 6, right? So it could be 2 times sine 7 pi over 6 is negative 1/2, right? And then it turns out to be negative 1, right? So the answer must be A. Now question 130. S equals R cosine theta. Substitute values. This is R and this is theta, right? So it could be negative 1 cosine of 5 pi over 3, right? Cosine of 5 pi over 3 equals 1/2, right? Negative 1 times 1/2. So it's going to be negative 1/2, right? I need to eliminate B and C. Now Y equals R sine theta, right? So it can be negative 1 sine of 5 pi over 3. So it's going to be negative 1 times negative root 3 over 2. So it could be root 3 over 2. So the answer must be D. Now question 131. This is theta. So S equals R cosine theta. It's going to be negative 4 cosine of negative pi over 2, right? Because the cosine function is even, then negative 4 times cosine of pi over 2, right? Cosine of negative s equals cosine s, sine of negative s equals negative sine s. So keep that in mind. Alright, so cosine of pi over 2 equals 0, so the answer equals 0, right? I need to eliminate a and b. Now y equals r sine theta, right? So it could be negative 4 sine of negative pi over 2, right? So it's going to be negative 4 times negative of sine pi over 2, right? Because the sine function is off, right? So we're going to apply the formula right here, right? So it could be 4 times 1, right? Sine pi over 2 equals 1, so the answer is 4, right? So the answer must be D. Now question 132. We need to convert rectangular coordinates to the polar coordinates. So we're going to do backward, right? Now you have the formula r squared equals s squared plus y squared, right? And then if s greater than 0, then you have angle theta can be calculated as tangent inverse of y divided by s, right? If s less than 0, and then angle theta can be calculated as tangent inverse of y over s, and then you need to add pi, right? So keep that in mind. Now we're going to apply this formula, right? So we need to calculate radius first. So radius squared equals s squared plus y squared, right? So it could be negative 2 square plus 0 square, right? So it could be 4, right? Now take square root both sides, so radius equals plus and minus 2, right? Now we're going to use radius equal to first, right? So look at this one, s equal negative 2 less than 0, so theta equals tangent inverse of y divided by s, which means 0, right? And then you need to add pi, right? Tangent inverse of 0 equals 0, so the answer must be pi, right? So you have the coordinate point radius equal to comma pi, right? Now look at the answer choice right here, it's not there, right? Now you need to add or subtract 2 pi to see if you have the answer, or add or subtract pi, right? It's similar to the previous question. Alright, so now if I add 2 pi, so I have pi add 2 pi, it's gonna be 3 pi. It's not there, right? So it's wrong. Now pi, I'm going to subtract 2 pi. It's going to be negative pi, right? So negative pi is right here. But radius must be positive, right? Because when you add or subtract even pi, the radius doesn't change the sign, right? So this is not the case. Now, next one, you're going to add pi. It turned out to be 2 pi, right? And then you need to change the radius to be negative 2. So negative 2 and 2 pi, the answer must be C right here. Now question 133. A complex number is represented by a point in the complex plane. The complex number has the rectangular coordinates negative 3 and 3. Which of the following is one way to express the complex number using its polar coordinates or theta? In the complex plane, the polar coordinates can be written as r cosine theta plus I r sine theta. So keep that in mind. Alright, so basically you need to calculate radius first, right? Now you have the radius equals square root of s squared plus y squared. Right, so it could be negative 3 squared plus 3 squared. It could be 18, right? So then it's gonna be square root of 9 times 2, right? Now 9 you can bring it outside. It turns out to be 3 root 2, right? So you can eliminate the answer B and D because the radius is wrong, right? Next one, you need to calculate the angle theta. It's going to be tangent inverse of y divided by s, right? So it can be tangent inverse of 3 divided by negative 3. So it's going to be tangent inverse of negative 1, right? So it can be 3 pi over 4. So the angle theta equals 3 pi over 4, right? The answer must be C. Now question 134, similar to question 133, right? I need to calculate the radius. So radius equals square root of x squared plus y squared, which means 1 over 4 plus 3 over 4, right? So it's going to be square root of 4 over 4. It's going to be 1, right? Now, angle theta equals tangent inverse of y divided by x, which means negative root 3 over 2 divided by 1 half, right? Now, I need to multiply the top and bottom by 2 right here, because I see the denominator has 2 right here. So this cancel out, this cancel out. The answer must be tangent inverse of negative root 3, right? So it's going to be 5 pi over 3, right? So angle theta equals 5 pi over 3 and radius equals 1. The answer must be C. Now let's move on to question 135. Given the complex number in the polar coordinate form, right? Now we need to convert this one into the rectangular coordinate x, y right here. Alright, so we need to use the formula s equals r cosine theta, right? Y equals r sine theta, right? Now this one means s, this one means y, right? So you have 3 cosine of 5 pi over 4. Alright, so it's going to be 3 times negative root 2 over 2. So it could be negative 3 root 2 over 2. Now y equals r sine theta, which means 3 sine 5 pi over 4. So it could be 3 times negative root 2 over 2, right? So it could be negative 3 root 2 over 2. So the answer must be A. Now let's move on to question 136. It's going to be the same thing, right? So I have S equals R cosine theta, right? This one is S, so it can be 4 cosine of negative 2 pi over 3, right? Because the cosine function is even, right? So this guy turns out to be 4 cosine of 2 pi over 3. Keep in mind, the cosine function of S is even, then cosine of negative S equals cosine of S. The sine is odd, so then sine of negative S equals negative sine of S, right? So keep that in mind. Right, so cosine of 2 pi over 3 equals negative 1 half, right? So it could be 4 times negative 1 half. Right, so it could be negative 2, right? Now, y equals r sine theta, right? So it could be this one right here. 4 sine of negative 2 pi over 3, right? Now, the sine function is odd, right? So this guy turns out to be negative 4 sine of 2 pi over 3, right? So this guy turns out to be negative 4 times root 3 over 2. So it could be negative 2 root 3, right? So x equals negative 2 and y equals negative 2 root 3. The answer must be B. Topic 3.14 Polar function graphs. Now question 137. The figure shows the graph of the polar function r equals f of theta, where theta from 0 to 2 pi. In the polar coordinate system, which of the following could be an expression for f of theta? Alright, so to do this type of problems, just pick a point on the graph and substitute into the equation and check. Alright, so for example, I pick this one, right? And you know that this point has the radius 3, right? And the angle is pi, right? Remember, you have the polar coordinates to be r theta, right? So I'm going to substitute pi for theta into each of these expressions right here to check, right? If the radius equals 3, and that's my answer, right? So theta equals pi, substitute here, sine pi equals 0, right? So you only have 1.5 left right here, which is not right? Cross it out. Next one, sine pi equals 0, you only have 1.5 left right here, which is not correct, right? Because you need 3, right? Now, cosine pi equals negative 1, right? So 1.5 plus 1.5 times negative 1 equals 0, right? Which is not right. And the last one, cosine pi equals negative 1, right? It's going to be 1.5 plus 1.5. It's going to be 3. The answer must be D. Now, let's move on to question 138. Question 138 similar to question 137, right? We're gonna pick the points, right? So I'm gonna pick this point right here, right? So I have all theta equals the radius is 3 and the angle is 0, right? Now I substitute 0 for theta into each of these expressions right here, and I'm gonna check to see if the radius is 3, right? Now sine 0 equals 0, right? So the radius is 1 right here, right? So this is not right. Now sine 0 equals 0, this one has 1 left, right? So this is not right. This cosine 0 equals 1, right? So you have 1 minus 2 times 1, which is negative 1. It's not right, right? And the last one, cosine 0 equals 1. So you have 1 plus 2 times 1 equals 3, which is right here. So the answer must be D. Let's move on to question 139. The figure shows the graph of the polar function r equals f of theta, where f of theta equals 1 plus 2 cosine 2 theta in the polar coordinate system for theta from 0 to 2 pi. There are 5 points labeled A, B, C, D, and E. If the domain of the function f is restricted to 0 to pi over 2, the portion of the given graph that remains consists of 2 pieces. One of those pieces is the portion of the graph in the quadrant 1 from A to B, right? So which means from here to here, right here, is given, right? Which of the following describe the other remaining piece? Alright, since you're given the equation of the polar function, go ahead and sketch this one in the rectangular system. Alright, so first I need to convert this one into the standard form. It's going to be f of theta equals 2 cosine of 2 theta plus 1, right? Now, you need to find the period, so the period is going to be 2 pi divided by b, right? B in this situation is going to be 2 right here, right? So it could be 2 pi divided by 2 is going to be pi, right? Now, I have the period pi, so I put pi right here. Alright, so half of pi is going to be pi over 2, right? Half of pi over 2 is going to be pi over 4. And then this one should be 3 pi over 4, right? Now, the midline is 1, right? So I have 1 right here. The amplitude is 2, right? So the maximum must be 3, right? And the minimum should be negative 1, right? The distance from here to here is the amplitude, right? So this is A equals 2. Alright. Since this is a cosine function, right? So the cosine function starts from the maximum, and then there is no negative sign in front of amplitude, so there is no reflection, right? So the cosine function starts from the maximum right here, right? Back down to the midline, right? So the midline right here, pi over 4, the first quadrant. This is the first quadrant. The second quadrant should be pi over 2 right here. It's going to be minimum, right? And back up to the midline, it could be the third quadrant, right? And the last quadrant is going to be pi over here. It's going to be maximum, right? So if you graph it, it's going to be something like this. The restricted domain is 0 to pi over 2, right? If you look at the polar graph, it's going to be from here to here, right? And if you look at the rectangular graph, it's going to be from here to here, right? Now, you need to find the 0 right here, right? So in order to find the 0 right here, I need to let this one equal to 0, right? So I have 2 cosine 2 theta plus 1 equals 0, right? Subtract 1 both sides and divide both sides by 2. I have cosine of 2 theta equals negative 1/2, right? I have 2 theta equals 2 pi over 3, and 2 theta equals 4 pi over 3. Now I need to solve for angle theta within this domain right here, 0 to pi over 2, right? So I need to divide both sides by 2, so theta equals pi over 3, right? And the second one, theta equals 2 pi over 3, right? This one is outside of this domain, right? So I don't need to worry about this one, right? So theta equals pi over 3, which means the 0 right here, right? So this is pi over 3. Actually, this one is 2 pi over 3 right here, right? But we don't need that one. Alright, now, So then we have two intervals. The first one is going to be 0 to pi over 3, right? Right here. The second one is going to be pi over 3 to pi over 2, right? It's going to be right here. Alright, now we're going to check the first case. When theta goes from 0 to pi over 3, which means it's going to be right here, right? This guy right here. So the angle pi over 3 is going to be right here, right? This is pi over 3. And then the portion of the graph in the quadrant 1 go from A to B, right? You see that? When the angles goes from 0 to pi over 3, the radius goes from A to B, right? This is the first one given right here. Now, the remaining one is the one goes from pi over 3 to pi over 2 right here. This one right here. This guy right here. Alright. So, since this guy right here, the radius is negative, right? Because pi over 3 to pi over 2 right here is below the x-axis, right? You need to reflect the point over the pole, right? So suppose I have the points right here, right? I need to reflect over the pole, so it could be somewhere right here, right? So it's gonna go from B to E. Why? Because the radius getting bigger and bigger, right? It's away from the origin, right? So the answer must be C. Now let's move on to question 140. Right, question 140 similar to question 139, right? Given the graph g of theta equals 3 sine 3 theta, right? Now we need to sketch the graph of this function on the rectangular system, right? So the interval we are going to explore is pi over 2 to pi over 3, right? So it could be from here to here, right? So you see that within this interval, the radius getting smaller and smaller, right? Because it's getting closer to the origin, right? Look, it's getting smaller. And then the radius within this interval is negative, right? So you need to reflect over the pole, right? Now, pi over 2 to pi over 3 is going to be right here. The reflection point should be within this interval, right? So then you will have the point somewhere else right here, right? Now, we need to know if the portion of the graph goes from C to D or D to C. We look at the radius right here. Right at 2 pi over 3 right here, it's going to be 0, right? Look, the radius getting smaller and smaller, right? So, right at pi over 2 right here, if you reflect, it's going to be right here, right? So, right here, it's going to be the biggest one, right? And it's getting smaller when it's go to the pole right here. So, it should be going from C to D, right? So, the answer must be D. Now, let's move on to question 141. A portion of the graph of the polar function r equals f of theta, where f of theta equals 1.5 cosine 3 theta, is shown in the polar coordinate system for theta from A to B. If A greater than or equal to 0 less than B less than 2 pi, which of the following could be the values for A and B? Alright, so given the equation, we need to sketch this one in the rectangular system, right? So first I need to find the purus, right? Purus equal 2 pi divided by b, right? So it could be 2 pi divided by 3, right? Because b equals 3, right? Now you need to find the midline, right? The midline d equals 0, which is the x-axis, right? And the amplitude a equals 1.5, right? So then you have the maximum is 1.5, right? Minimum is 1.5, right? Now you're gonna wrap this one in the rectangular system. So it's gonna be something like this. Now we're gonna check for the first interval. 7 pi over 6 to 4 pi over 3. So 7 pi over 6 to 4 pi over 3 is gonna be right here. This interval, right? Right, since 7 pi over 6 to 4 pi over 3 is gonna be from here to here, right? So it's gonna be this interval right here. Now within this interval, the radius is positive, right? So you don't need to flip it, right? So if you have the point on this interval, it should be somewhere right here, right? So then if you look at this interval right here, there is no portion of the graph, right? So which means this one is wrong, right? Now next interval, 5 pi over 6 to pi. right? 5 pi over 6, 2 pi, it's gonna be right here, right? And then on the polar graph, it's gonna be from here to here, right? And then you look at the rectangular graph right here, it's below the x-axis, right? Since it's below the x-axis, the radius is negative, right? The radius is negative, and then if you have the point within this interval, you need to flip it over the pole, right? So if I flip this point over the pole, I get some points right here, right? So the answer right here could be right. Now I'm gonna check the answer choice C. 5 pi over 3, 2 pi, right? 5 pi over 3, 2 pi, so it could be from here to here, right? Now, within this interval, I'm gonna split this guy into two intervals, right? The first one I'm gonna talk about is 5 pi over 3 to 11 pi over 6, right? From here to here first, right? From here to here first, right? So 5 pi over 3 to 11 pi over 6, it's gonna be from here to here. Now, if you look at the rectangular graph right here, you see that within this interval, the radius is negative because the function is below the axis, right? So if the radius is negative, you need to reflect it over the pole, right? If you reflect it over the pole, it should be somewhere right here, right? But you don't see any portion of the graph, right? So it makes C wrong. Now the last one, 3 pi over 2 to 2 pi, right? 3 pi over 2 to 2 pi. So it's going to be from here to here. So you see that this interval contains the interval 5 pi over 3 to 11 pi over 6, right? Right here. But we just proved that this one is wrong, right? So it makes the whole thing wrong, right? So the answer must be B. Now let's move on to question 142. Which of the following is the graph of the polar function r equals f of theta, where f of theta equals 1.5 plus 1.5 cosine theta in the polar coordinate system for theta from 0 to 2 pi, right? Now, in order to do this problem, you just pick a point and you substitute over here, you check, right? Now, to do this problem, I just pick the angle theta equals 0. I substitute 0 for theta into this equation to see what happens, right? So I have f of 0 equals 1.5 plus 1.5 cosine 0, right? Cosine 0 equals 1, right? So the answer must be 3, which is the radius, right? So when angle theta equals 0, the radius is 3, right? Now you're going to check answer choice A. Angle theta equals 0, so it's right here on the x-axis, right? The radius in this situation is 1 point something right here, right? But we need the radius is 3, so the answer A is wrong. Now, B. Angle theta equals 0, so it could be right here, right? And the radius right here is to be 1 point something. Now, the radius right here is 3, so answer choice B is wrong, right? Angle theta equals 0, so it could be on the polar axis, right? And the radius is 3 right here, right? The radius is 3 right here. So it makes C correct. Now, answer choice D, the angle theta equals 0, the radius is 0. This makes answer choice D wrong. Now, let's move on to the next question. Question 143. Which of the following is the graph of the polar function r equals g theta, where g theta equals 3 sine 4 theta in the polar coordinate system, theta from 0 to 2 pi? Alright, so in order to do this problem, we need to graph this one in the rectangular system, right? So it's going to be like this. The period is 2 pi divided by 4, right? So it could be pi over 2, right? So you have the period is pi over 2, so I have pi over 2 right here. Now half of pi over 2 is going to be pi over 4, right? Now we're going to check our answer. We see that at theta equal pi over 8, the function has the maximum value, which is the radius equal 3, right? Right here. As theta equal pi over 8, right? So pi over 8, which means half of pi over 4 is going to be right here, right? Look at this one, the radius is not 3, the radius is somewhere right here. I think that is going to be about 2 something. If you draw the line, it's about 2. So this one is wrong, right? Now, answer choice B, pi over 8, this is pi over 4, right? So pi over 8 right here. Now, if you connect this one, you see that the radius should be somewhere right here. It's not 3, right? So the answer choice B is wrong. Next one, C, pi over 8 is going to be right here. This is pi over 4. This is 0, right? So this is pi over 8. The radius is 3, yes, because it's on the third circle right here, right? So the answer choice C is correct. Now the last one right here, pi over h right here, there's nothing right here, right? Now question 144 similar to 143, right? We still do the exactly same thing, right? We just get this one, right? Now we're gonna check it. At pi over 4, the radius is 0, right? It's on the x-axis right here, right? So pi over 4 right here. Look at this is pi over 4. The radius is 6, right? So this one is wrong. Now pi over 4 right here. The radius is 0, right? So this one could be right. Now pi over 4 is going to be right here. The radius is still 0, right? So this one could be right. Now pi over 4 is going to be right here. The radius is 6, right? So this one is wrong. We're going to check the next one. At theta equals 0, the radius is maximum 6, right? So we only have answer choice B and C right here, right? Angle theta equals 0, right? So it's on the polar axis right here. Radius is 6. Yes, that's correct, right? So answer choice B is correct. Now answer choice C. Angle theta equals 0, so it's on the polar axis. But you see nothing right here, right? Radius right here is 0, right? So answer choice C is wrong. The answer must be B. Now let's move on to question 145. Which of the following is the graph of the polar function r equals f of theta, where f of theta equals 6 sine square theta in the polar coordinate system, theta from 0 to 2 pi. Alright, so in order to do this one, you just pick the angle theta, right? So suppose I'm gonna let angle theta equals pi over 2, and I'm gonna find the radius, right? So I substitute into this equation right here. So I have f of pi over 2. It's gonna be 6 times sine of pi over 2 all together square, right? So it can be 6 times sine pi over 2 equals 1, right? So it can be 1 square. So it can be 6, right? So at angle theta equals pi over 2, the radius is 6, right? Check. Answer choice A. Pi over 2 is going to be the y-axis right here. And then the radius is 6 right here. Yes, that's correct, right? So the answer choice A could be right? Now answer choice B, at theta equals pi over 2, the radius is not 6, right? Because there's nothing right here, right? So the answer choice B is wrong. Answer choice C, angle theta equals pi over 2, the radius is not 6, right? Because there's nothing right here, right? So answer choice C is wrong. Answer choice D, angle theta equals pi over 2, radius not 6, right? There's nothing right here, right? So it's wrong. So the answer must be A. Now let's move on to question 146. Given the graph f of theta equals 3 cosine 3 theta, right? Again, we just get this one to see what happens, right? So, alright, now we're gonna pick the angle and then we substitute over here to find the radius, right? So suppose I pick the angle theta equals 0 to see what happens. Substitute over here. Substitute 0 for theta, right? So I have f of 0 equals 3 cosine of 3 times 0, which means 0, right? So it could be cosine of 0 equals 1, so 3 times 1 equals 3, right? So f of 0 equals 3, which means the angle theta equals 0, the radius is 3, right? Look at answer choice A. Angle theta equals 0, the radius is 0, right? Answer choice A is wrong. Answer choice B, angle theta equals 0 is going to be on the polar axis, the radius is 3. Yes, this one could be right. Answer choice C, angle theta equals 0, the radius is nothing right here, right? So this one is wrong. And answer choice D, angle theta equals 0, the radius is nothing right here, right? So answer choice D is wrong. So the final answer must be B. Now let's move on to question 147. Given the graph f of theta equals 3 minus 3 sine theta, right? So we just get this one. Now suppose I pick the points right here. Theta equals 3 pi over 2 and the radius is 6, right? This is maximum, right? So I have the point, it's going to be 6 comma 3 pi over 2, right? Now angle theta equals 3 pi over 2, it's going to be right here, right? The radius right here is not 6, right? The radius right here is about 3, right? So this one is wrong. Answer choice B, 3 pi over 2 is going to be right here. The radius right here less than 6, so this one is wrong. Answer choice C, 3 pi over 2 right here, and radius is 0, right? Because there's nothing right here. It's one wrong. 3 pi over 2 is going to be right here. Radius right here equals 6, right? So the answer choice D is correct. Now, question 148. We need to sketch the graph right here, right? So we just rewrite this one as f of theta equals negative 2 sine theta plus 1, right? So then we have the midline 1, right? And then the period is 2 pi because b equals 1, right? So now for the answer choice A, angle theta equals 0, the radius is 2, right? Look at the rectangular graph right here. Angle theta equals 0, the radius right here equals 1, right? The midline right here 1. So this one makes answer choice A incorrect, right? Answer choice B, I'm gonna look at this one right here. I pick this point right here. Angle theta equal pi over 2, radius is negative 1, right? So angle theta equal pi over 2, radius is negative 1. Since radius is negative 1, I need to reflect over the pole. It becomes 1 right here, right? So answer choice B could be correct. Answer choice C, I'm gonna pick this point right here. The angle theta equals pi and radius is 1, right? So angle theta equals pi, radius is 1, which means it's right here. You don't need to reflect, right? So you see that there's nothing right here. So the answer choice C is wrong, right? Now for answer choice D right here, I'm going to pick 3 pi over 2, right? So 3 pi over 2 is going to be right here. The radius right here is 3, right? So 3 pi over 2, which means it's right here. And you don't see anything right here. Radius is 3. So it's positive. You don't need to reflect, right? So you see nothing right here. The answer choice D is wrong. So finally, answer choice B is correct. Now let's move on to question 149. Alright, so given the graph f of theta equals 6 cosine 2 theta. Alright, there are 5 points labeled A, B, C, D, and E. Alright. Now we need to sketch this one first, right? So we need to find the period. So the period equal 2 pi divided by b, which means 2 pi divided by 2, right? Because b equal 2 right here. So it's going to be pi, right? Now you're going to take pi divided by 4, right? So each quarter is going to be pi over 4, right? So I'm going to sketch this one. The interval from 5 pi over 4 to 3 pi over 2 is going to be from here to here. Alright, so within this interval, the radius is negative, right? Because it's below the x-axis, right? On the polar graph, you should locate the interval from 5 pi over 4 to 3 pi over 2, right? So 5 pi over 4 is going to be right here, to 3 pi over 2 is going to be right here, right? Now, you're going to check. Within this interval, the radius is negative, right? Since the radius is negative, you need to reflect over the pole, right? So if you reflect over the pole, it should be in the first quadrant right here. So it should be this guy right here. Only, right? And then you need to check the radius. Look, it's from 5 pi over 4 to 3 pi over 2. It's getting further away from the origin, right? Which means the radius getting bigger and bigger, right? So you need to check to see if it's go from E to B or B to E, right? So it's getting bigger, which means it's getting further away from the pole, right? So it should be from E to B, right? So it should be this direction. So E to B is going to be A. Now let's move on to question 150. Alright, given the graph of the function f of theta equals 6 times sine 2 theta, right? And then the restricted domain is going to be 7 pi over 4 to 2 pi, right? Now we need to sketch this graph, right? So you have the period is going to be 2 pi divided by 2 right here, right? So it could be pi, right? And you look at this one, it's 7 pi over 4 to 2 pi. So you need to extend this one to one more cycle, right? So if you grab it, it should have 2 cycles, so keep that in mind. So 7 pi over 4 to 2 pi should be right here. Alright, within this interval, the radius is negative, right? Now, on the polar graph, 7 pi over 4 to 2 pi is going to be from here to here. Now, since the portion of the graph within this interval is below the axis, right? So the radius is negative, right? If the radius is negative, it's reflect over the pole. So it should be this interval right here, right? From 7 pi over 4 to 2 pi. And you see that the radius getting smaller and smaller because it's getting closer to the pole, right? So you look at this one right here. It's from A to E or from E to A, right? So from A is the biggest, right? So it's go from A to E. because it is the pole, right? So the answer must be B. The bottom portion of the graph in quadrant 2 from A to E, right? The bottom right here, this one only. Topic 3.15, rates of change in polar functions. Alright, before we're going to dive into the problem 151, let's review this concept. If you have the plus sign times plus sign, the answer must be positive, right? Negative times negative, the answer must be positive, right? Because they have the same sign. Negative times positive, the answer is negative, right? And positive times negative, the answer is negative, right? Now, we're going to use the plus sign and minus sign to represent negative, decreasing, positive, and increasing, right? So, this is negative, we're going to use the negative side, right? Decreasing, which means negative side, right? So, negative times negative is going to be positive, right? This one is positive right here, right? So, the answer choice A could be right. Now, answer choice B, this is positive, we're going to use the plus side, right? Decreasing, we're going to use the negative side, right? So, positive times negative is going to be negative, but this one is positive, right? So, the answer choice B is wrong. We need to eliminate it, right? Now, next one, negative is going to be negative side, right? Increasing is going to be plus side, right? So plus side times minus side should be minus side, right? This one is minus side, right? So answer choice C could be right. And the last one, positive, we're going to use the plus side, right? Increasing plus side, right? So plus side times plus side is going to be plus, right? This one is minus, right? So the answer choice D is wrong. We need to eliminate, right? So we have A, C could be right. Now next one, we need to sketch this one, right? And this one very easy to sketch. You already learned in previous lesson, right? So if you don't know how to sketch this one, just revisit the video in the description below. Okay. Alright, so here's the graph of the function f of theta equals 2 plus 3 cosine theta, right? Now you know that the maximum is 5, right? Because the maximum equals the midline plus the amplitude, right? 2 plus 3 equals 5, right? The midline equals 2, and the minimum is going to be 2 minus 3 is going to be negative 1, right? And you see that the period is 2 pi, right? Because b equals 1, and you have period equal 2 pi divided by b, right? So it will be 2 pi, right? And cosine function start from the maximum, right? Back down to the midline right here, go down to the minimum, back up to the midline, and go up to the maximum, right? Alright, now we're going to check answer choice A and C, right? Now we look at the interval right here, 5 pi over 6, 2 pi, right? We have pi right here, but we don't have 5 pi over 6, right? So 5 pi over 6 could be somewhere else right here, right? It could be right here, right? Because 5 pi over 6 is between pi over 2 and pi, right? Now we need to check to see if 5 pi over 6 is positive or negative. If it's positive, it should be somewhere right here. If it's negative, it should be somewhere right here, right? So we need to substitute 5 pi over 6 for theta into this equation right here, right? So we have f of 5 pi over 6. It's going to be 2 plus 3 cosine of 5 pi over 6, right? Now it's going to be 2 plus 3 times negative root 3 over 2, right? So it's going to be 2 plus negative 3 root 3 over 2, right? And it's going to be negative for sure, right? So if it's less than 0, 5 pi over 6 should be right here, right? The point should be right here. And then you have the interval from 5 pi over 6 to pi is going to be right here. Alright, now observe that this interval is below the axis, right? This one below the axis, so it's going to be negative, right? And you see that it's going down, so it should be decreasing, right? So you see that it's negative and decreasing. So then the distance is increasing, right? So the answer is A, right? And you see that it's getting further away from the origin, right? So it's getting bigger, 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 right? So the radius is bigger. Now question 152, similar to 151, right? And then we need to sketch the graph of this one in the rectangular system, right? Alright, so here's the graph of f of theta equals 2 minus 4 sine theta, right? Right, the maximum is 6, the minimum is negative 2, right? The midline is 2, right? And you see that there is a negative sign in front of amplitude, right? So there is a reflection over the midline, right? Now we're gonna check it. The polar function r equal f of theta, where f of theta equals 2 minus 4 sine theta is graphed in the polar coordinate system for theta from 0 to 2 pi. On which of the following intervals of theta is the distance between the points with polar coordinates f of theta, and the origin decreasing. So the distance is decreasing, which means this one is negative, right? Negative can be written as negative times positive, right? Or positive times negative, right? So what does that mean? Negative, which means the function is below the axis, right? The function less than 0. Positive right here, which means the function is increasing, right? Now positive right here, which means the function above the axis, right? And this one, the function is decreasing, right? So it's make the distance between the point and the origin decreasing, right? So keep that in mind. Now we're going to check for every single interval. The first interval is going to be pi over 2, pi over 2, right? Pi over 2 right here. Now we need to find where pi over 6 goes, right? So we need to substitute pi over 6 for theta into this equation right here. We need to find f of pi over 6, right? So we have f of pi over 6 is going to be 2 minus 4 sine of pi over 6, right? And then sine of pi over 6 equals 1/2, right? So if we simplify this one, it's going to be 0, right? Theta equals pi over 6 is a 0, right? So it's going to be right here, right? So we have the interval, it's going to be from here to here, right? And you see that this interval is below the axis, so it's going to be negative, right? Now, it's negative and decreasing, right? Because it's going down, right? So it could be negative. Negative times negative is going to be positive, right? But we need negative right here. We need decreasing, right? So the answer choice A is wrong. Now, next one, 5 pi over 6 2 pi, right? Again, we need to calculate f of 5 pi over 6, right? So it's going to be 2 minus 4 sine of 5 pi over 6, right? So it could be 2 minus 4 sine of 5 pi over 6, it could be 1/2 again, right? So this guy is still 0, right? So theta equals 5 pi over 6 is a 0 of the function, it should be right here, right? Now the interval should be from here to here, right? This interval is above the axis, so it could be positive. And this interval is increasing, right? So it's going to be another positive. Positive times positive should be positive, right? So which means the distance is increasing. But we need the distance right here decreasing, right? So the answer choice B is wrong, right? Now question C. 5 pi over 4, 2, 3 pi over 2, right? We don't see 5 pi over 4 right here, right? So we need to calculate f of 5 pi over 4 to see where it is, right? It's going to be 2 minus 4 times sine of 5 pi over 4. Sine of 5 pi over 4 equals negative root 2 over 2, right? So it's going to be 2 minus 4 times negative root 2 over 2. Now, if you simplify this one, it's going to be 2 plus 2 root 3. So it's going to be positive, right? If it's positive, it should be above the axis, right? So it's going to be somewhere else right here between pi and 3 pi over 2. So it's going to be right here, right? Middle between pi and 3 pi over 2. This one is 5 pi over 4, right? Now the interval should be from here to here, right? Now it's above the axis, so it's going to be positive, right? And it's increasing, so it's going to be another positive. Positive times positive is going to be positive, but we need negative right here, decreasing. So the answer choice C is wrong, right? Now the last one, 5 pi over 3 to 11 pi over 6. We don't need to calculate it. We know that this interval right here should be between 3 pi over 2 and 2 pi, right? So it's going to be somewhere else right here, right? This one right here is 5 pi over 3. And this one right here is going to be 11 pi over 6, right? Alright, so you have the interval, it's going to be right here. Now you see that this interval is above the axis, so it's going to be positive. And it's going to be decreasing, so it's going to be negative. Positive times negative is going to be negative. This is what we need, right? Because the distance is decreasing, which means negative. So the answer is D. Now let's move on to question 153. The polar function r equals f of theta, where f of theta equals 1 minus 2 cosine 2 theta. Is graphed in the polar coordinate system for theta from 0 to 2 pi. On which of the following intervals of theta is the distance between the points with polar coordinates f of theta, and the origin increasing, which means plus sign, right? Now we just review this one. Plus sign can be written as negative times negative equals positive, right? Or positive times positive equals positive, right? So one of this one, right? Alright, so first you need to sketch this guy on the rectangular system, right? Alright, if you wrap it correctly, it should be something like this. Alright, since you have the negative side in front of the amplitude, so there is a reflection. And the period is going to be pi, because P equals 2 pi divided by B. B in this situation is 2 right here, right? So keep in mind it's going to be pi. Now I need to extend this one to one more cycle. So it's going to be 2 cycles right here. Because I see 7 pi over 6 right here is greater than pi, right? So keep that in mind. 0 to pi over 6, it could be inside the 0 to pi over 4, right? It's going to be inside of this one, right? If it's inside of this one, it should be negative somewhere right here. If it's inside the interval from 0 to pi over 4, right? And then you see that there is a portion below the axis right here, right? So it is negative, right? And then you see that the function is increasing because it's going up, right? So it can be positive. Negative times positive equals negative, right? But we need positive here, right? So answer choice A is incorrect, right? Now next one, pi over 2 to 5 pi over 6. It's going to be from here to here, somewhere right here, right? Now observe that 5 pi over 6 is greater than 3 pi over 4. So 5 pi over 6 would be somewhere right here, right? So you have the portion right here below the axis, right? This one below the x-axis, then the function is negative, right? And it's decreasing, right? So it's going to be another negative. So it turns out to be positive. This is what we need, right? But if you look at the one above the axis right here, right? The remaining one right here. This one is above the axis, so it can be positive, right? And it's decreasing, right? So it can be negative. So the answer must be negative, but we need positive, right? So answer choice B is incorrect, right? Now answer choice C, from pi to 7 pi over 6. 7 pi over 6 is between pi and 5 pi over 4, right? So it could be somewhere else right here, right? And then you have the interval, it's going to be from here to here, right? And you see that this interval is below the axis, right? If it's below the axis, it should be negative, right? And then you see that the function is increasing within this interval, which means it's going to be positive, right? Negative times positive is going to be negative, right? But we need positive, right? So the answer choice C is incorrect, right? Now the last one, from 7 pi over 6 to 3 pi over 2. So it could be the interval from here to here. Now observe that 7 pi over 6 is a zero of this function, right? 7 pi over 6 actually right here. Why? Because if you substitute 7 pi over 6 for theta into this equation, you will have f of 7 pi over 6 equals 1 minus 2 cosine of 7 pi over 6 multiplied by 2, right? So it's going to be 1 minus 2 cosine of 7 pi over 3, right? So this one can be written as 1 minus 2 cosine of pi over 3 plus 2 pi, right? And then you just ignore the period right here. So it's going to be 1 minus 2 cosine of pi over 3, right? It's going to be 1 minus 2 times 1 half, right? So it could be 0. So theta equals 7 pi over 6 is a 0, right? So within this interval, there is no portion below the axis, right? So it's completely above the axis, right? So it's going to be from here to here. Alright, so within this interval, you see that it's going to be above the axis, so it should be positive. And the function is increasing, right? So it could be another positive. Positive times positive, it could be positive. This is what we need right here, right? So the distance between the point and the origin is increasing. The answer must be D. Now let's move on to question 154. In the polar coordinate system, the graph of the polar function r equals f of theta is shown with a domain of all real numbers, theta within 0 to 2 pi. On this interval of theta, the graph has no holes, passes through each point exactly one time, and as theta increases, the graph passes through the point labeled A, B, C, and D in that order. On which of the following intervals is the average rate of change of R with respect to theta least? Now you know that the average rate of change is given by the formula f of b minus f of a over b minus a. Now, case number 1. If f of b greater than f of a, then does that mean f of b minus f of a greater than 0, right? So if this guy greater than 0, the average rate of change is positive, right? You have f of b greater than f of a. The average rate of change is positive, right? Now, second case, if f of b less than f of a, then f of b minus f of a less than 0, right? Look at this one. If it's less than 0, the whole thing should be negative, right? So second one, f of b less than f of a. The sign of the average rate of change is negative, right? Now the third case, if f of b equals f of a, then f of b minus f of a equals 0, right? So you look at this one right here, the average rate of change is 0, right? So f of b equals f of a. The average rate of change is 0, right? Now, you look at this one right here, least, which means this one right here. If it's negative, it's going to be least, right? So we just check from A to B. From A to B, you see that at point A and point B, you have the same distance from the origin right here, which means the radius should be the same. If the radius is the same, the average rate of change is 0, right? So this is not the answer choice, right? We need least, which means we need negative, right? Now from B to C, you see that the radius is going to be like this, right? And you see that from B to C, it's go this way, right? And the radius getting bigger and bigger. If the radius getting bigger and bigger, which means f of b minus f of a positive, right? Not the least, right? So the answer choice B is wrong. Now next one, from B to D, right? It's going to be this one right here. So within this interval, we need to split this one into two intervals. From here to here, it's getting bigger and bigger, right? Because the radius is getting bigger, right? But from here to here, the radius getting smaller and smaller, right? So it's conflict, right? Within the interval from B to D is conflict, right? So answer choice C is not correct. Now answer choice D, from D to A. From D to A, you see that the radius getting smaller and smaller, right? A is least, right? It's right here. You see that? The distance getting smaller and smaller from D to A. So if the radius getting smaller and smaller, which means f of b less than f of a, the sign of average rate of change should be negative, right? And then this one is the least. So the answer must be D. Now let's move on to question 155. 155 is opposite to 154, right? We do exactly the same thing. Now answer choice A, from A to B, which means from here to here. Alright, you see that the radius getting bigger and bigger, right? If the radius getting bigger and bigger, which means f of b greater than f of a, then the sign of the average rate of change must be positive, right? So this one is the radius one. So the answer choice A could be correct. Let's check for the other answer. Now the second one, from A to C, is going to be from here to here. And you see that they have the same radius because they are equal distance from the pole, right? So this one right here, the average rate of change is 0, right? This is not the radius, right? This one is positive. Now, the next one, from B to C, from B to C is going to be from here to here. And you see that the radius getting smaller and smaller, right? From B is the biggest one, right? And then it's getting smaller and smaller. You see that? So if it's getting smaller and smaller, f of B less than f of A, right? Which means the sign of the average rate of change is negative, right? So this one is the least. And then from B to D, it's going to be right here, right? Now, the radius getting smaller and smaller. It should be negative right here, right? You will see it. Alright, so finally, the answer choice A is correct. Now, question 156. The polar function R equals f of theta, where f of theta equals 4 cosine 2 theta, is graphed in the polar coordinate system. As theta varies from theta equals pi over 4 to theta equals 3 pi over 4. How is the distance between the origin and the point with polar coordinates f of theta changing? Right? So in order to do this one, we need to sketch this one in the rectangular system. Alright, so here's the graph of f of theta equals 4 cosine 2 theta, right? Now, we need to check this interval right here from pi over 4 to 3 pi over 4. So I'm going to look at this one, pi over 4 to 3 pi over 4. It's going to be two intervals from pi over 4 to pi over 2, right? And another interval, it should be from pi over 2 to 3 pi over 4, right? Now, the question is, how's the distance between the origin and the point changing, right? So we need to compare the radius from this interval to the origin, right? Now look at this one right here. You see that from pi over 4 to pi over 2, the radius is getting bigger and bigger because it's further away from the pole, right? Now, from pi over 2 to 3 pi over 4, the radius getting smaller. Look, right here is the maximum, and then it's getting smaller and smaller. You will see it, right? So the distance is increasing, then decreasing. The answer must be C. Now let's move on to question 157. Consider the graph of the polar function R equals f of theta, where f of theta equals 1 minus 2 sine theta in the polar coordinate system. Which of the following statements about the R equals f of theta is true over the interval 2 pi over 3 to 3 pi over 4, right? First, we need to sketch this one in the rectangular system. Alright, so here's the graph. Now be careful, there is a negative sign in front of amplitude, so there is a reflection over the midline, right? Now question A. The average rate of change of the radius with respect to theta is positive, and the points on the graph are above the x-axis, right? Now we need to check for the average rate of change first to see if it's positive or negative, right? So we need to calculate f of B and f of A. We need to compare, right? If f of B greater than f of A, then the average rate of change is positive, right? F of B is right here, right? So we have f of 3 pi over 4. Substitute 3 pi over 4 for theta into this equation right here, right? We have 1 minus 2 sine of 3 pi over 4. Sine of 3 pi over 4 equals root 2 over 2, right? So it will be 1 minus 2 times root 2 over 2. So it will be 1 minus root 2, right? Now we need to calculate f of A, which means f of 2 pi over 3, right? So it's going to be 1 minus 2 sine of 2 pi over 3, right? Now it's going to be 1 minus 2 times root 3 over 2, right? So it's going to be 1 minus root 3, right? Next one, we need to check f of B minus f of A, right? So it's going to be f of B right here, 1 minus root 2, subtract f of A, which means 1 minus root 3, right? And then it's going to be 1 minus root 2 minus 1 plus root 3 when you distribute negative 1 right here, right? So the answer must be root 3 subtract root 2, which is positive, right? If it's positive, I need to eliminate the answer B and D because it's a negative, right? Now I'm going to check to see if the points on the x-axis are below the axis. First, I need to find the zero of this function, right? I need to find the zero right here. So in order to find the zero, I just let this one equals 0, right? So it's going to be 1 minus 2 sine theta equals 0, right? So it's going to be sine theta equals 1/2, right? And then theta equals pi over 6. Theta equals 5 pi over 6, right? So pi over 6 is less than pi over 2, so it's not the case, right? So this one is not right. 5 over 6 should be right here. So this guy is 5 pi over 6. Now we know that 3 pi over 4 is less than 5 pi over 6, right? So then 2 pi over 3 and 3 pi over 4 must be on the left of 5 pi over 6, right? So 3 pi over 4 could be somewhere right here, right? And 2 pi over 3 could be somewhere right here, right? And then you have the interval, it's going to be from here to here. This interval is below the x-axis, right? So the answer must be C. This one is above the axis. Now question 158. Consider the graph of the polar function r equals f of theta, where f of theta equals 3 times sine theta cosine theta in the polar coordinate system. As theta increase on the interval pi over 2 to 3 pi over 4. Which of the following statements is true about the points on the graph of r equals f of theta in the xy plane, right? Now, in order to do this one, I'm going to copy this problem to the whiteboard because I need to use the unit circle. Now, the first thing I need to do is to find the zero of this guy, right? So how do I do it? I need to let f of theta equals 0. This guy is the same thing as 3 times sine of theta times cosine of theta equals 0. This one is the zero product, right? So I need each of this one equals 0, right? So I have sine theta equals 0 and cosine theta equals 0, right? Now if sine theta equals 0, theta equals k pi, right? And cosine theta equals 0, theta equals k times pi over 2, right? Where k is the integer, right? Now if k equals 0, you get 0 for the first one, right? You get 0 for the second one, right? K equals 1, you get pi, right? On the bottom, you get pi over 2, right? K equals 2, you get 2 pi. This guy, you get 3 pi over 2, right? Etc. Alright, now I have the 0, I need to draw the number line. I put 0 right here. The next one should be pi over 2, right? Next one should be pi. Next one should be 3 pi over 2. Next one should be 2 pi. Alright, now I'm going to check for the sign in each interval right here. From 0 to pi over 2, it's going to be the first quadrant right here. Right? This first quadrant, sine, cosine, positive, right? F of theta is positive, right? So this guy is positive. Now second one, the interval from pi over 2 to pi is going to be right here, right? Sine is positive and cosine is negative, right? Keep in mind, you have a trick to memorize this one. All students take calculus, right? The first quadrant, all trigonometric function has a positive value, right? The second quadrant, only sine positive. The rest one should be negative. The third one, tangent is positive. The rest one should be negative. And the last one, cosine is positive. And the rest one should be negative. So keep that in mind. Second quadrant, sine is positive. Cosine is negative. So if you multiply this guy up, it's going to be negative, right? So it's going to be negative right here. The third quadrant, pi to 3 pi over 2 is going to be right here. This quadrant, sine and cosine is negative, right? So if sine and cosine negative, when you multiply them up, it's going to be positive, right? So this guy should be positive. And the last one from here to here. Only cosine positive, right? Cosine is positive, sine is negative. The answer must be negative, right? So this one is negative. Alright. Now we're gonna check the interval right here. Pi over 2 to 3 pi over 4. Pi over 2 right here. 3 pi over 4 right here, which means it's inside this interval right here, right? So 3 pi over 4 will be right here. Within this interval, the radius is still negative, right? So if the radius is negative, the function is below the x-axis, right? So then you need to eliminate C and D, right? Because it's say above the axis, right? Now you need to check to see if it's getting farther from the origin or closer to the origin. In order to do that one, we need to check for the average rate of change. Now the formula for the average rate of change is going to be f of b minus f of a over b minus a. This one is a. This one is b, right? So you have f of 3 pi over 4 subtract f of pi over 2 over 3 pi over 4 subtract pi over 2. Now substitute 3 pi over 4 for theta in this equation. So we have 3 sine of 3 pi over 4 cosine 3 pi over 4 minus this one right here 3 sine pi over 2 cosine of pi over 2 over 3 pi over 4 subtract pi over 2 is going to be pi over 4, right? Sine of 3 pi over 4 is going to be root 2 over 2, right? So this guy equals 3 times root 2 over 2. Cosine 3 pi over 4 equals negative root 2 over 2, right? Now this one cosine pi over 2 equals 0, so the whole thing right here is 0, right? It's going to be pi over 4, right? Now simplify this one, it's going to be root 2 over 2 times root 2 over 2 is going to be negative 1/2, right? So it's going to be 3 times negative 1/2 over pi over 4, right? So this one is negative 3 over 2 over pi over 4, right? Now you need to multiply the top and bottom by 4, right? Because I see 4 right here. This one cancel out. So it could be negative 3. This one cancel. So it could be times 2, right? Over pi left right here. So it could be negative 6 over pi, which is negative, right? So if the average rate of change is negative, the function is decreasing, right? Now previously, we know that the function is below the axis, which means it's going to be negative, right? Minus sign to represent the negative, right? Decreasing should be minus sign. This guy times this guy is going to be plus sign, which means increasing, right? So the radius is increasing. If the radius is increasing, it's getting further away from the origin, right? So the answer must be A. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals that take us higher. The night's young and it's just begun as she puts her hand in mine.